Subscribe now and press the bell icon. Never miss an update.
Hi guys, this is Angela from the App Brewery, and before we get started digging in and building apps, the first thing I want to talk about is how exactly does an app work? Because we all have it in our phones, we use it to do really important things like banking and contacting friends, but there's actually very few people who knows just exactly how an app actually works. So let's start off by getting an overview of that. Now, the first thing we have to realize is that smartphones are actually no different from just any other computer. And an app is just code that we write to tell that mini computer what it should do. So let's say we have an app that just has a single button on it that says click me. When the user taps on the screen of that phone, then the sensors in the phone register that tap and sends a message to the operating system, which in the case of an iPhone would be iOS. Now the operating system then looks at the data that it gets from the sensor, including things such as how much pressure was applied onto the phone, at which location on the phone screen did it register that pressure, and a whole bunch of different things and a whole lot of numbers. But the operating system takes all of those numbers and makes sense of it. And once it does, then it'll know that this particular button on the screen of this particular app was tapped at this time point. And then it'll send a message to the app in question telling it that, hey, this button of yours got tapped. What should it do? And so the code that you write for your app should specify, in this situation, when the button called click me gets tapped, this is what it should do. It should change what's shown on screen, and it should do this and that and that. So essentially, as an app developer, you're planning out all of the scenarios and what should happen in each case. So it's almost a bit like emergency planning. If the building is on fire, what should happen? Well, we should probably evacuate the staff, and we should probably shut all the doors to prevent the fire from spreading. Well, it's exactly the same for apps. What should happen when a user taps on this particular button? Well, we should change the screen background to red, we should show them some other pieces of information, and then we'll wait to see what the user does next. And then there's a plan for how to respond to the next event. So there's essentially only 3 components to every single mobile app. There are the user interface elements that you see on screen. So that can be things such as buttons or images or toggles and sliders. And when we first build our app, we're going to set up the screen. So we're going to drag on some buttons, place it in a location that we think makes sense, and then add images or add other interface elements to the screen. Now, when those elements get interacted with by the user, say somebody taps on the button, then we've got the second component of the app that comes into play, which is the code. And this code is the plan. If this button called click me gets tapped on, then what's the next thing that should happen? Well, it's step 1, do this, step 2, do that, step 3, do that. But if the user, say, used the slider, then in our code, there'll be a section that plans for what should happen when the user uses the slider. And finally, most of the apps, especially if it gets more complex, will have data that's stored in the app. So for example, let's say we have a contact management app, right, where we have all the phone numbers of all of your friends and colleagues. Well, on the screen, when the user taps on a button that says, show me Bob's phone number, then that will send a message to our code, and we check through all of those lines of code to see how we should respond when the user taps on that button. And then the code will go into the data and fetch the relevant piece of data. So in this case, that's of course Bob's phone number. And then it's going to send it back onto the screen and display it on the screen so that the user now sees the telephone number of Bob. Now, previously I mentioned that a smartphone is just like a smaller computer, but there's still a few crucial differences. The first difference is that a laptop or a desktop computer is usually plugged into the wall, but a phone, on the other hand, is usually wireless. We usually keep it in our pocket and it's not always charging. It's also a lot smaller, so the battery gets depleted much faster compared to a laptop. Now, a phone also has less processing power, so if you try to play something that's really intensive on your phone, phone, say the latest Far Cry, or if you try to run Photoshop on your phone, then it's not going to be able to do it because it has less memory and less processing power than your computer. So because the phone has limited resources on all of these fronts, then in order for a user to actually have a good time using their iPhone, then we have to manage those resources very frugally. So for example, you can't just make an app that drains the user's power in 5 minutes, or make an app that's so demanding on processing power that it's so slow and barely chugs along on the phone. So in all smartphones, there's always a manager, somebody to manage all of those resources. And that is, of course, the operating system. So it's iOS in our case that we need to worry about. And this manager is a little bit like the factory boss. It tells our app, hey, you're about to come on screen now, get ready. The user wants to see something from you, don't let me down. Or it might say, hey, you're draining the battery way too much, I'm going to have to shut you down. Or hey you, little app, the user's getting a phone call right now, I'm going to have to switch you off. Make sure you save their data before you go home. And this is what I think about every time I see my apps shuddering and shaking in fear. So previously we looked at the 3 components that make up any app, namely the screen, the code, and the data. Well, we actually have to zoom out a little bit and see the bigger picture, which includes the role of the operating system. So when we think back to that plan that we're writing when we're coding up the apps, then that plan has to take into account all of the events that happen, not just when a button inside the app is tapped or when the user shakes the phone when our app is open, but also things such as when the operating system tells us that the user is getting a phone call. So our app is going to be switched into the background. So we have to also plan ahead for those situations. Well, if the user is getting a phone call, but they were midway through filling out a long form inside our app, we don't want them to come back after the call and realize all of that data has been lost. So we have to plan on how we save that data when a user gets a call, for example. So all in all, when we build an app, we're essentially writing a very long and very extensive plan to plan for what should happen under lots of possible scenarios. And when the app is launched on the phone, it looks to this plan to see what it should do. So in the course, we're going to be digging into every single aspect that we spoke about in this lesson. And this is a little bit of a teaser of what's yet to come and what you're going to be learning about, so that by the end of the course, you'll understand exactly how the app works and build any app that you dream of. Now, in the last lesson, we got an overview of how apps work on the phone. So in this lesson, I want to take you one step further and look at how apps are made from beginning to end. Now, one of my favorite shows of all time that you get on Discovery is a show called How It's Made. And it basically takes you into the factory and shows you how a bunch of random things get built on the factory floor. Things such as street bicycles, or floors, or drum crushers, or skateboard wheels. And I just find it so fascinating seeing how all of these everyday objects gets made and built. So if you're curious, have a look at some of the episodes, and there's some real gems in there, like how rubber gloves are made. And it shows you every step of the factory process, from dipping it in latex to drying it and rolling it. And I don't know why, but I find it so interesting, the process that's involved in creating all of these everyday objects. So that's what I want to do here. I want to do a special episode inspired by the show on How It's Made, the app episode. So the app industry is absolutely massive. Last year, Apple reported it paid app developers $26.5 billion US, and that number grew by 30% year on year. So it's a massive industry, and it keeps on getting bigger. Now, of course, some of that money goes to big companies such as Clash of Clans, or Clash Royale, or some other form of clashing. But there are also a lot of stories of independent, one-man developers who have made it big on the App Store. And one of the best examples is the 7-minute workout app. Now, in the course resource list, I linked to the article that's written by the maker of the 7-minute workout app, a guy called Stuart Hall. And by himself, he built an app that got 2.3 million downloads without spending a cent on marketing, which generated him over 70,000 US dollars in profits and was acquired and sold to a company just after 18 months. It's a really fascinating read, but he goes through the entire process of how he built this app from idea to app store, all by himself with no budget. Just the skills and know-how of how to build an app and the grit and perseverance of an entrepreneur. So I know that you're taking this course for various reasons. Some people want to get a job as a developer. Others just want to gain a new skill and make apps for fun. And other people want to build a business based on an app. But before we get started and really dig into learning and building our apps, I think it's really important to first have an overview of the entire process from beginning to end of how an app is built. So step 0, before you do anything else, is why. Ask yourself, why do I need an app? And in many cases, you actually don't. If you just want to build an app that simply displays data or information, say the opening hours of your shop or the services that your business offers, then you don't actually need an app. You can simply build a website that looks good on mobile, and that will take far less time to build, and it's much easier to do. But however, if you need to tap into the sensors of the phone, or if you want to be able to push notifications to the user, then you probably do need an app. But just make sure that you're on the right path before you even begin. Now, once you're sure that you want to build an app, then the next step is the idea stage. Not just coming up with an idea, which is the easy part, but validating whether if the idea is actually a good one. So let's say that I'm bored of swiping on Tinder for my next match, and instead I want to find my perfect match in the form of a Sunday roast. So what if I have an idea for an app that's called Tender, and it's going to match me with the dish that I fancy the most right now. And it could be a delivery app such as Uber Eats or Deliveroo, where I get that meal made and sent to me, or it could be just a recipe app where I try to find the thing I want to make today. So here's an app idea, but how do I know if it's actually a good one? Well, that's when you would need to validate the idea. Talk to lots of people and get a diverse range of opinions. Make a minimum viable product that doesn't require any technology at all to test and see if people are actually interested. Or put up a landing page describing your idea and promote it on social media and see if people actually want it. And essentially what you're trying to establish is, once this app gets made, will people actually want to download it and use it? Now, once you figure that out, then you're ready to move on to step 2, which is designing the app. And in this app development bootcamp course that you're enrolled on, I've included full modules on app design. So you'll learn how to build wireframes, how to build prototypes for your app, and learn how to use all the tools and the design principles to make not just a functional app, but a beautiful app that people will love. And then you can move on to step 3, which is the actual development, the programming of the app. And that is going to take up most of our time in this bootcamp. We're going to be building over 25 apps, and through the process of building these apps, we're going to be learning all of the fundamentals of iOS development and the Swift programming language, so that you become a well-rounded developer and you'll be able to tackle new problems that you haven't seen before or build custom features once you've completed the course. So let's take our Tender app, and let's say we've written all the code for all the functionality of the app, and we've developed and built it. Then the next step is to test the app. And I'm going to tell you about automated as well as manual ways of testing your app so that it looks and works well on all devices, so that people all around the world, no matter which phone device they have, will be able to enjoy using your app, so that you can get those 5-star reviews that are crucial for your app to get more downloads. Now, step 5, we're ready to publish it onto the App Store. And I'll tell you all of the ways that you can get press for your app launch, and also what are the rules behind getting your app featured on the App Store. Now that you've made and published your app, the next step is to tell people about it. So in this bootcamp, there's a full course on app marketing as well, where I show you all of the ways that you can get your first customers, get your loyal fans, and start getting those downloads and making revenue off the App Store. Now finally, step 7. As with all great things, you need continuous feedback and continuous improvement. So when your app is alive on the App Store, you'll start getting reviews of people who want to request other features, or they have suggestions, and you can take some of those on board and update and refresh your app and continuously improve your user's experience. So that's a very quick and broad overview of how apps are made from beginning to end. Now, if you scroll to the very bottom of the curriculum, you'll find that I've included a full-length version of this lesson, and it's a talk that I give often at conferences, hackathons, and various events, and it goes into far more detail on every one of those steps that I've talked about in this lesson. So if you're interested getting more details on each of the steps and seeing each of the steps fleshed out, then head over there and take a look at that talk. And then once you're done, continue back where you left off in the curriculum track, and we're going to get started building our very first app. As an enrolled student on the full course, you're going to get access to a huge bundle that we've compiled just for you. Now let me show you what this bundle includes. You're going to get access to a whole bunch of icons, which you'll be able to use within your app. You're also getting a load of gradients, which can be used as app backgrounds, as well as HD photos and faces for avatars. There's also a load of Photoshop files for buttons and controls, as well as a whole bunch of app mockups in Sketch and in Photoshop. And finally, we've included app icon builders for iOS and Android, so you'll be able to easily create your app icons and export them in all the right sizes. Now, collectively, this huge bundle of image assets is worth over $5,000, but we're going to give it to you for free as a part of this course to make life easy for you when you're creating your own apps. Now, on top of this massive bundle of image assets, we're also giving you access to our highly rated 12 Rules to Learn to Code book that consolidates some of our best tips for how you should go about approaching learning to code. So once you're ready, if you head over to your course contents, you'll be able to download all of these files. Alright guys, so you've signed up to the best iOS development course in the world, and you're going to find out very shortly why over 17,000 people have rated this course 5 stars. But in order to get the most out of the course, there's a couple of things I want to draw your attention to. Firstly, the majority of the course is going to be dedicated to programming and learning iOS development. But there are also full modules on app design and app marketing, which will supplement your knowledge on the entire process of app development. So be sure to look through the curriculum to find these extra modules, and you can work through it alongside the coding tutorials. So very often, I find that students do best when they do a little bit of programming and then switch their mind to a different problem, such as learning some design skills or learning some marketing skills. So feel free to dip between the design, marketing, and coding parts of the course. Now, while you're learning iOS development, I tend to recommend that students code on your main computer. Now, this is just my recommendation, but I find that students benefit a huge deal if you can watch these lectures on a separate device. So that can be an iPad, or that could be another laptop, or it could be even a Windows computer. It doesn't really matter. But having the tutorial videos side by side with the code allows you to more easily compare the code and also code along and complete the challenges in the tutorials. Now, while you're watching the tutorials, I find that it's helpful to have a small notebook to note down some of the things that you might want to do a bit of background research on, or you might want to read up more on. Something that's mentioned in the tutorials that you find fascinating, or something that you just want to understand more deeply. So having that there is also really useful. Now, at the beginning of the course, you should have already downloaded the entire syllabus. If you haven't, you can head over to the giant course resources list, and right at the top, the first link will be pointed towards this PDF. And in this syllabus, I've documented all of the skills that we're going to be acquiring as we're building apps and as we're progressing through the course. Now, I find that it's really helpful when students refer to the syllabus and just check off as they go along the things that they are comfortable with. So, for example, in the second module, when we learn about the Xcode interface builder, you can see that some of the learning points include things such as how to size UI elements or how to arrange UI elements by setting coordinates. So I'm going to be showing you how to do this in the tutorials. And once you're certain that you've acquired these skills and understand each of the syllabus points, then you can go ahead and just check it off. Now, some of these things might require a couple of reviews, so you could mark it for a review at a later date, or you come back to it, and that way you'll be able to keep track of the skills that you're acquiring, but also which parts need further review. Now, the coding tutorials were built so that it's a little bit like taking a hike up a mountain, and the slope is carefully designed so that each new tutorial builds on the previous one. So it's really essential that you don't skip coding tutorials, and instead you complete the curriculum in the order that it was designed. And this is really important because I know that when I look at a new course and I see something really exciting like learning machine learning, then I'm really tempted to just head straight there. But it's really important that you resist this temptation. Do each of the tutorials in sequence. Because of the fact that everything builds on top of the previous tutorial, then it's very easy to get stuck and get frustrated when you jump around in the curriculum. Now, in the course, there's also a whole bunch of coding challenges, and the challenges are there to make the process of learning iOS development feel a little bit less like school learning and feel a little bit more like a video game. So that means that there's plenty of small coding challenges dotted all over the course that are kind of like, you know, the skeletons in your video games. You're pretty confident that you can slash them down. You know, it doesn't take too many hits before you can beat them. But then there's also end-level boss fights, and these are kind of meant to be a little bit larger of a challenge. So you'll be building an app by yourself, or you'll be completing a longer coding challenge. And this is so that not only can you prove to yourself that you've understood the concepts in the tutorials, but also just providing that little bit of extra challenge that makes everything a lot more fun and really tests your skills and pushes you to level up as a programmer. Now, for those of you guys who are learning programming for the very first time, then I tend to liken the process of learning programming to a bit like putting a puzzle together. Because in the very beginning, I'm going to be presenting you with the corner pieces, and then I'm going to give you the side pieces, and then finally I'm going to give you more of the center pieces. And at the beginning, it's very difficult to see the bigger picture, right? You're only seeing the outer edge. But as you add more pieces, as you increase your knowledge and your understanding of different concepts in programming, at some point during the course, you're going to have an aha moment where the picture suddenly becomes more and more clear, and you realize the relationship between all of these different programming concepts and how they fit together. So the important thing is to be patient, and if a concept is particularly challenging, then continue for a few more modules and then coming back and reviewing that same concept a little bit later on, so that by the end you'll gain a complete picture of iOS development and Swift programming. Oh, and one last thing. If you find that I talk too fast or too slow, then if you look at the bottom of the video player, there are settings where you can see me. So I talk really fast like this, or you can slow the video down so that I talk a little bit slower like this. So depending on which way you learn best, feel free to change the speed of the videos so that it suits you. So I hope that's helpful in guiding you through the course and a little bit of a sneak peek of what's to come. But the thing I want to emphasize is that you're not doing this alone. There's loads of other students on the student communities who you can chat with and share your experience, help each other, and also I'm going to be here for you every step of the way. So in the next lesson, I want to talk about how you can get help at any point through the course. So see you over there. Alright guys, it's Angela from the App Brewery again. So At this stage, I'm presuming that you've probably at some point in your life done a tutorial or a lesson somewhere else out there on the internet. And inevitably, at some point, you'll probably get stuck on a problem. Now, I spend a lot of time thinking about how I can make the course such that you get stuck less often, but with programming, it's almost a core part of the learning process that you do get stuck and you get yourself unstuck. So I tend to find that when I get stuck on something, I try to see it as a challenge, because usually when I solve it and when I figure it out, there is a huge sense of satisfaction, and there's usually some associated growth. Now, having taught over 100,000 students online and offline, I've seen people struggle in lots of different ways. And I just wanted to summarize the steps that you can go through when you get stuck on any sort of programming problem and the framework that you can use to get yourself unstuck in the quickest way possible. Now, the first step is to evaluate what is the expectation versus what is the reality. What did you expect your code to do? Or what did you expect to happen? And what actually happened? So every time you run your code, think to yourself, what do I expect to happen? And then see what really happened and try to figure out what is causing the difference. Now, with Xcode, it's very helpful in pointing out errors in your code. And it almost does it too well, where it starts feeling a bit like a nagging parent. It starts giving you warnings and errors. Oh, you forgot to capitalize that, or I don't know what you mean when you're writing this. But it can be really helpful as well. And when you get a little red error in your code, it usually is accompanied by a little bit of text. And this is the error message. And most of the time, it might seem like these error messages are written by aliens because they don't seem to make any sense. But you can quite easily figure out the human meaning in English for it by just putting it into Google. And you'll usually get lots of different answers as to what the cause might be and how you can fix the problem. And one of the websites, if you don't already know about it, it's going to shortly become your very best friend, and that is stackoverflow.com. So I recommend searching for any errors that you come across into Google and then heading towards the Stack Overflow websites that come up as a result. And this is exactly what real life developers do every single day. And in fact, I've worked in teams where we will all just go to the pub and have a drink and end the day if Stack Overflow is no longer working. So it's not cheating, it's all a part of the developer workflow. Now, if that still didn't help, or you're confused by the results that you're getting back, then it's a good idea to re-watch some of the video up to the point when the code started breaking or it started doing something unexpected. Because in the videos, there are always step-by-step instructions, and it's really important that you check to make sure that you haven't made a typo here or there, or you haven't capitalized something that shouldn't be capitalized, and just re-watch the video right before when your code broke in order to try and figure out what might have gone wrong. Now, the next step is you can check your code against my code. At the end of every tutorial module, there is a completed project that you can download, and you can scroll through the completed code, compare it to your own, and see if there were any typos, any errors, any mistakes. And if it helps, you can even copy and paste sections from the completed code into your own module just to see if that line or that paragraph helped to fix the issue. And if that still doesn't solve it, then the next step is head towards the Q&A. So underneath every lesson, there is a Q&A section. And it's a good idea to check in the lesson when your app has broken to see whether if anybody else had similar issues to you. And if you can't find anybody with the same issues, then ask in the Q&A. But make sure that you ask your question in the lesson where you're having the issues. That way it makes it much easier for other students to be able to learn from your mistakes, and also for me to be able to quickly identify what the problem might be. And if you have a question about anything in the tutorial, it's a good idea just to include the timestamp at which it occurs in the video, so I can quickly watch it and figure out what you're referring to, so that I can better answer your questions. Now, when you're asking questions in the Q&A, the way to get the most helpful responses and solutions is by following a 4-step approach. So firstly, tell us, so myself and other students, what did you expect to happen? Then what actually happened? And then include a screenshot of all of your code that corresponds to this situation, and then include a screenshot of the debug console that includes any errors, if there were any errors or if your app has crashed. So in order to take screenshots on the Mac, this shortcut is going to save you a lot of time, and it might be worth noting this down in your notebook. When you use Command Shift and 4, you get this little crosshair that shows up, and you can start clicking and dragging the area that you want to take a screenshot with, and it will save it automatically to your desktop, which then you can upload into the Q&A area for the lecture. And the parts that are really helpful to help you diagnose what went wrong are the code that you've written, and also whatever is written in the debug console. So this is the part that's in the bottom half of your screen. And this is super helpful for trying to figure out what happened, especially if you scroll right to the top. That's usually where the most helpful messages are. So that's just a brief step-by-step process on what to do and how to get help when you get stuck. And it's important to remember that everybody gets stuck sometimes. I've spent days trying to find a bug in my code, and it turns out to be just a comma that was misplaced or a semicolon that was accidentally deleted. And one of the greatest joys for me anyways is figuring out these problems and fixing them. So don't worry if you do get stuck. Everybody will try to help you, and just remember that getting stuck and solving it is all a part of the learning journey. Alright, so in this lecture we're going to be covering some of the tools that you'll need in terms of software and hardware to start developing for iOS. First and foremost, you will need a Mac of some sort. Now, it doesn't have to be the latest or the greatest, but it just has to be able to run OS X. So it's now called Mac OS. And the reason why we need Mac OS is because we need to install a piece of software called Xcode that will allow us to develop our iOS app. So this means that iPads, even iPad Pros, are out of the question. But if you had a iMac, or if you have a MacBook, or even a Mac Mini, it will work just fine. So if you don't already have a Mac, and you don't want to invest a lot in, brand spanking new top of the range MacBook, then one of the cheapest ways is probably just going onto eBay and getting a second-hand Mac Mini for around $500, and it's a pretty great deal, and it'll do just fine. But what do you do if you only have a PC? Well, the other option is that you can go for something called Mac in Cloud. So if you head over to macincloud.com, they have a service where essentially they offer you a Mac in the cloud. So you can be using your PC and you have a remote connection to a Mac that is just for you, and it's already got Xcode pre-downloaded, so you can just get up and go. Now, there's a lot of people who ask about Hackintosh, or how can you run a Mac, sort of dual boot a Mac on your PC without having to pay for a service like Mac in Cloud. Well, there's a number of ways that you can do this, but one of the major downsides is that Apple is very strict about controlling their software and the environment in which their software runs. So even if you're using Mac in Cloud, or even if you're using a Hackintosh solution, you won't be able to run your app on a physical iPhone device that you own. The only way that you can do that is by having an actual Mac. But you will be able to run it on a simulator inside Xcode. So this is a simulated version of an iPhone, and for all intents and purposes, it will work just as well. It's just, say, if you're really excited about having your app on your iPhone, then you really need to find a way of either borrowing somebody's Mac or, getting one cheaply. The best resource, according to past students, is a website called Hackintosh.com, which talks in detail about how to run macOS on a PC. But I would still recommend try out some of the earlier solutions rather than going towards building a Hackintosh. It's just that we've had a lot of students on the in-person programming bootcamp who've tried to do this, and it's always given them a lot of headaches. So if you can really try and avoid this, this is almost the last-ditch solution. Now, the software that you'll be using is Xcode, and this is a piece of software that's written by Apple and allows you to write code, allows you to design your app, as well as run your app within the simulator that it comes with. And this is completely free, and in the next lecture we'll be showing you how to download it and how to get it set up. But in order to be able to download the latest version of Xcode, which is Xcode 12, you're going to need to update your operating system to at least macOS Catalina 10.15. If you're already running macOS Big Sur, that's fine as well, of course, but note that macOS Catalina 10.15.4 is currently the minimum requirement to run Xcode 12. So if you find that you're unable to download it, it might be because you need to update your macOS operating system first. To check which version of macOS you're running is super simple. Simply just head to the left upper corner where you've got the Apple symbol, and then go to About This Mac, and you should be able to see the versioning right there. In order to update the latest version of macOS, all you have to do is head over to the Apple symbol again, go to System Preferences, and then go to Software Update. Here you should be able to see the update for macOS Catalina, and you can simply click through the wizard to update your macOS. Now, another thing to note when you're updating your macOS is to check the age of your laptop or your desktop, because there are certain hardware requirements in order for us to be able to install the latest version of macOS. So here I've included a list that Apple has given, so check your computer against this one to see if you meet the requirements. But if you do have any difficulties updating your macOS, then this might be one of the reasons. And if this happens to you, it might be that you have to go down the Mac in Cloud route, or you might just have to pick up a cheap version of a Mac Mini off eBay. But that's a tip that trips up some people when they're updating their OS. So when you're testing your app, you've got the choice of either testing it on a physical device if you own an iPhone or an iPad. So because the course is aimed at teaching you how to make apps for iPhone, a lot of the designs that you'll be making and a lot of the project stubs will have the design and layouts optimized for iPhones. So you can still follow along with everything we do in the course with an iPad, but just be aware that some of the designs might look a little bit stretched and they might not look exactly the same as you see on the iPhone, but it will work just fine. If you don't have an iPhone, you don't have to run out right away and get one. This is something that I would recommend, once you realize that you're really into this, or if you're at the point where you're about to release it on the App Store, then you have to test your app on a physical device. It's at this point when you would actually get an iPhone. So, as I mentioned, Xcode comes bundled with a iOS simulator, and it's sort of like a virtual phone that runs on your computer, and you can essentially, use the rotate gestures, the shake gestures, you can zoom in and out, you can tap, etc. So it's just a simulated iPhone, and that works just as well. The only times when it doesn't really work so well is when you are using notifications, or if you're using Apple Health or Apple Home or some of those things, it can get a little bit tricky. Another thing that you should always ask yourself before you make any app is, do you actually need an app, or can you actually make do with a mobile responsive website? Now, because we have a mobile app development agency as well at the London App Brewery, one of the things that we tend to recommend, we have a lot of clients who come to us and say, I want you to make this app. And we actually spend a lot of time turning people away and telling them, look, you can get this made much quicker and much cheaper by just getting a web designer to make a website for you that's mobile responsive, that scales nicely on the phone. Because unless you're tapping into some of the sensors within the phone, say if you need the location, or if you need to be able to send people notifications, something that is inherent about the phone that you need. Otherwise, if you just need to display information, then making an app is a very time and money costly way of going about that. So always think about whether you actually need to make an app before you make any app. And finally, we're just going to mention that prior to Xcode 7, so Xcode 6, in order to actually download the app that you coded up, that you developed within Xcode, onto your physical iPhone device that you own, you actually had to pay Apple $99 a year in order to be on the Apple Developer Program. So as of Xcode 7, so I think that was September 2015, when it launched, you are now able to do this on any free Apple account. So all you need is just your normal iTunes account, which you use to download apps. And we'll be able to get your code and your app onto your physical iPhone device. Now, when would you consider signing up for Apple Developer Program? This is when you're ready to launch your app onto the App Store and start generating revenue. So I would recommend that try to delay signing up for the Apple Developer Program as long as you can, because you're charged on a yearly basis, rolling essentially. So if you're not yet ready to take advantage of the Apple Developer Program, if you haven't got your app together yet, if you're not ready to upload to the App Store, then there's actually no point paying Apple for that privilege. So build your app, test it thoroughly. Once you're ready and about to launch it to the App Store, then start paying for your Apple Developer Program license. And this gets you access to something called iTunes Connect. This is a portal where you can upload your apps, you can check your app analytics, how many times it's been downloaded, how many people are using it, you can check your sales, you can see how much money you're making every day, etc., etc. So this is something that we're going to cover in one of the last sections when we guide you through how to actually upload an app to the App Store. So all of that is coming up. Alright, so those were all the tools that you'll need in order to get started, and in the next lesson I'm going to show you how to install and set up Xcode so that you'll be able to get up and running very quickly and we can get started making our first app. We're now ready to download and install Xcode 12. This is the application that we'll be using to write our code and build our iOS apps. It's developed by Apple and it's free to download, so you don't have to worry about paying for it or paying for upgrades or any of that. But before we start, there's a couple of things that you need to check to ensure that your download and installation goes smoothly. First thing is to make sure that you have enough space on your hard drive. Xcode is a large piece of software. At the time of recording, Xcode alone takes up about 12 gigabytes. But you also have to make an allowance for the iPhone simulators that you'll probably download afterwards. The simulators can easily take up an additional 2 gigabytes. So overall, I recommend you have at least 25 to 30 gigabytes free on your hard drive. Why 25 to 30 instead of just 14? Well, if you actually use up every last bit of the space on your disk, your computer will slow down massively and it'll be hugely frustrating to actually use. So have some free space in addition to what you need for the download, and make sure that it's over 25 gigabytes. So first check to make sure that you have enough space. And to do that, it's pretty simple. Just head over to the Apple icon at the top of your menu bar and go to About This Mac. And when you're here, you can click on the Storage tab to see how much free space you have to play with. So the next thing that you need to check is to make sure that your Mac OS, your operating system, is updated to the latest version. So to make sure that you've got the right operating system, it's as simple as going to the Apple icon and going to, again, About This Mac, and you can see here which version you've got. And ideally, you'll be on Mac OS Big Sur, but at minimum, you should be running Mac OS Catalina 10.15.4 or above. And depending on the age of your laptop, you might be limited to a previous version of macOS, something like High Sierra or Mojave. In these cases, you won't be able to install the latest version of Xcode, which is Xcode 12. In that case, you can follow one of my previous courses, such as the iOS 11 or iOS 12 courses. So once you've done those two things, the last thing that you need to make sure is that don't download a beta version of Xcode. It's actually not that easy to download it by accident, because as long as you're going through this video and following along with what we're doing, then you can be downloading the official release version of Xcode and you won't have any problems. The reason why we don't like our students to be working with betas is because beta software is meant for testing. So it can contain bugs and it might end up giving you more headaches than it's worth. So no betas. Stick with what we're going to do, and you'll have a much better experience developing for iOS. Alright, so let's go ahead and do it together. So head over to the App Store. You can either use Spotlight by holding down Command and Spacebar to bring it up using the shortcut, or you can head over to the Spotlight icon over here, or if you want to be really fancy, you can even get Siri to do it for you. Siri, open the App Store. There we go. So head over to the search bar here and just type in Xcode. And then hit enter, and you can see it come up over here. And if you just click on this button here, you'll be able to install it onto your system. Now, this can take a little while, and sometimes you'll see it just hanging and it refuses to do anything. So have a look and see if some of those things I mentioned earlier might be the problem. So downloading Xcode can take anywhere between 30 minutes to 2 hours, depending on your network connection. You have to make sure that you have a good, strong, stable network connection so that it doesn't fail in the middle of downloading. Now, while you're waiting, it might be worth heading over to a bonus video that I've included, which is a talk that I often give to companies as well as students on how to make an app from beginning to end. But once you're done with downloading Xcode, then feel free to head over to the next lesson where we're going to get started by looking at Xcode and walking through all of the important parts. Alright, so now that you've got all the setup out of the way, let's get started by creating our very first app. Now, this app is called I Am Rich, and it comes from something really interesting that happened back in the days when we first had access to the iOS App Store. So there was a guy called Armin Heinrich who created this app called I Am Rich. And the interesting thing was that it's a really simple app. It was put into the art and lifestyle category, but he charged a whopping $999.99. And all it does is it just displays a single red ruby on the screen, nothing else. It had no functionality, basically. And this app that took him probably 2 seconds to create ended up getting bought by about 8 people. Some of whom thought it was a joke and they just clicked buy to see what would happen. Well, what happened was that they got charged the full amount, and there's a lot of really funny reviews for this app on the App Store. So subsequently, Apple actually removes this app because it doesn't actually have much functionality and it somewhat goes against the rules of the App Store. But the guy who created it still netted around $5,600 after Apple took a 30% cut from what he made selling those 8 apps. And to this day, you can still find copycat apps on the Android and Windows app stores for maybe a little bit less. The bargain bin price of $499, you can get yourself an I Am Rich app that does nothing on Windows. But it's a really, really funny story of how, I guess, a relatively ingenious guy decided that he would create this app for rich people to show off how rich they are. And it didn't really do anything at all other than display something on screen. But the reason why I'm telling you this story is because it's the perfect jumping off point for us to start figuring out how to create Xcode projects and iOS apps from scratch. So in this module, we're going to learn how to create and set up new iOS projects. We're going to get an overview of Xcode and how it works. We're going to design our app using Xcode and Apple's pre-built iOS components, and also incorporate some of our own image assets that we get either off the internet or our own pictures and images into the app. And finally, we're going to create a custom app icon to put onto our app and run it on a simulator and on a device. Once you're ready, head over to the next lesson and let's get started. Let's first tackle how to create and set up a new iOS project from scratch. So when you first open up Xcode, it should show you a welcome screen. And we can get started straight away by clicking on the link here that says create a new Xcode project. Now, if you don't see this welcome screen, it might be because this checkbox is disabled. So you can also go over to File, New Project to do exactly the same thing. So let's go ahead and create this new Xcode project. Next, we get to choose the kind of template we want for our new project. And firstly, up here, we've got different tabs for creating watch apps, tvOS apps, macOS apps, etc. But what we want is an iOS app. And this is the most customizable type of template. It basically doesn't assume anything about your app, and you're free to modify it as you need to. So now that we know what our template is all about, let's go ahead and click Next. On this screen, it's really important that you don't skip ahead, because you have to change this user interface from Swift UI to Storyboard in order for the rest of the lessons to actually make sense. And after you've done that and checked to make sure that your user interface says Storyboard, then we can continue with the rest of the lesson and add a product name. So this is going to be the name of your app. And we're going to call ours I Am Rich. And notice how down here, it's already starting to build out a bundle identifier. Now, a bundle identifier is kind of like a web address. It's meant to be something that's unique, and it will identify your app uniquely on the App Store. And you can see that it's created by what's called a reverse domain name. So whereas normally it would be something like yourcompany.com, well, they put the com at the beginning and then it's the name of your company. And that comes from your organization identifier. So the team you can leave as none for now. We'll revisit this a little bit later on when we actually need to launch our app on a physical device. But we should add an organization identifier. So for example, our company's web address would be www.appbrewery.co. So our organization identifier, because we're taking a reverse domain name, would be co.appbrewery. So it would look something like this. And the final bundle identifier is this plus this, and we get a unique URL, because most companies have a web address, and because web addresses are unique, this is a really simple way of ensuring that a company's app is uniquely identified on the App Store. Now, what if you don't have an organization identifier? What if you don't have a website? Then I recommend just writing com dot and then adding your name. So it could be Angela Yu, for example. This doesn't actually matter as long as there's nobody else who has used this bundle identifier using your name to try and publish an I Am Rich app on the App Store, then you'll be completely fine. Now, the very last thing to check is to make sure that the language that you've chosen to program with is Swift and the user interface is chosen as Storyboard. In later modules, we're going to be diving into Swift UI, but we'll need to learn a lot more about storyboarding and Swift before we can get there. And for the rest of the checkboxes, you can leave them unchecked like I have here, and then go ahead and click Next. Now it's going to ask you, where do you want to save your app? And if you have a specific folder that you want to save it to, then this is the point to go ahead and navigate to that. Alternatively, you can simply save it on your desktop if it's not too cluttered, or simply just create a new folder called Development, and you can start saving all your projects in there. Now we're going to go ahead and click Create, and it will generate our Xcode project for us. So that's it. That's our brand new Xcode project created. And remember that Xcode automatically saves all of your changes. And if you ever want to locate where this project is, then simply go to the very top over here, right click, and click on Show in Finder. At which point it's going to show you where it is on your computer. And if you go on to this view, you'll be able to navigate all the way up to see where it's actually located. In my case, it's simply on my desktop in a folder called Development. Once that's created, if at any point you want to pause the course and you want to close down Xcode, then you can always go back to where you saved it, open up the project folder, and then your project is located inside the file called iamrich.xcode project. And if you double click on it, it will open it right back up where you left off. So now that we've seen how to create a brand new project, the next step is to take a look around Xcode and familiarize ourselves with our working environment. Now that we've seen how to create and set up a brand new iOS project, and we've landed inside Xcode, it's time to get an overview of this piece of software that we'll be using to do all of the work of building our iOS apps, including designing the app user interface, as well as programming the code for the functionality of the app. So the first thing you want to do, if you haven't already, is to expand your Xcode to take up as much space as you have on your computer. Now, I don't recommend going full screen because then it's harder to get access to the menu items and it makes it difficult dragging and dropping files into our Xcode project as well. So without having to go to full screen, make sure the Xcode window is as large as possible. And then we're going to go on a guided tour of the Xcode software. So the first place we're going to look at is the page that we land on when we first create an app, which is the General tab here. So you can always come back to this screen if you select your project, go to the target, so this is your app, and then go to the General section. And here we have bits of data that we've already entered, such as the display name and the bundle identifier, and you can change things such as the version. Now, scrolling a little bit further down, we've got information for how our app is going to be deployed. So when it's run, where is it going to be running on? So for example, we can change the iOS versions that we target, and keeping in mind that this is going to be the minimum version that we want to target. So if we select iOS 13, then it means that anybody who has an iOS version that's above 13 will be able to use our app and download it. But if it's lower than that, then they won't be able to access it. So depending on how far back you want to support, you would select a minimum target here. And then we get to select whether if our app should be able to run on iPad and iPhone or just the iPhone. Now, later on, we'll take a look at Project Catalyst, which will allow us to run our app on Mac as well. But for now, let's just keep everything as the default. And then let's take a look at where we get to select the device orientation. If you want your app to be able to display it in all 4 dimensions, so when you turn the phone, it should turn with you to show the app upside down, landscape left, right, then you have all these checkboxes checked. But if you want to limit it to only portrait or one particular landscape orientation, which you'll see in a lot of games, then you can select the ones that you need. But again, I'm going to leave it as the default. Now, finally, you get to choose your status bar style, so whether if you want a white status bar or a dark status bar, and whether if you just simply want to hide the status bar. You can set those things right there. That's pretty much all for the settings page, and some of these other tabs we'll explore as we build more and more complex apps that might actually need us to go into some of these settings and tweak them around. But in most cases, you'll be keeping these settings as the defaults, and we'll be doing most of our important work inside the Swift files. So these are your code files, and the storyboard files, which are your design files. So notice how they have different icons depending on which type of file they are. So if you see the little Swift bird, that's a Swift programming file, and the design files have a yellow icon like this. So this is a good time to point out that usually the default layout of Xcode is split into 4 areas. First, we've got the top status bar here, which kind of reminds me at least a little bit of things like iTunes and other music players, because you have the play and stop buttons, you have the status of your app, and you have the selection for where you want to run your app. Now, if you hit the play button, it's going to run your app onto whatever device you selected here. And if you press stop, then obviously it just stops running the app. Now, over here on the left-hand side, we've got the navigator pane. And inside each of these panes, there's further subdirectories because there are lots of little tab bars. Now, for most of these, I'm going to mention as they come up, as we have a need for them. But the most important one you'll always pretty much want selected is the project navigator here, the one on the leftmost. And this simply displays your project. So if I open my project inside the Finder and I expand my project, my iMrich, then you'll see that each of these files correspond to what we see in Xcode in our project navigator. Now, because it usually takes multiple files to actually create a single app, it's really handy when we can see all of them at a glance right here where we need them. So when we need to go into our code, we can simply click into the viewController.swift. If we need to go into our design, then we click on our main.storyboard. Now, the main.storyboard is where you'll be designing most of your app. And here you get to access various components, things such as labels, buttons, all of the default iOS components, and you can simply drag and drop them onto the screen, like so. And once you have something on screen, then the right-hand pane becomes really handy. The right-hand pane are a bunch of inspectors. So when you click on something in your design or in your code, you might be able to inspect certain things about them. Now, by default, you will usually see the attribute inspector selected, especially when you're designing your app. And this allows you to change various things about the components that you've selected. For example, we can change the color, we can change the alignments, we can change whether if there's text shadows. And it's pretty much similar to any sort of other design program you might have come across, like Photoshop or Illustrator. Now, there's a couple of other tabs here. One that's really useful is the size inspector. And this one simply tells you the positioning of our component that's selected. So in this case, it's 144 pixels from the left and 228 pixels from the top. Next, we've got the width and height, which is pretty self-explanatory. And we've got lots of other inspectors as well, which we're pretty much going to leave as it is. But at the point where we need to use them, then I'll explain them in detail. So now that you see we have a label on screen, you can see that this little pane becomes quite handy. And this is what we call the document outline. So it shows an outline of all the components that are in your design file. So if you've ever used any sort of design software, you'll probably understand this best if you think of this as where the layers exist. So if I had two labels, one on top of each other, then we'll be able to see them both as separate layers inside our document outline. Now, if you don't know what a layer is, or you've never used Photoshop or Illustrator, it doesn't matter. This is just where your components are listed. And as you drag on different things, such as a button and a label or a slider, then you see them show up. And sometimes when your design has a lot of these components which are very close to each other, then it's actually quite hard to select the right one that you need. So it's much easier doing it inside here. But if you don't like this taking up the extra space, then you can just pop it away using this little button here. And all of these panes can be toggled. So the main toggles are for the three major panes. So the right side pane is here, the left side pane, and the bottom pane. Now, the bottom pane is called the debug area. And this is where you get messages if your app crashes. So this is the area that is pretty much just for the developer. So while you're developing the app and you need to see what's going on with your app, then this is where we'll be looking to. And we'll be exploring that a lot within the course. So if you want to get rid of these screens, then you can always use these toggles. But if you prefer using shortcuts, so for example, to pop this bottom screen down, you can hold down the Command, the Shift, and press the Y key on your keyboard, and you can toggle that. And if you look inside the resources for this lesson, there you will find a list of shortcuts which are commonly used with Xcode to speed up your workflow. Now, a word of warning, it does take a little bit of memorization if you want to go down this route. And everything that you can do with a keyboard shortcut, you can always do with the mouse. So depending on what sort of person you are, you might want to choose what kind of pathway you want to go down. Shortcuts or clicking with mouse. So now I'm going to go ahead and delete everything that I have on screen. I don't need it anymore. And I'm going to pop the bottom area away to give myself as much space as I can. And I'm going to go over to the viewcontroller.swift file to take a look at it. Now, this is where most of your code will live. So when you want to change the behavior of your app, then you're going to be writing some code right here. And notice when we head over to the code file, then the inspector tabs, they actually change. Because when you're in a code file, then you can't change, say, the color of your code or the size of your code. So it doesn't make sense to have a size inspector or to have the color menu drop downs. But it does have other things that are related to the code files, such as if you wanted to change the name of the code file or what type of file it is, then you might be doing it inside the inspector over here as well. So the right-hand pane is for changing certain properties of what's showing in the middle. The left-hand pane is mostly used for navigating between different files. Now the last thing I want to show you is something to do with settings. So if you head over to Xcode and go to Preferences, and you'll notice that in the General section, you can change the appearance of your Xcode version. So you can change it to the light mode, which is what I currently have, or the dark mode, which you might prefer because it's easier on the eyes. Now you can also change the way that your code is being colored by going to the fonts and colors. And there's a whole bunch of different themes that you can choose from. So you can click through each of these and see what you prefer and land on whichever one you like. But I'm going to be choosing the default light version. And if you're a beginner to programming, then I recommend you choose the same theme as I have, because it means that all the keywords in your version of Xcode will be highlighted in the same color as mine that you'll see in the videos, and it just makes it a little bit easier to keep up with what's going on in the lessons. But if you're already a programmer and you have strong preferences as to what you like to see in your color scheme, then feel free to change that here. Now, more important than colors are actually the font sizes. Now, I know from teaching a lot of students in class, they like to have really small fonts, and I don't know if it's because I'm going blind, but I find it really hard to read font sizes that are very small. So if you have a font size that's this big, then it's really going to hurt your eyes after a few hours of coding. So make life easy for yourself. Increase the font size so that you can actually see what's going on. And the shortcut to do that is holding down Command and hitting the minus key on the keyboard or the plus key on the keyboard, and adjust it to a point where you're happy and you can see quite easily. For me, I'm going to keep that font a little bit bigger than usual, just so that you can see it easily if you're watching this on a phone or an iPad, but feel free to adjust yours as you see fit. So that's pretty much the grand tour of Xcode. Now, if you enjoyed the tour, then feel free to leave me a review. But in the coming lessons, as we come across different parts of Xcode that we'll need to use, then I'll introduce them to you individually as well. And don't worry if all of this is a little bit overwhelming, you can't remember which part was the navigator pane or the identity inspector. I'll always be showing you exactly where you need to go and what you need to do anyways. Plus, if you head over to the resources for this lesson, you'll also find a map of Xcode. So you'll be able to see the areas highlighted, say the status area at the top, the inspectors area on the right, and the navigator pane over here. And it might just be worth getting used to some of those words that might be used quite frequently. And as well as for you to get used to the different areas of Xcode and their purpose. But now that we've toured Xcode, it's time to actually do some work and build the design and the layout of our app. So that's what we're going to be doing in the lesson. So I'll see you there. Now that we've had our grand tour of Xcode, we're ready to design our app using iOS components inside the Xcode storyboard. Remember where our design file is located? It's right here in the main.storyboard. A lot of students, when they're first starting out, often confuse the main.storyboard with the launch screen.storyboard. The launch screen looks pretty much identical to the main.storyboard, which is why people get confused. But this is the part that you can design to determine what shows up in the first moments when your app gets launched. So very often you'll see a company logo or maybe the words loading, but it's going to appear in a flash and then it's going to disappear. So this is not where you want to design your app. Instead, you want to make sure you're inside main.storyboard before you start adding UI components into the screen. Down here, you'll see View As, followed by an iPhone model. In my case, it reads View as iPhone 11. And if you click on it, it starts giving you various options. So you could change the type of device, and notice how it doesn't have every single device. It doesn't have, for example, the iPhone 7 or the 6 or the 5, but it does have the 4. So why is that? Well, it's because there's a number of iPhones that share the same aspect ratios. For example, the iPhone 6, 7, and 8, they all have the same aspect ratio screen, which is a 4.7-inch screen. And that means if you were to select the iPhone SE second generation canvas size, then the app will look exactly the same on an iPhone 6, 7, or 8, because they all share a 4.7-inch screen. But for other sizes, for example, the plus sizes, then it's got a different width and a height, so you might need to have a different canvas to see how it would be laid out. Now, you've also got the selection of the light and dark modes, as well as the landscape and portrait. So you can change these as you're designing to quickly see what your design would look like on each of these different settings. So I'm going to use the iPhone 11 canvas, which has the same 6.1-inch screen as the iPhone XR, but you can use a different canvas too if you like. And as long as the canvas that you've chosen isn't much larger or much smaller than what I'm using, you shouldn't have any issues following along with me in this tutorial. Besides, Apple regularly updates this list as they release new devices and update the Xcode software. So now that we have our canvas selected, let's go ahead and collapse that menu to again give ourselves as much space as possible. And you can actually move around in the canvas using your trackpad. So if you put 2 fingers on the trackpad and you move left and right, then you can pan your canvas around. If you move up and down, then you can also move it up and down as well. You can also do pinch to zoom to make it larger or smaller. But if you ever find yourself in a position where you can't actually find your screen anymore, then simply just click on the View Controller scene in the document outline and it'll bring it back to the center of the screen. So now let's go ahead and add some stuff to our canvas. And to do this, we have to head over to the Object Library. And we can bring up the Object Library by clicking the plus button. Notice how it's already telling me that this is the library. And the first thing that I'm going to drag onto the screen is going to be a label. So I'm going to click and select my label, and it tells you a little bit about what this component is and what it does. It presents read-only text, so you can't type into it, for example, you can't edit it. But this is exactly what we need, so we're going to click and drag it onto the screen. Now, when you drag things onto the screen, you see these little blue lines pop up. And these are called the guidelines. They help you position your elements. So for example, if I wanted it bang in the middle, then you can see that it shows up right here. Now drag it on somewhere close to the top third of the app and make sure that it's in the middle. And we're going to change what it says. Now remember, if we want to change something in our design, we first have to select it, and then we have to go into the Attribute Inspector, which is denoted by this symbol right here. And if you hover over them, they also tell you what they are. Inside the Attribute Inspector, we can get started changing our label. So the first thing I'm going to do is I'm going to change what it says. So I'm going to write, I am rich, and then hit enter for that to update the text in my label. And now let's change some other things about it. Let's change the color to white, which of course will make it disappear from the screen. So if you ever need to find it again, then the document outline is your best friend. And if you don't see this pane, then simply just click on the toggle right here to bring it out. So now that we've got our white text, which is also very small, let's go ahead and change its size. So we click on this T button right here, and we can change the font size to something a lot bigger, say size 40. And we can also change the style, so whether if it's bold or not bold. But if you want to change the font, you have to go in here and select Custom first before it comes up with this drop down for the font family. And you can change it to whichever font you prefer. Now I'm going to change it to the Helvetica Neue font, and I'm going to keep it as regular, but I'm going to make sure that the font size is 40. So we've got this label, which we can vaguely select by using the document outline, but we can't see it because it's white on white. So the next thing I want to do is to change the background color of my app. Now notice that in my document outline, I have my label, which I created just now, and it's sitting inside something called a view. Now the view is basically what you see in the background. And we can change it by, again, selecting it in the document outline and going to the attribute inspector. And here we can change its background. So let's go ahead and select a random background color. We can make it purple. Notice how that changes the background color, and now my white text is visible once more. So I can position it easily and I can select it easily on the canvas. Now, if you want a really specific color, then you can go to Custom, and if you go into the Slider tab and go to RGB sliders, then you can actually enter a custom hex color. So let's add my hex color that I want to use, which is 24495E, and I'm going to hit enter, and I get this nice sort of dark green blue color. Kind of indigo-ish, I would say. Now, one of the tools that I rely on quite heavily is something called Color Hunt. And it's a website where professional designers have curated some of their favorite color palettes. So let's say if I really like this particular palette, well then I can go ahead and click on this dark blue color, and it copies the hex code right there. And now I can go into my background, select my view, change the custom color by clicking on that custom, and then paste in that hex code right here. And now if I unselect the view, you can see it's now the color that I got from the tool. And if I want to have a matching color palette, then I'm going to copy this pink color and change my title to use a custom color. And I'm going to make sure I've got RGB slider selected so I can paste in my hex code. And now I have a beautiful color palette without any hard work at all. All I've done is just browsed for one that I really liked, and I started using the colors in that particular palette set. So this is a really easy way of making a really beautiful looking app without needing a lot of design knowledge. Now, if you want to undo anything that you've done, then simply just hold down Command and hit Z or Z, and as you keep going, you'll be able to revert to whichever stage you want to go back to. So that's a really neat trick if you just want to unwind the clock. So sometimes when you're working as an iOS developer, you might be working in a team, and in your team you might have somebody whose job is to design the canvas and the user interface. So you might have an app designer. And in those cases, you probably won't be able to just drag something around and just position it where you see fit. They might provide you with exact specifications for how it should look. So what do you do in that case? Well, let's say that I wanted this label to be 166 in width and 48 in height and a specific position. Then I would again select the label, and instead of going to the attribute inspector, I would go to the size inspector to change the position and these sizes. So let's say that I change the X position to 124, so move it to the right a little bit, and I change my Y position to 156, move it up a little bit, and I keep my width as it is, and I change the height to, let's say, 48. Right? So if your designer is giving you these precise positioning and sizing instructions, then you can change that inside this tab right here. But if you're building your own app, then of course you can place it wherever you like, in whatever position that pleases you. Now, the next thing we want to do is we want to be able to add a picture into our app. So to do that, we need to use a component from the object library called an image view. As a challenge, I want you to see if you can remember how to get pre-built components out of the object library and position it onto the screen. Once you've dragged and dropped it onto the screen, then I want you to give it a specific position. So the X position should be 72, the Y position should be 313, and change its size to have a width of 270 and a height of 270. Pause the video now and try to complete that challenge. Alright, so did you remember how to do that? Well, first things first, we have to be inside the main.storyboard, and we have to open up the object library by clicking on this button right here, and then we simply search for an item. So you can either scroll through this list to find the image view, or you can simply type in the search bar image view, and it will show up the component that we need. This component will show an image or a series of images as long as we drag and drop it onto our screen. Once it's on our screen, then we're going to change its position and its height and width. So the X position we said was 72, the Y position was 313, and then the width and height were both going to be 270. So now you should have a UI image view that's positioned on screen in the exact same location as what you see in this video, because we've used precise coordinates and width and height to achieve this effect. Now, if you're wondering, what does the 72 and 313 actually refer to, and how do you figure out that this position should be those values? Well, you don't have to wonder anymore. We're going to talk about how positioning works in Xcode. Let's say that we have a UI element that we've moved around on screen and we're happy with its position, and we want to be able to define this position in terms of coordinates, so an X and a Y. Well, you can imagine the iPhone screen as a graph, where the top left corner is 0, or the origin of the graph, and where the X-axis runs along the horizontal edge of the phone, and the Y-axis corresponds to the vertical edge. Now, on an iPhone 6, the width of the screen is 375, and the height is 667. If you want to know these values for different size screens, then I recommend taking a look at Paint & Code's Ultimate Guide to iPhone Resolutions, where you can see the sizes of the iPhone X, the iPhone XR, the 5 series, 6 series, the Plus series, and you can see their sizes defined as points. Now, why does it say point and not pixels? Well, as the resolution of the iPhones improved, they managed to cram more pixels into the same screen size. So, for example, when you take a look at the original iPhone 2G, 3G, then 320 points by 480 points is literally 320 by 480 pixels. But in the iPhone 4, they managed to double the amount of pixels crammed into the same screen size. So the screens are still the same, but now we have doubled the resolution to make the images much sharper. So the points simply refer to the sizes that you see in the app, and the pixels refers to essentially the number of light bulbs, if you will, in the screen. So the more light bulbs, the more detail you can get, and the sharper the image. But when we're talking about designing for iOS apps, we're always talking about the sizes in terms of points. So we know that our iPhone 6 has 375 points along the horizontal and 667 along the vertical. How can we define the position of this purple UI element? Well, we define the position by, again, the upper left corner of any element. So we know that the screen starts its origin at the top left corner, and the elements are positioned by their top left corner. So in this case, we would say run a line up to the x-axis, and we get to a point which is kind of halfway to 375. So let's say it's about 165 points on the x-axis, and then if we run a line to the y-axis, or the vertical, then you can see that from 0 down to 667, let's say this is about 75 points. Well, now we have our position for this element. It's x equals 165 and y equals 75. Pretty simple. Now, in the next lesson, we're actually going to use that image view that we put onto the screen, and we're going to learn how we can incorporate image assets into our Xcode project so that we can put a picture inside the image view. So for all of that and more, I'll see you on the next lesson. Now that we're done designing our app in Xcode, it's time to add an image into that image view. And we're going to do that by incorporating some of our own image assets. The first thing to know about an image view is to simply view it as a picture frame. It's a picture frame where you can put images into it. And this picture frame has lots of different properties, so things that you can change about it. For example, you could change the size of it, you could change the color of it, and most importantly, you can change the picture that goes inside. So if you select the image view in the document outline and head over to the Attribute Inspector tab here, then you can see all of these properties that we talked about. Say, for example, we could change the background of the image view, or, as you saw earlier on, we changed its width and height. But the one that we're really interested in is this image property. Now, you can see that it's expecting me to type the name of an image. But where do I get that image from? Well, if you take a look over here in the navigator pane, you can see that we've got a folder called assets.xcode assets. And if you click on it, you can see that it's completely blank at the moment. It has one template that is always there, which is the app icon template. And these are the slots for all of the app icon images that you need to provide. And we're going to look at that in the next lesson. We're going to be filling all of these up. But right now, what I want is to start adding some other image assets into this folder. Now, we've prepared some assets for you ahead of time already. So if you head over to appbury.co/p/iOS-course-resources, here you'll find all the links that you'll need during the course. And I recommend bookmarking it so you can get to it easily. I'll be referring to the course resources or the course links regularly during the course, and we'll try to post lots of links to this page to help you. But essentially, if you head over here and you click on where it says I am rich image assets, then it should automatically download a zipped file of all the image assets that we've created for you. So now if you go ahead and unzip that file, and once you open that folder, you should see a whole bunch of images. Now, some of these that are named icon are the ones that we're going to be using as the app icon for this I Am Rich app. And we're going to be dealing with that in the next lesson. But the one that we want is this one called diamond.png. And as you can see, it's just a simple image of a diamond that we're going to incorporate into the design of our app. So once you've got Xcode open, and if you either Command Tab or simply open up your Finder from the dock, then you can click and drag this image over here into your assets.exe assets folder. Now notice how as soon as you do that, it gets dropped in at the 1x position. What does that mean? What does it mean when it says 1x, 2x, and 3x? Now, you could think about it this way. Let's say we have a picture here of the settings icon in the app in iOS. Now, if I had blown that up to a gigantic size, then you can see that it's super pixelated and it's not very clear at all. So how can we make things look sharp on a screen? Well, if you had, say, a fixed number of pixels, say in this case we have 3 by 3 pixels, and each pixel can only have one color, right? So this one's a light blue, this one's a white, and we can try and represent a picture by changing the colors of each of these dots, kind of like a mosaic. But if we had double the number of pixels, say in this case instead of having a single tile we had 4 tiles, then we would be able to have far more fine-grained control over what the image looks like. And that means that it will look sharper to the human eye. So where do these 1x, 2x and 3x sizes come from? Well, let's imagine we have 3 boxes and they're each a centimeter by centimeter. Now, let's say in the first case it's a 1x image. Well, we only have 1 pixel, just one color square to represent it. Now, let's say that in the second image, we were able to use 4 squares to represent it. Well, we can now add a little bit more detail to our picture. You can see that there's a little white bit in the top right corner. And what if we went even further? We actually had 9 tiles. Well, you could see that this little white bit is actually not just a white bit. It's actually got a sort of shape associated with it. So this is how Apple managed to increase the screen resolution. If you remember almost 10 years ago when the Apple iPhones first came out, they had a 1x resolution and everything was super pixelated. You can even see the pixels with your human eyes. But then over many years and many iterations, we now have much fancier iPhones, including the X series as well as the Plus series. And now they've managed to cram 9 times as many pixels into the same space on the screen as they had before. So this means that the images are way sharper on the latest iPhones than the older ones. When we think back to this 1x, 2x and 3x images, well, the 3x image is actually 3 times as large as the 1x, and the 2x is 2 times as large. But if you have an image that's 3 times as large, that's then shrunken to 1/3 of its size, then it's obviously going to have smaller pixels and it's going to be sharper. So how do we create each of these image sizes? Well, you could start with an image that's, let's say, 300 by 300 pixels, and then you would save it as the 3x version, and then you would scale it down to 200 by 200 pixels, and save that as the 2x version, and then finally scale it down to 100 by 100 pixels, and that will be your 1x version. So if your 3x version is 300 by 300, then the maximum size that you can actually use it in your app is going to be 100 by 100. Because eventually what's going to happen is that the iPhone, depending on where it's being displayed, an iPhone 4 or an iPhone 5 or an iPhone 6 Plus, then it will scale down these 2 images. Both of these are going to be squeezed down to this size. So you can imagine that this one, which started out being super large, if it's squeezed into a smaller space, it's going to look a lot sharper than the one which only has 100 by 100 pixels to display. When you're creating assets for your app, you can either do this manually, or if you're using software such as Sketch or Illustrator, then you have existing tools that allow you to export images in their 1x, 2x and 3x sizes. Now, what if you don't have Sketch or Illustrator and you're not familiar with design software? Well, the simplest way of generating image assets is to simply use an online tool called App Icon Generator, and you can go to appicon.co, and this will be in the course resources as well as the link. And if you head over to image sets, then you can select your design base size. So ours only go up to 3x, so we're going to select that. And then we're going to select the platform that we need the images for, which is going to be iOS. So that's going to be 1x, 2x, 3x. So we can uncheck Android. And now all you have to do is, if we take our diamond.png as an example image, then we can just click and drag it and drop it onto the app icon generator and click generate. And now it's going to create a set of images that are already modified. So you can see this 1x is 67 kilobytes. The 2x is just a bit more than double its size, and the 3x is way, way bigger. So you can see these resolution differences. And the website has already scaled these down for us and added all those necessary prefixes. So now we can go back to Xcode. Let's delete our diamond image. And let's head over to those images that we just downloaded, and let's click and drop it into here. And Xcode is clever enough to take those postfixes at 2x, at 3x, and simply put them into the right slots. So we're now finally ready to use these assets. If we head back over to the main.storyboard, we can select our image view again. And here, when we get to select the image that's going to go in the image view, we can click the drop down and we can see that we've got the diamond image that comes from our project. So this is reading that folder here, the assets.exe assets. And if you have more images in there, then it will show you all the possibilities. So if you have loads of them, then you can also just simply search as well. And that makes it easier to narrow down on the one you want. So once we've selected diamond, then that goes right inside our image view. So the frame is obviously see-through and our image is now on screen. Brilliant. We're almost done. All we need to do now is just to add an app icon, and we're going to do that in the next lesson. So I'll see you there. Now we're really close to the home stretch. All that's left are the last two things. And in this lesson, we're going to learn how to design and create a custom app icon, which will display when we run our app. Now coming back to Xcode, the place where you would add the app icons is inside the folder assets.exe assets. And we already saw earlier that we have this blank template full of slots for all of our different app icons. Now, why are there so many different slots, you might ask? Well, they are used for different purposes. For example, you might have a certain size for the icon that gets shown when you get a notification. You might have one that's in the spotlight area. You might have one that's displayed on the iOS App Store. And if we're creating both iPad and iPhone apps, then there's also different dimensions. And the reason why we're providing lots of different dimensions rather than just a single large one and get the iPhone or the iPad to scale it down is because of speed. If while our app is running, it has to try and scale down to all of these different sizes, then it's going to make our app seem a lot slower than it could be. So that's why Apple wants us to create all of the assets and all the sizes that it needs so that it doesn't have to do any scaling to keep our app as fast as possible. Now, if you head back to that folder of images that you downloaded in the last lesson, you'll be able to find a whole bunch of icon images. And notice how we've actually named them with the 2x, 3x postfixes. So if you want, you can simply click and drag to select all of these icons and then drop them into the app icon slots. So it should automatically know where it needs to go because we provided all the size information in the naming of the icons. Now, sometimes though, it doesn't know where to place something. For example, this 1020 sized icon should actually be in the slot which needs a 1020 image. So you might have to manually adjust things occasionally. Now, notice how our iPad slots are missing. Now, here's a question. If you were creating your own app with your own app icons, how would you go about making all of these different size assets? Well, one of the easiest ways is using that website that we saw earlier on, App Icon Generator. And we previously saw that we could use their image set generator to create the 1x, 2x, 3x images and to scale it down automatically. But they also have an app icon feature, which is again free to use. So the way that this works is that you should start out with a large image size, and it should ideally be 1024 pixels by 1024. And then you can select all of the places that you want to use it, including iPhone, watch, or Android. So how do we generate the initial icon image? Well, if you already have a picture or something that can be scaled down to this size using a piece of design software, well, if you're familiar with design software such as Photoshop, Illustrator, Sketch, or anything that you want to create a app icon with, then you could use that to create your app icon. But the way that I'm going to show you today is probably one of the easiest to learn, and it's completely free to use and there's nothing to download. Head over to canva.com and go ahead and sign up. And once you've signed up, you should see a screen that looks like this. Now, they have a whole bunch of pre-sized templates. Say, for example, if you wanted to create a presentation or a Facebook cover or an Instagram post. But in our case, we're going to choose custom dimensions, and we're going to put in that dimension that we saw earlier on from the app icon generator, which is 1024 by 1024. And now that creates a blank square for us, ready to add in our design. Now, the cool thing about Canva is that they have a whole bunch of professionally designed templates where you can just simply switch out the picture or change the text. So, for example, if I just drop that in, then I can simply change these things and create my own design. But in our case, we actually want to create a app icon, so it's going to be completely different from what they've imagined. So these are pretty much just kind of like Instagram posts or some sort of blog titles or images. Instead, I'm going to go over to the elements, and I'm just going to start with some really simple shapes. So let's say that I had a circle, maybe, that I'm going to try and place in the center just by dragging it around. I'm going to change it to a nice, let's say a teal color. So we've now got a circle as our app icon, and you can choose from other things such as charts or different shapes, different gradients, lines, and a whole bunch of vector illustrations that you can pick from as well. But in my case, I'm going to keep it really simple. So I'm going to just add another shape, probably just a triangle, and I'm going to put this right over here and then make it cover just about half of the screen. And then I'm going to change this to a white color, and then I'm going to change the background to maybe something that's got an interesting gradient. And finally, for our diamond app, I'm just going to search for the word diamond and see if they have some nice free assets that I can use. So this one looks pretty good. So I'm going to put that in the middle, and then I'm going to scale it down a little bit and then center it. Now all I have to do is give my file a name. I'm going to call it Diamond App Icon, and then go ahead and click download to download it as a PNG. Click download, and it should only take just a little while for it to save. And now I can go back to my app icon generator, click and drop it here, and only check the ones that I want, which is the iPhone and iPad, and then click generate. And now I've got all of my app icons created. And once you've unzipped that file, you should end up with a folder called assets.exe assets. Now let me just switch over to this view so you can see all the levels that the folder contains. Inside that folder, there's something called appicon.appiconset, and inside that folder, there's all of the different sizes that our app icon needs to be. So notice how this folder is exactly the same as the name of our assets folder. Well, if we go ahead and right-click on our app icon and click on Show in Finder, you can see that it mimics exactly the same naming convention as what we have in Xcode. So in Xcode, our app icon set is saved inside a folder called appicon.appiconset. Inside there's a whole bunch of icons and a file called contents.json. Now, this file is the one that arranges each of these icons in their correct placeholders. And if you look at the folder that we downloaded from our app icon generator, it's also got a contents.json. So this means that if we replace this app icon folder with the one that we currently have, then we can have all of our images already placed in the right placeholders without any extra work on our part. So what I want you to do is to take the folder called appicon.appiconset from the assets folder that you downloaded, and then just click and drag into the same area where you've got the appicon.appiconset from Xcode. Now, once you let it go, it will ask you if you want to replace the existing app icon folder, and you're going to say yes, replace. And now, notice how we have all of our app icons already placed where they need to be. Now, there's just usually one extra one that's unassigned, which is what's creating the little warning here. So if you hit backspace, it will delete that and it'll get rid of that warning. We're finally done with our app and we're ready to run it and check it out. In the next lesson, I'll show you how to run the app on a simulator if you don't have a physical iPhone device. And then later on, I'll show you how to actually run it onto an iPhone or an iPad if you indeed have one. So for all of that and more, I'll see you on the next lesson. Alright guys, so now that we've built our app, we're finally ready to actually run the app. And running our app is the process where we turn our code into the actual app. And this is done using Xcode, of course. So there's two ways of running our app. Either we could run it onto a physical iPhone or iPad device, or we could use the Xcode simulator, which creates a simulated iOS device on our Mac. Let's first look at how to run on the simulator because it's really easy. All you have to do is to go up into this top left corner, click on the app name, and then in the drop-down list, you can select the simulator that you want to use. So the simulator device that you want to run your app on. Now, in my case, I'm going to choose the iPhone XR, and then all you have to do is just hit the play button. So just like iTunes, you can run by hitting the play button and hit the stop button to stop running the app. And you can watch as the progress happens up here, and once it's done, it should automatically open up the simulated device by itself. Now, the first time you run your app, it might take a while for the simulator to load up. It's just like cold starting your iPhone. But after the first time this happens, then using the same simulator device should take a couple of seconds for it to load up your app. So I fast forwarded the process a little bit, but it should take anywhere between 1 to 5 minutes for it to load up for the first time. And then once it's done, you should see a blank screen for a couple of seconds or more, and then it should display your actual app. And you can move the simulator around just by dragging on its name, and then if you hover around the edge, you can actually resize it to the size that you prefer. And you can even go to the hardware menu here and click on various things such as the home button or to rotate the app left and right. Now, at the moment, because we've designed our app on a iPhone 11 or an iPhone XR canvas, the diamond and the text is only going to look centered on devices with the same aspect ratio, so the XR, the 11, or the X. Now, in coming modules, we're going to learn how to make this right and set rules for our display. But for now, if you have a physical device that has a different aspect ratio, so you had one of the plus sizes, then you can actually just simply change the canvas right here in the size inspector, update the design, and then when you run it, it should look exactly as you see in the canvas. So now that we've seen how easy it is to run the app on the Xcode simulator, the next step is to run it on a physical iPhone. Now, if you don't have a physical iOS device, an iPhone or an iPad, then feel free to skip the rest of this lesson and continue on to the next module. But if you do have a physical device and you want to be able to see your app running on it, then continue ahead with me. Now, running on a physical device, because it has all of your sensitive pieces of data and a lot of personal information, it's a little bit harder than running it on the simulator. So there's a 6-step process that we're going to go through, and I'm going to run through it with you step by step. So the first step is to check that your Xcode and iOS versions match. Now, what do I mean by matching? Well, if you head over to Xcode and go to About Xcode, you should see the version of your Xcode, and currently I'm running 11.0. So for Xcode version 11.0, you'll know about iOS versions 13.0 and below. If you have a physical device that's running iOS 13.0, you're perfectly aligned with the Xcode version. Now, how can you find this information out? Well, it's easy as going to the settings and then general and about, and somewhere in this list you should see your software version. Now, I know I'm showing this to you on the simulator, but if you do the same on your iPhone or your iPad, it should be exactly the same process. So the easiest way is to update your Xcode and update your iPhone or iPad both to the latest versions, and then check that the number after the decimal place actually matches. And notice how Xcode 11 is the matching version for iOS 13. So if you had Xcode 10, then it won't know about iOS 13. So you'll have to update Xcode. But the easiest way of making sure that everything runs perfectly smoothly is checking that you have Xcode 11 and you have iOS 13. And that the number after the decimal place matches between your Xcode and your iOS. So that's step 1. Step 2 is you have to add an Apple developer account. Don't worry, you don't have to pay for this. You can simply just use your free Apple ID that you use to download apps on the App Store. Now, in order to do this, you can go into Xcode and click on Preferences. And then here, you should be able to add a Apple ID by clicking on the Add button. Select Apple ID, and then here, enter your Apple ID, which is usually an email, and then your password. And once you've successfully logged in, you should be able to see your App ID show up right here inside the Accounts tab. So now that we've added our Apple developer account, it's time to sign our app. So back inside Xcode, make sure that you've got your project IamRich selected and your IamRich target selected, and then head over to Signing and Capabilities tab and make sure that the automatically managed signing checkbox is checked. Now click on the team drop-down list and then select the account that you've added just now, or if you have a developer account like I do, then you'll see your team's name or your company name in there. Now, if you don't see anything in here, you only see none, then make sure that you've actually added your account successfully and that you see it underneath here as an Apple ID. So once you've selected your team, all the errors on this page should go away. But if it doesn't, and you see an error that looks like this, something about failed to create provisioning profile, then it might be because you haven't got your device connected using a USB cable. So just continue on and watch the next step of the video. And then you'll be able to click on this Try Again button here, and the errors should go away. Now just remember that we've also created that side-loading troubleshooting PDF guide, which you can download from the previous lesson, so that if you encounter any issues with side-loading your app onto your physical device, then you'll be able to refer to that and resolve any problems there. And we should now be ready to actually connect our device. So we'll do steps 4 and 5 together. Grab your USB cable and connect your physical device, your iPhone or your iPad, to your Mac. Now at this point, you might see a pop-up show up on your phone, which asks you whether if you trust this computer. So go ahead and tap on the Trust button. And it might also require you to type in the phone device passkey and follow the on-screen instructions to complete that process. Now that you've successfully connected your device and trusted your own computer, it's time to run your app. So go ahead and click on the top bar here and select your physical phone as the device that you want to run your app onto. Now you might get a warning here saying something like device iOS version lower than deployment target, something along those lines, and that's just because you need to update your iPhone or your iPad to the latest version of iOS that's compatible with Xcode, which we talked about earlier on. But once you've got your device selected, then go ahead and hit the play button to run your app. And at this point, you might see a message like this: iPhone is busy preparing debugger support. You'll probably see this the very first time you connect your phone and after every major iOS update. What's happening is that your phone has to tell your computer all about itself, like what kind of hardware it's running and its crash logs, amongst other things. I've seen this take anywhere between 2 and 15 minutes, so you might just have to be a little bit patient. At some point, it'll all be done and the window will disappear. You should then see the app open up automatically on your phone, and it's really important that you let Xcode always automatically open the app. Even if you see the icon, as I do right here, if you tap on it, it usually means that you're actually opening a slightly older version. It's always best to wait for Xcode to do its thing. Now, if when you run your app and the end result looks a little bit crooked like this, then it might be because you've got a different screen size compared to the one on your canvas. So here, my design is created on an iPhone 11 canvas, but I'm running it on an iPhone SE. So say if you had a physical iPhone SE or an iPhone 4 or something that basically has a different aspect ratio to your canvas, then the end result of your design will look a little bit weird like this. So in later lessons, we're going to be learning about something called auto layout and setting constraints, where we're going to fix this so that our designs always look the way we want, no matter which screen size it's being run on. But meanwhile, if you want to fix this and you want it to look good on your physical device, then you can simply go and change the device to match the device that you actually own. So for example, if you wanted to run this on an iPhone SE, then we could change that and then we can update the locations of our label and our image view so that when we run it on our device again, it ends up looking the same as the canvas, like this. So now that you've set up your device and Xcode for running your apps onto your physical device, the next time you need to run it, you don't have to repeat this process. All you have to do is to plug it in, select it, and then hit run. And it's much, much easier from now on. Now, so far I've shown you how to run your app from your computer if you have a wired connection, but you can also run it wirelessly. So I'm going to quickly show you how to do this. To start off, you need your phone to be connected to your Mac with a wire. We first have to use a USB cable and get the wireless side loading set up first. Once you've got it plugged in and you can see it as a device right here, then go ahead and go to Window and Devices and Simulators. And you should see your connected device right here. If you don't, make sure that you repeat the previous process that we've gone through in order to make sure that it shows up here. And then we're going to go ahead and click the Connect via Network checkbox. Now, it's really important that for this to work, your phone and your Mac has to be connected to the same Wi-Fi connection. So not only does your Wi-Fi have to be on, both on your Mac and your phone, but you have to be using the same Wi-Fi. But now, once that's done, you can unplug your phone, and you'll see that you can still find your phone up here in the devices. And now if you hit run, it will be able to run it wirelessly across the internet and show up on your phone. Now, I'm not sure what your experience will be, but for me, I find that the wireless connection tends to be a little bit unreliable. So when I've got a cable with me, I'll always run my phone via the cable. And that way I have a much smoother experience when I'm testing my apps. So that's it. That's how you can run your app on a simulator, on a physical device, and even wirelessly. I hope you had fun doing that. And if you had any issues, be sure to rewatch the video because there were quite a few hoops that you need to jump through before Apple's going to let you through the gates and allow you to get side loading set up properly. Now, once you're done, head over to the next lesson and I've got a challenge for you.
Subscribe now and press the bell icon. Never miss an update.
Now, up until this point, we've only built apps that display an image or a layout, but we haven't yet built anything that has any functionality. That's what we're going to do in this module. And by the end, we'll build a beautiful dice app where we can hit the roll button to be able to change the dice faces randomly. So if you're ever on the move and you need to settle a score with somebody or bet on something or play a board game, this will be the app that you'll reach for in your pocket. So how do we go from a display-only app where we're displaying a design to something that has user interaction? How can we have an app where there's a button and we detect when a user actually taps on the button to translate that action into some sort of change in the app? Say, changing the background color or some sort of property of a user interface element on the screen. Well, that's exactly what we're going to tackle in this module. And in the process, we're going to look at all of these things. We're going to see how we can clone an existing project from GitHub so we can learn and use one of the most useful tools that developers rely on, which is GitHub. And then we're going to spend some time designing our user interface of the Dicey app, as well as learning how to change the UI elements such as buttons or images programmatically using code, as well as detecting when a user interacts with those UI elements and respond to it with our code. Finally, we're going to learn some new Swift concepts. So we're going to talk about variables, constants, arrays, printing, commenting, and a whole lot more of Swift theory. And finally, we're going to talk about randomization, how it works, and how we can use it to create our random dice faces. For all of that and more, head into this module and we'll get started straight away. Alright, so the first thing that we're going to do is we're going to clone an existing Xcode project from GitHub. Now, firstly, what is GitHub? Well, it's a really popular service that developers use to upload their code, to be able to share their code with other developers and also manage their programming projects. If you head over to github.com, you can find out a bit more about what it does. And the reason we're using it is because you now know how to create image assets, drag and drop them into your assets folder. We want to spend more time learning and less time doing rote tasks. So we've done all of those things for you already. We've created the image assets, we've added it into a skeleton Xcode project. Now for you to be able to get access to it, we're going to share it with you using GitHub. And GitHub is one of mine and probably loads of other developers' favorite tools. And it was recently acquired by Microsoft for over $7 billion. That just goes to show just how important it is to the development community. So how do we get access to the skeleton project? Well, as always, it's going to be a trip to the iOS course resources, which hopefully you've already got bookmarked. And if you head over to the Dicey module, and then go ahead and click on the Dicey starting project, then it will take you to a page on GitHub which hosts the starting file. So this is what it looks like. And you can read a little bit about our goal, what we'll create, what you'll learn. But the most important part is the code that's in here. And the code is spread out over a number of folders, and these are the folders that you've already seen in your previous Xcode projects, but we don't want to share a single file by file. We don't want to use things like Dropbox to share these things because code changes constantly, and this is one of the most efficient tools of managing that complexity. So how do we clone an existing project? So we've got this iOS 13 Dicey starting project. I want you to go ahead and click on this clone or download button, and then you can click on this button which copies the link to this project. Now note that this link is not the same as this. This refers to the actual project, whereas this is the page where the project is hosted on. So if we go ahead and copy that, then we can go back into Xcode. If you have any projects that are currently open in Xcode, I recommend you to go ahead and close them all down by clicking on this button. Don't worry, everything in Xcode is automatically saved every few seconds, so you don't even have to hit save for that to happen. It's very rare that you end up losing work in Xcode. Once that's closed, then I want you to head over to Source Control and click on Clone. Alternatively, if you've just opened up Xcode and you see the welcome screen, then you'd also click on this Clone an Existing Project link as well. So both of these buttons do exactly the same thing. They take you to a place which allows you to paste that URL that you copied over just now into the search bar. Now, don't worry if you don't see anything in here in this window. This is because I have a GitHub account and it's logged in and tracking all the things that I've viewed and used. But you don't even need to sign up to GitHub or have a GitHub account to be able to clone these projects. You simply need to paste that link you got from over here and then click Clone. And it will take anywhere from a few seconds to a few minutes, depending on your network connection, for it to be able to download that project file. Now it's going to ask you to choose where you want to save it, and I'm going to put it inside my development folder, inside desktop, just as I've done previously. And I'm going to save it as the same name as the original file, which is Dicey iOS 13. But feel free to modify this as you wish. You can delete the iOS 13 or change its name if you want. Just know where you've saved it and what you've called it so you can find it later on. So now click Clone, and once it's done cloning, you should see the Dicey starting project. This is the README that you saw previously on GitHub, and in the project navigator you can see all of our familiar files. If you take a look inside main storyboard, you'll be pleased to discover that there's absolutely nothing that we've done here for you. I think it's still a good idea at this stage to practice creating more of the user interface. But if you have a look inside the assets folder, you can see we've already created all of the app icons and all of the various image files. So you don't have to download anything or drop it in either. If you take a look inside the launch screen, we've already created a launch screen. So if you run the app as it is, you'll see the launch screen briefly flash up for a moment. Remember, this is a place where you normally have your company logo or your game development studio name, whatever it may be, or your own name, in fact, or maybe an inspirational quote. But it simply shows up for a few seconds. And there it is, you saw it for a flash, and now it's launched the main.storyboard, which is of course a blank screen. Now you are ready to get started and work on this skeleton project without having to download image files, drag and drop them in, and we can spend more time learning about the meat of iOS development. For the final part of this lesson, let me show you the true power of being able to clone projects from GitHub, because you'll be using it for more than just cloning the skeleton project and checking out the completed code. There are loads of other cool open source projects that you can clone and run. So for example, if you search for open source iOS apps in GitHub, you'll find lists such as this one, where, for example, you can find the Firefox iOS app, which is built in Swift. So this is the actual Firefox app, and it's obviously very, very complicated for where we are right now, but there's also some other cool projects too. And as you develop your skills in Swift, you'll be able to use these projects to inspire you and to be able to see how other people code. Now, one of my favorite projects is the Flappy Bird that's implemented in Swift. Here's a challenge for you. I want you to clone this Flappy Swift project to your local Xcode and to run the app to be able to play Flappy Bird in the simulator or on an iOS device. So you should already know how to do all of this. So go ahead, complete the challenge and have some fun. So that's going to be super simple. We're going to copy the link, and then we're going to go into Xcode and we're going to clone this project right here. And I'm going to hit clone, and then I'm going to simply save it in my downloads because I'm not going to keep it around for very long. And once it's done, I'm simply going to run it in my simulator, and I recommend to only run it on the simulator. Because if you want to run it on a physical device, then you'll have to go into sign-in capabilities, choose your team, and also change the bundle identifier to something completely unique so that it doesn't correspond to anybody else's version of this app. But again, this code came from the internet, so I recommend to only run it on the simulator instead of an actual device. So now I've got Flappy Bird running, and you can play a version of Flappy Bird. Now, I'm really bad at Flappy Bird, so this is going to be a really short demo of my gameplay. But if you want to explore more open source iOS apps, there's a really good collection on GitHub by this guy, D.K. Hamsing. Not sure how that's pronounced, but if you scroll down, you can see there's loads and loads of different things that they've collected for different platforms, say Apple TV or Apple Watch projects, and this is a really fun place to browse through, clone, and as we get more skilled with iOS, we'll be able to understand more of the code that's in these sample projects and be able to learn from them as well. That's all for this lesson. In the next lesson, we're going to continue building out our Dicey app, and we're going to be designing the user interface. So for all of that and more, I'll see you there. Must get better at Flappy Bird. Okay, I'm still not any good at this game, but what I do know about is how to create apps. So now that we've cloned our starting project, we're ready to continue building it out. So if we head into our main.storyboard, we can get started building out the user interface. So I'm going to zoom out a little bit so I can see my entire view controller. And the first thing we're going to do is we're going to grab an image view to cover the entire area of the app so that we give our app a background image. As previously, we're going to go to the object library up here and we're going to search for an image view. Now, again, you can scroll through if you want, or you can simply just search for it. But we're going to place it in the top right corner, and we're going to drag the toggles so that it fills the entire screen. So now we have a image view which is going to act as the background, and in order to add an image into it, we of course have to change one of its properties. If you navigate into the assets.exe assets folder, you can see we've already got this green background set up for you with the 1x, 2x and 3x images. So we want to place this as our background for our app. In order to do that, we of course have to select our image view, head over to our attribute inspector on the right, and we're going to change one of its properties. We're not going to change its background color or anything else, but we want to change the image that's displayed in there. Given that we know our image is called green background, I can start typing for it and it filters through all the possibilities until it lands on the one I want. Alternatively, in our case, given that we don't have all that many to choose from, you can simply click the drop down button and find the one that we want. Now, when I first put that image in, you can see that it's not taking up the entire space that's available. In fact, because the original image that we have is a square, so it's a 1:1 aspect ratio image, well, it's going to display itself like this because we have the content mode set to aspect fit. So again, this is a property of the image view. And if we want to get the image to cover the entire area, well, then we're either going to have to stretch it in the vertical axis, or we're going to have to increase the size of this so much so that it becomes a square that's about this large, so that it covers the entire screen. Now, what's the difference between those two approaches? Well, let's see. So firstly, if we choose scale to fill, it will stretch the image up and down until it fills the entire area, which doesn't look so bad actually. But notice that if you zoom in, you can see that it looks a little bit stretched. Now, this background was sort of meant to evoke a sort of felt-ish kind of material, like the material that you get in the sort of casino tables because we have a dice rolling app. But it's now being stretched, and in this case it's actually not so obvious, but let's have something that has a little bit of text, say this one. You can see clearly when this image is scaled to fill, it looks really weird and awful. So the other option that we have is the aspect fill. Now this keeps the aspect ratio of the image while scaling it to fit the entire image view. If we go back to our green background image, then you can see in this case the felt stays as it is without changing its proportions. Essentially, these are the top 3 choices that we'll be choosing from in pretty much all cases. Aspect fit, where we keep the aspect ratio and make sure the entire image is visible. Scale to fill, which scales the image so that it fills the entire image view. And aspect fill, where it fills the entire image view but keeps the aspect ratio of the image intact. So depending on the effect that you're going for, you might want to choose one of those. And in this case, it really doesn't matter whether if you choose scale to fill or aspect to fill. As long as the entire background is covered, then it's good enough. Alright, so the next thing we want to do is we want to be able to place that image, the Dicey logo, somewhere near the top of the app. So as a challenge, I want you to head into the object library and use an image view to put that logo into the upper third of the app. So pause the video and try that now. Okay, so this is going to be pretty easy. We're going to press the plus button and either search or scroll to find an image view and drag it onto the screen. And then in the image property setting for this image view, I'm going to change it to that Dicey logo image. Brilliant. So now we have our logo inside an image view near the upper third of our app. The next challenge is to put the first dice 1, to show up somewhere near the middle of the app on the left, and I want you to change its size so that it's 120 by 120 points. So it should be a square roughly about this size. Pause the video and give that a go. Okay, so again, as before, we need an image view to display an image. And we're going to choose the image that is the Dice 1 image. So that's gone in there, but our image view at the moment is a rectangle. So I want to be able to change the size of it. And we did this in the last module by going to the size inspector. Whenever you need to change anything about a user interface element, it's going to be somewhere in the right-hand pane. And you might just have to click through some of the different tabs to see what they each do before you get familiar with where to find the exact thing to change. Here we're going to change the width to 120 by 120 so that we have our perfectly square image view. And we're going to place it somewhere in the middle of our app. Now, the next thing I want to do is, because I want to have a 2 dice app, I want a copy of pretty much exactly the same thing as this. I want an image view with the dice in it with 120 by 120 in terms of its size. Now, I don't want to go through the entire process of replicating that. So what can I do? Well, a really simple trick in Xcode is if you hold down the Option or the Alt key and then you click on this element and drag, and then be sure to let go of your mouse before you let go of the Option key, then you end up with a perfect copy of the previous element. And you can do this lots of times. So for example, if I select both of these that I've just created and I do the same trick again, then I end up with 4, and then I can end up with 8, and you can quickly create lots and lots of copies of the same thing if that's what you need. The last thing we're going to do for our design is we're going to add a button to our screen. Similar to before, we go to our object library and we try and search for a button. And then we simply drag and drop it onto the screen somewhere near the middle, and we're going to change a number of properties for that button. For example, I might want to change the title of the button, which is under the title property, and I'm going to call it roll, because this is going to be the button that the user is going to click on when they want to roll the dice. I'm just going to make it a little bit bigger so it's easier to see for you. And of course that also means changing the font size. So we're going to click on that T button and change the font size to, let's say, maybe a 30-point font. That should be large enough to see. Now I'm going to change the text color to white, and finally maybe change the button's background color. Now feel free to choose whatever color you like, but here's a cool trick. Now often with design, it's good to have a consistent color theme. So if we wanted the background for our button to be exactly the same color as the background of our dice faces, then we can go to custom and then use the color dropper tool to simply select that color. And then that becomes the background of our button. So it all looks very, very coherent and very well put together. And we're now ready to move on to the next step to actually use code to change the properties of our user interface elements. Instead of using the attribute inspector and changing it manually by clicking around, we're going to use our viewcontroller.swift to automatically do that for us by running some code. For all of that and more, I'll see you on the next lesson. Alright, so now that we've completed designing our user interface, we're finally ready to start doing some programming. And we're going to be writing some code to allow us to change some of the properties of those user interface elements that we've added earlier on. Now, we already know that when we select any of these user interface elements, such as these image views or the button, we can head over to the attribute inspector and change its properties. So, for example, if I wanted this leftmost image view to show the dice 2 image rather than the dice 1 image, all I have to do is to select the user interface element that I want to change, which is this one right here. And then I can simply type a different image. So, for example, I want it to show dice 2. Well, then I would tell it that the image for this image view should be dice 2 instead of dice 1. But if you imagine that our app is already running on a user's iPhone, say a million miles away, because they downloaded it from the App Store, we can't then get a copy of their app and change it in Xcode and then send them the new version, right? This doesn't work. So in our main.storyboard, we're essentially designing all the components that need to be on the screen. And while we're designing it, we're able to change a lot of these properties. But if we need to change these properties on the fly while the app is running, then we're going to have to resort to code. So let's change this back to our dice 1. And let's figure out how we can do exactly the same thing, but using only our code. So firstly, our code file is going to be this one, the viewcontroller.swift. And when you create any Xcode project, it always comes with some template code for you to get started with. Now, notice how these are actually two completely separate files. The viewcontroller.swift is our code file, and the main.storyboard is our design file. Now, given that we can only write our code in this viewcontroller file, how can we access the components in the main.storyboard file? Well, here's where something called the assistant editor comes in handy. So if you open up the main.storyboard and head over to the right corner, here you see a number of lines, and we can adjust the editor options. So if you click on it, you can go ahead and select the assistant view. What this means is that we have our design file on the left. So if you take a look up here, you can see that we're inside the Dicey iOS 13 project and inside the main.storyboard file. But on the right here, you can see that it's automatically figured out that the companion code file is the viewcontroller.swift file. So that's what's showing on the right. In order for us to be able to refer to specific user interface elements in our design file, we have to create something that's called a IB outlet, or an interface builder outlet. So this main.storyboard is also known as the interface builder, because we're using it to build the user interface. And so in order to create our IB outlet, all we have to do is to hold down the control button on our keyboard, not the command button, and then we're going to click on the image view, dice 1, and then we're going to drag it over to our code file. Now, make sure that you don't let go until you're ready to drop it. And the place where we want to put it is just below this class view controller on line 11 and before this override function view did load. So anywhere between 11 and 13. And then we're going to let go and we get a pop-up asking us what name we should give this connection. Now, this is going to be the name that we'll use in our code file to refer to this specific image view. I'm going to call it the Dice Image View 1. Now, notice the way that I've named this. I've started with a word that is completely lowercase, and then every subsequent word has the first letter capitalized. Now, why do we do this? This is a really easy way of being able to see where each word ends and the next one begins. And you'll see this pretty much commonly across all programming languages, not just in Swift. So if we go ahead and click Connect, then you'll see that we've created an interface builder outlet. So it's a way for us to be able to access this particular user interface element by referring to the name that we gave it, which is Dice Image View 1. Now, this particular way of naming things is called camel casing in programming. Think about a camel and its humps. Then you might be able to, with a lot of imagination, see that the first word should be lowercase and every subsequent word is a hump, so it needs to be capitalized. This means that programmers can avoid those situations like those long Twitter hashtags where you can't really tell what it says because all the words are lowercase and you don't know where it starts and where it ends. And similarly, for stationary websites, which are called Pen Island, you will have less issues if you were able to keep it camel-cased. So coming back to these connections created from the design file to the code file, or these interface builder connections like this one that we just created, they are a really common source of errors, especially for beginners. So let's say that we've created this IP outlet, and at some point I've decided, you know what, actually I've made a typo, and now I want to make it read Dice Image View 1, but instead of 1 I want to use the actual word. So now I'm looking at my code and it looks great and there's no errors, but when I actually run my app right now, you'll see that your app will crash, and this is what it looks like. It'll say something like signal sigbot, and down here you'll get a whole bunch of stuff being outputted, but if you scroll right to the top it says terminating app because of this reason, and the reason is because something is not key value coding compliant for the key Dice Image View 1. So looking at this clue, we should be reminded that previously we had something in here called Dice Image View 1 with that number at the end, but we changed it, right, in the code. Now, what you don't know is that behind the scenes, when we create each of these outlets, there's actually code that's being written in the main.storyboard, and you can view it by right-clicking and opening as source code. So if we scroll right to the bottom, you can see that one of the connections has a reference to something called Dice Image View 1, so that old spelling there. And because we changed it here, it can no longer find it inside this file, which is why your app crashes with this particular error code. So I recommend getting really used to seeing this particular type of error when your app crashes and looking at what it is that it has a problem with. So when you do have this issue, then what you want to do is to simply right-click and just delete this connection. And now, when you run your app, even though this connection is now broken, it won't crash. You can relink it by simply starting from the circle and pointing it back to the element you want to link it to. But in the future, if you actually want to rename one of these outlets, or anything else you name for that matter, the best way is to simply right-click on it, and if you're new to Mac, that means holding down the Control key on your keyboard and clicking on this, and then go to Refactor Rename. And in this case, it's going to pick up all of the places where this word is used, including the main.storyboard as well as the viewcontroller.swift. And now, if you rename it, it will make the changes everywhere where this name is used. So now when you click rename, then you've done it safely, and when you run your app, it won't crash. So just keep in mind this point when you encounter these problems. And remember that when your app crashes, you can always scroll to the very top of the debug area and look at what the reason is. The most useful parts are at the top here. And here it tells you this particular reason. So when you look at the reason, you can exclude all the parts that are unique to your app, for example, the name of your app and the particular instance, etc., and look at the message. So it says something about this class is not key value coding compliant for this key. Now this is the same message that it's going to tell everybody that has this problem. So if you go ahead and just copy it and paste it into Google, then you'll find that other people have encountered the same problem, in fact more than 1,000 people, and you'll see people's explanations and solutions for how to solve these problems. Coming back to our code, we've got this line of code that's been written automatically by Xcode when we simply control dragged and dropped it inside our code file, linking the two files together. When you hover over this little circle, you can see that it's now highlighting the particular element that's actually linked to this particular name. So we can now use this name and change the properties of this particular image view. And the place where we're going to do it is inside the curly braces of this thing called viewDidLoad. Now this is what we would call a block of code. And it's essentially a bunch of lines of code. Say currently it's got 2 lines of code inside the block, and they're all going to be activated depending on a condition. Well, in this case, the condition is when the view loads up, so when your app first shows up on the phone. And what we want to do is we want to change one of the properties of this dice image view 1 when the view loads up. So right now you can see that in our design we've got the first dice image showing up, so dice1.png, but I want to be able to show, say, dice 6 as soon as my app loads up. In order to do that, I can use the dot notation. The way that we would write our code is who needs to be changed, dot, what property about this thing needs to change, and finally, after an equal sign, we set the new value, so what it should be changed to. So let's try and apply this. In this case, the who is going to be the dice image view 1, so this one right here. And so we're going to type dice image view 1. And you can see that as soon as I start typing, Xcode is going to search through all the possibilities and bring the most likely possibilities up to the top. And indeed, this is exactly the one I wanted to type. So now you can hit either the tab key or the enter key for it to insert automatically. And it's a really good idea to use auto-completion with Xcode, because it means that you don't make silly mistakes like typos where you have a V here or you have an O here. And another way to tell if you've made a typo is that when you have an actual piece of code that is recognizable by Xcode, it gets highlighted in a different color once you finish typing it. In this case, it's this sort of dark sea green. But if you make a typo, say I had a lowercase v instead of uppercase v, it doesn't know what it is. And it will give you an error telling you use of unresolved identifier, which means I have never seen this thing. I don't know what you're talking about. Check your spelling. So that's another potential downfall that you can avoid by simply using autocomplete. Now we've got the who we want to change, and then we add a dot and we tell it what we want to change about this thing. And in fact, as soon as you write the dot, Xcode actually gives you a whole bunch of things that you can choose from to change, so all the possibilities, but it's a little bit overwhelming. The easier way to do this is to pop open the attribute inspector again and select the element that we want to change, that image view, and then just simply look at the names of all the properties. So you've got this thing called image, you've got this thing called content mode or alpha or background, and we can use that name here as well as the what. So the what that we want to change in this case is actually that image property. So after the dot, I'm simply going to write image. And you can see that Xcode also tells me that this is perfectly legal. There is indeed something called image I can change. And down here, it gives you a brief description of what it will do. So by setting this image property, I will change the image displayed in the image view, which sounds pretty much exactly like what we want to do, right? And if I scroll around, then you can see that for each of these different properties, it tells me what it will do when I try to change it. But I want to change the image. Now I've got the who I want to change, After the dot, I've got the what I want to change, and finally I'm going to add an equal sign and tell it what is the value. What do I want to change it to? So in my case, I want to change it to the dice 6 image. So this one right here. Now, how can I tell it to change it to that image? Well, there's something really handy called an image literal, and that allows us to define the actual literal image that we want to set as the value of this image view. I'm going to start typing, and I'm going to write image literal, so all one word, and you can see that we've got the image literal being suggested to us. Once that's highlighted, either you can double click on it or you can simply toggle around and hit enter, and now we have a little image that we can select. So if you double click on it, then it pops up with all the possibilities that you can choose from, and I'm going to select the 6th dice to put in there. So now we've set the who, the what, and finally the value. And if I run my app right now, once my view loads up, this block of code will trigger, and one of the instructions in that block is to change my dice image view 1, this one, its image property, to dice 6. And you can see that as soon as my app launches, that's exactly what it does. And even though the first dice is shown in our design, but in fact, when our app launches, we see dice 6 because we changed it in our code. Now, another important thing to highlight at this point is what we mean by a block of code, or when I say write something inside a particular block of code. What does it mean to be inside? So here we have the same view did load, and you can see that in between these curly braces, this is where the code will go. So it's a case of when the view loads up, then trigger all the code in between the curly braces. But often you will have lots of lines of code, and it gets a bit confusing if we had to extend it really far out this way to keep it all on one line. So often the formatting you'll see in any programming language is something like this, where you have the block of code enclosed again by curly braces, but the curly braces are now split across multiple lines. But notice that when the brace faces right, that's the opening part, that's the start of the block, and when you see a curly brace facing left, then that's the end of the block of code. And everything in between these two curly braces are the code that will be triggered. And in Xcode, there's 2 really helpful tips. One is if you find the closing brace and you just go left and right on it, it will flash to you where the corresponding open brace is. Alternatively, if you double click on the closing brace, it'll actually highlight the entire block. So these are all the lines of code that will be triggered when the view loads up. Now, don't worry too much about some of these other keywords for now, like weak or override or super. We're going to go through them when we have enough knowledge to understand what they do. But all that we need to know right now is this particular block of code will trigger when the view loads up, and we can add as many lines of code as we want into the block in order for the code to happen when the view loads up. So currently, we're just setting the image of the image view. So here's a challenge. I want you to change the alpha property of this image view. So if we go into the attribute inspector after we select this particular image view, and I go to the alpha section, this refers to the transparency. So 1 means it's completely opaque, and 0 means it's completely transparent. I want you to set it to 0.5, so half transparency. How can you do this but not using the attribute inspector? By using the code. So keeping in mind the who.what equals value format, and keeping in mind what particular property we want to change, try and complete this challenge. If you have managed to successfully complete the challenge, you should be able to see that left-sided image view dim to about half its original opacity, at least compared to the right side, as soon as you launch the app. But in the main.storyboard, you should still see it fully opaque, and the alpha property should still be 1. So it's all dependent on your code. Now, I recommend giving these challenges a real good try because these are the moments where you learn. It's not watching tutorials, it's actually giving it a go yourself. But once you're done, and if you want to check your solution against mine, then head over to the course links and there will be a link to a solution file on GitHub. And you can scroll through it to see the actual solution and compare it against yours. The next challenge is to set the image of the right-sided dice view by creating an IB outlet called Dice Image View 2. Try and think about what you learned in this lesson and change this image to dice 2, the second dice image, which is this one, when it loads up, but make sure it still shows dice 1 in your main.storyboard, and it's only when you run the app does it change that to dice 2. And apply what you learn about the who.what equals value equation and see if you can complete this challenge. And here's the solution. Just as before, we're going to hold down Control and click and drag to underneath the previous line, and we're going to give this one the same name other than the final number, which is Dice Image View 2. And we're going to click Connect. So now we have a reference to that right-sided image view as well as the left. And when our view loads up, we can also tap into the right side, so the Dice Image View 2, and change its image. And we're going to change it to another image literal, but this time we're going to double click and select the Dice 2 image. So now when I run my app, I'm expecting the left one to show the Dice 6, right one to show dice 2, and that's exactly what I see. Perfect. While you're learning, it might be helpful to write some comments for your future self, in case you take a break and you come back to your code a month later and all of this starts looking like it's a foreign language again, even though right now you know exactly what's going on. The way that programmers do this is through commenting. So we would write 2 forward slashes, and notice how everything I type now will become grayed out, so not interpreted as code. And this allows us to leave notes for our future self or for other people who we're collaborating with. So for example, I might say that an IB outlet allows me to reference a UI element, and then maybe down here I'll write something like this is the who, and then this is the what, and this is the value. This really depends on you. From person to person, people leave different comments, but a well-commented piece of code might make the code look a bit longer, but it does mean that it's easier to understand exactly what's going on without having to spend a lot of brain power trying to piece it together. Feel free to leave comments to yourself as you go along, but in order to keep the code not overflow, given that I've got such a large font size, I'm actually going to delete these and change all of that back. And we've now learned about changing things in our user interface programmatically. In the next lesson, we're going to look at how we can detect user interaction and respond to it appropriately. For all of that and more, I'll see you on the next lesson. So in the last lesson, we looked at how we can change these UI elements and their properties programmatically by creating an IB outlet, which gives us a reference to that particular thing, be it an image view or a button or a label, and then we can use our code to actually change its value. Now, in this lesson, we're going to look more closely at how can we do it the other way. How can we detect user interaction on the screen and then respond to it in our code? Notice currently on our screen we have 4 UI elements. We have a logo, which is an image view. We have 2 dice image views, which are already linked up through IB outlets. And finally, we have a button, which is the roll button. Now, given that we need to change the appearance of these 2 image views, we need that reference or that IB outlet to be able to grab hold of the correct image view and then set its image using code. But with our button, we actually don't need to change it at all. We don't want to change its background or its text or its appearance. So we don't actually need an IB outlet. But what we need instead is a way to detect user interaction with this particular UI element, and then for our code to do something when it detects that. So to achieve this, we have to create a different kind of link. But the process is pretty similar. We hold down the control button, click and drag, and I'm actually going to drop it right here, just above that final curly brace. And when I let go, notice that the connection type is usually automatically selected as an action. Now, this is because this roll button is a button, so the natural way of interacting with it, or the natural connection you would want to create, is an action. We're going to leave it as it is, but if you needed to change the appearance of that button, you could also change it to an outlet, which would be very similar to these two. Now, the next thing we have to add is the name for this button. And whereas previously our IB outlet describes the UI element, so the dice image view 1 or the left dice image view, whatever it may be, in this case we're actually describing the action. And notice that this action is going to be triggered by a particular event. And there's loads of different events, but the most commonly needed one is touch up inside. Now, there's nothing naughty about touch up inside. All it means is that the user's finger fell within the boundary of this button and they lifted up their finger while they're inside the boundary. So it basically is describing a common tap gesture, just in a lot of words. The name that we want to give this action is something that describes the trigger. So in this case, I'm going to call it roll button pressed to describe the fact that it was tapped or it was pressed. And finally, I'm going to change the type of thing that triggered the action. So if you click on the drop-down list, you can see that we can select that it was a button that triggered this particular action. So now we're going to leave the rest of them as they are, and we're going to click connect. Now, notice that this time, the code that gets generated is pretty different. It's no longer an IB outlet. It's instead an IB action, an interface builder action. So it's a bit of code that will be triggered when an action occurs on this particular user interface element. So in this case, what should happen is whatever we write in between these curly braces. So here's the block of code that we can define so that we trigger something, for example, a change in our image views. We can test this out using something called a print statement. And you can create one of these by simply writing print, and then inside some round brackets or some parentheses, you put down whatever it is that you want to print. In this case, I'm going to print some text which says, button got tapped. And notice that in order to describe what you're writing as text, namely telling Xcode that this is not code, this is in fact just some text that I want to have printed into the debug console, well then you have to wrap it inside some quotation marks. And in Swift, the convention is to use double quotes, whereas in other languages you might have seen people use single quotes, but this is what we're going to be using from now on when we're just describing non-code or text. Now, if we go ahead and run our app, now what we expect to happen is when we press on the roll button, which we know we've linked to this particular IB action, then it should trigger all the code that we have in this block, and what we've told it to do is just to print this text to the debug console, which is going to pop up. So let's test it out. As soon as I press on the roll button, you can see the text, button got tapped, printed down here, and it will do that for every single time I press the roll button. If you think about the fact that we have our design file on the left, our code file on the right, our IB outlets are essentially when we want to go from here to here. So where we want our code to change something in our user interface. Whereas our IB actions are going from left to right. They are when an interaction with the user interface leads to something happening in our code. If we want these dice faces to change when we press the roll button rather than simply when the view loads up, well, then we have to connect these two things. So here's a challenge for you. Given that at the moment, when our app loads up, the 6 dice is shown on the left and the second dice is shown on the right, try and change the code so that when you press on the roll button after you run the app, that both these image views change to show dice 4. Pause the video and see if you can complete this challenge. Alright, so given that we know that we can change the properties of our image views programmatically, just as we have done right here, by using that who.what equals value equation, well, we could do the same thing down here, right? Let's delete this print statement, and I'm going to tap into the dice image view 1, and I'm going to change its image property, and I'm going to set it to a new image literal. And in this case, it's going to be dice 4 that's going to be shown. And I'm going to do the same for the second image view. And it should be exactly the same process. But now, if we run our app, what happens is that the first thing that gets triggered is the block in view did load. So our left dice gets changed to 6, our right dice gets changed to 2. But then this part of the code is actually not going to happen unless I trigger it through this IB action. So remember that touch up inside? So touch, and then as long as I lift my mouse up inside the boundaries, then it's going to trigger this block of code and change both image views to show dice 4. So did you manage to get that right? If not, I recommend taking a look at the previous lesson and revisiting how we figured out to change these properties through using our code. Now, the next lesson is an optional lesson, and we're going to talk more in depth about some of the things that we've used and we've already covered. For example, naming conventions other than camel casing, or commenting in your code, as well as print statements and string interpolation. So if you're already an advanced programmer, then feel free to skip the next lesson and continue building out the app and learn more about iOS development. But if you want to do a deep dive on some of these things I've just mentioned, then head over to the next lesson. Guys, welcome to the first of many Swift deep dives. In these sections, I take the opportunity to go into more detail on some of the Swift programming concepts that we've covered in the previous lessons. And the reason is because for all of these things, I'll explain to you as I go along while we're coding, but sometimes some of these topics just deserve a little bit more explanation. Now, for a lot of you who are new to programming, it can seem like there's an overwhelming amount of things that you need to learn. So these deep dives are partly revision to recap some of the things that we've learned in previous lessons, but it also gives me an opportunity to address those of you who are new to programming directly so that we can really get a deep understanding of the concepts that we're using and we're learning about. The first thing I want to talk about are naming conventions. And previously, when we created our IB outlets and IB actions, we started naming them using camel casing. Now, as I mentioned, camel casing in Swift starts out with a lowercase letter, and every subsequent letter has its first letter capitalized. Now, camel casing is probably the most commonly used way of naming things in programming, but there are other ways too. So often in web development, you'll see a lot of kebab casing, so words which are all lowercase separated by a dash. And there's also snake case, where words are separated by a underscore. Now, some of these things are just convention, so often you'll see file names being named in snake case, you'll see a lot of web development using kebab case, and you'll see a lot of application programmers using camel casing. Now, in Swift, we don't even have to think about these other two, we're going to stick with camel casing. So whenever you're naming something in code, this is the format that we're going to stick with. Now, the next topic I want to talk about is commenting. We saw how we can use Swift to comment out code. So commenting out means adding 2 forward slashes, which tells Xcode that this line is not code anymore. It's now a comment. And you can do this by simply planning on writing a comment. So very often you'll write a comment to explain what the next line of code does, to save yourself time the next time you come back to it. But other times you might have an actual line of code, and just by putting 2 forward slashes in front of it, then you deactivate that line of code, but you still keep it around in case you need it in the future. So in order for you to have a play around with this, I recommend heading into Xcode and creating a new playground. So if you head over to File, New, and then select Playground, and then it should create a new playground for you, and then it will ask you what kind of template you want. So we're going to make sure we create an iOS template that is completely blank. So let's go ahead and click Next, and then I'm simply going to name it My Playground, and I'm going to save it in the same place as everything else. Now, once you're done, then you should be able to see this blank playground, and I'm going to expand it to obscure our dicey project behind. And the playground has 3 really important areas. You've got the code editor over here. You've got the interpreter, which shows you the intermediate steps. And then finally, you've got the debug area, which works really similar to the one we have in Xcode. So the first thing I like to do with playgrounds is to click and hold this button and then change it to automatically run my code. So now every time I type some code, it's going to run it automatically without needing me to do any extra work. And then we're going to delete everything that's currently in our playground, and I'm going to create a new comment. This is a comment. Now, as I said before, if we had some actual code, let's say I had a print statement which just says hello world. Now once that runs, you're going to see it print down here in the debug console, and then it's also going to show up as an intermediate step to show what this will print as. Now for now we can ignore this right hand side. When we learn a little bit more about Swift programming, it's going to come in more handy. But right now I'm interested in the fact that this is code which is being executed and printing those words that I've told it to print. But if I put 2 forward slashes in front of it, then it comments out the code. So it deactivates the code, and when it runs again, then it no longer prints that code. And this is now inactive code, represented by this gray area. Now, while one option was to do what we did, which is just to add those 2 forward slashes manually, there's a really helpful shortcut that Xcode gives us access to. If you hold down the command key and you're somewhere on the line that you want to comment, then if you press the forward slash key, it will automatically add 2 forward slashes. And this is because usually when you're typing code, you're kind of towards the end of the sentence and then having to touch the mouse and go back to the beginning. It's kind of painful. So it's easier to just hit command forward slash and it comments out the entire line of code. And you can toggle it as many times as you want. Now, if you're somebody who likes to write a lot and you want to write multi-line comments, then you can do it like this. You have a forward slash and then an asterisk, and then you can just start typing as much as you want over multiple lines. Once you're done, you type another asterisk and then close it off with a forward slash, and everything in between these 2 areas will be interpreted as a comment. Go ahead and try this out in your Swift playground. See how I can type, and as long as I'm in between these 2 asterisks, then I can write a comment. But as soon as I'm outside, then this is going to be interpreted as code, and if it doesn't make any sense, then it's going to give me an error. So this is a good segue onto another topic that we saw, the print statement. As you saw, a print statement is pretty simple. We write the command print, and then in between some round braces or some parentheses, we add whatever it is that we want to print. Now, so far, we've pretty much just been printing these strings, but we can also print other things. Let's say if we wanted to perform a calculation in the middle of our print statement. So let's say I wanted to calculate 2 plus 3, so that instead of printing hello 2 plus 3 world, I wanted to print hello 5 world. For this little bit of calculation to happen, it can't be interpreted as just text, right? It has to be code. How can we insert bits of code in between bits of text? Well, we can add a backslash and then a set of parentheses, and everything that goes in between those parentheses will be interpreted as code. And you can see that it gets highlighted even in a different color, because text is always going to be red and code is going to be highlighted usually in a different color. So now when my code runs, it should say hello 5 world. That is obviously being calculated and being executed. So this is how we can insert code into our text. Now, text in programming is usually called a string because it's kind of like a string of letters, right? Notice how each of these letters are kind of just strung together like pearls in a necklace, and that's what we call text. So this way of adding code in between strings is called string interpolation. By using that backslash and parentheses, we can insert bits of code in between bits of text, which actually comes in really handy when we're trying to figure out what's going on in our code or when we're trying to test our code. So, for example, if you wanted to write the result of 5 plus 3 equals, and then you can simply add a backslash, a set of parentheses, and inside here you can actually make Xcode calculate 5 plus 3, and now when it runs it'll say the result of 5 plus 3 equals 8. So this is how you can insert code into a string. That's all for this first Swift deep dive, and we can now head back and continue building out our app. Alright guys, so currently we have succeeded in making the world's most boring app, because all it does is it changes the dice images when it loads up, and when we press the roll button it changes the dice faces to dice 4, and that's it. There's nothing else that happens. So this won't do. How can we make it better? Well, it would be great if these images could actually change every time we press the roll button. So in order to do that though, we need to have a sequence of all our images lined up so that we can pick and choose which one we want to show. So how can we create a sequence of things? Well, we need to use something called an array. Delete everything that you currently have inside your view did load. So remember, inside means inside the curly braces. And do the same in the roll button pressed IB action. Now instead, we're going to create an array. Now an array is simply an ordered sequence of items. And the type of items that I want to put in a sequence is of course all 6 of our dice face images. So I'm going to go ahead and simply create an image literal, and I'm going to add my dice 1. So now I have a single image literal, and I'm going to put it inside an array. And I do that by putting a set of square brackets around it. So now I have an array with 1 item. And it's important to note that while you're programming, you can see there's a whole bunch of different types of brackets, right? We've seen round brackets like these, curly brackets like these, and now we're looking at square brackets. Just remember that in Swift, square brackets are pretty much exclusively used for holding a collection of items. And in our case, it's going to be a collection of image literals. So we've got the first image down, but now I'm going to select it, hit Command C to copy it, and then I'm going to add a comma and then paste it so that I have a second one. And I'm going to do this until I have 6 image literals on screen, like so. So now I have an array, but I have an array of the same image. So instead I'm going to double click on the second one, change it to image 2, third one's going to be 3, and so on and so forth, until I've created myself an array of all the possible images I could place into my image view. So all 6 dice faces. Now, once I've created my array, you can see that I'm getting a yellow warning that says expression of type, an array of UI images is unused. So at the moment, it's kind of just sitting there. kind of unloved and unused. So let's use it and make it feel useful. And we're going to do that by setting the dice image view 1 to show one of these images from the array. So I'm going to write dice image view 1 dot image, of course, to change the image property, and I'm going to set it equal to the value. But of course, I can't set it equal to the entire array, and Xcode tells me as much. I can't set 6 images into one image slot, right? Which one is it going to show? Instead, I have to specify the actual item in this array that I want to show in my dice image view. And I do that by adding another set of square brackets. Now, inside the set of square brackets, I can specify which item I want out of this array. So if I add the number 1 right here, then you might think that we will get the first image out of the array. But in fact, if I run the app and press the roll button, you can see that, strangely enough, it's showing me the second image. And you can see that if you change this to 2, it's going to show dice 3, and if you change it to 3, then it's going to show number 4. So what's going on? Well, it's because programmers like to count from 0. So we like to use the full 10 digits from 0 to 9. This one is actually at the position 0, and this one is at position 1, 2, 3, etc. So once you adjust that, then if I put in 0, then that's going to pick out the first item. Here's a challenge. Change the code that you see right now so that you display the 6th dice image. Alright, so let's try this out. So 0, 1, 2, 3, 4, 5. So if we change that to 5, and then run our app, then we get dice 6 showing up. So easy enough. Now I'm going to set that position number back down to 1, so that we get the second dice image being shown. But now I want to be able to give this value a name so that I can refer to it in exactly the same way that I can refer to my dice image view 1 or dice image view 2. Because they have a name, I'm going to go right up here just below my IP outlets, and I'm going to create a variable. And I do that using the var keyword, and then I'm going to give my variable a name, and I'm going to call it left dice number, and I'm going to set it to equal this value. So I'm going to cut that value from here and paste it in here instead. So now that value is now stored inside a named variable called left dice number. And I can refer to that value if I ever need to by using its name, which is left dice number. So now our code works exactly the same way as before. And when the dice image view needs to figure out what image to display, it gets the value of left dice number. So this gets replaced by 1. And then it picks out the 0, 1, so that particular image to put into its image view. So what has this achieved? It seems like we've just written some extra code, and it hasn't really changed anything about our app. So what was the point? Well, now that we have a variable and we have a name pointing to a specific piece of data, we can now keep track of this piece of data, and we can change it. We can vary it, essentially. So down here, after we've assigned the image view an image, the next task we're going to get it to do is to increase the left dice number. So we're going to set the left dice number to equal the current value of left dice number, which is, of course, 1. We're going to set it to equal that value plus 1. So now, let's imagine ourselves as the computer. When we first press the roll button, we know that this block of code gets triggered. And the first thing that happens is we set the dice image view's image to the number 1 position from the array, so this particular image. The next thing that happens is we increase that number to 1 plus 1, which is 2. So that means this variable now is holding the value 2. And the next time we press the roll button, Well, this is now 2, so it's going to pick out the third image from our array. And this goes on and on until we get to the very end of our array. So if you run your app at this point, and you click on the roll button, changes to the second image, and then the third, and then the fourth, the fifth, until it runs out of images because there is no seventh image, and this is the point when our app will crash because we're out of range. We're out of images to show. But that's fine. We've achieved the goal of actually making our user interface do something different every time we press the roll button. And we've achieved this by having a value that we keep track of, and we give it a starting value of 1. But now, every time the roll button gets pressed, we increase its value. And so we can go through our sequence one by one and display all of the images that are inside. Now, here's a question for you. What happens if I cut this line of code and paste it into my roll button pressed? What do you think will happen if you had to guess? Now pause the video and run the app as it is and see if your guess was correct. Now what happens here is that when we press on the roll button, it puts that number 1 into here, and we pick out the second image, which is the one that we're seeing on screen. But watch what happens when I press on the roll button again. Absolutely nothing. So why is that? Well, remember that we said this line of code where you have the var keyword, well, that creates a variable and it gives it a value at the point of creation. So it's set to equal 1. That 1 gets put in here, and now left dice number is increased by 1. So at this point in the code, left dice number actually equals 2. But the next time that you press the roll button, we recreate our left dice number and we set it back down to 1 again. So now at this point, the left dice number is now equal to 1 again. And you can actually confirm this by using that print statement that we learned earlier on. By printing the left dice number there and printing the left dice number down here as well. And when you run your code and you press the roll button, you can see that the first print statement gets fired and 1 is printed. And then it continues until the second print statement gets fired and 2 shows up. But if I press on the roll button again, it's still 1 and 2, 1 and 2. Whereas if I move this part where I create the variable and give it an initial value back up to the top of the file, well then when I run my app and we take a look at what's being printed, then you can see when I press the roll button the first time, the left dice number starts out being 1, but then it gets changed to 2. Now, if I press the roll button again, then the left dice number at this point is now 2, and then it gets changed to 3, and then 3 to 4, 4 to 5, and that's why our images keep changing. So remember that when you press the roll button, all of the code inside this block gets triggered again. So print statements are really helpful when our code is not doing what we expect it to do. And it can help you diagnose the problems by looking at what your expectations are. So what would you expect the left dice number to be at this point? And what would you expect it to be here? And then looking at the reality. And of course, you can use a string interpolation to actually make this a lot easier on the eye by saying left dice number at beginning equals, and then we're going to add that backslash and parentheses and put in the name of that variable to be printed. And then down here, we're going to write left dice number at the end is equal to, and so we won't get so confused by just looking at numbers. So when I press roll, you can see at beginning equals 1, at the end equals 2, at the beginning equals 2, at the end equals 3. This is really, really helpful for us to diagnose problems. Alright, so here's a challenge for you. At the moment, our left dice will increase in number until the number 6, at which point when we press the roll button, our app will crash. This is fine, but as a challenge, I want you to figure out how you can change the code to get the right image view involved as well. But it's not as simple as simply repeating what we did with the left side. Now, when you run your app, what we want to happen is when I press roll, the left side goes to 2, but the right side goes to 6. And then the right side will count down while the left side goes up, until your app crashes when the left side reaches 6 and the right side reaches 2. Pause the video and see if you can complete this challenge. So here's what we would do. Let me go ahead and delete these comments and print statements to declutter our code. And notice how I'm currently inside the viewControl.swift instead of being inside main.storyboard where we have the split view. And this is because when your code editor has a very, very small amount of width, it will wrap the code onto different lines, making it quite confusing to see what's going on. So when you're done usually with designing your app and creating the IB outlets, I tend to recommend students to head straight for the view controller so you get as much space as possible to be able to write your code. So the first thing we're going to do is we're going to start out the Dice Image View 2 with the 6th image. Right here, when we have the roll button pressed, we're going to tap into the Dice Image View 2 and set the image property to equal the 6th image in this array. So I'm simply going to copy this line of code here to save myself a bit of time. And instead of left dice number, if I want to pick out the 6th image, I have to put the number 5 here. So what if instead of having this number 5 hard-coded, which I can't change because I don't have access to it using a reference like the left dice number, what if I create a reference to it? So I create a variable called right dice number, and I set that equal to the value I have here. So I'll cut it from here and I'll paste it in here. So now I've got this thing called right dice number, and it holds that value 5. So I can now use that right dice number here instead of that number 5. When I run my app right now and I press the roll button, my Dice Image View 2 is now showing the 5th item in our array, which is of course Dice 6. Now all I have to do is figure out how to step down this number by 1 each time. Well, that's where we're going to vary our variable right here. So after it's displayed the image, we're going to set the right dice number to equal the current value, which is 5, and then instead of +1, we're going to -1. So now it's equal to 4, and then it's equal to 3, and then 2, and then 1. So if I run my app right now, and I press my roll button, it shows exactly the behavior I showed you earlier on. Did you manage to get that? If not, be sure to continue to the next lesson where we do another Swift deep dive on variables and arrays. But if all of that made a lot of sense and you already know about variables and arrays, then feel free to skip the next lesson and continue building out the app. It's time for yet another Swift deep dive. And in this deep dive, we're going to look at variables. So essentially, we've seen that variables are simply a way of giving a name to a piece of data so that we can reference it in our code later on. We did that for our IB outlets as well as our dice number variable, which we created from scratch. And the problem that it solves is really simple. Let's say that if I was to give you a phone number to remember, and I give it to you written down on a piece of paper. Now, if all I had on there was just a number, I know what my drawers look like, and if I have a single piece of paper floating around in there, after not even a day, I'll forget what that number was all about. So how can we make this better? How can we remember what this piece of data is about? We could associate that data with an actual label and give it a name. So we're essentially taking our data and labeling it with a name. Well, this is essentially a variable, because if we needed that piece of data in the future, we can simply refer to the label name, which is Angela, and it will be able to retrieve that piece of data. So we have to write a little bit more if we're creating this in code. We have to add a var keyword, which tells the computer that we're creating a new variable. And then we add an equal sign to tell the computer that on the right-hand side of the equal sign is the value that we're assigning to that particular variable. So you can essentially view creating variables similar to creating just a box, right? And you whack on a label, which will be able to identify what's inside the box, and you put some data inside the box. And now you can store it somewhere on a shelf ready for retrieval. And by looking at that label, you'll know what's contained inside. So if you need the data that's inside, you simply find the right box with the right label. Now, variables were made to be varied, right? That's the whole point. So we can simply remove the old value and put in a new one if we wanted to. And now that label name, Angela, is associated with a completely different piece of data. In the resources for this lesson, you'll find a download link for the Swift cheat sheet that we've created for you. And this is just a handy reference guide. A lot of students like to print it out to have it beside them when they're learning. And it's a way for you to be able to quickly refer to the grammar of the Swift programming language. So just as in English, we have our commas and our full stops, and they have meaning in the sentence. In Swift and other programming languages, we have certain keywords like the var keyword, which is used for creating variables, or the equal sign, which is used for assigning a value to a variable. And this is a handy guide that you can always flip back to when you're completing challenges and when you're trying to write your own code. So the way that we create a variable is we start out with the var keyword, then we give our variable a name, and then we assign it a value. That's the theory of it, but let's head into a playground and actually create some code from scratch. So let's say that we had a variable called a, and we gave it a number, let's say 5. And then let's create another variable called b, and let's give it a value of 8. Now, if I decided to print these values, so print A and then print B. Now, notice in this case, I don't have those quote marks around the A and B, because if I had that, then it would simply interpret this as a command to simply print the letter or the string A, and that's what you see here. But if I actually want the value of my variable A, then I have to make sure that I'm putting it in as a variable name A and B rather than anything with quotation marks in it. I can make this a little bit fancier by adding some string interpolation. If you remember, the value of A is, and then I can add that backslash and put my variable inside some parentheses, and now I get printed the value of A is 5, and I can do the same thing for B. The value of B is B, and let's just make sure we're not missing that final quotation mark. And now we get the value of A is 5, the value of B is 8. So now that we've covered the theory of Swift variables, let's get a little bit more practice with Swift programming through a coding challenge. Now, as always, the challenges are completely optional, but solving them will help cement the concepts that we've covered and make you a stronger programmer. Also, figuring out and solving these little puzzles is going to be a lot of fun. So, what's the challenge? Without changing these lines, or changing these lines, can you swap the values of A and B? So that when these two lines execute, it will say the value of A is 8 and the value of B is 5. But here's the catch. You can't type a single number. So in your solution, you're not allowed to type a 5 or an 8. You have to figure out how to switch these two without simply assigning it with a different number. Because the easy way is to say A will now equals 8 and B now equals 5. and I will get that A is equal to 8 and B is equal to 5, and I've switched those two values around, but I have used a number. So for this programming challenge, we're going to be using code to achieve this, and you have all of the tools and knowledge to be able to do this, but you might have to think a little bit outside of the box. So this is a really common interview question that you will get as a programmer, and it just tests you a little bit in terms of your lateral thinking and whether if you understand variables well enough. I'll give you a few seconds to pause the video before I show you the model solution. Alright, ready? Did you have a go at the assignment? And did you manage to get it right? Now, the trick to solving this puzzle is to simply create another variable. So let's go ahead and replace this line with our code. I'm going to create another variable called C. And I'm going to set C to equal the current value of A. So at this point, C is going to be equal to 5. Now next, we can set A equal to B. Now at this point, A is now equal to 8. And finally, we can set B to equal the value that's held inside C. And so B now equals 5. And within our 3 steps, if we run our code, you'll see that A is now 8 and B is now 5. We've managed to switch these two values around in only 3 lines of code without needing to write any numbers such as A equals 8 or B equals 5. I'll see you on the next lesson where we'll learn more about Swift arrays. Are you ready for another Swift deep dive? In this lesson, I want to talk about arrays. And arrays are essentially just collections of items. So whereas variables, you have a name that's associated with a single piece of data, what do you do if you have lots of data that are somehow associated with each other, like a basket of apples? Well, that is kind of like an array of apples, right? Creating an array is pretty simple. We use these square brackets, and inside the brackets, we drop in all the items that we want to put into the same collection or the same array, and we separate them by commas. So we now have an array of names, and we have 3 items in our array. Now, when we want to access items from an array, then we can use another set of square brackets and we tag it on at the end of the array. And inside the square brackets, that X is a number that refers to the position of the item that we want to retrieve from the array. And if you remember from previous lessons, we said that programmers love counting from 0. So the first item, that Angela, is at position 0, Jack is at position 1, and Philip is at position 2. So if we replace the X with 0, 1, or 2, then we will be able to retrieve a single item out of our array, depending on which position we specified as X. So just as we can store other pieces of data, such as numbers or text, in a variable, an array is just like any other piece of data, and it too can be stored inside a variable. Let's say that we had a variable called friends. We can assign it the value of our array. So now when we want to access this array, we can refer to that reference called friends. And again, when we're accessing items from an array that's been stored inside a variable, it's exactly the same thing. Whereas before we had a straight up array and we tagged on at the end a set of square brackets and a number that referred to the position of the item that we wanted to access. Well, if we had the array stored in a variable, it would look like this. We would refer to the name of the array, and then we would again tag a set of square brackets at the end, and the X refers to the position of the item that we're interested in from the array. The easiest way to think about an array is to imagine you had a spreadsheet where you only have a single column. For example, here I have an array of famous people, and I've got a whole bunch of names in my array, and they are numbered. So in the case of a spreadsheet, they're numbered from 1 to 10, but if this was an array, then this would be at position 0, 1, 2, etc. It's essentially a single column with a whole bunch of data in it, and each piece of data has a position associated with it. So that's just another way to think about arrays. And if you've worked with spreadsheets a lot, then this might be a really easy way for you to understand and visualize arrays. So I've got a challenge question for you. Why did the programmer quit his job? Well, because he didn't get a raise, of course. Now, that's not the actual programming challenge. Instead, you're going to be writing some code to test your knowledge on arrays. Now, the array that I'm going to create is going to be stored inside a variable called numbers. And I'm going to set it to equal a bunch of numbers. So let's say 45, 73, 195, and 53. So I have an array of 4 numbers. Again, if you need to refer to how arrays are structured, namely what kind of brackets does it use and how do you separate each of the values in it, then you can take a look at the Swift cheat sheet and remind yourself of how you create variables and how you create arrays. Now, I'm going to create another variable called computed numbers, and I want you to write some code so that when you print the computed numbers, the end result that you should see down here is the first number multiplied by the second as the first value, and then it's the second number multiplied by the third, and finally it's the third multiplied by the fourth. So let's say we had an array of 1, 2, 3, and 4, then the outcome that should be printed is 1 times 2 equals 2, 2 times 3 is 6, and 3 times 4 is 12. So that would be the desired outcome. But instead, you're going to be working with these large numbers, and I don't want you to actually take a calculator and work out what is 45 times 73, and then what's 73 times 195. And in fact, I don't even want you to write any code that includes those numbers, 45, 73, 195, and 53. I want you to use purely just your knowledge on how to pull items out of the array and use the Swift program to calculate these values for you. Now, in order to complete this challenge, you'll need to know that to multiply a number, say 1 times 2, in Swift, it's done using the asterisk symbol. So if I print 1 times 2, and let me just comment out the code that's currently incomplete, which is giving us some errors, then once my code runs, you'll see 2, or 5 times 2, which should be 10. So multiply the value at position 0 by the value at position 1, and then the one position 1 by the one at position 2, and you should end up with an array of computed numbers which is going to be printed, and it should have 3 items in that array. And I'll see you on the other side. Good luck. So our app now at least has some functionality. And when we press the roll button, things actually happen on screen. Well, at least until it crashes when we run out of images to display. So there's a couple things I want to do here. First, I want to simplify the code a little bit. Because we no longer need anything to happen when the view loads up, then we no longer have a need for this block of code. So we can simply go ahead and delete it. Now, the next thing I want to show you is that while we have this very clear way of writing left dice number equals the current value of left dice number plus 1, there's actually a far more efficient way of writing this. And because in programming, we often need to increase the value of variables by 1 or by 2, this is why there's pre-built ways of making this easier. So in Swift, we could simply write plus equals 1. And that will take the current value of left dice number, add 1 to it, and then set it to the value of that variable. But if you look at this straight away without the context, then it can be a little bit confusing as to what's going on. So I'll leave you to be the judge of which version you prefer. And remember that it's not just plus that you can do this with. You can do minus or multiply or divide, and it will basically do the calculation as if you're taking the current value, dividing it by the value after equal sign, and then assigning it as the value inside the variable. I'm going to leave that as plus equals 1, and I'm going to change this to minus equals 1. And if you run your app, you'll see that it works exactly the same way as before. Nothing has changed other than the fact that we've made our code a lot shorter. Now, there's gains in other places as well, and we'll talk about them when we come across them. But the main goal right now is to make our app not crash when it gets to the end of the array. And the other thing to think about is that it's not really a dice app if it just goes through all the numbers in sequence, right? That's not random. So how do we get some random numbers showing up instead? Well, in Swift, you can generate a random number by simply writing int. So this is the data type that refers to an integer, which is also known as a whole number, so no decimal places. And then if we write a dot random, then we can tap into a range of numbers. So we can say, give us a random whole number from 1 to 10. And that's what that 3 dots do. It's specifying a range from 1 until 10. And when this line of code runs, it will look at the range and generate a random number that's between 1 and 10, so inclusive of both 1 and 10. Now, if I go ahead and simply wrap a print statement around that and hit run, and when I press the roll button, you can see that we get a bunch of random numbers being printed, or at least until our app crashes because of this line again. So let's put 2 and 2 together. What we need is a random number here to be able to pick out a random image from our array. So we have 6 array images and they start counting from 0. So this one is at position 0 until position 5. So we basically need this to be a random number between 0 and 5, right? So maybe at one point when we press the roll button, it'll generate 4, but the next time it'll be 2, and then the next time it'll be 0. But it has to be random. So let's transplant this code here inside the print statement, which we already know can generate us random numbers between 1 and 10, but let's replace that range and make it between 0 and 5. And I'm going to do the same for the bottom as well. I'm going to delete that print statement and let's run our code again. Now, if I press the roll button, you can see that I'm getting completely random numbers showing up. And there is no end to this app anymore because it's just going to stay within the limits of our range here that we've specified between 0 and 5. It's never going to go to 6 or 7 or 8, which does not correspond to an image in our array. We can no longer crash our app, which is wonderful. So we've made our app behave more like a real dice, and in addition, we can now delete this left dice number and right dice number, both where we're using it as well as where we're creating it. So our code is now even simpler. Now, this is what we call refactoring in programming, where we take our code and try to make it simpler and make sure that we don't have any code that is repeating or unnecessary. We can take this even further because look right here. We have that same array that's being used in both places. So why don't we instead just create a reference to it, give it a name, and use the name every time instead of having to create this array? And even though Xcode makes this display really nicely and show us the images, as soon as there's some issue in your code, let's say we commented out this code, you can see what's behind the scenes is actually quite complex. There's something called an image literal being created from a resource name, and this makes our code quite long and quite wordy. So it'd be great if we didn't have this duplication. So what if we could create a variable that holds this array as the variable's value, and then we can refer to that variable when we need to use this array. Just above these 2 lines, I'm going to create a new variable, which I'll call dice array, and I'm going to set it to equal this array right here. So I'm making sure I'm copying in all the square brackets, and I'm going to paste it in here. Now, in Swift, it's really important to make sure that you have consistent or symmetric amount of space on either side of the equal sign. So, for example, you could have no space either side of the equal sign, or you could have one space, but try to avoid where you have an asymmetric situation like this, because you'll get an error from Xcode. Now, when you see a warning or a error, so the yellow triangles are the warnings, which says, hey, I think there might be something wrong, but you might know better, so you can continue. Or the red stop signs say, stop, there is an error and you must fix it if you want to run this app. And when these symbols have a little white dot in it, it means that Xcode thinks that it knows the solution to this problem. So if you click on it, you can see a fix button. And you can see what it's going to try and do when you click on this fix button. So in this case, it's going to insert a space after the equal sign. Let's click fix, and it automatically fixes that for us. Now, it's really important that when you click on the fix button, you know exactly what it's trying to do and why it's doing it. So you understand what's going on before you just let Xcode fix everything. Because Xcode is still quite far from Skynet. It thinks it's very clever, but it's actually not. So there are many cases where it thinks it knows the solution, but actually it just messes up your code. You are the human programmer. You are the one telling the computer what to do. Make sure that you know exactly what Xcode is trying to fix before you click on it. Now that we've got this dice array here, I'm going to ignore this warning for now, and then we'll come back to it a little bit later on. But the point is, we now have a reference to our array, and we can reduce the duplication right here. So instead of actually providing the array, we can simply refer to the array, and if I type in its name down here, then when this line of code runs, it's going to go and look for this dice array, which lives right here, and then it's going to try and pull out a random item from it between 0 and 5. Now on the next line, I can do exactly the same thing, so use the reference to dice array, and if we run our app right now, you'll see that nothing has changed. We still have our dice rolling functionality, and it rolls any random dice between 1 and 6. Now let's come back and address this warning from Xcode. It says, the variable dice array, this one, was never mutated. Consider changing to a let constant. What is this trying to tell us? Well, here we've created a variable, which is created using the var keyword, and we've basically given this collection of items a name so that we can refer to it later on. But given that it's a variable, surely we would want to vary it at some point, right? But at no point in our code do we ever change the value of dice array. It's not like right at the end we tap into the dice array and we set it equal to a different set of image literals. So maybe the dice array is now composed of the logo and the background image. In this case, we've created the variable and then subsequently we vary the contents of that variable. So we've changed the values that's held inside. Well, this is what a variable is used for. And it's really common when, say, if you had a score, right, where the user starts out with a score of 0, but then later on we add 1 to it so that we increase their score. Well, this is where we're varying the variable. But in our case, we don't actually need to vary the dice array because that's all the images we have. We don't have any other images. So why do we need to change it? Well, we don't. So that's why Xcode is telling us, consider changing it to a let constant. And again, this warning here has a white circle in it. So it means Xcode thinks it knows how to fix this. So let's click on it and see its suggestion. It says, why don't you replace the var keyword with a let keyword to turn it into a constant? So let's click on fix, and now all our warnings go away, and if we run our app again, it will work exactly the same as before. But all that we've done is, instead of allowing this to be changed, this is now a constant. So if I decided that dice array was going to have some other images inside, I don't know, let's say if we deleted some of these values, then you'll see that it'll actually give us an error. You can't assign to this value. Dice array is a constant. And it tells us that if you do want to change this array, and you want to change its values, well then you have to change that let back to a var. And that's what its automatic fix does. So we don't want that. We're never going to change the array, so we can keep it as a let constant. We've seen that we can generate a random whole number between the range of 0 to 5. And this is a really heavily used bit of code whenever you're programming anything that needs some randomness, say for example a game. But in our case, if we just wanted a random item out of our dice array, there's actually an even simpler way of doing it. We can delete this and simply write dot random element. And that will do exactly the same as this. It will look through this array, see how many items there are inside, and then give us a random element. So if you wanted the ultimate succinct code, then it would probably look something like this, where you're picking a random element for each of these dice image views. But if you find it easier to see what's going on and to practice using this random generator, then you might want to keep your code like this. The choice is yours, but I recommend that at this point you take a moment to write some comments in the code to tell your future self what each of these lines of code that you've written does. So that when you come back to it, when you review it, you'll be able to understand quickly at a glance. So pause the video and have a think about some of the new things you've learned in this lesson and write some notes on those things. In the next lesson, we're going to be doing another deep dive into randomization in Swift, as well as the range operator in Swift, and look at the difference between the let and the var and when you would use each. So if you already know about all those topics, then feel free to skip ahead. But if you want to learn more, then have a look at the next video. Alright guys, it's time for another episode of Swift Deep Dive. And in this lesson, we're going to cover a lot of the things that we've come across in the previous lessons when we were building out our app. And we're going to talk about them in a little bit more detail. So the first one I want to talk about is the Swift constant. And the reason why I have a bronze elephant here is because recently I went to a bronze sword making workshop where you get to cast your own bronze sword from melted tin and copper. Now the reason why I'm talking about bronze in a programming class is because, similar to constants, once you've cast the bronze, it's actually very hard to change it. It's not like iron, which you can hammer and reshape. Bronze is really hard, and it's just going to stay as the shape that you've cast it. And if you wanted to change it, then you would have to melt it down and recast it. So similarly, constants, once created, they don't change their values. So if we think about the last time when we had a Swift deep dive, and we talked about this analogy of a variable being a box that contains data with a label on it so that you can refer to it later on. Well, a variable is kind of like a box with a lid on it. You can take out the value and put in a new value and change it as much as you wish. But a constant is different. A constant is kind of like a box which you tape shut, and you can never ever change what's inside again. And creating a constant is no different from creating a variable. All we do is simply change the keyword. So instead of a var for variable, we create a let for constant. Now, the reason why it's called a let is because Swift, when it was designed, was intended to be a very human-readable programming language. So the idea is that you would say, well, let Angela equal 0784236, etc. So it sounds like you're creating this thing and you're keeping it constant. And indeed, if you go into your playground and if you create a variable a and you set it to equal 3, well, that's the initial stage. That's like building the box, putting the value in. And then you can tap into the value inside by simply using that reference, that a, to use the value. In this case, I'm printing the value. But I can also vary the value, right? So I can say a now equals 5. Now, a has been reassigned to hold a different piece of data. And when I print a at this point, it's going to show 5 instead of 3. Now, if I had changed that keyword from var to let, where I'm creating now a constant called a, well, now I get an error because I can't assign a new value to a because it's a constant. And so my program crashes and I'm not allowed to continue. So why do we have constants and variables? What's the point? Well, part of it is to do with efficiency. Because if you create a constant, the computer knows that the piece of data that it has to hold is never going to change. The contents of that box will never change. So it can store the data more efficiently. For example, if I sent you to the market and some days I asked you to buy 5 loaves of bread, but other times you only need to buy 1. Well, in this case, you might bring a large shopping basket with you, just so that you can adapt to this flexibility, right? One day you might need to buy a lot and put into the basket, and the other day you might not fill your basket at all. So that's a variable. But if you knew that every single day you needed to get 2 loaves of bread from the market every time, then you would bring a container that's perfectly sized for the job, so you don't have to carry any extra weight. So similarly here, if I create a variable a, at the beginning it might be storing a single number, right, which doesn't take a lot of space. But if at some point down the line you needed to store a much larger number in that variable, then that initial container, that box that gets created, needs to be large enough to allow for this future flexibility. Now, had this been a let constant, however, well then you only need to make a container as large as it needs to store this single value. So it's a lot more efficient. So that means that when you want to store a piece of data and give it a reference, and you know that that data is never going to change. Say, for example, you wanted to store the value for pi, right? And it was 3.14159. Well, pi is not going to change between today and tomorrow. So you could create a constant for it, right? Whereas if you had a user score, for example, well, that's constantly going to change. Every time they get a new point, then that score is going to be changed to a new value, and you can't use a constant. So by default, try to make everything a constant unless you need to change it. Now, the next thing I want to talk about are some of the most commonly used basic data types that you see in programming. Now, we've already seen a couple of data types in our programs. For example, whenever we print a piece of text to the debug console, we're creating a string. Now, a string is short for a string of characters. So just like you would have a string of pearls to create a necklace, you can have a string of characters to create a piece of text. Whereas we would normally call this text, in programming we often call it a string. And you can tell that something is a string because when we create it, we usually put 2 quotation marks around it to tell our code that this is just text and this is not code, so don't interpret it as code. The next data type that we saw in the last lesson was the int, which is short for integer. Now, an integer in mathematics refers to a whole number. It doesn't have any decimal places. So 12 or 34 or 1239, these are all integers. And integers can also be negative as well. It's not limited to being a positive whole number. Now, what if you needed some decimal places? What if you were calculating something that needed a greater level of accuracy than a whole number? Well, you could use something called a float, which is short for a floating point number. And of course, that floating point refers to the decimal point. Now, if you needed a greater number of decimal places to have greater accuracy, say you're creating some sort of scientific calculator and you need to give people, say, 600 decimal places, then you might want to consider using a data type called a double. The reason why it's called a double is because it has double the amount of accuracy of a float. So it can hold more numbers after the decimal place. And if we were storing pi, which of course goes on until infinity, then we can have a much more precise calculation with our pi that has a double data type. Now, the final primitive or basic data type that all programming languages use is something called a bool, which is short for a boolean. And a boolean only has two possible values, true or false. That's it. Because often in programming, you'll need to check if something is true, in which case you should perform some sort of action. Otherwise, or if it's false, then perform some other sort of action. So in the Swift cheat sheet, if you have a look at the red block here, we've got all of those data types that I've talked about just now, plus some extra ones that we're going to learn about later on. And I've got some example values on the right so that you can quickly remind yourself if you need to see what kind of values these data types refer to. That's a quick handy tip. Now, the final thing I want to talk about is randomization in Swift. In nature, there's a lot of randomness. The pattern of leaves falling from trees, or the way that rain droplets fall on the water, these are all pretty much random events. Now, in a computer though, where it's essentially just a bunch of switches, a bunch of ones and zeros, ons and offs, it's a highly controlled environment where there really isn't much randomization. So how are random numbers generated from a computer? Say previously when we generated our random numbers, how does the computer even do that? Well, if you're curious about that, have a look at the course resources page where there's a link to a really good video on Khan Academy where Britt Cruz explains how random numbers, or rather pseudo-random numbers, the randomness that we get from computers, are generated. And it's a really, really fascinating video that gives you a lot more background on this topic, if you're interested. Now, in our project, we saw that we could generate random whole numbers by using a functionality of the integer data type. So we wrote int.random, and then we provided a lower and an upper bound. Now, in this case, what we get are random numbers anywhere between the lower and the upper bound, and including the upper bound. So if we create a new constant here called random number, and we assign this reference to a new random integer between 1 and 3. And notice that there's 3 dots in between those numbers. You can separate these out if you find it easier to see this way. But this is what we call a closed range, because when I hit print, my random number that we printed will be a whole number between 1 and 3, but inclusive of 1 and 3. So I might get 1, I might get 3, I might get 2. So if I stop my playground and rerun my playground, then you can see that I'll get different random numbers. But I've already traversed all 3 numbers, 1, 2, and 3. So all of the numbers in this closed range are possible. Now, just now, you saw me use a closed range, and that refers to something called a range operator in Swift. For example, the 3 dots that we used would be known as a closed range operator, where the range is inclusive of the upper bound. But Swift also has a half-open range operator, and this is done by using 2 dots and a less than sign. So this defines a range between the lower and the upper bound, but not including the upper bound. So if I change that last dot to a less than sign, then you can see that I get 1 and 2 occasionally, but I will never get 3. If I wanted a different type of number to be generated, say if I wanted a random floating point number, then I can simply change the data type at the beginning to a float. We can change that int to a float and we will start generating random numbers with decimal places. And in this case, because it's a closed range, it could include 1.0000 all the way up until 3.0000. But if we change this to a half open range, then you can only get up to 2.99999 recurring, and you will never get 3.0000. So just by changing that data type at the beginning, you can determine what type of random number you get. And this works for Booleans as well. But of course, Booleans can only be true or false, so there's no range in this case. Now, we saw in the last lesson that we can get hold of a random element from an array by asking for a random element from our array. But you can also use a shuffle method so that the items in the array change their positions in the array completely randomly. And we're going to be using this in a later lesson as well. Now that you're well versed with randomization and variables and constants and arrays, well, it's time for another challenge. And the challenge is to create a password generator. Here, we've created an array which has all of the letters in the alphabet, and each of them are stored as a string, so with quotation marks around them. And there's a total of 26 letters in the alphabet. Now I want you to write some code to randomly pick 6 letters out of the alphabet to create a random 6-character password. Now it's important to note that you can combine different characters together by simply using the plus sign. Here, if I create a constant called password, which is made up of the character A plus the character B, then when I print this password, then you'll see what prints is A, B. The strings are combined together with no space in between. And in programming, we call this concatenation. So just putting them right next to each other. And you do that using the plus sign. Coming back to our challenge, can you create this 6-character password, which is a random bunch of characters from our alphabet array? Once you've completed this challenge, then it's time to head over to the next module and create an app all by yourself based on what you've learned.
Subscribe now and press the bell icon. Never miss an update.
Now, while we've been building our apps thus far, some of you might have already noticed that when you rotate the apps or when you try to run the app on a different screen size, often our beautiful designs get completely corrupted and they look terrible when in landscape or when run on different devices. So even though our Dicey app works perfectly, when we try to rotate it, bits of it gets completely cut off and we can no longer really interact with our app properly. So we can't really upload our app as it is to the App Store. We first have to learn about the rules that we can put into place in order to make it look great on all orientations and screen sizes. And these rules allow the iPhone to figure out how to lay out each element as it gets rendered on a different screen of a different aspect ratio or size. So, for example, if we had 3 buttons, a blue one, a red one, and a green one, then we could tell the blue button that whenever it gets laid out on screen, it always has to be 10 pixels from the top and 10 pixels from the left. So it's pinned to the left corner. And when we have our red button, we're going to tell it to be centered in the app, so vertically and horizontally in the middle. And finally, for the green button, it's going to be centered only in the vertical axis, so this one, and it's going to be pinned 10 pixels from the bottom. So by implementing these various rules, we can tell each of our user interface elements how it should be displayed, even when the size of the phone changes or when the aspect ratio of the screen changes. So in this module, we're going to be doing a full exploration of all things to do with auto layout, the rules that enable our user interface elements to know how they should be laid out. And in the process, we're going to learn about size classes and how to define those in the Xcode interface builder, as well as understanding the rules or the constraints that we can set to specify how components should be laid out on screen. And then we're going to learn about how to use alignment and pinning and a combination of these to design how our app should look in landscape and in portrait. And then we're going to learn about how to use containers, so views that can wrap other views to get more fine-grained control over what things should look like. And finally, we're going to learn about something called stack views, to stack our components vertically and horizontally on the screen. There's a lot to learn in this module, and once you're ready, head over to the course resources where you'll get a link to the Auto Layout iOS 13 starting repository on GitHub, and then go ahead and clone it to your local system. And once you've done that, head over to the next lesson and we'll get started straight away. Here's my freshly cloned copy of the starting app for the Auto Layout module. And if you run the app, you'll notice that it's basically the completed version of our Dicey app. Now, when I rotate, however, then the problem starts. It doesn't really render itself properly on any of the orientations other than the original one. Although our functionality is still intact and it's working, it doesn't look good when we change the screen size. For example, if we run it on a different simulated device with a different aspect ratio, or if we turn it to landscape. And you can check this out by going to Hardware, Rotate Left, Rotate Right, or simply just setting the orientation here. But essentially, this is our starting point, and I want us to have the same starting point rather than using the completed version of Dicey from the last module. This way we have the same screen to work with, and you'll be able to follow along much easier. Throughout all the apps that we've been building so far, we've always had this niggling little yellow warning here. And if we click on it, it takes us to the problematic area, which is, of course, our design in our main.storyboard. And in particular, it's concerned with this roll button. Because say if I orientate my phone into landscape, then you can see that that button has completely disappeared. And there's no way for the user to interact with our app anymore. All they can do is just look at a pretty logo. So in order to address these issues and others, such as our user interface completely being cut off, we have to learn more about auto layout. And instead of starting out with our main.storyboard, which has quite a few components on it, instead we're going to head over to our launch screen.storyboard. And the launch screen storyboard works exactly the same way as the main.storyboard. They are both our interface builders, so we can build our interface on it. And this one is the screen that flashes up for a couple of seconds before our main screen shows up. So this is where people usually put their logos from their company or a tagline. And because the interface here is much simpler, we can get started here learning about size classes and orientation. We have the same problem here as our main.storyboard. When we rotate the orientation, part of our background is completely cut off. It's still pretty much in the vertical orientation. If you click on it, it's just staying exactly the same. And our logo is somewhere down here, which is completely invisible because it's off the screen. We're able to see this by using this area here, which is where we can specify our different size classes. Each of the icons here represent a different size class. And that's why you'll see iPhone 4S, iPhone SE, but there's no iPhone 6, 7, or 8, even though you might own a 6 or 7. So why is that? Well, it's because each of these separate size classes represent a particular group of devices. The iPhone 8, 7, and 6 all have the same size screen and aspect ratio, so they are grouped into the same iPhone 8 size class, whereas the iPhone 6, 7, 8 Plus all have the same size and orientation, so they have a different size class. It just means that when we're using these size classes to take a look at our canvas, we don't have a whole bunch of devices that are unnecessary. We only have one for each size. And back in the days when it was a lot simpler, when all we had was the same 3.7 aspect ratio screen, so for the 3, for the 4, for the 4S, then we could have just a single canvas. But these days, there's a whole bunch of different devices, one for every size and need, so that's why they've created these size classes. And previously, when we were creating our I Am Rich app, and I mentioned that if you wanted to run your app on your own device, but you had a different device size to the one that's by default on the canvas, which is our iPhone XR, then I told you that you could simply select your size class and update the design as needed. So if you had an iPhone 4, for example, then you could simply drag and drop the logo so that it's in the middle of the iPhone 4. And this way, when you run it on an iPhone 4 or 4S, then it would look perfect for your particular screen size. But of course, we can't do this for everybody on the App Store. We can't adjust our size as they are running it. So that's why we have to define rules for how to lay out these elements rather than manually adjusting it for one particular screen size. Now down here, the area that we've been using to adjust our canvas size in the interface builder is called the size class area. And notice how if I give it a little bit less space, it becomes this sort of drop-down list. And if I give it a little bit more space, then it actually shows me all the possible size classes. So you can use that to see which device is currently being selected, which interface style, so light or dark mode, and which orientation. So while you're designing your user interface, you can use this area to quickly check what it looks on different devices and different orientations. And if you need more space in your canvas, then you can simply click here for it to disappear. So now that we've seen different size classes and we know how to design our app manually to fit different size classes, then it's time to learn more about the automatic rules or constraints that we can place on our elements to make them automatically lay out itself to look good on all devices and orientations. For all of that and more, I'll see you on the next lesson. Let's change our size class back to the default, which is the iPhone XR. And we want to fix our problem where our background image gets cut off when the orientation changes. So how can we do this? Well, essentially, we need this background to resize itself so that all 4 edges of that image is tied to the 4 edges of our screen, so that the top edge here is always sticking 0 pixels to the top of whatever orientation the screen's in. The right is always sticking 0 pixels to the right of the screen. The bottom is 0 from the bottom, and the left is 0 from the left. But of course we can't just adjust our image like so, because as soon as we flip back to the other orientation, it stays exactly the same. So we need to add some rules or constraints onto this image view. And that is what we're going to tackle in this lesson. To begin, let's make sure that you also have the same size class selected, the iPhone XR, and that it's in portrait mode. And then we're going to select our App Brewery background image view, and we're going to resize it so that it fits the entire screen of our iPhone XR. And then we're going to make sure that our logo is bang in the middle of our screen. So this is kind of our desired look, at least in portrait. From here, we're going to add some constraints to our App Brewery background so that even when it's in landscape or on a different device, it still is touching all 4 sides of the phone and it's stretching to fit the entire screen. And then we're going to go and click on this button right here, the little square button, which is going to allow us to add a constraint. And the constraint that we want to add is to specify a 0 pixel distance from the top of the phone, 0 from the left, 0 from the right, and 0 from the bottom. So we're going to click on these red lines and turn them from these dashed lines to solid lines to activate those 4 constraints. And then we're simply going to click on this button. Now, if you don't see 0 in each of these boxes, then go back and make sure that your background is placed exactly like so, and it's fitting the entire screen. Once you're done, go ahead and click Add 4 Constraints. And now, when we go into our landscape orientation, you can see that our background image view is now more or less stretching to fit the entire space. But there's a couple of problems here. Firstly, why is it that our background is not going all the way to the left and right? What's going on there? Well, we can actually explore our constraints and figure out what's gone wrong with them by expanding our constraints here, and we can see what these constraints or rules are doing to our user interface. So the first one is a rule that says the right side, or the trailing side, as highlighted here, of our AppBrewery background should be equal to the safe area's trailing. So this means that when our phone goes into landscape, the safe area is the area which normally contains either the battery information or the signal information of the phone, and at the bottom of the iPhone XR, it's the home button essentially. It's the part which you swipe to go back to the home area. So often if we're creating an app that has buttons on it, then we don't want it to be in these safe areas. So we'll define rules that keeps it out of these areas. But in our case, because it's just a background, we want our background to actually cover the entire screen rather than have this sort of blocky effect. So we actually don't want it to be set to the safe areas trailing, and in fact we want it to be set to the super view. So this is our current element. The super view is the view that contains this element, and this super view that's at the base of our view controller is always going to be covering the entire screen. So we want to define this constraint. Rather than relative to the safe area, we're going to define it to the super view. So this one right here. And we're going to say that it should be equal to the super view's trailing. So now our AppBrewery background, the trailing, the right side edge, is now fitted to be 0 pixels from the trailing edge of our view. So that's the one that's highlighted in blue right here. And if we now go into landscape, you can see it's now fitting right to the edge of that right side, or the trailing side. So let's go ahead and fix the same thing with our leading view. So you can see we've got our AppBrewery background leading set to be equal to the safe area leading. So let's go ahead and change that from safe area to the super view. And now when we go into landscape, you can see that it looks perfect as it is. Now you can see that each of these rules, when you click on them, you can view them in more detail in the attribute pane. And you can see the rules that have been set up here that set the constraint between a first item and a second item and the relationship between them. So for example, if I wanted my AppBrewery background top to stop at the safe area, then I would change this to my safe area and change that constant to 0. So the top of my image view is now 0 from the top of my safe area. And if you want to see where the safe area actually is, you can simply click on it here and you can see where it stops on the top and the bottom, and also in the landscape orientation as well. Let's restore that constraint back to what it used to be, which is where the top is equal to the top of the super view. And let's look at another thing. If we take a look at the trailing, so the one on the right, it's currently set to the super view's trailing, but we can also set it to be relative to the margin. So the margin is that thing that pops up when we have an element that we drag to the right or to the left. You can see that blue line that pops up. And often when you have a button or when you have a logo, you don't want it to be right to the edge because it's hard to read. And instead, you want it to have a little bit of a margin to the edges. So in that case, you can define this to be relative to the margin of the super view's trailing area. So if I select that, then change my constant to 0 and hit enter, you can see it's now limiting my background to that margin. So these are some of the things that you can do with your constraints, and when you add them using the menu here, they don't always get added the way that you think it will. You can have a little bit more control over it if you click on the drop-down list. So for example, if I select my logo here and I click on here, then you can see that I can define it relative to the safe area or to the view. And I can change the distance or the value from those areas. So our background is now pretty much sorted, and if we take a look at all the different device sizes, all the way from small ones to large ones, it's basically adapting it to fit the entire screen background. And even when we change the orientation, it still looks pretty good. The next thing to do is to figure out how we can lay out our logo. And to do that, we need to learn about alignment. And that is what we're going to do on the next lesson. So I'll see you there. The next thing to tackle is, of course, our logo. And we want it to be centered in the screen, in all orientations and device sizes. So let's first bring it to the middle where we want it, so we can see these margin lines pop up. And now that it's bang in the middle, we have two options, right? We could simply go ahead and do what we learned before, which is where we select it and add the constraints so that it's pinned to the edges of the super view. But this is not going to look very good when we turn to landscape, because it's unable to have 300 from the top and 300 from the bottom, because now that the phone is in landscape, there isn't so much vertical space. So let's hit Command Z to undo all of those constraints. So we're now left with our Appery logo without any constraints. Instead, let's go ahead and click on the alignment button here and align it to be horizontally in the container and vertically in the container. So let's add those two constraints. And now when we turn to landscape, you can see it works just perfect. It behaves exactly the way we want it to. Now that's pretty easy, and it means that we're leaving the phone to work out the size of the screen that it's being rendered on and place the element in the center, even if it's on an iPad or on an iPhone 4 device. So when we think about adding constraints, we can think about it in terms of pinning, where we add these constraints that define the distance between our element and the containing view. And when we turn our phone, in this case the landscape, it'll try to fit it still to the edges. But of course, some of these will have to break because we can no longer afford 100 pixels, say in this case, from the top and 100 pixels from the bottom. There isn't that amount of vertical space anymore. The alternative to this pinning method is by using the alignment technique, where we say that we want to align our button horizontally in the center of our screen as well as vertically in the center. So now when our phone turns, our button is going to forever remain in the middle. Now we can also use a combination of these two techniques, where we say that our button needs to be in the horizontal center of the phone, but it also needs to be constrained so that it's always 30 points from the bottom of the safe area. So now when our phone turns, it's going to keep all of those rules, and it's going to look slightly different from before, where it was just simply in the middle of the screen. But we're now using a combination of both alignment, which aligns to the center vertically or horizontally, as well as pinning, where we add a distance that our element needs to be from the edge of its containing view. So let's restore our size class to the iPhone XR, and let's think about how we can use what we've just learned. Now, if we go into the object library and drag on a new label, so just below our logo, and then go ahead and style and edit the label however you want. In my case, I'm simply going to change it to a company tagline. And now I'm going to change its color, and I want it to be a little bit below my logo, but in the horizontal center of the app. So now, here's a challenge. Add some constraints to the label to make it centered in the horizontal axis, but make sure it's also about 30 pixels below that logo, even when we turn to landscape. So pause the video and try to complete that challenge. Alright, so the first part is easy. If we want it to be horizontally aligned in the center, we simply have to click on the alignment button and click on horizontally in center. And then we add that constraint and it's now in the middle. But now we get some errors because it doesn't know how to lay it out on the vertical axis. So should it be here? Should it be here? Should it be? Where should it be? Well, now we're going to use our combo move where we click on the add a constraint menu and we set it to be 30 pixels from the app brewery logo. So let's change that to 30, and we can click on the drop down list to make sure that we're actually putting that 30 pixels relative to the app brewery logo rather than the view or the safe area or something else. So now let's make sure that again says 30 and then click add a constraint, and now the errors go away, and when we turn it to landscape, it'll still be in the center horizontally, but it'll be 30 pixels below the logo. So we've now learned about the two main type of rules that we can set, or constraints, which are the alignment constraints as well as the pinning constraints. In the next lesson, let's tackle some more complex layouts, namely our main.storyboard, using some of the things that we've learned, but also creating some containers to embed our elements in so that we don't always have to align or pin it to the super view. For all of that and more, I'll see you on the next lesson. Alright, so now that we've learned about the basic components of constraints, namely alignment and pinning, we're ready to move on to our more complex interface, which is our main.storyboard. So if we head over there, you can see that we've got the same kind of green background, and we want it to cover all four sides. So as the first challenge, to review what you learned in the last lesson, add some constraints to that background green felt so that even when it's in landscape, it covers all four sides without stopping at any of the safe areas. Pause the video and try to complete this challenge. Alright, so just as before, we're going to select the item that we want to add a constraint to, either in the document outline or on the canvas, depending on how cluttered it is. And then we're going to go and set our constraints to be 0 from all four sides, and we can click on the drop down to make sure that it's actually selecting the view rather than the safe areas. And now we've got 0 from all four sides of the super view here, and now we can add our constraints and we can check in landscape as well as portrait. And also we can inspect our constraints in more detail by clicking on it and looking at the attribute inspector. So that's pretty easy, but the next part gets harder, because how are we going to lay out all four of these elements on screen in this layout and make sure that it looks decent in the landscape orientation as well? Because the problem here is that, firstly, we can't simply just use alignment because we don't actually have anything that's right in the middle of our screen. There's nothing that exists here. And if we wanted to use pinning, well, we don't actually have enough vertical space to be able to pin all of our elements together. So what can we do instead? Well, we could use some containers to split up the screen into 3 equal parts. And then we can embed each of these elements inside its own container. So now the super view to this particular logo will be this purple container, and we can set it to be vertically and horizontally aligned in the middle of that container. So let's give that a go. Let's start by creating a container. To do that, all we need to do is go to our object library and locate a view element. Now, because there's a lot of things that are called views, table view, image view, progress view, I find it's usually easier to type UI view, which is actually the underlying element here. And it's simply just an empty view. And in this case, we're using it to lay out some of the subviews. So something that we're going to put inside this container. Let's click and drag it onto our screen. And I'm going to put it somewhere near the top here. And then we're going to drag it out. And now we need to embed our Dicey logo inside this new view. And to do that, I'm going to click and select my Dicey logo and then drag it so that this little circle here is indented below the view. So this shows that it's going inside, whereas when it's alongside it, it means it'll be just parallel. So we know that the layout of our view goes from the bottom to the top. So this is at the very top, and then it's this at the next level, then this, and this is at the very bottom. So our eye is looking this direction. We could change where our Dicey logo lives relative to that new view, but in our case we actually want it to be inside the view, so we need it to be embedded, so we get this effect. So now that we've embedded our Dicey logo in its own view, let's go ahead and embed these 2 dice image views in its own container in the middle. And I'm going to use a different way of embedding. I'm going to go to Editor, and then I'm going to go to Embed In, and I'm going to select a view. So now the 2 dice image views have been embedded in its own view. And it's exactly the same thing as what we did before, but it's perhaps a little bit easier, a little bit quicker. And finally, for the roll button, I'm going to show you a third way of embedding in a view, which is to click on this button and then embed in view. So depending on which method you remember or you find easiest, then you can choose whichever way you want to do it. But they all do the same thing. So now we have 3 views, and they're all called views, so it's a little bit confusing. So we can go ahead and select it, and then click on the Identity Inspector and give it a label. So we can call this one the middle view, because it's right in the middle. And we can call this one the top view, and maybe this one the bottom view. So now we've got all 3 on screen, and we can collapse them, and you can rearrange them if you want to make sure that it says top, bottom, and middle, although be careful that you don't accidentally embed one of the views in another one. So by the end, you should have all of them aligned to the same indentation, showing that none of these are inside each other, but they are all inside the super view. And now we have our 3 containers, which can now be used to lay out these subviews or these items that are inside it. So, for example, our Dicey logo can now be aligned to the horizontal and vertical center of that top view. But notice that as soon as we do that, we get an error. If we click on this button, it tells us what the problems are. And it's because even though we've defined the constraints for the logo, well, the location of this container view is kind of ambiguous. We don't know where to put it for its X position or for its Y position, because it's currently kind of just hanging out in the middle without any constraints of its own. So how can we give it some constraints? Well, to explore that and more, I'll see you on the next lesson. In the last lesson, we created a bunch of these container views so that we can lay out the containing elements relative to the containers. But the problem is that we haven't given these containers any dimensions or positions of their own. We haven't specified how they themselves are going to be laid out, which is why if we add some constraints to the subviews, or the things that are inside these containers, well, it's still ambiguous because it doesn't know how to lay out these containers. In order to solve this problem, we're going to learn about something called stack views. And a stack view is exactly the way it sounds. It's a way for us to be able to stack views together, either vertically, for example in this case, our 3 views are vertically stacked on top of each other, or we could also create horizontal stacks, such as our 2 dice views. They're horizontally aligned with each other. If we take our top view and then hold down the command key and select the middle view and the bottom view, so we have all 3 selected, we can go ahead and embed them inside a stack view. So you can go to Editor, Embed in Stack View, or we can simply just select this button and embed it into a stack view. Now that they are in a stack view, Xcode knows how to align these 3 things relative to each other. But we've still got some problems because while we know how these 3 should be placed relative to each other, namely in a sort of horizontal column, we don't actually know where the stack view begins and ends. So in addition to putting these views inside a stack view, we also have to give the stack view some constraints relative to its super view. But this is relatively easy because we want that stack to stretch out so that it takes up the entire screen and to make sure that it doesn't go into the safe areas. Think about what you did for the background in terms of setting its constraint, and as a challenge, I want you to add some constraints to the stack view to make these errors disappear, and the stack view should be constrained so that it doesn't go into any of the safe areas at the top or at the bottom. Pause the video and have a think about this problem and try to solve it. Alright, so we've got our stack view selected and we're going to add some constraints. Now in my case, I want it to be 0 from all 4 sides, and instead of being relative to the super view, I want it to be relative to the safe areas. Now notice how when we click on the drop down, we can select safe area in most of these drop downs other than the top one. Well, in my case, the reason is actually because this top part of the stack view has already gone past the safe area. You can see where the safe area is, and you can see where my stack view ends. So if we bring it down just a little bit so that it's right next to the safe area, then if I try to add my constraints this time, you can see that the safe area now exists as a possible relationship. So let's go ahead and add these 0 to all 4 sides, but notice how my bottom constraint is no longer showing the safe area. So let's go ahead and simply add this as a 0 constraint to the containing view, and then we're going to add these 4 constraints and we can fine tune it using our attribute inspector. So if I go ahead and select the bottom of my stack view, so it should read stack view.bottom, you can see that currently it's set relative to the super view's bottom. So let's go ahead and change that to the safe area bottom and change that constant to a 0. And now if I hit enter, it'll be aligned relative to the bottom of the safe area. Now that we've constrained our stack view to all 4 sides, the next thing to do is to configure this stack. Now, notice when you drop 3 elements that are roughly vertically on top of each other inside a stack view, it'll automatically choose the vertical axis. Now, the next thing we're going to do is we're going to change the distribution to fill equally, because we want all 3 of these views that are contained in my stack to have equal heights along the vertical axis. And as soon as I do that, you'll notice some more errors will go away, and it'll know how to lay out these 3 elements even if it's in a horizontal orientation. Notice how it's avoiding all of the safe areas. Meanwhile, it's dividing the height evenly between all three containers. So now that we've specified our stack, it makes it so much easier to align these other elements. So our roll button, for example, can now be horizontally and vertically aligned in its container, which is of course now the bottom view rather than this one. So let's go ahead and add those two constraints, and it gets put in the middle. Now, as a challenge, I want you to put these two dice views in a horizontal container so that they are equally aligned to each other horizontally. So pause the video and try to complete that challenge. Okay, so as we did before, we select these two things and then we go ahead and embed them in a stack view. And because they're roughly next to each other on the horizontal axis, they automatically get placed in a horizontal stack view. And now we can select our stack and make it centered in the middle container. You can also adjust the spacing between the elements in the stacks. So for example, our vertical stack, if you wanted to have more spacing, say let's change it to 30, then you could have these elements spaced further apart. But in our case, I actually want the spacing to be minimal, just enough so we can actually see the edges of each of the containers, but I don't want them to have a lot of distance away from each other, so that when we go into the horizontal, there's enough space to go around. Now, for our horizontal stack, I'm going to change the spacing to about 50 to keep them a little bit closer together. And once you're done with using these containers, because we're only using them for layout, we don't actually want it to look like this in our final app, we can go ahead and select these container views and change the background to default or see-through. And now they're there for layout, but they're no longer obscuring our background. Now, the final thing I want to show you is notice how our roll button has been collapsed so that it's very small and fits precisely the size of the text that's inside. And this is because we've added alignment, so center horizontally and vertically in its container, but we haven't specified any sort of size constraints. So by default, it resizes itself to fit its content. So that means that if I had a little bit more text in here, then it will actually make it larger. But if we wanted a little bit of space around the text, then we would actually have to add our own width constraint. So we can specify a custom width and even a custom height if we so wish. So I'm going to change the width to 100 and the height to 50. And now I'm going to add my constraints. But notice that as soon as I added the width constraint, I get a warning here. And the warning tells me that there's a problem with auto layout because I have a fixed width constraint. And if we go over here, you can see that it tells us this problem in a little bit more detail. The width is set to always be 100. But what if we had more text in there? What if we had a longer piece of text that was being rendered? Well, then it will clip the text, right? It won't show the entire line. So this is what it's trying to warn us about. And there's a couple of ways of fixing this. So if we click on this triangle, you can see we can either remove the constraint, which will resize our label to the size of the content, or we can set the constraint, the width being 100, to being greater than 100. So this allows the label to extend if there's more text, or we can set it to greater than the minimum width, so to make sure the button doesn't shrink below the minimum size. So I'm going to select this one and click confirm. And now it's going to say that it should always be greater or equal to 100. So it means that if I didn't have a lot of text in here, let's return it back to our previous roll text, then it's going to make it 100. But if we had more text in there, then it's going to resize it to fit the text, which is exactly what we want. So now we've learned about constraints namely alignment and pinning constraints, as well as stack views, vertical and horizontal stacks, and also these modifiers such as the greater than or equal or less than or equal. And I think you're ready for a challenge. Head over to the next lesson where we've got a challenge for you to test your understanding of auto layout. And you're going to apply all of these things to a new app and see how well you've understood what we've talked about. Have fun on the challenge, and I'll see you on the next module. Hey guys, in this video, I'm going to walk you through the solution for the calculator layout challenge. So we know that this is what we're aiming for, right? This is what it should look like on portrait, and this is what it should look like in landscape. Notice a couple of things here. Firstly, we've got nicely stacked rows and columns, right? So it makes it a perfect opportunity to use the stack views that we've learned about. The other things are a couple of small details. Notice how between each of these buttons, there's a very, very small gap in between. So we're going to have to take into account of that when we create our layout. And finally, also notice how this 0 inside what seems to be a label is actually indented from the right. It's not glued to the right edge. There's a little bit of space there. So let's think about some of these things and try and lay out our interface. So of course we're going to go to our main.storyboard, and here you should see that I've already created essentially the user interface that you are aiming for. So this is very handy because it means that everything is already pretty much pixel perfect, whereas in reality you probably wouldn't get access to a file that's already been laid out for you. So you might end up with things that are a little bit more misplaced and, sized kind of differently. And it's your job to use these rules and these constraints to bring it together and make it look the way you want it to. So the first thing we notice about our user interface is that it's really regular. There's a lot of rows and a lot of columns. So let's start off by creating some stack views. So this seems like a natural stack, right? So if I'm holding down my command key and I'm selecting all 4 of these buttons, then I can simply go ahead and embed them into a stack view like this. And because they are roughly along the same horizontal line, they get embedded into this nice, neat little horizontal stack. Now, don't worry if at this point you see it's completely messed up the user interface. The point is not to keep it pixel perfect every step of the way, because as we change these rules and as we apply new constraints and new stack views, it's obviously going to evolve and change. All that matters is that the final thing looks like this. And in the process, we're going to be messing it up even more than this. So now that I've created one horizontal stack, it kind of seems to make sense that if I have one row here, one row here, one row here, row here, row here, row here. So I have 5 rows of buttons here. Now I'm going to go ahead and embed each of these rows into a stack view. And now you should end up with 5 stack views. We've got 5 horizontal stacks and this label at the very top. Now, if we go ahead and select each of the 5 stack views, as well as the label at the top, and drop all of these into a stack view, then it's going to create a vertical stack. Now, our interface is pretty much completely messed up, but that's not a problem. It's now laid out in roughly the relationship that we want. So all we have to do now is to add some constraints on top. Firstly, our vertical stack view, which contains all of the rows, is going to need to go to all of the edges. So we're going to put 0, 0, 0, 0 so that it gets stretched and fits to the entire size of the screen. Now the next thing to address is some of the properties of this stack view. So for example, notice how at the moment the spacing is massive between each of these rows. It's like 81. Instead, we only want that small space that you see here, right? Which, let's just call it 1 pixel, and let's see how that looks. So let's go ahead and change the spacing to 1 pixel, and you can see that this part now looks pretty much like the outcome that we want. But for some reason, there's a big gap here between these top parts and the bottom parts. So how can we make it distributed more evenly? Well, you might remember that we can change the distribution of the stack so that it's filled equally, like so. And the alignment, instead of making it leading, so everything all squished up to the left, we can also change it to fill, so that it fills the entire space that it's got access to, which is the entire width of the screen. Now, at the moment, if we look at each of these rows, they look a little bit messed up, right? So how can we make them look like the way that we saw in the README file, like this, evenly distributed and filled to take up the entire space? Well, we of course have to change some of the properties for each of these stack views. So let's start with the top one. And we're going to change the alignment from top to fill. And we're going to change the distribution to fill equally, so that they take up an even amount of space along that horizontal row. So that's now looking pretty good, right? And if we want to apply the same things to the rest of the stack views, then all we have to do is select them by holding down Shift. And now we've got all 4 stack views, which we're going to change the alignment to fill and the distribution to fill equally. So we're getting pretty close to what we've got in the README file, right? So now the only one that looks pretty weird is this bottom one, because in the README file, in the example, we kind of had the 0 button taking up twice as much space as these two. So there are certain ways that you can set this. Well, the simplest way is actually to just embed these two into their own stack view. So now, if we look at this bottom row, we have 2 items which are meant to fill equally. So this width and this width is meant to be equal. And then if we go into this second horizontal stack view, and we make it also fill equally, then we get the effect that we want, which is where this 0 takes up as much space as these 2 buttons. And everything is now more or less aligned. Now, if you're noticing that on the iPhone 11 or the X series canvases, and it's not going all the way down to the bottom, the reason for this is because for our main vertical stack view, we set the constraints so that they would go to all 4 edges. But remember that on the iPhone X series, there's actually a sort of home button of sorts here, where the user can swipe up so that they can go back to the home screen. So this area in black here is known as the safe area. But if you wanted the bottom of this stack view to go all the way to the edge, then you can double click on this and change that from safe area bottom to super view bottom, and change that constant to 0 so that there's no distance between them. And then you end up with this kind of effect. Now, it depends on you really, because usually it's not a good idea to put user interactive elements into the safe area, because it makes it really confusing when the user's trying to dismiss your app going to home, but instead they end up pressing on 0 or the dot. So I'm going to go ahead and select that constraint and change it back so that the stack view bottom is equal to the safe area bottom with 0 pixel distance, like this. And I'm going to show you how to address the next thing, which is, notice how R0 here is right up to the edge here. There's literally no distance between it and the right edge. But in the README file, you can see that there's clearly a big gap here, so it looks a little bit better. Now, how can we do this? Well, at the moment, we've got our label inside our stack view, and it is being asked to fill the entire width, right? That's what this alignment fill tells it to do. But if we wanted this to have a little bit of a gap, but none of these other rows to have a gap, then we have to embed this label into its own view. Now it's kind of inside a container. And let me just go ahead and make the background of this container see-through so that it doesn't actually affect our label. And then our label that's inside the view can then be asked to have some constraints. So, for example, we could set the constraint so that it's 0 from the top, 0 from the bottom, and then 20 from the left and 20 from the right. And now if we add our constraints, you can see that we're now getting that little indentation there inside our stack view. And that's it. That's the solution to this challenge. If you struggled with this challenge, I recommend playing around with this interface, seeing if you can remove the stack views, create new stack views, maybe switch things around a bit, and just make it a few times until you really understand what's going on here and what each of these settings and properties do. And just mess around with it. There's nothing that can really break. So change it up, change the alignment, change the distribution, change the axes, see what happens until you get a good grasp of how this works. Alright guys, another day, another app. And today, the app that we're going to be learning how to build is a music app, and it's called Xylophone. And in the process of building this app, we're going to learn how you can help yourself using the official Apple documentation and how to look things up on Stack Overflow. So one of the biggest questions that students always ask at this point is, well, when I'm coding along with you, I can see how the code works and I understand what's happening, but how did you know how to do that? Where did you find out this information? And I have to admit, I'm not a genius by any means. I don't know all the solutions, but I do know how to get to the solution by looking it up on Stack Overflow on the internet, as well as reading the official documentation to be able to understand the code that I'm writing. And that's what we're going to be tackling in this module. I really want you to understand how to solve your own problems so that you can create apps of your own. And by the end of this module, we're going to be building a beautiful xylophone app which will allow you to unleash all of your musical talents and impress all your friends. So we're going to be tackling this through a number of steps. We're going to be first setting up our skeleton project, and then we're going to figure out how to play sound using the documentation and Stack Overflow. I'm going to be exploring both of those things in detail. And I'm going to show you my 5-step process of solving any programming problem or figuring out how to do anything in programming. And then we're going to learn more about Swift functions, how to package functionality together, and as well as linking multiple elements to one IB action so that when we press any of our buttons on screen that it triggers the sound playing functionality. And finally, we're going to look at how to create functions with inputs, as well as how to play different sounds for different buttons using those functions with inputs. So we've got a packed schedule ahead of us. So once you're ready, head over to the next lesson and let's get started. As always, first things first, we've got to clone and set up the skeleton project. The skeleton project you can find at github.com/appbrewery/xylophone-iOS13, and you'll also find this link in the course resources page as well. You can just click on it there or just type in the URL. And once you're here, it should really be pretty familiar to you. We have to copy the GitHub link, and then we go over to our Xcode and either clicking on clone existing project or going to source control and clone, we paste in our URL and click clone. And then it's going to ask us, where do we want to save our project? And again, in my case, I'm putting it inside my development folder on my desktop. And then I'm just going to change the name maybe to Xylophone and click clone. Alright, so here's our cloned project. And the first thing I want you to do is to take a look at the main.storyboard, because we've already created the user interface for you. Now, it might be worth taking a look at some of the constraints that we've set up, and in order to see how they work. So you can see that we've got 7 buttons of decreasing size, so their width keeps on going down, and we've created that by setting the constraint to be slightly smaller each time. So this one has a constraint of 40, whereas this one only has a constraint of 15. And this is how we're able to create this cascading effect, which, if you look at it in the landscape, you can see it looks a bit like a real xylophone. Now, each of these buttons don't do anything yet, so we have to link them up if we want them to do something. So let's go ahead and open up the assistant view so that we can see our design and our code side by side. And now we're going to link our red C button, so this one, to the viewcontroller.swift file, which you can see up here, viewcontroller.swift. And then we're simply going to hold down the control key, click and drag somewhere around here, and we're going to create an action. And this action we're going to call key pressed, using camel casing. So the first letter is lowercase and every subsequent word has the first letter capitalized. And finally, we're going to change the type from any to be more specific. We're going to say that this is actually a UI button that we're linking up. And then we're going to click connect. So now whenever we tap within the boundary of this button, it will trigger this IB action and it will trigger any code that goes in between this block. So here's a challenge. Go ahead and test this link by printing the message "I got pressed" into the debug console down here whenever the red C button is pressed. And remember, you'll have to run the app to test this. Alright, so that's pretty easy. We have to use the print statement, and then inside I'm going to put in the string "I got pressed." And now if we run our app, because our IB action key pressed is linked to our red C button, when I press on the top button, you can see that the words "I got pressed" will get printed down here. But when I press on any of the other buttons, then nothing happens because we've only linked up the first one, which is exactly the way we want it to be. So that's it. We've set up our skeleton project, we've taken a look at how the design is built, and we're now ready to proceed to the next lesson where we figure out how to actually play the sound that we've included in here in the skeleton project. You can see that there's a sound file for each button, and you can play it or preview it in Xcode if you want to, just by clicking down here when you've got it selected. But we essentially want the sound to play whenever we press that red button instead of printing "I got pressed." And we're going to explore how to do that in the next lesson. So for all of that and more, I'll see you there. In the last lesson, we got our skeleton project off of GitHub, and we managed to link up an IB action with a single button on our main.storyboard. And that's the first button, this red button here, so that whenever it's pressed, the words "I got pressed" get printed into the debug console. We're now pretty certain that our IB action is linked to that red button, and we can trigger some bit of functionality to happen when we press on the button. Now, of course, the actual functionality we want is to make it play a xylophone note, but we don't know how to do that yet. Now, I could simply tell you, well, here's step A, this is what you do, but it doesn't answer the question of, well, how did I know how to do it? Instead, I want to show you how we can use the application programming interface documentation, which is quite a mouthful, but essentially just refers to the components that Apple have already built into iOS that we can simply tap into and use. Because application programming interface takes like a whole second to say, but people will often refer to it as the API. So the API for your TV would be something like turning the volume up and down, or switching the TV on and off, or changing the channel number. So the API docs for your TV would then be the instruction manual, which you probably threw away. But luckily for us, the Apple API docs are hosted online, and you can find them at developer.apple.com and then in documentation. So this is basically the instruction manual for programming iOS apps. But just like most manuals, they're so information dense. And if you dig into each of these, you'll find that they have endless links after links after links, and It's really hard figuring out exactly what you need to do from the documentation. Just like when my mom has a problem with her TV, she'll always call up tech support, which is basically me, instead of reading the actual instruction manual for her TV. Well, programmers also don't usually start with the API documentation. Instead, we tend to use the programmer's tech support, which is Stack Overflow. Now, Stack Overflow is basically a Q&A website, like Yahoo Answers or Quora, but for people who code. So let's say I had a question, and because programmers are programmers, there are some crazy questions on here and some brilliant answers. If you ever wanted to know what is the most efficient way of pairing socks from a pile, well, you could search on Stack Overflow and you'll see that somebody has asked this question 6 years ago with 3,000 upvotes. So it was a really popular question. And we have a bunch of answers, in fact, 2 whole pages of answers here. And the top answer got a lot of upvotes as well as the check mark, which means that the original person who asked the question has accepted this as the answer. So if you ever want to know how to sort your socks in the fastest way possible, well, apparently you could use a hashing algorithm. Now, because there are literally millions of things that you can make your iPhone app do, it would be impossible to remember all the names of those things that you need to use, or the exact code that you would need to write. Even things like how to change an image in an image view. You don't need to memorize the code imageview.image. You could just look it up. And in the answer, people will often provide a code snippet where they show you the answer or how to achieve what you want to do. So in this case, here's your image view outlet dot image equals your image, and then we would be able to set the image view. So whenever you want to solve a problem in programming, or when you want your code to do something specific, then I recommend following this 5-step process, which we're going to go through by trying to figure out how we can get our app to play sound. Step 1 involves Google. Step 2 involves going to Stack Overflow. Step 3, implementing the code that you find there. Step 4, looking up what the code means in the docs. And step 5, customizing the code for your needs. And we're going to go through this step by step. So let's start with the first one. Now, ask any experienced programmer and they will tell you that a large part of getting good at programming involves getting good at Googling. And 2 people with the same resources, say a computer that's connected to the internet, don't always end up with the same solutions. And some people might not even find a solution. So when you're doing mobile app programming, I recommend following this search structure. So first, what I want my app to do. Secondly, which programming language am I using? And third, which resource do I want to come up? In our case, our search query will look something like this. Play sound using Swift on Stack Overflow. So let's try it out. In Google, I'm going to put in those exact search terms. Play sound Swift using Stack Overflow. And what we're looking for is a website that starts out with stackoverflow.com. So we're basically leveraging the power of Google's search engine to find the most relevant result on Stack Overflow. Now you saw that we could also just search for our query in Stack Overflow itself, but I find that Google is far better at search algorithms than any other company. Google looks at how often a search term leads to a click of a link, and then whether if the person stays there, which means that they found the right resource for that search term, or whether if they head back, which means that they didn't find the right one and they have to look through the list. So step 1 basically ensures that you get a more relevant result. And once we've found the Stack Overflow answer that seems to most closely match what we want to do, in this case the question is how to play a sound using Swift. That sounds pretty close to what we want to achieve, right? Well, then we can go ahead and head over to Stack Overflow and take a look at the question and answer there. This takes us on to step 2, exploring the question and answer on Stack Overflow itself. And in this case, it's a good idea to take a look at the question to assess whether if your own query is similar to what this person is asking for. In this case, they want to play a sound using Swift, And they had some code that worked previously, but it doesn't work in newer versions of Swift. So they want to know, how do you do it now? So if we scroll down, you can see that there are a total of 13 answers that have been provided. And people will often compete for highly voted questions because it means that their answers will get more exposure and they're more likely to collect reputation points. So every time you upvote somebody's answer or accept their answer as the correct answer, they get reputation points, which you can see down here. And this is kind of like a gamified system to incentivize programmers to help each other so that they can gain reputation. And as you get better in your skills, it's a good idea to pass it forwards and help people with what you know. And also when you go to job interviews as a programmer, by mentioning a really high reputation on Stack Overflow, it also counts for a lot. So it helps to help others. Now over here in the accepted answer, so the one with a green tick, you can see that they provided code snippets for how to implement this functionality of playing sound using various different versions of Swift. So Swift 2.3, 3, and 4. I recommend looking for the latest version and anything from Swift 4 onwards, so Swift 4, Swift 5, 5.2, these are all pretty similar. As long as you see something that is Swift 4 or plus, then you should be alright implementing the code. The order of the answers are presented in a specific way. The first one that you will see is often the accepted answer, so the one with the green tick on it. And if you scroll down, you'll see the answers ordered by the number of upvotes. At least this is the default order system. Now, because everything in development and programming moves on so quickly, just because the person asking the question accepted this answer back in, say, 2013, it doesn't mean that it's still the best answer. I always recommend students to take a look not just at the top answer, but the top 3, to see if there's something that's more relevant to today. So now that we've found our answer on Stack Overflow, it's time to go to step 3 and implement the sample code in our app. In this case, I'm actually going to use the top answer. Not only was it accepted, but it's also got a whole bunch of different versions, and it seems to be the most compatible with where we are today. Let's try and use this code snippet to implement it in our code and try to get our app to be able to play sound. So the first line of code I see here is this import AV foundation. I'm going to put that into our project. Just below where we are importing UI kit, I'm going to import the AV foundation module. Now these modules are essentially the libraries of code that Apple has written to allow us to interact with different parts of the hardware and to perform different tasks. So in this case, the AV foundation refers to the audio-visual foundational module. Now that we've added the capability of interacting with the audio hardware, which is what this line does, it's time to actually set up our audio player. Notice how here we're creating a variable called player, and we're setting it to be a AV audio player. So we're going to do the same in our code. So we're going to create a variable called player, and then we're going to add a colon to specify the data type of our player, which is going to be AV audio player. And then we add a question mark at the end. Now, we're going to ignore this for now. I'm going to explain it in a huge amount of detail later on. But for now, let's focus on trying to get our sound playing ability to work first. The next thing I'm going to do is I'm actually just going to copy this entire thing wholesale, the rest of the code that's in the code snippet, and simply paste it into our project just above the last closing brace, so right about here. Now, once I've pasted it in here, now we're going to have to do a little bit of modification because we don't actually have a resource called sound name and with the extension of MP3, because we have sounds that are named like this, C.wave, D.wave, so we have to change these. So I'm going to change this to a capital C, which looks exactly the same as this sound file, and I'm going to change the extension to wave, which is WAV, not WAVE. So now I've modified the sample code in the Stack Overflow code snippet to work with our resource, and I'm going to leave everything else as it is. But because this play sound lives in a separate block of code, I'm going to trigger it inside our key pressed IB action. So I'm going to delete that print statement and instead call this play sound functionality, so that when we press the red key, this block gets triggered and it looks for this thing called play sound, it finds it right here, and then it executes all the code in this block. So let's hit run and see if it works. Alright, so here's my app, and I'm going to press on the top button, and you can hear that a sound is being played. So now that we've achieved our first 3 steps, we've managed to implement the solution we found from Stack Overflow. We're now ready to head over to step 4, which is to look at the Apple API docs to understand what the code does. I'm firstly going to delete all of the existing comments that the person who provided the solution has put in there, so that we only have the code. And then I'm going to head over to the API documentation. And you can find that by heading over to developer.apple.com/documentation. I'm going to search for that thing that we imported, which was called AV Foundation, to see what it does. And the first result is the AV Foundation module that comes up. And this, as you can see, allows us to work with audiovisual assets. So, for example, our sound file, to control cameras, to process audio, and to configure audio interactions. So it seems to do a lot of things. And you can see that the documentation is split into different topics: playback and editing, media capture, audio, etc. If we read through this, you can see that there's one part that allows us to play, record, mix, and process audio. Playing audio is pretty much what we wanted to do, right? So if we click through on this link, you can see that it gives you more details on how to play sound using AV Foundation. And it says that for playback of a single track, use AV Audio Player. And if we take a look at our code, well, the AV Audio Player is exactly what we're using to play our sound. Now, if we move down in our code, we can see that we've got this thing called a bundle. Now, what exactly is a bundle? So let's try and understand that by looking inside the documentation and searching for a bundle. Now, if you click on the first link with the capital B for bundle, then you can see that it's simply a representation of the code and resources stored on the disk. And in our case, we're using the main bundle to locate our sound file resource. So if we ignore all the sort of programming keywords in pink, you can see that we're essentially creating this constant called URL, which is looking for a resource called c.wave in our resources, so the disk area allocated for our app. And then the next thing in our code that we're using, the next sort of word that's really unfamiliar, is the AV audio session. I'm going to copy this and look for it inside the docs by, again, going to the search bar and typing it. And once we're here, then we're going to look for this thing called set category. What does set category actually do? On this page, AV audio session, I'm going to hit Command F to find this set category. And if you look through, you'll see where it tells us all about it. So here we could click through to this link and learn more about this set category and what it does. Here we have a bit of discussion on how it works. And you can find out that there's actually a whole bunch of categories that we might want to use. And the one that we're using is something called playback. So on this page, we can see there's ambient, which means that the sound playback is non-primary. So your app can be used successfully with the sound turned off. So then there's other types like solo ambient or record playback. And this is the one that we're using, which is saying that the category for playing recorded music or other sounds are central to the successful use of your app. Given that it's a musical app, then playing our sounds, playing those notes is pretty central to the success of our app. It's not just like background music in a game or some sound effects. It's actually really important for that sound to come through. So by setting that category, even if the user had their phone on silent, we will still be able to get our sound played because we're saying it is that important. And if you read through the documentation, the entire documentation on AV audio session, which is what I did, then you'll find that there's this paragraph that explains to you that when in iOS, when the device is locked, the app's audio is silenced. In iOS, setting the ring silent switch to silent silences any audio being played by the app. So this is the default audio session. And we had to use this line of code to change that default audio session to a new category so that we can actually get our playback happening even if the phone is in silent mode. So notice how we're always researching the parts of the code that are sort of purple in color. Well, that's because by the end of the course, you will know full well what each of the pink parts do, because these are the Swift programming concepts, but you won't know all of the purple parts because these come from Apple's application programming interface documentation. So there are a myriad of things that you can do in there, anywhere from playing video to recording sound, and it's not possible to cover all of the things that you can do. But once you've understood how the programming works and you know how to search and find the answers to your problems, then you'll be able to research through the code just as we're doing right now. If you continue through this process of researching what each of these things do by using the documentation from Apple, then you'll get a pretty good idea of what our code is doing right here. We're basically grabbing hold of this c.wave file in our app resources right here. And then we're making sure that our sound gets played even if the phone is on silent. And then we tell our audio player that this is the file that we want to play, c.wave. And then we actually play it. And if there were any errors, then we actually catch those errors and print it out. Now, this is a good time for a quick tip. Now, when you search for things in the Apple developer documentation, you get the full documentation, and it is large. Very often, when I'm using something new that I've never come across before, I tend to try and read the entire page on it and look through the links and try to get an overview of what I'm doing with my code. But when you're just trying to look up things quickly to see what they do, you can also simply hold down the Option key on your keyboard and click on various things in your code. So as soon as I've got my Option key held down, I've got this crosshair that shows up. And now if I hover over things, such as my AV audio player or my bundle or AV audio session. So basically anything that's not programming. So not the pink words, which are to do with Swift programming keywords, but the purple parts, which come from Apple's APIs, then we can click on it and it will show us the quick documentation. So it's kind of like a shortened version of this. It only contains the top part. And you can get a quick idea about what each part does, or take a look at it in detail in the developer docs. So that's just a neat trick for you. Now we're finally ready to move on to the last step, which is to customize your code. Now, reading the documentation can be quite a long and laborious process. But once you've implemented the code and gotten it to work, then the documentation can be really helpful to help you figure out what each of these moving parts are doing and what their roles are. Once you've more or less understood what each line of code is there for, well then it's time to make it your own. Because not everything that's in the code is necessary, and the person who wrote the highest upvoted answer is not Steve Jobs, right? So they might also be wrong, or they might be doing things that you don't actually need. And this step is probably the hardest part yet, because it requires a little bit more knowledge of Swift programming. And you'll be able to do this yourself once you've finished the course. But for now, I'm going to vastly simplify the code so that we deal with the harder programming concepts after we've mastered the foundation parts. If you open up the README file here, I want you to copy all the code that's inside the replacement code. And go ahead and copy it and replace everything that's currently inside your view controller with this new code. Now, this, of course, relies on the fact that your IB action was indeed called key pressed, and it was spelled exactly the same way. Be sure to head into the IB action and right-click on your button just to make sure that that is exactly the same as this, so that when you run your app, it doesn't crash. And we're going to simplify all of the code that we had before down to just these few lines. Now it's much simpler, but we've gotten a little bit less functionality than before, but it's fine for our needs. We're still using the AV Foundation library from Apple. We're still creating a new AV audio player. And then we're setting our URL to be the location of our c.wave sound file in our project. And then we put this file into our player, just like loading up our CD player with a CD. And finally, we tell it to play the sound. Now, remember, because we took away the parts which allow our sound to be played when the phone is on silent, if you run this app right now and your phone is on silent, on your physical device, then it will not make a sound. But as long as you switch it back onto normal, then it will be fine. And this is all of the code that we got from our searching and our documentation reading, and we now have code that we understand, as well as having implemented for our purposes. Now, all that's left to do is to understand more of the Swift programming concepts behind this code. For example, functions and what it's doing in our code. For all of that and more, I'll see you on the next lesson. Welcome to another lesson on Swift Deep Dive. In today's lesson, we're going to talk more about functions. And we've already seen functions in action, so we know that there are two stages to any function. First, the part where we create the function, where we have the func keyword and we specify the name of the function, and then we describe what the function should do. And then there's a second part where, some point down the line, where we call the function and the computer will look to see where our function was defined and do all of the stuff that we said it should. So what is the problem that a function actually solves? Well, let's say that you had a little robot that you bought and you need it to fetch some milk from the store. So you would have to tell it a whole bunch of instructions. Say you had to do it via print statements. You would have to tell it to leave the house and then move right 2 blocks, move up 4 blocks, move right 2 blocks again, and then buy the milk, and then all the way back with all the instructions in order to get your milk. So if you had to do this day after day, then your fingers would hurt from typing, literally. So how can we make this better? Well, what if we could take all of these instructions and package them together into a function? And this is essentially what our functions do. It packages a whole bunch of instructions into a block of code which can be triggered simply by calling the function name. So now we can identify all of these instructions by a simple and descriptive name. So the next time you want your robot to buy you some milk, you can simply just call getMilk, and it will be able to look up what it needs to do through the getMilk function and then be able to perform that task. much shorter and much less typing. So here are the two parts of the function. The part where we create the function looks like this, and the part where we call the function looks like this, where we simply specify the name of the function, so in this case it's called getMilk, and then we add a pair of parentheses which are empty, and a little bit later on when we look at more complex functions, we'll learn what we can put inside these parentheses. But if we simply just want to trigger a block of code like this, then we just need to call our function like this. Now, if you open up your playground again, or simply create a new playground if you can't find the other one, then delete everything that's currently inside to start with a clean slate, and we're going to create a function of our own. We're going to use the func keyword to specify that we're creating a new function, and then we're going to give that function a name, so we're going to call it greeting, and then we're going to add a set of parentheses, and then a set of curly braces. If we break this line down, this is the keyword that creates a new function. This is the name that we've given the function. The round braces, or the parentheses, is where we can put some potential inputs. And the curly braces is where the body of the function will go. So when this function is triggered, it's going to look inside these curly braces to see what code needs to get executed. Now, more commonly, you'll see a function formatted like this. And in fact, every time you create a new function, as soon as you open up the open curly brace, if you just hit enter, Xcode will automatically insert the closing brace for you in the right position. And this makes it much easier to avoid these missing curly braces and make your code a lot easier to read. Let's say that in our function, when it gets triggered, it's going to print hello to the debug console. So if we go here, click on it and hold and change to manually run, I can manually select which lines of code I want to run until. So if I click on, say, line 6 or line 7, and it's going to run all of the lines above. Now you might expect something to happen, but nothing happened. Why? There's nothing wrong with your computer. It's actually because it's not enough to just create a function. You also have to trigger it or execute it. And in programming, we call that calling the function. So on line 6 or 7, we can call the function by simply tapping into its name. And you can see that as soon as I do that, we get a little F symbol here, F for function, show up, and it shows us that, hey, did you mean to call the greeting function? And yeah, I did. So I'm going to hit enter, and it automatically inserts the rest of the code for me. So now if we try to run our code, and including the line where we called our function, well then you'll see it actually trigger all the code in here, and the word hello actually gets printed. Remember, the func keyword is used to create a set of instructions and package it with a name, and the actual name plus the parentheses is where you actually activate or call that function. Here's a challenge. Change the code so that you get the word hello printed 4 times. Now, there's a few ways of doing this, and as long as you can get the words hello printed down here 4 times, then you can consider yourself successful. Now, one way of doing this is to simply copy our print statement and have it execute 4 times when we trigger the greeting function. That will get us our hello printed 4 times. But the alternative is we could have also just called our function 4 times, right? So if I press play, you can see that this line goes to find greeting, prints hello, second line, prints hello, third line, prints hello, and so on. We get the same effect. Now, the last thing I want to talk about before we move on from functions is this idea of scope. Scope is really important because it describes when a function can be accessed or can be used. Just as if I have an apple tree in my garden, then only myself or members of my family can actually pick apples from the tree. Whereas if that apple tree was in the neighborhood well then everybody, all my neighbors, everybody on the street can pick from that apple tree. So here I've got two functions, one called greeting1 and the other called greeting2. And they do something slightly different. This one prints hello and this one prints hey. Now, inside each of these curly braces, it's a block of code. So you can view these as the walls of a house. So that means that if I was to create a variable, say inside greeting1, let's call it my name, and we'll set it to equal Angela. I can actually only use this variable, my name, inside greeting1. So let's try and print my name. That is perfectly acceptable. But if I try to do this inside greeting2, and I try to run it, then there's a problem here, because this my name is an unresolved identifier. It doesn't know what it is because it was created within the four walls of greeting1. So it's only available for use inside these curly braces where it was created. Similarly, if I had created my greeting2 inside the boundaries of my greeting1 function, so greeting2 is now nested inside greeting1, well now I can't actually call greeting2 outside of this boundary. So this doesn't work and it'll give me an error, and the only way I can trigger it is by moving it inside of the block where it was created, so namely right here. So these curly braces matter a huge deal, and that's why when you're coding, especially when you're creating functions, it's really important to keep them indented in such a way that you can always follow the closing brace vertically up to the line where the opening brace is located. There's a couple of tricks here. You can double click on the closing brace and it'll highlight the entire block for you. Alternatively, you can find a closing brace and hit the left and right key on it and it'll flash the matching opening brace just to show you where the boundaries lie. If you have your indentation really off and you're a bit messy, it might help to hit Command A to select everything and then go to Editor, Structure, and click on Reindent for these closing braces to be placed in the position where they are supposed to. And as you get used to this way of indenting closing braces, at some point your eye will be able to see easily that this is a block of code and this is another block of code. The best way of making sure that your indentation is correct is whenever you find yourself creating a opening brace, simply hit enter, because Xcode will then automatically insert the matching closing brace, and that way you'll always have the proper indentation. So that's all on the most basic type of functions. The next thing to do is complete the function 1 assignment. In this lesson, we'll learn how to link multiple elements to a single IB action. And in the process, we'll also learn how to differentiate between the buttons that the user has pressed. Once we figure this out, we can turn our app into a real xylophone and play a different sound for each button. So how can we know which button they pressed? Well, a simple option might be simply creating a IB action for each and every button. Now, that's not the best option. Firstly, because it's going to be really tedious to do that, and we have to click and drag almost 7 times in order to achieve this. And secondly, because it creates way more code than necessary. So what else can we do? Well, if you go ahead and open up the assistant so that we can have our main.storyboard on the left and our code on the right, then notice when we hover over this little circle, it already highlights that we've linked to the C button. Well, if you click on this little circle and hold and drag, Well, then you can drag this IB action for it to be linked to all of the buttons on screen. And this is very quick and it doesn't require you writing any more code. And now when I hover over the circle, you can see it highlights all of my 7 buttons. So I've managed to link all 7 buttons to the same IB action. So that now, whenever any of these buttons are pressed, then it's going to trigger this code block. And you can test this if you simply run the app and click on all the buttons. Now, notice that no matter which button I click, it's still going to be triggering the play sound function, which has the functionality of playing my C.wave file. So every button is a C sound. What we actually want is a different sound for each button. But to do that, we first have to be able to identify, well, which button was pressed. If you look closely at our IB action, you can see that it's actually really similar to the functions that we just learnt about. It's also got the func keyword, it's got a name, it's got a set of round brackets where we said the inputs go into, and then it's got a code block, which has the curly braces. And in between the curly braces, we tell it what it needs to do. All that's different here is that it has this IB action annotation. And this shows that it's linked to the interface builder. The IB is the interface builder part. And the other difference is that in this case, there's actually something inside these round braces, rather than being simply empty. Now, this part inside here are the inputs to our function. And unlike the functions that we've created so far, this function is not actually called by us. It's not triggered like play sound, where we call it and it gets executed. There's nowhere in our code where we call key pressed. And this is because this function actually gets called when the linked button gets tapped and when a touch gets detected on one of these buttons that it's linked to. And when that happens, the identity of the button that got tapped gets sent over to this function that it triggers inside this input. So we can in fact use this input to get information about the button that triggered it. Inside this IB action, just above our play sound, I'm going to go ahead and print what is the value of this sender. So if we go ahead and run our app again, and now when I press on, say, the first C button, you can see that what gets printed is some information about a UI button. This corresponds to the sender right there. So it tells us the frame of the button, whether if it was opaque, whether if it was auto-resized, what its tag is equal to, and a bunch of other things which are related to how it's displayed. This is the identity of the button, essentially. But we can actually dig a lot deeper. Let's try and print out the background color of the sender. Think back to how you managed to get the image property from the image view, and go ahead and try to print out the background color of the button that got pressed. Pause the video now and try to complete this challenge. When we had a image view, what we would write is image view dot image, and we would get access to the image property, which we were then able to set, or we could then print. And now what we want is the sender, which we know is a button. So it's going to be one of these 7 buttons. And these buttons all have a bunch of properties, including a background color. So that's what we want to be able to print. So we can tap into our sender, and then if I type dot, I can access its various properties, including its button type, background image, and if I search through this, I can find something called a background color. And down here it tells me that this is going to correspond to the view's background color. So let's hit enter. And now if we hit run and we press on any of these buttons, then you can see that we're getting the system yellow color or the system orange color. So let's click on the purple button and you can see that we got the system purple color. So it's able to tell us the color of the button that got pressed. So remember that any of these properties that you see in the attribute inspector, we can tap into using that dot notation. So wouldn't it be cool if we could actually just simply get the title of each of the buttons? Because we have our C, we have our D, and they correspond to the names of our sounds. Instead of printing the background color, can you figure out how to print the title of the button that got pressed? Try using the 5-step process that we used for figuring out how to play sound to figure out how to print the title of the button that we pressed. So that if I press this one, I get C printed. If I press this one, I get G printed, and so on and so forth. Pause the video, go through the process that you learned, and try to complete this challenge. Did you have a go at printing the button's title? Well, there's actually a number of ways you could have completed this challenge. Let's take a look together and let me show you the 3 approaches you could have used to solve this problem. Alright, so the first one we've got on Stack Overflow is how to get the current title of a button. Let's click on it and let's see the answer. So we can tap into the sender.title, or we can tap into the sender.titleLabel.text. And if we take a look at some of the other answers, say this one, checking UI button title in Swift, then you can see that you can use button1.currentTitle. So there's a lot of ways of doing the same thing, and often you'll come across different answers. The simplest in this case is to simply tap into the current title. And you can see that this corresponds to the current title that's displayed on the button. But another way of doing this is, of course, tapping into the title label and getting the text that's in the title label. Alternatively, we can get the title for a particular control state of the button. So when the button is normal, what is the title? So there's lots of ways of doing the same thing. But in my case, I'm going to keep the simplest one, which is sender.currentTitle. So if I hit run now and I press on each of my buttons, you can see that I've got F and this one is G, A, B. So I'm able to get the value of the title by using this code. So now we know that we can get hold of the title, which is using the sender.currentTitle, and that title corresponds exactly to the name of the sound file that we want to play. We just have one problem. How do we move that information from here inside the IB action into our play sound function? How can we get it to go from here to here, so that when we press the D button and our IB action triggers, our D.wave actually plays? In order to do that, we need to learn a bit more about how to create functions with inputs and how to use it in our function. So for all of that and more, I'll see you on the next lesson. Welcome to another Swift deep dive. The goal of this lesson is to really understand the Swift syntax behind functions with inputs. Our current problem is that when our xylophone key is pressed, we want to pass over the title of the button to our play sound function. To solve this problem, we have to learn about function parameters, arguments, and data types. Now, if you think back to the greeting function that we created earlier on, all it does is say hello. But what if we wanted it to do something slightly different every time? What if, say, we wanted it to greet whoever came to our house? So it would have to say, hello Angela, or hello Jack, depending on who's actually at the door. How can we pass the name of that person to the greeting function as an input? Well, this is how we might create a Swift function that can take an input. So that way, the input can be incorporated into the body of the function to do something different every time. In programming lingo, the input is called a parameter. And the parameter is a bit like a variable without a value. All we have to do to create it is to give it a name and then give it a data type. So here would be the name of a parameter, and then it would be a colon, and then the data type of that parameter. Previously, when we were creating variables or constants, we've kind of just ignored their data type. But in fact, every variable in Swift gets assigned a data type when it's created. This means that the variable can only hold data of a particular type. So in this case, we have a variable called Angela that's holding a int type data. So you could also create this like so. And here, after a colon, we specify the data type of the data that's going into this variable. Now, how come we were able to create our variable like this without assigning the data type? Well, Swift also has a capability called type inference, which means that it's able to infer the data type based on the data that you've put into the variable. So in this case, our data is a whole bunch of whole numbers, right? There's no decimal places and there's no text. So this is assigned the type or the data type of an int. Now, the thing about the data types are that they have to stay the same. So if you create a variable that's meant to hold integers, well, it can only ever hold integers in its entire lifetime. And if you try to fit a different type into the variable that holds integers, well, it's not going to fit. It's just like those children's toys, which you have to fit a particular shape through a particular hole. And if you try to fit a star through a square, then it's not going to work. Let's see Swift data types and type inference in action. Let's go ahead and create a new variable, and I'm going to call it my age, and I'm going to set it to equal 12. Now, in this case, because we made this variable my age store a piece of data that is a whole number, then my age actually gets assigned the data type of int. And we can confirm this by holding down the option key and clicking on the name of our variable, and you can see that this is the data type that it managed to infer from our value right here. Remember that we can change the data that's stored inside a variable by simply setting it to equal a new piece of data. But we can never change its data type. So if I decided this was going to be equal to 3, then this is not going to work. It's going to give me an error, and it's going to say that cannot assign value of type string to type int. So my age is of type int. 3, this text here is of type string. So there's a mismatch on this line right here. Now, if you change the data type of the variable when it was first created, then it wouldn't give you any errors. It would be able to accept a data type of string, but now if we hold down Alt and we click on this, it's now assigned a data type of string, and it can forever only hold string data. So this will now give us an error. Now, instead of letting Swift infer which data type we want, we can also assign it at the point where we create the variable. And to do that, we add a colon, and then we specify the data type. So in this case, it would be a string. And all the data types start with a capital letter. So we could say it's a string, or we could say it has to hold an int. Now notice how the assigned data type will override whatever value you put in there. So this line has a complete mismatch, and we get an error. Because this my age is of course of type int, because that's what we said it would be. And then we try to make it hold a string or text data. So that doesn't work. It has to be matching with the data type we specified. So now that we've understood about these data types, let's go back to creating a function with an input. When we create our function, we specify the data type of the input that we're expecting. And when we call the function, we call the same function name, and then in between the round brackets, we specify the input, or in programming, it's called the argument. So the parameter is the name of the input. The argument is the value of the input that we actually pass over when we call or trigger the function. Let's create another function called greeting2, and this function is going to have an input parameter in between these round brackets. The input is going to be called who to greet, and it's not going to have a value, but it does need a data type. So the who to greet, which is the name of the person that this function has to incorporate, is going to be a string data type. And that's it. So this is almost like what we did for creating a variable, other than giving it a value, and we're not using that var keyword. Now we're planning ahead. When this greeting2 gets triggered, what do we want to happen? Well, we want to somehow incorporate this who to greet variable. So let's say that we had a printed message which just says hello, and then it says the hello to the who to greet. But of course, in order to insert a variable into our string, we have to use our string interpolation, and then we can write who to greet inside. So now if we call this function greeting2, you can see that it automatically inserts the name of our parameter, who to greet, and then here we've got a little placeholder to specify the value. And whatever we put in here is going to be assigned to this variable, and then it's going to be printed out right here. So let's put in a value of Angela. Now if I run all of my code and this line triggers, then it's going to print hello, and then it's going to add that name Angela. So that Angela got added in as the input when we called greeting2. So it moves to be the value of this parameter who to greet, and then it gets used inside the body of the function. Now try calling this greeting2 function that you've created with some different values and see what you get. So I could say greeting2, and I could say Jack Bauer. And now if we run our code, you'll see that it'll write hello Angela, hello Jack Bauer. Our greeting function is no longer always doing the same thing anymore. Instead, it's adapting to whatever input we give it, and it's able to achieve different end outcomes. So even though once we've created a function, we can't really change what's going to happen with that function ever again, but we can still make it do different things as long as we provide different inputs. Functions with inputs vastly improve the reusability of our functions by providing parts that can be modified. So if you think back to the analogy of our housekeeping robot, it'd be really useless if it could only ever fetch milk. If we had an item to fetch input, then we can tell it to get bread one day and then newspapers the next day, and we can use that input within the body of the function. So now that you've seen how you can create functions with input and how you can call them later on, it's time to complete the functions2 coding exercise and complete that assignment. Now that we're all skilled up on functions with inputs, we're finally ready to complete our Xylophone app. Given that we've just learned all about function parameters and function arguments, I'd like to start this lesson with a challenge. Can you modify the play sound function so that it can take a string input, so an input of the data type string, and it's going to be called sound name, and then use that input instead of this hard-coded C letter. And finally, pass over this sender.currentTitle when you call the playSound function, so that when you press any of the keys, it will play the corresponding sound. So pause the video and try to complete that challenge. Alright, so first things first, let's add an input to this function playSound. Let's modify it. And we said that we were going to call the input sound name. And then we were going to give it the data type of a string. So now that we've modified our function, we can now use this sound name inside our function. And we're going to use it to replace this resource name. So instead of using just C every time we want to play a sound, we're going to use that sound name that gets passed in. And that could be any one of the titles of our buttons. So now when I play sound, I'm going to pass over the sound name. Notice how it's telling me that I'm now missing an argument for the parameter sound name. And if I click on it, I can say fix. So now it adds the parameter name, which is what we specified here, and it's expecting a value. Now that value is not going to be something I'm going to simply type out, D or C. Instead, it's going to be based on what the sender.current title is. So I'm going to cut it from there and paste it in here. And then I'm going to delete my print statement. Now, the final thing that we actually have to do is we have to click on this and simply click fix on one of these options. Now, the one that I'm going to choose is an exclamation mark, and the reason why we need it and why we get that error is because the sender.current title has a data type that is something that we would call an optional string. So the optional comes from that question mark, and it's because that we could have a button whose title is actually nil. It doesn't exist. In which case, we would be playing around with some non-existent value, and we'd be trying to pass it over to our playSound function, and then we would try to play a non-existent value, and then our app will just come tumbling down. So the reason why this is an optional, and it forces you to put in an exclamation mark, is because it forces you to check and think, is there a situation where one of my buttons might not have a title? And we can see that out of all of the buttons that's linked to our IB action, they all have a title. So there's really no case where this can fail. So we can safely add an exclamation mark to say, don't worry, we've checked. It's always going to have a title. So we'll just send it over as the input to our playSound function. So now if I click on the C button, sender.current title will be equal to C, and then C becomes the sound name, and C gets put in here. So then it plays C.wave, and it will change that depending on which button I press. So now let's run our app, and if I go ahead and click notice how every single key now has a different sound. And we've now completed our xylophone app using a bit of knowledge about Stack Overflow, about Google Search, as well as the Apple documentation for iOS programming. So run your app and play the xylophone to your heart's content. And once you're done, we're going to tackle a boss challenge.
Subscribe now and press the bell icon. Never miss an update.
Hi guys, it's Angela from the App Brewery, and in this module we're going to be learning how to make an egg timer, and in the process we're going to be learning about control flow, if and else statements, switch statements, dictionaries, optionals, a whole lot of goodness. By the end of the module, you will have built this beautiful egg timer app so that you will be able to time your eggs to perfection. So if you want soft eggs, you'll never have to eat hard eggs again, unless you like hard eggs, in which case you'll get really solid eggs. And you won't have to be like Rocky, drinking raw eggs. But once you're ready, go ahead and download the skeleton project and clone it in Xcode. And then head over to the next lesson and we'll get started. Once you've cloned the starting project, we need to do a bit of setup. This will give us a chance to understand the user interface of the project stub and link the storyboard to the view controller. The first step is to take a look around the project, most importantly the main.storyboard. So here we've got a title label, and the first thing I want to point out is if you want to have a large font size in your label, But if you want it to also be able to render on a smaller screen size, say for example in this case, you can see that our text in our label has been truncated. So our user can't actually see the full message. Now there's two ways of solving this. One is by changing the number of lines to 0, which means that there's now no limit to the number of lines, and it will try to keep the font size while creating as many lines as needed or that can fit into the space. So for example, if I added a bit more text, you can see that it will also overflow because we run out of space in the vertical dimension. So in addition to setting the font size to 0, the other thing that you can do is to change the auto shrink to have a minimum font size. So you can say that, well, we can shrink the font size, while normally it's 30, we can make it go down all the way to 15, so that if we had a lot of text, then it will simply just reduce the font size and keep everything visible. So those are two ways of manipulating labels so that the user will be able to see the text on all screen sizes. The next thing to notice is that there are 3 egg buttons, soft, medium and hard, and there are 3 egg image views. Now if you click on each of these buttons, you'll notice that they actually all have a title. This one says soft, this one says medium, but we can't actually see that. So what's going on? Well, remember how I said that in Xcode, when you look at the document outline, you have to imagine that your eye sits right here, and you're looking at all the layers this direction. So that means that the egg image view is in fact on top of the egg button, which is why we can't see the text of the button. Drag and change the order, then you will be able to see all of the text on the buttons. Now, why don't we simply just add an image or a background image to our button? So we could click this one and then select hard egg. Well, it's because it's actually much more difficult to make the image view scale to fit on a button. So that's why we've actually left the image out, and we've actually used a separate image view behind the button to show the user what the hard egg looks like and what the soft egg looks like. Now you can of course change the aspect fit using code, but this is just a much quicker and easier way of doing the same thing. So now all that's left to do is of course open up our assistant, and we're going to link up our design with our code. Now here's a challenge for you. Create a single IB action called hardness selected, and make sure that it's linked to all 3 buttons, soft, medium and hard, so that when they are touched, it will trigger our hardness selected IB action. And then write some code so that when you run the app and when you click on each of the buttons, it should print the soft, medium or hard, namely the titles of each of these buttons, depending on which one you pressed. Pause the video and give that challenge a go. So here's the solution. All we need to do is to create a single IB action from each of these buttons. So make sure that you change from outlet to action and change the type of the connection to a UI button. And then we're going to change the name to hardness selected, and then we're going to hit connect. And now we can simply drag it from here and point at our medium egg button as well as our soft egg button so that they're all linked up. And notice, because we've got quite a few things on screen, it's actually more precise to use the document outline when you are dragging and dropping. So now that we've got our IB action hardness selected, we can simply write a print statement which prints the sender. So remember, that was the button that triggered this IB action. And then we're going to tap into one of its properties, and it's going to be the one that we used before, which is the current title. So now when we click run, it will be able to print out the title of the button that we are selecting. So after doing a lot of research, eating a lot of eggs, We've come to the realization that a soft egg should take about 5 minutes to boil, a medium egg about 8, and a hard egg about 12 minutes. Now, given that I can only really eat 2 eggs before I start feeling a bit woozy, this experiment took a long time, but we wanted to confirm what the internet says, so these are the definitive numbers. So how can we add these numbers into our app? Well, we could create some constants, right? So right at the top of the file, we can create some constants, and remember, we create constants using the let keyword. And I'm going to create one called soft time, which is going to be equal to 5, and then medium time, which is going to be equal to 7, and finally hard time, and these indeed are hard times, so I'm going to change that to 12. And now we've got these 3 constants, and we've also got this hardness which the user has selected, right? So we could, for example, add that to its own storage container. So we're going to create a new constant called hardness, and we're going to set that equal to sender.currentTitle. And I'm actually going to delete that print statement because we don't need it anymore. Now, as soon as we do this, we get a warning from Xcode, and it says, initialization of immutable hardness was never used. Consider replacing it with an assignment or removing it. Now, I want you to actually copy this entire warning message and paste it into Google and check out what Stack Overflow has to say about what this means. And then once you're done, come back and we'll continue with the course. So let's paste in the important parts of that warning, and let's see what Google gives us. So we've got a couple of different answers here. So the first one that we see seems to have a very specific question in terms of what they're doing wrong. So if we take a look at one of the other ones, you can see that this one is more generalized. It's trying to ask what this is actually all about. So the answer tells you that these changes are recommended because if you don't use these variables or constants, then you should consider replacing them with an underscore. The idea here is to say that, well, if you created a variable or a constant and you haven't used it yet, so consider replacing it with a underscore or consider removing it. But of course, this is just Xcode being preemptive, and in fact, at some point later on, we're definitely going to use our variables and constants. So just be aware that this is what this warning is about, and that you can simply just copy and paste these warnings and errors into Google to be able to figure out what it means. Alright, so now we have this constant called hardness, and we have these different times that correspond to the different hardnesses. So here's a challenge for you. How can we print the soft time, which is 5, if the hardness that was selected by the user was soft, and 7 if they selected medium, and 12 if they selected hard. So if you have completed the challenge successfully, you should be able to press on the soft button and it'll print the soft time, which is 5. Medium will print the medium time, and hard will print the hard time. So if you think you know how to solve this challenge, then go ahead and solve it, and that probably means that you know all about if and else and conditional statements in Swift, so you can go ahead and skip the next lesson. If you don't know how to solve this challenge, then continue on to the next lesson, where we'll do a Swift deep dive on conditional statements, so if and else statements, and we'll learn how to be able to solve this challenge. So the choice is yours. Either way, I'll see you on the next lesson you choose. Hey guys, welcome to another episode of Swift Deep Dive. And in this lesson, we're going to talk about if and else statements, also known as conditionals. So the idea here is, what if you could check for a condition, and based on whether if that condition is true or false, then you would perform different actions. So in this case, if the green light was on, then the car should go. But if the red light was on, then it should stop. So we can also express this in code like so. So here we're checking if the traffic light is equal to green, then we will perform the action of go. Otherwise, namely if this is false, namely if the traffic light is not green, then we will perform the action of stop. Now, similar to what you saw with functions, curly braces often contain more than one line of code, so more frequently you'll see this formatted like so. Now, that's all very well and good, but in a lot of cases, especially in code, it's not always just true or false, because here our condition, whether if the traffic light is equal to green, can only be true or false. It's either green or not green. So we only have our if and our else blocks. But in real life, as with code, there's often other possibilities. So what do you do, for example, if the traffic light was amber? Then we might have to adjust our code a little bit to take into account this third condition. So I'm not sure about the highway code, but at least when I drive, if it's amber, I just press the gas pedal and just as long as there's nobody on the road, I just go. Now, don't trust my word. Read the highway code. But if we convert this condition to code, then we're saying that if it's green, then definitely go. Else, if the traffic light is equal to amber, so we're tagging on another condition here, well then in that case, use your judgment. And then the final else is if all of those are not true, then we're going to stop. In programming, we call these conditional statements because we're performing different actions based on different conditions. So here's a challenge for you. I want you to either open up your previous Swift playground and delete everything inside, or simply just create a new playground. In that playground, I want you to create a function called loveCalculator. Inside the function, generate a random number between 0 and 100, and then store that number inside a constant called loveScore. Now, if the love score happens to be equal to 100, then I want you to print, you love each other like Kanye loves Kanye. Otherwise, I want your code to print, you'll be forever alone. Then finally, call the function so that you get a message showing up in the console, and 99 out of 100 is probably going to say, you'll be forever alone. So feel free to modify my messages as you wish. So basically, you'll have two messages, and depending on the condition of the love score, it will trigger either one of those messages. So pause the video and try to complete this challenge. Alright, so the first thing we're going to do is create a new function, which we're going to call loveCalculator. And then inside this function, we're going to create a random number generator. So we're going to generate whole numbers, so they're going to be integers, and then we're going to use that random function that we saw before in order to generate those numbers. Now, if you forgot any of these parts, be sure to just simply do a quick Google, do a quick search on Stack Overflow, and you should be able to find these bits of code relatively easily. You don't have to memorize them. And inside our random number generator, we're going to provide a range. So I want to generate numbers between 0 and 100. So now we've got our random number, we have to hold it within a container, right? So we're going to store it inside a constant. And we create constants with the let keyword, and then we're going to name it loveScore. And then we're going to set it equal to the right-hand side, which is of course going to be a random number between 0 and 100. Now that we have our random number, loveScore, we're going to use our if statement that we just learned about. Now, if you want to get a starting structure, you can actually simply type if, and on the left, you've got this little code snippet symbol. Then if we hit enter, it'll insert our code snippet. So it shows a placeholder for our condition that we're checking, and then finally for our code that needs to execute if that condition was true. So our condition in this case is whether if the love score that we generated is equal to 100. Now notice that there's a big difference between two equal signs and one equal sign. Two equal signs means that we're checking if the left-hand side is equal to the right-hand side. So this entirety is going to be a condition that's going to be true or false. And if you want to see what this is actually going to be equal to, then feel free to try and print it. Then you can see that this will be true or false. So this double equals means checking if left-hand side equals right-hand side. A single equals means make the left-hand side equal to the right-hand side. So it's assignment versus checking. Now we've checked if the love score is equal to 100. Well, then in this case, the code that should execute is a print statement that says you love each other like Kanye loves Kanye, which is a lot. Now, if they get 100, that's what's going to print, but then we're going to add an else statement to trigger if that was not true. So if the love score was not equal to 100, then in this condition, we're going to print, you'll be forever alone. Cool. So now the final thing to do is to actually call our function loveCalculator so that we actually trigger the running of this function. And if we hit play, it will say you'll be forever alone because the score that got generated was 23. And you can click play a number of times to see some different scores. Now, it's going to be pretty unlikely that I'll ever be able to reach 100, so that I'm not going to try. But this is essentially the solution to our challenge. So we've seen the is equal to check, but there's actually a whole bunch of other checks we can make as well. Whether something is not equal to is an exclamation mark and equal sign. Whether something is greater than or lesser than, greater than or equal, lesser than or equal to. So you can use all of these different comparison operators to compare the left-hand side and the right-hand side. And then the end result is a condition that will still be true or false, which determines whether if your if statement gets run or if your else statement gets run. Here's the second part of our challenge. I want you to modify the love calculator so we'll get our you love each other like Kanye loves Kanye message trigger more frequently, and it should print that message if the love score is greater than 80. Otherwise, if the love score is between 40 and 80, then it should print you go together like Coke and Mentos. And finally, if the love score is less than 40, you should print you'll be forever alone. So go ahead and try to make those modifications to your love calculator and complete the challenge now. Alright, so all we need to do here is to change our condition here from checking whether if love score is equal to 100 to whether if it's greater than 80. And then we're going to add that else if, which checks for the next condition. So else if love score is greater than 40. And in this condition, we're going to print you go together like Coke and Mentos. Cool. So now finally there is the final else statement which will catch everything else, and including if the love score was not greater than 40 and not greater than 80. So this is the solution to our challenge. Now, if you're wondering how our code actually flows, then let's think about a couple of example numbers that we might generate. Let's say that we generate 55. Well, the first condition checks if love score is greater than 80, so that's going to be false. So we're going to skip that one. And then the next condition to check is going to be if the love score is greater than 40, which is true. 55 is greater than 40. So it's going to do this block here. And then once it's done, it's going to complete, and that's going to be the end of the running of our function. Now, let's say that we had a higher score that we generated. Say we generated an 85. Well, in this case, love score is indeed greater than 80. So A, this block will trigger, and then it's going to skip checking all of the other conditions because these conditions have an else in front of it. So it reads kind of like English. Well, if love score is greater than 80, then do A, else, so namely if this was false, then check this, else do this. So none of these else statements will trigger because the original if statement is already true and has already been triggered. So here's a bit of a brain teaser. What if instead of having an else if here, I replaced it with an if? What do you think would happen in this case? Pause the video and have a think about it. And if you want to see the solution, just change your code in your playground and you'll be able to check whether if you managed to predict the outcome correctly. the difference between the else if and the if statement is that in this case, we're going to check if the love score is greater than 80, which it is, so it's going to do A. But then because there is no else that's coming up, it's going to check the next condition, which is whether if love score is greater than 40, and 85 is indeed greater than 40. So it's going to do B as well before it retires. So in this case, because we don't have the else if, it means that it's going to check all of the conditions with an if, but if you have an else if, it means it will skip it as long as the previous one or one of the previous ones were true. Now, the final thing that I want to show you is that you can also use these combinations where you can combine these checks so that you can check if two conditions are both true, or if one of the conditions are true, or finally, if something is not true. For example, in terms of our love calculator, we could also write the code like so, right? We could say that if love score is greater than 80, then do A. And then we could use an if statement that checks if love score is greater than 40 and it's less than or equal to 80. So between 40 and 80. Well, in this case, it's going to do B. So now, even though we still have two if statements like before, this time it's actually only going to execute one of these blocks. Because even if the first one was true and it's going to do A, it's going to continue and check the next one. But the next one is actually not true anymore because love score 85 is indeed greater than 40, but this condition also requires that love score must be less than or equal to 80. Because one of these is not true, therefore this condition overall is going to be false. And you can have a go at changing the conditions in your playground to use the and, or the or, and the not to see how each of these work. So now that you've learned all about the Swift conditional statement, the if, the else, and else if, then it's time to complete the if-else assignment. So have a go at that. Hey guys, it's Angela again. Welcome to another episode on Swift Deep Dive. And in this deep dive, we're going to cover Swift switch statements. Now, if you were a train driver and you were pulling into a large station, say Paddington or King's Cross, and you had to manually check if every single platform was empty or if it was occupied, that would take you a long time. And that's kind of like trying to write an if-else statement for a whole bunch of conditions. What's way more efficient and much easier is if you could just ask the station manager which platform should I pull into, and they give you a number, 1, 2, 3, or 4, and you just go to that platform. So this is kind of like how switch statements work. We can have a variable. Say if we think about our egg timer, we have this variable called hardness, which of course depends on the button that the user presses on. And we can check to see what the value of that variable is equal to. If it's equal to soft, then we could print 5, or the soft time. If it's equal to medium, then print 7, it's hard, print 12. So essentially what's happening here is we're matching the value of this variable to each of these cases. And depending on which one matches, then we're going to perform different actions. And finally, at the end, there is a default statement in case none of our cases match the current value. So usually that's where you might print an error, where you might say none of the values match, or hey, you might want to check and see what's going on here. Or you could use it like an else statement, like a catch-all, do this in all other cases. Now, the reason why switch statements are so great is because not only do they reduce the amount of code you have to type, instead of having to type if hardness is equal to soft, open brackets, close brackets, if hardness is equal to medium, etc. But underlying how a switch statement versus how an if and else statement works, if you have more than 5 cases, it's usually more efficient to use a switch statement because it performs a search rather than having to manually go through each of the conditions and check them. If you have less than 5 conditions, then it's often quicker and easier to write just some if statements. Now, what if you can't match the precise value of a variable? What if you wanted to match a range? Say if hardness was actually a number and we wanted to check if it was between, say, 3 and 5 and then 5 and 7, what would you do in that case? Well, here's where the Swift range operator comes in again. And we saw this already before. We saw that you could use 3 dots to create a closed range, where you're creating a range between A and B. So for example, we could create a whole bunch of random numbers between 1 and 100, including 1 and 100. Then we would use the closed range. And then we have the half open range, where we have a less than sign at the end. And this means that we have a range between A and B, but not including B. And finally, one that you haven't seen yet is something called a one-sided range operator, where you leave one of the sides, either the A side or the B side, empty. So this means that we're creating a range that is up to and including B, but it can be any number that's less than B. So bearing in mind what we've just learned, I want you to challenge yourself and play around with these range operators as well as the switch statement by changing our existing love calculator that you created using an if, else statement into one that uses a switch statement only. So have a think about what you need to do. Maybe rewind and take a look at the range operators if you need to, or Google for the range operator in the Swift programming language book and have a read over there. But essentially, the challenge is to simply adapt your love calculator that's using an if statement into one that uses a switch statement. So pause the video and try and give that a go. So here I've got the code from before where we're using our if, else if, and else statements to check if each of these conditions are true and perform the correct actions. Now in this case we're going to change it to a switch statement, and again I'm going to use the capability of Xcode to provide code snippets by just starting out with writing the keyword, which is of course switch, and I'm going to hit enter, and then it inserts a code snippet with these placeholders for me to replace. So in this case, the value that we're checking or we're switching on is of course our love score, so that goes there. And then the case or the pattern that we're matching is whether if love score is greater than 80. So in this case, I'm going to check if the love score is greater than 80. So to do that using the closed range operator, we would write 81 ... 100. And in that case, the code that should get executed is of course this line, printing "You love each other like Kanye loves Kanye." Now, in order to add another case, I'm simply just going to write the word case, and then I'm going to provide the case pattern that I'm trying to match. So in this case, we'll need to check if the love score is greater than 40 and less than or equal to 80. Let's use the half open range operator this time, so that I'll write 41 ... less than 81. So in this case, what we should do is to print "you go together like Coke and Mentos." And the last case I'm going to add is if it's between 0 and 40. Let's use the one-sided range operator this time by writing ... 40. And finally, we're going to print "You'll be forever alone." Now, the default statement should catch if love score was ever outside of this range. And because we're creating a random number here between 0 and 100, it's really unlikely that it's ever going to go outside of our 3 switch statements. And if it really doesn't, then we should print that there's an error and love score is out of range. And that's my sample solution to the challenge. Now your code might be slightly different and you might have used slightly different range operators, but as long as you print the same output as with the if-else block, then your solution is correct. So here we've created our switch statement and it replaces our if and else statement. Now in this case, it might seem like we're actually writing a bit more code than before, but if you had a lot of cases, say 5 or 6 or 7 or more, then it would be a lot more efficient writing it like this. And your code will also run much faster than if you just had a whole bunch of conditions, which each need to be checked and confirmed. Instead, in this case, we are pattern matching the value of this against one of these cases, and it's more performant when there are a lot more conditions. So how did you get on with the challenge? Well, there's of course quite a few ways of solving this challenge, and one of the simplest is by using some if and else statements. So we could check to see if the hardness that the user selected, which is captured in our constant here, is equal to soft. So remember, this is going to correspond to the title of the button that was pressed, and our buttons are named soft, medium, and hard with a capitalized first letter. So if the hardness was soft, so if the soft button was pressed, then we probably want to print the soft time. Now, else if the hardness that was selected was equal to medium with a capital M, then in that case we should probably print the medium time. And finally, we have an else statement that captures the last condition. Because there are only 3 buttons, it can only be the hard button that got pressed, so we'll print the hard time. Now, an alternative to this is we could have also used a swift switch statement. So we could have switched on our hardness value, so this string, and if the case was that it was equal to soft, well, in that case we should print the soft time. And if the case was equal to medium, then we could print the medium time. And either through the use of the default, which of course we can only have 3 options, we could print our hard time. Alternatively, we could add another case and make the default catch exceptions, where for some reason or other we have a button that's triggering this IB action whose title is not equal to soft, medium, or hard. So in that case, we could add another case, hard, and this one would print hard time, and this one would print error. So both of these work, and if you used either of these solutions, then consider yourself successful and you've solved the challenge. But there's actually an even shorter way of performing this action. Instead of using these 3 constants where they're just holding a single piece of data, we could also just capture them all in a single dictionary. So let's create a dictionary, and I'm going to create the dictionary as a constant, so using the let, and then I'm going to call it egg times, so this is the name of my dictionary, and then I'm going to set it to equal a set of square brackets. Now, this might seem familiar to you because we've already used square brackets when we were learning about arrays. But there is another type of collection that we could use, and it's a dictionary. Similar to a real-world dictionary, you have a key, so for example, a word that you were looking up in the dictionary, and let's say that word was soft, and then you have a corresponding matching value. So for the soft word, in our case, the value is going to be equal to 5. For the medium string, well, our value is going to be 7, and for the hard string, our value is going to be 12. So we've basically done exactly the same thing as what we had before, soft time, medium time, and hard time, but now we have it captured in a single dictionary. And at this point, I want to pose another challenge for you. If you have seen dictionaries before in other programming languages, or if you already know about it from Swift, then you should be able to use this egg time dictionary to print out the correct time for the hardness that's selected. So we know that we can capture the title of the button that got pressed. I want you to replace this switch statement or the if statement that you currently have with a way of pulling out the values from our dictionary based on the keys we've got here. This challenge will require you to know a little bit about both dictionaries and optionals. So if you know how to complete this challenge and you've managed to use the dictionary to print out the correct time for the button that's selected, then feel free to skip the next lesson on our Swift deep dive. But if you don't know how to complete this challenge, or if you've never seen dictionaries, you want to learn more about Swift dictionaries, then head over to the next lesson where we're going to do a deep dive on Swift dictionaries. Hey guys, welcome to another Swift deep dive. In this lesson, we're going to cover Swift dictionaries. Just like the array collection type, dictionaries are another collection data type in Swift. So how do they work? Well, just as how if you look inside a dictionary, you'll find words, and each word has an accompanying explanation or meaning. Well, in programming, we have a similar concept. So you could express this dictionary entry in code like this. So you could create a dictionary variable and set it to equal a collection. So all collections in Swift start and end with the square brackets. And as opposed to an array where we just have a whole bunch of items separated by commas, in a dictionary we have what's called a key value pair, where the key is simply the item that we could look up, say the word in a dictionary, and the value is the accompanying piece. So in this case, it's the definition of this word. Now, you're not limited to just a single entry per dictionary. You can have as many as you want. So for example, we could have a dictionary where we have a brewery and the definition of a brewery, and then we could have a bakery and the definition of a bakery. So we have multiple key value pairs which are separated by the comma. Now in this case, in my dictionary, my key and my value have the same data type. They're both strings, the pieces of text. But you can mix it up. You could have a dictionary where you have a string as the key and an integer as the value. For example, you could create a phone book dictionary where you had each of your friends' names and their phone numbers stored in separate key value pairs. And notice how in this case, I'm actually specifying an explicit data type instead of using type inference. So when I create my dictionary, I specify a data type using the colon, and then I say that this is going to be a collection type, so square brackets, and the key, so the first item, is going to be of string data type, and then the second item, the value, is going to be of integer data type. So now I can stuff as many of these key value pairs into my dictionary as I want, as long as I stick to those data types. So keys being strings and values being integers. If we think about arrays and we think about the way that we created an array, we simply stuffed a whole bunch of values separated by commas into a collection, right, into a set of square brackets. And then when we had to retrieve an item from the array, we used the name of the array, and then we added a set of square brackets at the end, and we put in an index value, so a number that pointed to the item that we wanted from the array. So in this case, this particular line of code would actually retrieve the word brewery. Now, how does it work for dictionaries? Well, in this case, our dictionary would be defined like so. So it's a string int dictionary. And when we want to retrieve a item out of our dictionary, we, instead of adding a number, we use the key. So we would use the name of the dictionary, which is called dict, and then we add a set of square brackets just as we did for arrays. But now we provide the key that we want in order to retrieve the value, which in this case, this line of code would be equal to 07712345678. So now that you've learned about dictionaries, complete the dictionary assignment. Welcome to yet another Swift deep dive. In this episode, we're going to talk about optionals and what the heck are optionals. So we keep seeing these exclamation marks and question marks all over our code, especially when we find it from Stack Overflow or when we see it in the Swift documentation. Now, what exactly does it mean and how do we use it? So in order to understand this better, I want to introduce you to our shared cat, Fluffy. So this is our cat that we have to look after now, you and me. But we have to transport our cat, and we're going to do that in a cardboard box. So Fluffy goes into the box, and we're pretty sure that currently we have definitely a real cat in the box.
Yeah.
But let's say that during the hectic time of moving, we also accidentally popped a bottle of poison into the same box as Fluffy. So now we package it up and we kind of move it around in the van, shake it around, and the poison bottle might be broken, and we now basically have an optional cat, right? We have a cat with a question mark at the end of it. We don't know if Fluffy is dead or alive. And if we were to force open or force unwrap our box and see what's inside, well, we might discover that indeed we do still have Fluffy. She's alive and well, and she's smart enough to not eat the poison because, we're good at rearing cats. But we might also find that Fluffy is no more. She got tempted by the poison. It smelled like Play-Doh, so she had a little bit, and now Fluffy is dead. So we might actually have no cat, which in programming lingo we would call nil. This is essentially how optionals work. There's frequently cases where you need a container, so a variable, that might often need to start out containing no data. Let's say that you had a field in your app where you were going to save the user's username. Well, before they actually create it, that username variable is going to be nil. But then hopefully at a later date, when you need to use the username to display it on screen or to use it in some way, then you're hoping that the user has already filled it in. So it does in fact have a value. In order to represent this uncertainty, in Swift, we use something called optionals. So you've seen that when we create a variable, we can specify a data type at the point of creation. So we could add a colon and then add the type of data that this variable or this container or cardboard box is going to store. But then we can add a question mark at the end of our data type to turn it into a completely different data type. And it becomes a optional data type. So now this variable hardness can store a string, or it can simply be empty. It could have no data or store nil. In a blank playground, I'm going to create a new variable and I'll call it player1 username. And I'm going to set it to be a string data type. And at the very beginning of the game, before any player has even gotten the chance to assign themselves a username, well, this variable is not going to contain any data, right? It's going to contain no data or nil. And as soon as you try to run this, because our variable is only meant to hold data of string data types, it gives us an error. So we can't just simply take a normal variable container and try to give it no data. What can we do instead? Well, we could instead create a variable called player1 username, and instead of assigning it to a string data type, we give it a string with a question mark at the end. So now it's a optional. And now I can quite easily say that actually this player1 username has no data stored in it. But at a later date, I'm going to ask the player, well, what is your username? And they'll give me a username, which might, let's say, Jack Bauer is awesome. So now I have a value inside my optional player1 username. So if I was to print my player1 username at this point, you will see a optional string being printed. So the word optional and then a string. So how can we turn it from an optional, which it is at the moment, which you can see right here, but you can also check by holding down the optional Alt key. You can see that its data type is clearly an optional string. Well, we could simply just force unwrap it. So we unwrap our box and accept whatever the consequences may be, and we try to use the unwrapped version. Now, if I run my code again, you can see that my optional has become a normal string again. And in fact, if I simply go ahead and create a new variable called unwrapped p1 username, and I set it equal to player1 username unwrapped, then you can see that when I check the data type of this unwrapped p1 username, it's now back to a normal string. So it's no longer an optional anymore because I have overridden the safety check. So The safety check is there to prevent us from crashing and burning when we try to do something with a nil value, so a null value. Let's say if at some later point I changed my player1 username to again equal nil. So let's say that the player has reset their username. And in fact, I'm going to comment out this line just to make it a bit clear what's going on here. So we started out by creating a container that can hold nil values, so an optional string data type. And it started out being nil, but then we gave it a value, but then we removed the value, and player1 username no longer contains any data on line 10. So now if we try to print it and we unwrap it forcibly, saying that I am so sure that this will definitely always have data, computer, listen to your master, which is me, the programmer, just do as I say, and we run it, and then all it's going to do is crash, because if we have a nil value that we're trying to do something with, say we're trying to add 2 to nothing, it doesn't make any sense. If we try to print nothing, if we try to do anything with a nothing data, it's like taking thin air and trying to do something with it. So that's when our app would crash. In order to prevent this from happening, we can enact some safety checks. The first safety check is actually your brain. The reason why a lot of things are optionals are that you are reminded that some of these values can have nil as its value. You want to be able to check through the code and make sure that it won't ever become nil. Now, another way of doing this is we can actually just explicitly check to see if player1 username does not equal nil. So that's what that exclamation mark equals means. It means does not equal. And in that case, well, then we could use it and we can unwrap it forcibly. Because now, even though player1 username is equal to nil, our app is no longer going to crash because it's going to bypass the line that would cause an issue. Because this is not true, player1 is in fact equal to nil, then we're going to skip the line and we're not going to crash our app by using a piece of data that's nil. Now, there's a really fun comic that somebody once made on if programming languages were weapons. And one of the biggest problems with a lot of older languages, like Java, is this idea of a null pointer exception. So this is essentially the same as what we've been talking about. So it says that Java is a belt-fed 240G automatic weapon where sometimes the belt has rounds, sometimes it doesn't. So sometimes it has data, sometimes it's equal to nil. And when it doesn't and you try to fire it, then you get a null pointer exception. Or you get an error like we did and the gun explodes and you die. So this is one of the biggest problems with some of these older languages. And the way that Swift was designed is to be a safer language. So the gun doesn't explode in your face and you actually have a fun time using it. But in order for it to work, we have to understand when we're using an optional and to make sure that if we are unwrapping it with an exclamation mark, that we're certain that it's never going to be equal to nil. If we're not certain, then we should probably check for it and to prevent our app from crashing. So that lines where we're unwrapping our optional are protected by an if statement. Now, in later lessons, we're going to dive deeper into some other fancy things that you can do with optionals, such as optional chaining and optional binding. But for now, I just wanted to introduce you to the idea of a nil value, that a variable can actually contain no data at all. And the idea that if you tried to do something with nil, then your program will likely crash. And optionals are there to safeguard us from these situations, first by making us think about whether if it could be nil, and second by getting us to protect against those scenarios. So now that you've learned a bit more about optionals, it's time to complete the assignment that is on beginning optionals. And on the next lesson, we're going to head back into building our app. Previously, I've challenged you to use the egg times dictionary to print out the hardness that was selected by the user. To solve this challenge, we will combine our knowledge of working with both dictionaries as well as optionals. In order to solve this challenge, all we had to do was simply, inside our print statement, add the egg times dictionary, and then use the square brackets to tap into the egg time that we want, depending on the hardness that was chosen by the user. So in this case, we know that our sender.currentTitle can only be one of three values: soft, medium, or hard. So if we match these with the keys in our dictionary, then we'd be able to retrieve each of these values. So we could simply write egg times, and then we could add our hardness in here as the key. Now, even though our code seems to work, we get an error from Xcode, and it tells us that value of optional type string ? Must be unwrapped to a value of type string. In order to solve this, they give us 5 ways of fixing it. And the reason is because the sender.currentTitle is something that is a bit of an unknown, right? You might have a button which triggers this IP action where it doesn't actually have a title. Well, in which case, sender.currentTitle would be equal to nil. So then if you have a nil value that you put in here that you try to retrieve from your egg time dictionary, well then it doesn't know which one to give you, right? Nil is not soft, medium, or hard. So then we end up with an error down the line and our app would crash. So to prevent this, the sender.currentTitle has a different data type. So if you hold down Option and you click on it, you can see that its data type is a string ? Which is what we call an optional string. So the reason why it's optional is because you could have a button that doesn't in fact have a current title. So the current title could legitimately not exist. But of course, in order to use it inside our dictionary, because all of our dictionary keys are in fact pretty solid strings, right? They're not optional strings. Well, then we have to convert this hardness, which comes from sender.currentTitle, into a non-optional. One way of doing that, as you might have seen before when we used the code from Stack Overflow to play sound, we added a exclamation mark at the end of sender.currentTitle. So this essentially says that, yes, I am the human programmer, I know better than you, Xcode. I know that all 3 buttons, which are linked to my IB action, so all of the senders will always have a current title, and this will never fail, it'll never crash in the future, don't worry about it. So now, if we go ahead and run our app, you can see that it actually lets us run the app, because errors will stop the app from running, but warnings will not. So if we now click on each of our buttons, you can see that we get an optional printed. I know it seems like we just unwrapped the sender.currentTitle, so why are we seeing an optional again? Well, this optional doesn't have anything to do with our sender.currentTitle. Instead, it has something to do with how dictionaries work in Swift. Now, why is that? Why are we getting an optional out of our dictionary? Well, our dictionary has keys which are of string data types. So let's say that we try to retrieve 5, the value 5 out of our egg time dictionary. Well, I could simply provide the key soft, right? And when this is printed, we would get 5. But what if I'd made a typo in this? Because it's a string, right? Nobody's going to check whether if I've typed it correctly or not. Well, in that case, the soft with a lowercase s doesn't actually exist in this dictionary as a key. So then this result would end up being nil. So if I run this right now, and if I press on any of the buttons, all I will get is nil, because it can't find anything with the key soft in this egg time dictionary. So that's why when you provide a key as a piece of text to retrieve an item out of a dictionary, the end result will be a optional. And I can show you that if I say let result equal egg time, and if I hold down option and click on result, you can see that the result is actually an optional integer. So it's trying to grab an integer out of our dictionary, but it doesn't know if we'll definitely be able to find one using this key. Then the result becomes an optional. So if we wanted to not be an optional, then we could of course hit the exclamation mark. And in fact, if we were using the hardness value, which comes from our button titles, then we know that they are for sure spelt correctly, because we can see them right here and we can match the spelling of the soft, medium, and hard with these three keys. So in that case, then we can be pretty sure that this result, so retrieving an item out of our dictionary, is definitely not going to fail, ever. Then we can add an exclamation mark at the end. And if we now print our result, which has been what we would call unwrapped, then you'll see that instead of getting an optional integer, we actually get an actual integer. Now, if you manage to complete the challenge from the last lesson, then this should be the effect that you now have. When you press on one of these buttons, so the soft button, the countdown timer should start from 300, medium starts from 420, and hard starts from 720. So now if I press on the soft button, you'll see that I'm getting a countdown timer that fires every second, counting down the amount of time that my egg still has to cook. Now, if you haven't got this effect, or you don't know what I'm talking about, then you might have missed out on the last lesson, which was a challenge lesson. So be sure to complete the challenge so that we can actually move on. Now, if you have completed the challenge, then I want to go through the code that I've got, and you can compare it to yours as well. So the first thing that we did was we converted our minutes to seconds, because we're going to be counting down every second. And then we created a variable called seconds remaining to keep track of how many seconds there are. And then when the user selected the hardness that they wanted, we assigned the value in our egg times dictionary, so be it 300, 420, or 720, to the variable seconds remaining. So at this point, seconds remaining now equals one of these values. The next thing we do is we create a timer. So this timer code you would have found probably from Stack Overflow or Googling around, but essentially it has a bunch of parameters in it. So it asks you for how often do you want the timer to fire. So in our case, because we want our timer to update every second, then we've set that as 1.0, so 1.0 seconds. And then we've got a parameter for whether if we want our timer to repeat. So we don't want it just to stop after the first second. So we've set that as true. And then we've got this parameter called selector. And the selector is a bit of a remnant from the olden days where we used to create things using Objective-C. So the way that we use it is we provide a name of a function. So it's almost like it calls this function that we put in here every single second, every time the timer fires. Now, when you created this function called update timer, you might have gotten an error that has a little white dot in it. And it says that selectors come from Objective-C. So in order to expose this method or make this method work with Objective-C timers, then you have to add that little annotation, the @Objective-C in front. So that's all it is, and we don't really need to understand how the timer works or how a selector works. The goal of the challenge was to get you just comfortable with finding out how to do things through searching and through using the 5-step method to just make it do what you want it to do. And in later lessons, as we get better at Swift and as we learn more programming, then these small things will become more and more clear to us. So here we have a function called update timer, which we know will fire every second. In here, we're checking to make sure that we've still got time on the clock, so seconds remaining is larger than 0. And if so, we're going to print the the number of seconds that we currently have remaining, and then we're going to minus 1 from it, so that the next time our timer fires, we'll be printing a second that's 1 lower from before. So this is essentially how we've achieved this timer mechanism. But if you've been testing it carefully, you will notice that if you start out pressing one button, so the one that should start at 300, and then midway you change your mind and you press a different button, now our timer seems to have sped up. It's actually running down the seconds, almost 2 seconds in one go. So it's doubling its speed. And if we press another one, then it's going to speed up even more. It's now 3 times as fast as before. So what's going on here? Well, the reason is because we create this timer, but we never actually cancel it. We never stop it. So it's the same timer that's running. And every time we press one of the buttons, we create a new timer, and we call this method every second. So now we're calling this method twice a second or 3 times a second, depending on how many times we've pressed this harness selected IB action. So how can we prevent this from happening? Well, we could create a variable called timer and set it equal to a timer. And then down here, we assign that timer variable a new piece of data, which is the actual scheduled timer. But every single time that the button, the soft, medium, or hard buttons get pressed, we actually invalidate our timer. So we stop it and cancel it so that the next time we create a timer, we actually create a brand new one. So now if we run our app, and we press one of the buttons, you can see it's counting down 1 second every second of the clock. And if I change to a different button, it will still count down once per second instead of speeding up like before. Now, here's another challenge for you. How can we change the label that's currently on our main.storyboard? So the one here where it says, how do you like your eggs? How can we make it say done once our timer is up? So in order to make it easier to test your code, I recommend changing these egg times from 300 seconds, where you have to wait a whole 5 minutes, back down to 3 and 4 and 7. This way, when you're testing it, it's much, much faster. Pause the video and try to see if you can make the code change the title label to make it say done once our timer is up. Alright, first things first, we need an outlet to be able to change this label. So right up here, let's control drag it over, and I'm going to call it just a title label. And hit enter. So now we're actually able to change our title label, and we're going to do it right here. So here we have an if statement that checks if the seconds remaining is greater than 0, then continue ticking along. But if the seconds remaining was in fact equal to 0, so not greater than 0, well, then we could capture that with an else statement. So we add the else statement, and when this happens, we first invalidate our timer. So we run our timer.invalidate again to stop the timer from continuing to tick every second. And plus, on top of that, we tap into our title label.text property, and we make it say done. So now if we run our app, and I'm going to select the soft button, and you'll see my timer goes 3, 2, 1, done. So that's exactly what we wanted. Alright, so now that we've got our timer functionality down, the next step is to add a progress bar. So that's what we're going to do in the next lesson. So I'll see you there. Now, as the developers of the app, we can of course see what's printed inside our debug console. So when I press on one of these buttons, we can see that our timer is firing and we're getting our countdown for our egg timer. But of course the user can't see any of that. So how can we relay this information to them in an intuitive way? Well, one of the ways we could do that is by using something called a progress view. The progress view will help us show the user how much time is left until their eggs are done. We'll use the progress view to visualize the value of seconds remaining. So if we go back to our main.storyboard, press the plus button and search for a progress view, then you can see that this will be able to show a lengthy task is underway and indicate the percentage that has been completed. So we could use this to show the percentage that our egg is complete. So in order to use it, we're going to drag it onto our screen. Now notice that I've got a vertical stack with 3 things in it: a egg stack, a title view, and a timer view. So I want that progress view to go into the existing timer view. So making sure that it's indented like this under the timer view, and then drop it in. So that now goes inside my timer view. And now I'm going to select my progress view, and then I'm going to pin it so that it's 0 pixels from the left and from the right of the containing view, so the timer view. And once I've added those 2 constraints, I'm going to make sure that it's vertically centered in its container, so that it's right in the middle there. Now, the next thing I'm going to do is I'm going to change this progress view from a normal sort of default progress view to a bar. And the reason for this is because I can now go into my constraints and actually give it a height. So I'm going to make it 5 pixels high so that we can actually see it better. And once that's done, then you can see it's now a square bar that looks something like this. And we're going to change some of the colors so that it stands out a little bit better. So making sure that you select the progress bar instead of the timer view. We're going to change the progress tint, so the part that's already done, to the system yellow to match our yolks. And the track tint, so the part that's not done, we're going to change it to system gray. So now we've got a part that's done and a part that's not done. Now, the way that a progress bar works is you can see that it has this property called its progress. And when it's 0.5, it means the progress is going to be halfway. If it was 0.1, then it's going to be 1/10 of the way. So it goes from 0 all the way up to 1, essentially. Now, here's a challenge for you. Without changing anything in the attribute inspector, can you write some code so that when you press one of these egg buttons, the progress bar goes to 100%? Have a think about that. Pause the video and try to complete the challenge. Alright, so first things first, we need to link the progress bar to our view controller with an IB outlet. So making sure that you're dragging not from the timer view but the progress bar, and that when you see the type here, it should say UI progress view in the drop down. So let's name this our progress bar and hit enter. And now we can go into our view controller, have it full screen to see what's going on, and we can change our progress bar. And what we're going to do is, we said as soon as one of the egg buttons get pressed, we're going to change our progress bars. And remember, the property that we were changing before when we were making this bar move around was the progress property right here. So we're going to do the same in code. So we're going to tap into the progress bar. We're going to use the dot to find its properties, and we want this particular property. So the current progress shown by the receiver, which is the progress bar. And notice that over here it tells you what data type it needs. So it wants to have a floating point number. So now if we hit enter, we can set it to equal 1.0, which is basically 100%, and it's expressed as a decimal point number. Now if we run our app and we press on any of the buttons, it will increase our progress bar straight up to 100%. We're getting closer to achieving what we want, but we're still not quite there yet. We still have to adjust our code a little bit. Now, before I show you how we do it, I want you to really pause and think about how you might tackle this problem. At least list down the logical steps which you might change the code or you might think would work to make our progress bar show the amount of time that remains. So pause the video, have a think about that, and once you're ready, head over to the next lesson and I'll show you how it's done. So in the last lesson, we've incorporated a progress bar into our design, and we've figured out how we can change the amount of progress that it shows by updating a number that essentially represents a percentage from 0 to 100. And that number has a data type of a float, so it's a floating point. And 1.0 is completion, so 100%. 0.0 is the starting point, so it's 0%. Now, we know that we've managed to get the seconds remaining variable to reduce itself by 1 every time, but we're still a little bit far from what we want, which is for the progress bar to show the amount of time that's left. So in order to solve this, we have to think about it logically, and so here's what we know so far. We're going to need a percentage that's expressed as a floating point or a decimal number. So for example, 56% would be 0.56. And we need that percentage to increase from 0.0 to 1.0, representing how far along our egg is. So from just put into the pan all the way to finished boiling, at least for the chosen hardness. Now, the next thing we know is that we have a different amount of time to count down depending on which egg hardness was selected. So soft eggs require a total of 300 seconds, hard eggs require 720. Now, we also have a function called update time that can do something every second because it gets called by our timer, which ticks every second and triggers update time. So at the moment, we've got this variable called seconds remaining, which basically shrinks by 1 every second, and we're printing it out. But we can't really use it directly in our progress bar. So what if we thought about it the other way? What if instead of having a seconds remaining, we had something called seconds passed, and we look at how seconds passed varies compared to the total amount of time that the particular egg hardness requires. So then we can track our progress from 0 to 90 depending on how many seconds passed out of the total time. So effectively we can express this as an equation. We could say that the percentage progress is equal to the seconds that have passed divided by the total amount of time that the egg requires. Applying that logic to our code then involves a couple of things. Firstly, I'm going to delete this line of code because we don't need it. We're not updating the progress bar in the IB action. And the second thing is that notice I've still got these quick and easy to test seconds, 3, 4, and 7. And I'm not going to change this until the very end when we are actually ready to wait 5 minutes for our egg to be done. So at the moment, we have our seconds remaining, and I'm actually going to delete this variable and replace it with 2 others. One is total time, which I'll set to 0, and another is the seconds passed. So this seconds passed, unlike seconds remaining, is actually going to go up. So it's going to go from 0 to 1 to 2, whereas seconds remaining counted down from the total amount of time. So the place where we need to set the total amount of time for our egg is, of course, here. So instead of setting seconds remaining, the total amount of time is going to be based on the hardness that's selected. So it's either going to be 3, 4, or 7. And then we need to have this seconds passed variable increase by 1 every single second. So instead of minus equals, we change that to plus equals. So now seconds passed is going to go from 0 to 1 to 2 every time update timer is called, which is every 1 second. So now I'm going to delete this print statement, which uses that old seconds remaining. And instead of checking for whether seconds remaining is greater than 0, I'm going to check to see if the seconds passed is less than the total amount of time. So let's say that we selected the soft egg in our button selection. So the total amount of time gets set to 3. And the first time update timer gets called, second passed is 0, total time is 3. So 0 is less than 3, and therefore seconds passed gets increased by 1. And then the next time, and the next time, until seconds passed is equal to 3, at which point it's no longer less than total time, at which point our egg is done. So this if statement is the place where we're going to update our percentage progress. So just before we increase it, we're going to create a new constant called percentage progress, and we're going to set it equal to the seconds passed divided by the total amount of time. And so now we have this thing called percentage progress, and we're going to set that as the progress bar's progress property. So we'll set that equal to percentage progress. Now we're going to have an error though, because it says that the percentage progress has a data type of a whole number, but the progress bar dot progress needs a floating point number. And we can verify this by again holding down Option and clicking on that. Percentage progress is in fact an integer. So how can we convert an integer into a float? Well, Xcode seems to know. It says, well, why don't you wrap your percentage progress inside a float? So let's try it, and you'll see that Xcode doesn't always know what it's doing. So if we click Fix and we try to run our code, and we press on our button, you can see that it goes straight down to 0. In fact, our progress bar doesn't do anything other than just make the progress go down to 0. So what's going on here? Well, this is a bug in our code, and like the olden days where the computers would get a moth stuck in it and some bit of circuit won't work, in modern days we don't have to worry about moths so much, but we do have to worry about ourselves. We are our own greatest enemies, and our fallacies and logic leads to our code breaking and not working. In the next lesson, we've got a 5-step process. Again, 5 steps. I really like the number 5. And it's a 5-step process for you to figure out how to debug any problem you come across. So join me on the next lesson where we're going to fix this. Alright, so let's go through our debugging 5 steps together. Firstly, well, what did you expect your code to do? Well, when we ran our app, our expectation was that when we press on one of these buttons, it would, at least for the soft egg, because it's got 3 seconds, so it should be 3 sections, 3 seconds, and moving that yellow progress bar across. But what happened instead? Well, instead of that, what actually happened is that when we press on any of these buttons, it just turns our progress down to 0. Step 3. Well, what does your expectation actually depend on? Well, in our case, it depends on the fact that this percentage progress is first going to divide 0 by 3, then 1 by 3, then 2 by 3, and it should be equal to a decimal number, right? So it should go from like 0.333 to 0.666 to close to 1, right? And that is the thing that we're using to put into our progress bar's progress. Essentially, our expectations depend on this number increasing by 1 every time, this number staying the same, and the calculation that this results in should be a decimal number that is going to be our progress bar progress. Step 4. How can we test the things that our expectations depend on? We already know that this part of our code is crucial to it behaving the way we want it to. So why don't we go ahead and test it by printing our percentage progress? And then printing, well, what does this actually equal? What is it that we're trying to put into the progress bar? I'm hoping that it's something like 0.3 or 0.6, but I don't know. So I'm going to go ahead and print the right-hand side here as well, where that percentage progress gets converted into a floating point number. So now let me run my app and see what happens. So when I press on, say, the medium button, I get 0, 0.0, 0, 0.0, 0.0. So what's going on here? Why is it all 0 instead of 0.3 or 0.4? Why is it that my percentage progress is 0 and my floating point percentage progress is 0.0 every single time? If we stepped into a playground and let's say I create a constant called a and I set it equal to 5, create another constant b and set that equal to 2. So then next I divide a by b, and because a and b are both integers, right? They're whole numbers, but I want a decimal number. So instead I'm going to convert this result into a float. So we've essentially done the same thing over here. We've effectively just said, well, let's wrap this result inside a float, and then we can assign this as the percentage progress, right? But when we do, in fact, print this percentage progress, then it always happens to be equal to 0. And if we print our float, which converts a divided by b, so right here, if we simply press print, you can see that we're getting the result 2.0, which is weird because we know that 5 divided by 2 is not 2.0, but it's actually 2.5. So what's going on here? Well, it all depends on the sequence in which things happen. The first thing that happens is a whole number is divided by a whole number. So 5 divided by 2, the result is going to be a whole number. So it can't have any decimal places, and we can confirm this by deleting that float part. And now if I run the code, you can see what I get is 2, the integer 2. So that means all that we're doing is we're wrapping the 2, that integer, into a float, which is of course just 2.0. So a divided by b is 2, float of 2 is 2.0, and float of a divided by b is again also going to be 2.0. So what should we have done instead? Well, actually, what we need to do is to have converted each of these into a float before dividing it. So if we turned a into a float, and then b into a float, and then divide it, then you'll see that the result that we get is not 2.0, but 2.5. So there's two ways of doing this. We could say up front that actually a is actually a floating point number, and so is b. Then in this case, we actually can simply just do a divided by b, so it's a float divided by a float, so the result will be a floating point number, which will have decimal places. So we now arrive on the last step of debugging, which is to fix our code to make reality match expectations. Back in our code, let's simplify this a little bit. I'm going to make the percentage progress equal to the float version of seconds passed divided by total time, but instead of wrapping the entire thing in a float, which I'm actually going to keep so that we print it and see what it's equal to. So this is our old version. Instead, in our new version, I'm going to first convert the seconds passed variable into a float, and then I'm going to divide it by the float version of total time. And now I'm going to also print this first version over here. So we're going to print that here. And now when I run my app, let's see what happens. So I'm going to click on the soft button. And you can see we've got 0, 0.333, 0.666, and then it ends. So this version is actually giving us a calculation that has decimal places, whereas this version simply does the calculation first, rounds it down, and then turns it into a floating point number. So that's the difference, and that's what we've managed to deduce from our debugging. Now, we've come across another problem now, because at the moment, our progress bar doesn't actually go to the end. It stops when it's 2/3 of the way along. What's the reason here? Well, try using the 5-step process and see if you can solve this problem. So we can already see that our expectations relies on the fact that this progress actually goes to 1, but it actually stops at 6. And the reason is because we're checking to see if the seconds pass is less than total time. So once seconds passed reaches 2, it's not going to go any further. So our largest number here can only be 2 if we structure our code like this. However, if we move this line where we increase the seconds passed to above our progress bar, well, now if we were to print this right-hand side and run our app, now you can see that it starts out being 1/3, then 2/3, and then all the way done. Now, all we have to do is to tie up the loose ends. So I'm going to delete the print statements in my code. If you want to keep it and you want to add comments to your code, then feel free to do that now. The next thing we need to address is that we need to be able to reset the progress bar down to 0 so that when we press one of the other buttons, it can restart. So the place where we need to do that is, of course, where the user selects a different hardness. So in addition to invalidating the timer, setting the hardness to the current title, and also setting the total time based on which button they selected, we're also going to set the progress bar's progress back down to 0.0, so a floating point number. And we're also going to set the seconds passed back down to 0 to start from the beginning again. And finally, we want to reset our title label as well, because once the timer is done, it's going to read done, right, in the text of the timer label. So instead, if we set this to equal the hardness that the user selected, so the title of the button, then we'll be able to see at a glance which hardness of egg we're actually making right now. So let's run our app and see this in action. If we start out with soft, then it counts for 3 seconds until it's done. Medium will count for 4 seconds. And hard will count for 7 seconds. That's it. Feel free to modify your egg counter as much as you like, but we've got one final challenge for you before we tie up this module. Now notice that in the skeleton project we already included an alarm sound, and we want you to use the knowledge you gained in xylophone, especially the part where you looked up how to play sound in Stack Overflow, to look it up again, figure out how to play the alarm sound once the timer is done. Pause the video and try to complete that challenge, and once you're done, have a look at the completed code in the module to see if you've gotten it right. So I hope you enjoyed this module, making your egg timer, and I'll see you on the next module. Alright, welcome to another module of the Complete iOS App Development Bootcamp. In this module, we'll learn all about struct and the model view controller design pattern. We're going to be teaching you some key design patterns in programming iOS apps. And we're going to be taking your knowledge that you've learned so far much further by building a more complex app. So by the end of the module, this is what you'll have made. It's a quiz app that allows you to choose a question, and you can see your progress as well as see your score. And we're going to be organizing this quiz app using what's called a model view controller design pattern. And by the end of the module, you would have learned how to be able to show our quiz questions, how to check the answers that the user selected, as well as learn about Swift structures and using it inside design patterns such as the model view controller pattern. And we're also going to learn more about functions, namely functions that can have inputs as well as outputs. And finally, we will learn about this idea of immutability in Swift programming. So there's a lot of new words in there, there's a lot of new concepts coming up, so load up on the coffee and I'll see you on the next lesson. So the first thing we're going to do is, of course, clone our starting project, which you can find in the course resources link. And for those of you guys who want practice creating the user interface and doing the auto layout, then there's, of course, the alternative that you can work on. In other words, you've got two stubs to choose from. One stub with the screen already designed for you so you can focus on Swift programming, and one where you can practice recreating this design on your own. Now the goal of this lesson is to set up our project and link up our storyboard to the view controller. That way we can make our buttons interactive and show different questions on the screen. So here's our main.storyboard, and the first thing we have in our stack is a label, and then we have a true button and a false button. And finally at the very bottom we've got a progress view which is styled as a progress view bar. So now all we have to do is open up the assistant editor and link up our code with our design. So firstly, I'm going to create an IB outlet from my question label as well as my progress view. And I'm going to call the top one question label. And I'm going to call my progress view simply a progress bar. Alright, so we now have our two IB outlets, our question label and our progress bar. I'm going to create two more IB outlets for each of the buttons. So one from the true button, which I'm just going to call true button. And then another one from my false button, which is going to be called false button. Alright, so everything on screen now has an outlet. So the final thing to do is to add an IB action which gets triggered when either the true or the false button gets pressed. So let's start from the true button, and I'm going to call this action answer button pressed. And of course I'm going to change the type of my sender to a UI button and then hit connect. And now I'm going to click back and drag it back to the false button as well, so that they're both connected. Alright, so now we're done with all of our linking, so we can head straight into the viewcontroller.swift and see what we have done. So we have this block of code which will be triggered whenever either of the answer buttons are pressed, and we can change everything on the screen through these four outlets. Currently, when we run our app, all that we see in our question label is just the words question text, because that's what we added here as the starting sort of placeholder values. But we want to replace that text with an actual question. And I want to pose this as a challenge to you. Without touching anything in the main.storyboard, namely the attribute inspector, can you write some code so that even though our question label starts out in our main.storyboard saying question text, as soon as the app runs, make it actually show a question. So in this case it says 4 plus 2 is equal to 6, and then the user would have to choose whether if that's true or false. So pause the video and try to complete that challenge, and have a think about which part of your code gets triggered when the app is first loaded up. Alright, so here's the solution. We have this function called viewDidLoad, and already in the comments of our template, Apple already is hinting at us that this is the place where we do any additional setup after loading the view. This is the block of code that we can affect if we want something to happen as soon as the view loads up or as soon as the app appears on screen. So what we want to happen here is we want to tap into the question label and change its text property to say 4 plus 2 is equal to 6. Now if we run our app, then you can see that even though our main.storyboard starts out with question text, as soon as the view loads up, it says 4 plus 2 is equal to 6. Brilliant. Now, a single question quiz app is not most people's idea of fun, so let's jazz it up with some more questions. And to do that, I'm going to create an array. So right up here, just below my IP outlets, I'm going to create a constant called quiz, and it's going to be an array that stores 3 questions. Alright, so now I have an array of strings, and I've got 3 items in here which are separated by commas. And now I can use this array to show my questions in my question label instead of having these bits of text floating around. So here's another challenge for you. Make the question label display the first question from our quiz array. So the end outcome should be the same. We should still see the same question on screen, but we can no longer use it directly like so. Pause the video and review what you learned about arrays to see if you can complete this challenge. Alright, so in order to complete this challenge, we have to use our quiz array. And in order to get the first question out of our quiz, we can simply add a set of square brackets and pick out the one at 0 position, which is of course the first question in our array. Now when we run our app, we get exactly the same as before, but now we're using some more dynamic code rather than just setting it manually. Now, even though we've got 3 questions, we can't actually progress through them yet. And ideally, we'd really like our answer button pressed function to be the trigger that changes the question label.text. So in order to do this, we first need a variable to keep track of which question the user is currently reading. Let's call it question number, and we'll start it out with 0 because that would match with our 0th position, which is the first question. So now we can change this 0 from using a hard-coded 0 to using our question number. So again, if you run your app at this stage, it will work exactly the same as before, but we've now made our code even more dynamic, and we can now increase our question number by 1 every time a answer button gets pressed. So we can either write question number equals the current value of question number plus 1, or of course we can use the shortened version that we've seen before, which is just plus equals 1. So here's a question for you to play computer. What do you think would happen if we ran the app at this stage? So don't run it, just think about what might happen. Do you think it will change the quiz text every time we press the answer button because we're increasing the question number? Well, let's check it out. So when we press the true or false buttons, notice that nothing is changing about our question label.text. So what's the reason here? Well, the only place where we're changing that question label.text is of course inside our view.load block, which only gets triggered once, the first time the view loads up. So in order for this to keep changing, we actually need this line of code to be triggered again. So why don't we go ahead and create a function that captures this functionality, and we'll call it update UI. Because in all likelihood, we're probably going to need this functionality a few times. So if I command X to cut it from there and paste it inside update UI, every single time I need that functionality, I can now call my function update UI. So I need the UI to update when the view loads up, but also after I've increased the question number. So now I've got my code in two places, all triggering the same function, which is to update the question label based on the current question number. So now if we run our app, you can see that when we press on these buttons, it will increase and go through our quiz questions. Now, of course, if you go beyond the third question, your app will crash. And this is, of course, because we only have 3 questions. If you're requesting for the 4th one that doesn't exist, well, then we get a index out of range error. So our index, which is currently number 3, is out of the range of our quiz because it only has 0, 1, and 2. And here's a quick way of seeing what's actually going on. Notice how when your app crashes, it highlights to you the line where the fatal error, which is really dramatic for Xcode to say, but this is where the fatal error occurred, and that's what killed your app. Now, when your app crashes, you will see the debug console pop up, and you will see the useful messages, usually at the top of the debug console. So if you ever are in doubt, just scroll to the very top and read what it says. Now, the other thing you can do is you can expand this little drop-down list here, and you can see the value of some of the variables we have created. So currently at this point in time, when the app crashed, my question number variable was equal to 3. Now that means that I tried to pull out the quiz value at index 3, 0, 1, 2. Of course, 3 doesn't exist. So that's another way of helping you to debug and figure out what's wrong with your app. But there's no problems here. We expected that to happen. So let's go ahead and just stop our app. And in the next lesson, we're going to figure out how to not just solve this, but also how to check the user's answer and see if they got the answer right. For all of that and more, I'll see you on the next lesson. In the last lesson, we managed to create a single array which contained 3 questions, and we were able to show it on screen and show each of the questions. Now, in this lesson, we're going to try and figure out how to be able to check to see if they got the answer correct. So whether if they chose the right answer to each question. And in the process, we'll also learn how to work with a 2-dimensional array in Swift. Now, in order to do this, we need to somehow associate an answer with each question, right? We need to be able to say that, well, maybe this one should be true, and this one should be true, but this one should be false. So how can we associate 2 pieces of data together, even though our quiz lives inside an array? Well, one way of doing this might be through the use of an array within an array, or what you might call a 2D array. So far, the arrays that we've been creating look something like this. We have as many items as we need, all separated by a comma and placed inside a single array. So this is our collection of items. Now, we can also create a 2D array where we have individual arrays. So there's 3 arrays in this case, each with 2 items, all packaged inside a larger array. So how would you retrieve a single entry out of a 2-dimensional array? When we had a 1-dimensional array, retrieving items was pretty straightforward. In order to retrieve items out of our array, we simply added a set of square brackets and a number after the name of the array. And that number, well in this case I, refers to the position of the item that we want. Now, if we had a 2D array on the other hand, in addition to adding a first set of square brackets where we're picking through the outer layer of arrays, now that we've picked out the item that is at this position, let's say this one, which is position 2, well now we have access to yet another array. And in order to pick from this inner array, we have to tag on another set of square brackets in order to pick between these 2 items in the inner array. So here's a question. If we had an array that was a 2D array that looks like this, so we have 1, 2, 3 inside its own array, 4, 5, 6 in its own array, 7, 8, 9, and then these 3 arrays are packaged into another array, well, how do you get hold of the number 9? pause the video, have a think about that. What would your code look like? Well, in this case, the positions of the outer array are 0, 1, and 2, and then the positions inside the array are also at 0, 1, and 2. So in order to get hold of this number 9, we first have to tap into our array, and then specify that we want the array that's at position 2, so it's this one, 7, 8, 9. And then within this array of 7, 8, 9, we then specify the position of the item we want, which is again at 0, 1, 2. So now we have array square brackets 2, square brackets 2, in order to get that number 9 out of this 2D array. Coming back to our code here, we currently have a 1D array, and we can turn it into a 2D array by simply making each of the items an array itself. So we now have a question and an answer, and I'm keeping it simple by making the array keep the same type of data, so they're both going to be strings, right? So let's go ahead and modify the rest of these. So we now have 3 arrays within an array. And if we take a look at the data type of our quiz constant, you can see it's now a 2D array of strings. So it's got 2 brackets around each side. And now if we wanted to pick out the first question out of our quiz array, then instead of simply specifying quiz question number, we also have to tag on a 0 at the end, because now it's going to pull out the first array using the question number, which starts out being equal to 0, and then within that array we want to get the first item, so the one at position 0. So this would be our code overall. So now that we have the quiz in a 2D array, well, let's check the answer that we have in our 2D array against the answer that the user chose. So firstly, we have to figure out what answer they chose. So right here, I'm going to create a new constant called user answer, and I'm going to set it to equal the sender.current title. So whichever title they chose from the 2 buttons that are linked to my IB action, so true or false. Now this user answer is going to be equal to the string true or the string false. So we can now use it to check against the actual answer. Now the actual answer is going to be equal to the quiz array at position 1, right? So similar to how we got our quiz question, we're going to set this equal to the quiz array, and then the first layer is going to be question number. So it's going to be one of these arrays, depending on which question we are on. And then the second one is going to be position 1, because that's where the answers live. They're all at position 1 inside the array. So now, in order to check to see if the user got the answer right, all we have to do is create an if statement and check to see if the user answer is equal to, so double equals, to the actual answer. Well then, in that case, that means they got it right, right? So we'll just print right. Otherwise, namely else, well, they probably got it wrong because their answer doesn't match the actual answer, so we'll write wrong. Now if we run our app, we should be able to see that question checking mechanism in action. So if we run our app, you can see that if I press 4 plus 2 is equal to 6, yeah, that sounds right, so let's press true. We got it right. 5 minus 3 is greater than 1. And then finally, 3 plus 8 is less than 10. That's definitely false. So now we get our last answer, but then our app crashes because we again fall out of the range of our quiz array. We don't have a 4th question. So we've got a working quiz app now, although it's a pretty buggy one. And if your app crashes on a user's phone, they won't know what's happened. They won't know that the index is out of range. They'll just think that you've made a terrible app. So let's fix this and help you maintain your reputation as an app developer. So the first thing that we need is a safety check. So inside the answer button pressed, before we increase the question number, let's first check to see if we're actually at the end of the quiz. And I'd like to pose this as a challenge to you. Can you use an if statement and only increase the question number as long as we're not yet at the end of the quiz? I'll give you a few seconds to pause the video before I show you my solution. Okay, here's my sample solution. So in our case, we want to prevent the question number from being increased past number 2. You might think that you can simply write the following. If question number is less than 3, then increase question number by 1. Or you might have written it like this. If question number is less than quiz.count, so the length of our array, then increase question number by 1. But let's double check this by running our app again. Even though we think we might have fixed the problem, you'll notice something quite peculiar. So if I press on the third button, my app still crashes. What's going on? Well, the line that's being highlighted is right here. So this is obviously the line that's crashing my app. And the reason is because the index is out of range. So the only thing that has an index that changes is my question number. And we can see down here that the question number was again allowed to go to 3, even though we said don't increase the question number unless the question number is less than the quiz count. So what's happening here? Well, here's what's happening. When the question number is equal to 2, 2 is less than quiz.count, which is 3. Well, now, in this case, question number increases by 1. So question number is now 3. And then it goes into the update UI, and it tries to update the UI by getting the item at position 3 out of our quiz, which is what crashes our app. So instead of simply checking if the quiz number is less than quiz.count, we actually have to increase this by 1. So now when it gets to question number 2, then it's going to add 1 to it, so we never go beyond 2. And now if we run our app again, you'll see that we've solved our bug and it no longer progresses beyond the last question. Here's another challenge for you. See if you can change the code to make the quiz restart from the beginning when it reaches the end. So you should end up with a never-ending quiz. And it'll look something like this. So here we've got our first question, our second question, third question, back to the first question. So pause the video and try and see if you can get this functionality working in your app. Alright, so how do we achieve this? Well, the place where we reach the end of the quiz is, of course, when the question number plus 1 is actually equal to the quiz count. So how do we catch that scenario? Well, we can simply add an else statement. So if it's gone beyond the number of items we have in our quiz, well then we're simply going to set the question number back down to 0. So the next time we update our UI, we fetch the first question out of our quiz again. And that means our quiz will loop on and on endlessly, or at least until the user gets bored. At this point, we're showing new quiz questions, we're checking the user's answer, and our app is no longer crashing. So now is a good time to restructure and reorganize our code. Currently, one of the biggest eyesores in our code is this 2D array. It's hard to read, it's hard to understand, not just for you, for any programmer. So how can we make this better? Well, we could use a Swift structure to create a question structure that contains a title property, so the title of the question, and then a answer property, so the answer of each question. So if you know all about Swift structures, and you can create a structure to capture our quiz array so that we get rid of our 2D array and instead have an array of quiz items, each with a title property and an answer property, then you can probably skip the next Swift deep dive. But if you've never heard of structures, then I recommend heading over to the next lesson where we're going to do a deep dive on that and more. So the choice is yours, and I'll see you on the next lesson you choose. Hey guys, welcome to yet another Swift deep dive. And in this deep dive, we're going to talk about structures. Now, structures helps us create custom data types. So whereas previously we saw that there were loads of basic data types that comes pre-built along with Swift, for example, strings, ints, floats, doubles, booleans, arrays, and dictionaries, you name it. There's a whole lot of different pre-built data types. But what if we needed our own data type, something that groups together related properties and behaviors? For example, our quiz questions. Currently, we have a 2D array, which basically forces these two pieces of data, the answer and the question, to be associated with each other. But actually, these are two properties of a question, right? The text of the actual question, as well as the correct answer of a question. Those should really somehow be interlinked together. And in order to do that, we could use a structure. So we create a structure by using the struct keyword, and then we give it a name. Now notice how the names of structs are a little bit different compared to methods or properties. When you're creating a struct, the name that you give it has to be capitalized even at the beginning. So that way you can tell that it's actually a data type. Similar to how our string, int, or float data types all start with a capital letter. Let's go ahead and create our own structure in Playgrounds. So let's say that I was to create the structure of a town. Well, I would start by writing the struct keyword, and then I would give my structure a name. So let's just call it town. And then I'm going to open a set of curly braces, inside of which I can define the properties of my town. So what are the kind of properties that a town might have? Well, it might have a name, right? So let's create a constant using the let keyword and give this constant a name of name. So the name of the town. And then I'm going to give it a value. So let's call it Angela Land. Now let's think, what are some other properties that a town might have? Well, it probably has some citizens, right? But in this case, I'm going to create a variable. And the variable is going to be called citizens, and it's going to be equal to an array. So these are all the people that live in Angela Land, and it will be myself and, let's say, Jack Bauer, my ultimate hero. And so now that we've got the citizens who live in the town, the name of the town, the last property I'll add are the resources in this town. So let's say that we had some grain, maybe 100 bags of grain, some ore. I think I've been playing a little bit too much of Settlers of Catan recently. This is all I can think about. Let's say we had 42 blocks of ore. I'm not sure what's the unit of count of ore. And then let's say we had some wool. Notice how here I'm creating a dictionary. So it's a variable called resources, which is a collection of dictionary items. So we've got our key and our value. So 100 bags of grain, 42 bags of ore, 75 bags of wool. And these three properties are now all packaged together into my town structure. Now that we've created our struct, it's time to actually initialize it. By initializing, I mean creating an actual object that we can use. So to create an actual town from our town structure, all that we would need to do is create a new var, and this var will be called myTown. Now, this myTown is going to be the actual town created from this structure. And to express that in code, we would write var myTown equals town and then a set of parentheses. So now what I've done is I've created a new copy of this town structure, and it's held within the variable of myTown. So that means I can actually use this object myTown, and I could access the properties of my town. For example, I could print my town, and to access the properties I would use the dot notation. So as soon as I write dot, you can see all the things I can tap into. And let's say that I wanted to print who are the people who live in my town. I'm going to print my town.citizens. And currently it's just me and Jack Bauer. Now I can tap into some of the other properties as well. So for example, if I wanted to use my string interpolation to get hold of my town.name, so the name property of my town, and then let's say my town has, let's do like a little report, shall we? How many bags of grain have I got? So then it would be my town.resources, and then we would use the square brackets to access the grain key. And then we could say, well, it has this many bags of grain. So now if I run my code, you can see that these are the citizens, and Angela Land has 100 bags of grain. That's a pretty good town, if I might say so myself. Now with the object that we've created, my town, we don't have to limit ourselves to just retrieving data or retrieving the values or properties of this object, but we can also add and modify it. So for example, if let's say that my town has a new citizen, let's say that Keanu Reeves decided to move into this wonderful town, well then I might say my town.citizens, so it access the citizen property of my town. Well then I can append, so add something to my citizens array, and the name that I'm going to append is of course our new neighbor, Keanu Reeves. So there's 3 of us now in our town, and I can print, for example, my town.citizens.count. And when I do that, you can see that after I've added Keanu Reeves to the citizens of my town, we now have 3 people living there. Whereas previously, when I printed my town.citizens, we only had 2 people. Now, so far, the structure of our town only defines the properties of a town. So towns should have names, towns should have citizens, and they should have resources. But we can also define a behavior of our structure. So we can make towns be able to do things like build barricades and, get everybody inside, and we sort of eat all our 100 bags of grain. And to do that, we would simply just create a function within our structure. So let's say we created a function called fortify. And now, inside this fortify function, we could simply just, for ease of use, we'll just print defenses increased. So now our town structure has properties, and it has something that it can do. Now, when we have a function that's associated with a structure, well then the name for it is actually called a method. So if you hear the words functions or methods when people refer to it on Stack Overflow or online, just know that they're both referring to this same thing, the thing that we create with a func keyword, and it defines some behavior inside the curly braces. But if this behavior was defined inside the curly braces of a structure or a class, then we would call it a method. But if it was sort of standalone, free floating around somewhere, well then we would call it a function. At the end of the day, it's just defining behavior, something that it can do. But now I can trigger this method or this functionality that my town has by writing my town, so this is the actual object that can do things and has properties, dot, and I'm going to make it do something. Now notice here that this M stands for method, and if I hit enter, then my town is going to fortify itself when I run that line of code. And we can see that my town has its defenses increased, so it's able to perform an action or a behavior. When we create a struct in our code, we're essentially creating a blueprint for an eventual object that will get created from our blueprint. And in this blueprint, we get to plan ahead for how this eventual object will be. For example, we create variables, And when our variables live inside a struct, that variable is associated with our struct, and it's known as a property of that struct. Similarly, we've created functions inside our structs, and when functions are created inside a struct, they're known as a method. So you can consider these properties as a way of defining what this eventual object created from the struct will be like. So its attributes or its properties. And the methods can be thought of as what the object can do. So in the context of an actual car object that gets created from a car struct or car blueprint, well, those properties might be things like the color of the car, or the number of seats it has, or the number of doors it has, or whether if it's a hatchback or a sedan, something that describes what this eventual object is going to be like. And the methods for the car, well, those are things that the car object can do. So things like drive, or brake, or switch on the indicator lights. And it's through describing these properties and methods of the objects that will get created when our app is running. So these objects are invisible. We can't see them, we can't touch them, but we can plan for how they will behave and how they will look by creating these properties and methods. So when we were defining our town struct, we were writing the blueprint for the eventual object that will get created. And we can take our blueprint and initialize it, which turns it into the actual object, in this case maybe an actual car. But what do I mean by that? What does initializing mean, and what does the code actually look like? Just like we would create a function, we create our initializer in a pretty similar way. We have our parentheses for the inputs that gets passed over. We have our curly braces for the implementation or the code for how to initialize our structure. So how does the initializer get used? Well, the initializer gets triggered when we create our object from our blueprint. But why do we have initializers in the first place? What's the purpose of the initializer? Well, suppose you want to create the next Civilization or Settlers of Catan video game. Well, in that case, you're going to need more than one town, right? Well, in addition to Angela Land, you'll need Athens, Beijing, and New Delhi, and many, many more. But all of these places are different. They have a different name, different citizens, and different resources. Wouldn't it be nice if we could use our struct to act as a blueprint for all of these towns, but still be able to customize each town? Well, that's where the initializer comes in. Let's head back into Playgrounds to see this in action. Let's delete everything we have here currently and just be left with our structure. Now I'm also going to delete the values of these properties to keep my town very generic. So the name is going to be a string data type, the citizens are going to be an array of strings, and the resources are going to be a dictionary made up of strings for keys and integers for values. So now my town structure has blank properties for each of these attributes, and I can now define a custom property every time I create a new town. But before we do that, we need to create the initializer. So I'm just going to write init, and when my Swift code snippet symbol comes up, I'm just going to hit enter. And inside the placeholder, which says parameters, I'm going to add some input parameters. So when I initialize a new town from my town structure, I'll be able to use these inputs to fill in my properties. The first one is going to be town name, which is going to be of type string. Next, it's going to be the people of the town, which are going to be an array of strings. And finally, I've got the stats for my town, which is going to be a dictionary comprised of string keys and integer values. So that's all three inputs that I need for my initializer. And inside the initializer, what I'm going to do is I'm going to set my town's name property to equal whatever got passed in as the town name. And then I'm going to set my citizens property to equal whatever got passed in as the people of the town. And finally, my resources property is going to be populated with the stats that have been inputted for this town. So now, if we're creating our town with an initializer, the way that we would do that is, let's create a variable called, I don't know, another town. And let's set it to equal a town created with our town blueprint. And then once we open a set of parentheses, you can see all of those input parameters show up: town name, people, and stats. So if we hit enter, we can use these placeholders, and you can hit tab to go between them. And we need to provide some values in each of these positions. And we can also see what type of data we need to provide. So the first one for the town name has to be a string. So let's call this nameless island. And the people who live in this nameless island will just be one guy, and it's going to be Tom Hanks. And for the stats of this town that I'm creating, it's just going to have a whole lot of coconuts. And let's say it's got 100 coconuts on this nameless island. So now that I've created another town, I can do exactly as what I've done before. I can tap into my object, the another town. So remember, the object is the thing that's actually created from the blueprint. And I can, of course, print the properties, say the citizens or the name. I can call or trigger the methods or the behaviors that the town can do, namely fortify itself. But I can also, of course, tap into, let's say, our citizens. And then, just as we did before, we can append a new element, which happens in this case to be a beach ball who's going to join the citizens of Nameless Island, and he's going to be called Wilson. So now we have another town, which is an object created from the town blueprint with all of these properties that we've specified when we created the town using the blueprint. And we're able to use this object just as we did before to tap into its properties or to manipulate or change some of those properties. And we can, again, if we wanted to, now print our another town, so our object's property. Let's print and see who lives in this town. So this time it prints there's Tom Hanks and there's Wilson on Nameless Island. Now notice how I'm twisting these names so that they don't overlap with the names I've got as the properties of my town. Because in reality it would be much easier for me to just name this name this citizens, and name this resources. But now, when I initialize it, I have to set the name equal to name, and the citizens equal to the citizens, and the resources equal to the resources. Now, it kind of makes sense if you really think about it. So I'm saying that the name property of my town structure should be set to equal the name that got passed in as the input parameter. But this code is very confusing because this name matches exactly this name. Now, what else can I do? Well, I can make it really explicit which one I'm talking about, whether if it's the property or whether if it's the input here, by simply adding the word self in front. Now, you might have already come across this keyword self, and we haven't really gotten around to explaining it, and this is the perfect time to really explain it, because the self keyword refers to the eventual object that will be created from this structure blueprint. Whereas right now, we're saying self.name referring to the property name of our structure town. Well, eventually, when we try to initialize our town, that self is going to refer to the object that's initialized. So, for example, the another town. By adding that self keyword in front of all of these properties, I can now easily differentiate them by saying, well, self.name, of course, refers to my town's name property. Self.citizens, of course, refers to my town's citizens. And you can view this self keyword as referring to the structure. Now that I've changed the parameter names of my initializer for my town structure, well, I also have to change them here, right? So this is what this error is about. It says that the labels should be the name, citizen, resources, but instead we have town name, people, and stats. So we can go ahead and click fix for it to change it for us to the ones that we specified in the initializer, and all the errors go away. But from now on, also, when we create, say, let's create a ghost town from our town blueprint, and when I hit enter, you'll see that these are now the parameter names I have to provide. Let's create our ghost town, which is going to be called Ghosty McGhostface. And the citizens are none. There's nobody living here because it's a ghost town. And the resources are, it's just got like a lot of tumbleweed of 1. It's just tumbling around in our ghost town. So notice how right now I've got one object created from my town blueprint, which is called another town. And in there we've got Tom Hanks with a bunch of coconuts. And we've got another town called Ghost Town, which again we've created from exactly the same blueprint. But this town's completely different. It's got a different name, it's got no citizens, and it's got just a single tumbleweed. So now when we tap into our object, let's say that in another town we've got a new citizen who's moved in, so we'll append Wilson to that town. Whereas in the ghost town, well, nothing really happens, but let's say that we just decided to fortify the town. Notice how here I'm tapping into different objects that have essentially been created from the same blueprint, and when I hold down Option click on each of these objects, you can see that they both have the same data type. They're both created from the town structure. But they are really different from each other. They have different names, different citizens, different resources, and I can specify which one I want to manipulate, which one I want to change, whose properties I want to tap into, and now we've got essentially a whole bunch of things that we can play with by using this blueprint as a starting point. So now that you've learned all about structures, it's time to test your knowledge in the structures assignment, so head over there before you continue in the project. And once you're back, I'll see you on the next lesson. Alright, so now that we've learned all about structures, let's go ahead and remove our functional but slightly ugly bit of code here, where we have our 2D quiz array. And instead, let's turn it into an array of quiz items created from a structure. In order to create a structure, we're going to go ahead and make a new file. So you can either go to File, New File, or simply just right-click on one of these folders where you want the file to live inside and go to New File. And there, we're going to choose a new Swift file. So under iOS, choose a Swift file and hit Next. And now we're going to name our file Question. Now, it's convention that we have the same file name as the name of our structure. So our structure is going to be called Question. So ideally, you want your file to also be called Question. Now, it's not obligatory. It's just good programming practice so that other programmers will be able to recognize what it is that you're doing. So inside this new file, we're going to create a struct with the struct keyword. And if I hit enter, you can see that it uses the code snippet for a struct to help me create this new struct. And structs are pretty easy. They just have a name and some fields. So the name of my struct is going to be question with a capital Q. So now that I've created my struct, I'm going to give it some fields. So let's delete that placeholder. And let's go ahead and think about what fields or properties would make sense to be associated with our question. Well, each question really needs a bit of question text and an answer that's the right answer. So in our question struct, I'm going to create those two fields or properties, and I'm going to create them using constants. So we have a constant called text, which is going to be of data type string, and we have a constant called answer, which is also going to be of data type string. Now that we've created our properties, we can go ahead and initialize it inside our view controller. Right here, we're going to replace this array with a question item. To initialize a new structure, we write the name of the structure, and then we add a pair of parentheses. And then inside here, we're going to go ahead and initialize some of those fields that we had, namely the question text and the answer. So the text is, of course, this one. And the answer is going to be true. So we're going to paste that in there, and we can now delete our previous array. So now we have a question object here, and we can replace these two as well. So now we have an array of question objects, and that's reflected when we hold down Option and we click on our quiz array. You can see it's now a collection, so square brackets, and inside the collection we've got a whole bunch of question objects. So now we've avoided the sort of ugliness of a 2D array, and our quiz array is now far easier to understand. It's just got a whole bunch of questions, each with a text and an answer. So now we have to go and fix our code to use this new format. Here, instead of tagging that 1 at the end, we're instead going to write .answer, because this is going to look inside our quiz array, and it's going to pull out the item at this particular position. So let's say that we put out the first one. So then we get a question object, and we can tap into its answer property by simply writing .answer. Now, if you find it easier, you can actually split it into two parts. So you can say the actual question, which is equal to quiz at question number, and this allows you to inspect on its data type, which is a question data type. So that's that custom data type that we created. And then, of course, this question data type has two properties, text or answer. So that means if we then go ahead and write actual question, then we can write a dot, and we can see all the properties that it has, text and answer. So you can either do it this way or the previous way, whichever way you find easier to understand. Now, I'm going to keep it like this just to keep it short and sweet, because I think this should be explanatory enough. So now all we have to do is to fix the last line of code inside our update UI function. I'm going to leave this to you as a challenge. Try and fix this error using what we've just learned about accessing properties from our structures. Pause the video now. Alright, so again, we're going to remove this second part because we used to have a 2D array and now we don't. And instead, I'm going to tap into the text property to populate my question labels text property. So now, if we run our code, you'll notice that absolutely nothing about the functionality or the appearance has changed. But our code is now structured a lot better, and we can easily extend it by creating more structures in the way that we have done here. And we have code that is now easily understandable at a glance, here where we create our quiz array, as well as here where we tap into the quiz questions properties. Now, we can actually make this code even simpler if we went into our question struct and actually created a custom initializer. So we can say that when we have to initialize a new question instance, instead of putting text and answer, which is quite wordy, why don't we just have Q, which is going to be a string, and A, which is going to be a string. that way, when we initialize our question, we can set our text to equal Q, and we can set our answer to equal A. Now, when we initialize our question object here, instead of having to write text and answer, all we need is just Q and A. And this way we can customize how we initialize our structures so that we write even less code and even more succinct code. Now that we've understood how this works, we're going to go ahead and actually delete all of these questions that we've created in order to learn about structures. And instead, I want you to go into the README file and scroll down to the section where it says Default Quiz. I want you to copy all the questions that are currently inside that section, and then we're going to paste it inside our quiz array. So to save you from typing a million lines, we've created all of these questions for you in the structure of the question that we have created. So now, if you run the app, you'll see that we now have a working quiz with 12 question items. We've just added the question struct to our project and replaced the quiz array with our sample questions. There's only one problem, because the debug area, which is giving us feedback about whether if we got the questions right or wrong, can only be seen by us, the developers. We need to somehow relay this information to the user in the app. Instead of using our print statements here, we have to think of another method. So let's go ahead and delete these. And instead, we're going to set the background color of the button that the user pressed either green or red, depending on whether if they got the right answer. We can get hold of the button that they pressed by simply tapping into the sender object, and we can say sender.background color property, change that to equal UI color.green if they have gotten it right. Otherwise, we're going to change the sender's background color to UI color.red. And these UI colors are sort of pre-built colors that come with the iOS palette. So you can write simply just a dot and scroll down to see all of the different colors that you can choose from. But we're going to stick with just green and red for now. Now, if we run our app, you can see that it sort of works, because when I select true, you can see that the true button that I selected gets highlighted with the color that reflects whether if I got the question right or wrong, but it doesn't go away. So I end up with something that doesn't really make much sense. So we need to make the color change back to clear as soon as we go to the next question. So where does that happen? Well, inside our update UI, of course. So right below this line, we're going to add some more code to our update UI to make it take our true button. So that, of course, comes from the IB outlet that we set up earlier on, the true and false button up here. And we're going to set its background color to UI color.clear. And we're going to do the same with the false button as well. So that way we reset all the button's background color every time we go to the next question. So let's run our app again. Now we have a new problem. Why is it that our color's not showing up at all anymore? Well, try and use the 5-step debug process and see if you can figure it out. Pause the video and I'll wait for you. Alright, did you manage to figure it out? Our expectation is when we hit this line, if the user got it right, the color should change to green, and if the user got it wrong, it should change to red. Whereas in reality, it's not changing at all, so what's going on? Well, we know that we've got this part which changes the background color back to clear, and that happens pretty much almost immediately after this. So that means even though the background color does get changed, it happens in such a short period of time because it takes no time at all to get through these few lines of code that we don't even see it. Here's a challenge for you. Now here I've got the code from my Egg Timer project open in front of me. And this line of code, well, even though it's on 2 lines, it's just because my font size is massive so that you'll be able to see what's going on. But we use this line of code to create a timer. And the timer would be triggered after 1 second. And once that time interval is up, it calls a method inside the selector. So whatever we put in here. I want you to take a look at this line of code and have a think about how you might be able to adapt it to implement a 0.2 second delay. The delay should happen between changing the background color to green or red and resetting it back to clear. All going well, this is the effect that you should observe when you run the app. It changes the color for 0.2 seconds and then it changes back to clear. Pause the video and try to complete the challenge. Alright, so essentially what we need is a bit of a time delay before this method gets triggered. So instead of directly calling update UI, I'm going to write out the code for my timer right here. Now, the timer is currently set to have a time interval of 1 second, so I'm going to change that to 0.2 seconds. And then the selector, which is the method that it calls once the time is up, is called update timer, which comes from our egg timer. But instead, I'm going to make it call update UI. And I'm going to delete this method call right here. Finally, we don't actually need this timer to repeat at all, so we can change this to false. We only need it to run once, wait for 0.2 seconds, and then call update UI, and then that's it. It can end. It doesn't need to continue. So we don't actually need to store it inside a variable because we don't need to invalidate it if it only runs once. If it's a timer that repeats, then we should probably stop it so that it doesn't continue on in the background. But in this case, because it's a timer that just runs once and then stops, we don't actually need to store it inside any sort of variable. Now, the only last thing we have to fix is, of course, selector relies on Objective-C, so we have to add the Objective-C annotation in front of our update UI function. Now, if we run our app, it's now working exactly as we would expect it to. It would change the color for 0.2 seconds and then it would go to clear. Now, all that remains is to set up our progress bar. At the moment, we've already got our progress bar linked to our view controller through an outlet called progress bar. So I want you to use what you've learned from the previous lesson about progress bars to make it display our progress through our quiz. So you know that you can get hold of how many items there are in the quiz array, and you also have this variable that keeps track of where you are in the quiz, which question you're on. Now here's a hint, it only takes 1 line of code, but by the end you should end up with an app that starts out with a fraction of progress, and as we answer more questions, the progress bar completes until we get to the last question where the entire progress bar is full, and then when we circle back to the first question again, it resets. So have a think about how to solve this and try to remember how we used the progress bar previously. So pause the video and try to complete that challenge. Alright, so the logical place to update our user interface, namely our progress bar, is of course also inside our update UI function. Just below the previous line of code, I'm going to tap into my progress bar, which of course comes from my IB outlet here, which is linked to my UI progress view. And then I'm going to change its progress property, which of course expects a floating point number between 0 and 1 to represent the progress of the bar. So in order to calculate this progress of where the user is, I'm going to take the current question number, so which question they're on, and then divide it by the total number of questions in the quiz array. To do that, I'm going to write question number divided by quiz.count. So now that would work, other than the fact that, of course, we need a floating point number for our progress. And remember that we shouldn't get tripped up by floats. We can't simply wrap everything inside a float. We have to change each of these integers, or these whole numbers, into a floating point number first before we carry out the division. So in exactly the same way that we did in the egg timer. Now, if we run our app as it is, you'll notice that it doesn't behave the same way as what I showed you. It starts out being completely blank, but once we reach to the last question, the one about chocolate and dogs, it actually doesn't get to the end. And in fact, the next thing that happens if I press the button is it resets back to the first question, and we never get the wonderful sense of completion. In order to solve that, we of course know that question number starts from 0. So 0 divided by anything is going to be 0. So instead, we want to add 1 to question number so that in the very beginning, we already get a little bit of progress to represent that we're currently in the middle of question 1. So did you manage to get that right? If not, be sure to review the lessons in the last module where we explored progress bar, progress, and floating point conversion in detail. But in the next lesson, we're going to talk more about mobile design patterns and the model view controller. So for all of that and more, I'll see you there. Now, while our app works at the moment and we can use it and it's got pretty much all the functionality we need, there's just one problem. Our code is not in very good shape. All of our logic is pretty much stuffed into our viewcontroller.swift, and it's just a bit of a mess in here. Well, why is this a problem? What's wrong with having just one file with lots of code? Imagine if we had, say, 100 questions. We would even struggle finding our functions and our view to load and figuring out what's actually going on in here. Even for a relatively simple app, the logic is already getting a bit out of hand. And the classic metric of, do you think you could understand what's going on in your code if you came back to it in 3 months? Well, you might or you might not. So in order for us to be able to build more complex apps, we need to understand the concept of design patterns. A design pattern is what can help us get organized and structure our code in a better way. So what is a design pattern? A design pattern is simply a proven solution to a common problem. So what exactly is the common problem that we need to solve? Well, with software, it's usually complexity. And we can see this in our app. All of our app's logic and all of our app's code is stuffed into a single file that's getting increasingly long and increasingly complex. Let's say that you had a windmill that you had to manage to generate some electricity. Well, you could probably manage it just by yourself, and you could live in the windmill, you would have a joyous life. But what if instead you had to manage a whole nuclear power plant? It'd be really difficult to do it by yourself, and if you did it badly, you might end up with a Chernobyl situation on your hands, and nobody wants that. So if we think of software as a busy restaurant, if one person had to do everything from cooking to taking orders to cleaning dishes, well, that person would work really hard, but they still wouldn't be able to serve many customers. So you might think that the solution is simply more staff, more code, but actually a restaurant full of staff who don't know what they're doing would be complete mayhem. So what do we need instead? Well, the best restaurants have staff who know exactly what they're supposed to do at any given point in time. And it's the same thing managing complexity everywhere. Companies have a lot of complexity, and so do software. So we need to come up with an org chart for our software. Now, this is a hotly debated topic. What is the best design pattern to use for X? And people have really strong opinions. Some people say that, oh, everyone should use Viper. And your colleague John might say, no, you should always use MVVM. If you've never heard any of these acronyms, don't worry about it. There are so many different design patterns that you could possibly choose from. So much so that I've filled up an entire screen of some of the ones that come to the top of my head. Now, the thing to remember is there isn't such a thing as the one best ultimate design pattern that you should learn and always use and never think about any of the other ones. Because at the end of the day, a design pattern is kind of like an architectural blueprint, right? And depending on what your requirements are, you might have a different architectural blueprint. Say if you needed to live in the Arctic, then you might need the blueprint for building an igloo. If you wanted to live on top of a tree for some reason, then you would need the architectural pattern for building a tree house. Depending on what app you're building, you might need to use different design patterns. And on top of that, there's also style-based choices, where you might be the sort of person who wants to live in an entirely pink house with irregularly shaped windows, but you might also prefer a different style. And it's the same story with design patterns. For some programmers, they want to have as few lines of code as possible, while others want their code to be as readable as possible. So in this lesson, we're going to learn about the most fundamental design pattern that everyone who's learning how to make mobile apps should know about, and also the design pattern that Apple chooses to use. And this is, of course, the MVC design pattern, or the Model View Controller. Now, how does this work? Well, we split our project into three main components: the model, the view, and the controller. And by making these three components work together, we end up with the MVC design pattern. The M stands for model, and in order to create the model, we separate out the parts of our code which handles all the data and the logic of dealing with that data. And then we have a view component, and these are the parts of our code which handle what goes onto the user interface and deals with user interaction. Now finally, we have our C, which is our controller, and this is the mediator of it all, the conductor, if you will. And so if we had an app where the user taps on the user interface, then we would get a message from the view component to our controller, sending over those input events. And then our controller interprets that and maybe makes a request to our model for some data. And the model will implement some business logic and process the data in some sort of way, and then it outputs some formatted data and sends it back to the controller. Now finally, the controller takes that data, interprets it, and sends the relevant parts to the view to modify the user interface. So the view and the model never directly talk to each other, and it's only through the controller that they're able to interact. So why is this pattern so useful in app programming? Why do you need to separate the model and the view? Well, imagine if your newly built quiz app becomes so popular on the App Store that users are demanding a version in German, in French, others want a history version, and a science version, and a humanities version of the quiz app. Now, if you had created your app using the MVC design pattern, then you won't actually need to touch the controller or the view. All you would need to modify to change the app for this purpose is to switch out the model. You might need to update the logic a little bit, you might need to update the data, but you won't need to go into the viewcontroller.swift file or the main.storyboard or any of the design files. So MVC is really great for reusing code, separating out your components so that they are modular. And this also happens to reduce errors and makes your program much easier to understand, especially for other programmers who already know about the MVC design pattern. In the next lesson, we're actually going to take the theory that we've learned and apply it to our app and use the model view controller design pattern. In the last lesson, we learned all about the model view controller design pattern. And in this lesson, we're going to apply the theory that we learned to our quiz app. First, we're going to separate out the part of our code that deals with the quiz data. namely this quiz array and our question struct. Go ahead and right-click on that question.swift file and select New Group from Selection. This is going to create a folder that contains that question.swift file, and we're going to rename that folder Model. Next, we're going to do the same thing for our main.storyboard. So we're going to create a new group, and we're going to call this one the View. Finally, we're going to right-click on the View controller.swift and create a new group called Controller. So if you're OCD like me, feel free to drag the folder around so that they are in the right order. And now that we've set out our MVC structure, the next step is to actually do the work of converting our code into the MVC design pattern. In order to do that, we need to split up our viewController.swift. The controller should really only be responsible for telling the other components what to do and respond to changes in other components. This means that the viewController.swift should handle what to do with the user interaction from the view and tell the view what it should display. It should also fetch the relevant data from the model to send to the screen and tell the model to update itself. But at the moment, our view controller is handling all of the quiz data as well as all of the quiz logic. So we first have to separate this part out. Go ahead and right-click on the model folder, create a new Swift file in there that we'll call the quiz brain. This is going to be the brain of our quiz, and it's going to handle all of the logic. In here, we're going to create a new structure called quiz brain. And the first thing that I'm going to add to this quiz brain is my quiz array here that's currently living inside viewController.swift. So I'm going to cut it out and put it into my quiz brain. And with a little bit of reformatting, we should now have our quiz as a property of our quiz brain. Now, we don't need to initialize this quiz property because we've already given it the value that it needs, and it's never going to change because it's a constant. And we're also not going to be adding questions or removing questions in the middle of running our app. Next, we're going to move the question number variable over to the quiz brain as well, because the quiz brain is now going to be the one that's tracking these sort of things to do with the quiz. Now, at this point, if you take a look inside your view controller, you'll notice that pretty much all hell has broken loose out here. And there will be errors left, right, and center. You might have doubts about whether if you should have started this endeavor at all, but fear not, I'm here, and the result will be worth it, I promise. If we examine our answer pressed function, you can see that it's actually currently fulfilling two roles. One is the answer checking part, and two is the quiz progression, so going to the next question. Now let's create a new instance or new copy of our quiz brain at the top of our view controller. So just below our IB outlets, we're going to create a new variable called quiz brain. And of course, the copies of our structs need to be lowercase to begin with. And we're going to create that from our quiz brain structure. So quiz brain in capitals, and then a set of parentheses at the end. And you might need to just hit Command B every so often for it to recognize what you're talking about. Now we can use our quiz brain inside our viewController.swift. So next we're going to move our answer checking logic out of our viewController.swift and make our quiz brain handle it instead. To do that, we'll need a function inside our quiz brain. Now, whenever a function is associated with a structure or a class, basically some sort of custom type, well then usually we call it a method. But this is just something that's quite pedantic. In reality, if you hear functional method, they essentially refer to the same thing, a package of instructions wrapped inside a name. So inside the curly braces of my structure, quiz brain, I'm going to create my method, which is going to be called check answer. And this method is going to need an input in order to work. So the input is going to be the answer that the user chose, and this is going to be a string. Next, we can go into our view controller and delete this line of code. Instead, we're going to move that functionality to our QuizBrain. We're going to call QuizBrain.check answer, and then we should be able to add the parameter, which is user answer, and the argument that we're going to pass in, or the value, is of course going to be this one. So it's going to be user answer. Now, if you think this is a little bit excessive in terms of the naming of our method, check answer, user answer, then one way of making this a little bit shorter is actually to add an external parameter name. So remember that the parameter name refers to the name of the input that comes into the function. So we can have an internal and an external parameter name in Swift. So for example, if I decided to call the external parameter name answer, then I would be able to use answer here as the external parameter name. Meanwhile, inside the function, I can use the internal parameter name, which is that user answer right here. Now, what we can also do is we can also simply say that there shouldn't be an external parameter name. And to do that, we simply replace the external parameter name, so the first part, with an underscore. And now, inside our view controller, we can simply write check answer and pass in this as the argument. So remember, the argument is the value that gets passed in as the input. The parameter is the name of the input. And we now have an external and an internal parameter name. We use the internal parameter name inside the function. The external parameter name is used when we call the function. And in this case, because we turned it into an underscore, it no longer needs an external parameter name. And our method now reads a lot better in English. Check answer, which answer to check? Well, the user's answer, of course, which comes from here. Now, at this point, we get an error that tells us that this user answer is actually an optional string. But check answer is, of course, expecting an actual string. So in our case, because we only have two buttons that are linked to this IB action, and they both definitely have a title, we can be fairly confident in force unwrapping this current title. And that turns our user answer into a actual string data type. So now let's go back to our QuizBrain and check the user answer that was passed in against the actual answer. So let's add our if statement here, check to see if the user answer is equal to the quiz at the current question number dot answer. Well, then in that case, they got it right. So user got it right. But otherwise, then the user probably got it wrong. So now, while we're in the process of implementing the MVC design pattern, we're coming up against a roadblock. Our problem is that the answer checking happens in our QuizBrain, but it's our view controller that's responsible for updating the UI, changing the sender's background color to green or to red. How can we get the result of this check answer method out from the QuizBrain and send it over here into the view controller? Well, if you can solve this problem, you might already know how to use Swift functions that have outputs. But if you don't know how to solve this, then head over to the next Swift deep dive, where we talk about the third type of functions that can have outputs. Hey guys, welcome to another Swift deep dive. And in this deep dive, we're going to talk about functions that can have outputs. So far, we've already seen two types of functions. The most basic, or the vanilla version, if you will, is simply where we package a bunch of code together and we execute them line by line in the same order. So that saves us from typing lots of code repeatedly, and especially when we have a functionality that needs to be executed multiple times, these types of functions can be really handy. Now, we also saw the upgraded version of the function, the strawberry flavor, where in addition to calling a function, we also were able to modify what the function did by providing an input. So, for example, we could tell our robot how many bottles of milk to get, instead of it just executing the same row task every single time. Now, in this lesson, we're going to cover the third and obviously the most awesome type of functions, the chocolate flavor, which also happens to be my favorite. And in this third flavor, not only are we able to provide an input, namely how much money to give our robot, but we also get an output. In this case, it's how much change the robot ends up with after buying our milk. So now we're talking about the type of functions that can actually have an output. Now, this is how we would create our function. We again have our func keyword, the name of our function, and we can, if we want, to have a set of parentheses where we provide our input and the data type of the input. Now, in order to specify that this function can produce an output, we add a return arrow here, which is simply just a hyphen and a right angle bracket. And then we add the data type that we expect to return, so the return type. And then we have a return keyword somewhere in the body of our function. And after the keyword is where we provide the value that will be the output of this function, or the return value. And that value, of course, must match the return type that we specified earlier on. So when we call the function, this is what our code might look like. Unlike previously where we just had the function call and then we just expected it to execute, well, in this case, we actually have an output, and this function call right here will actually become replaced by the output. So in this case, if we gave this function 4 as an input, 4 becomes the amount of money. 4 minus 2, the change becomes 2. The change that's returned, or the output of this function, is 2, which is of course a integer or a whole number data type. So this whole right-hand side of the equation becomes equal to 2, and that value gets assigned to our variable change. Previously, we saw these two types of functions. A function that just has some code in it to be executed, and we called our function like so, which simply just does whatever is inside the curly braces. And we also had our functions with an input, which can of course incorporate some piece of data into how it executes the code. So now it incorporates that and prints out the message depending on the input. Now in our third type of function, greeting 3, well, now we might also have an input. Let's say it's a string data type, but we're also going to provide an output. And the output in this case I'm going to choose is a Boolean, because what I want to do with my function is check to see if the input name, so the person at the door, let's imagine, has the name that matches somebody on my guest list. Let's say I'm only going to allow Angela in, or if the name was equal to Jack Bauer. So only Jack Bauer and Angela are allowed admittance, and in this case, if it did match, then we're going to return true, which is of course a Boolean data type, but otherwise we're going to return false. So no entry. Now when we call our function greeting 3 and pass in a name, let's say my name, now this particular line, this part, will be equal to the output. When the code runs, as you can see in the right hand side of our Swift Playground, it will be equal to whatever the output is, which is of course true. Now we can also capture this inside a variable. Let's say door should open. And we could set door should open to the output of our greeting function. And now you can check and see that this door should open has been assigned a Boolean data type, because the value that gets put in it is, of course, the output of our function greeting3. If you were to print door should open, then you will end up with the true value as long as this name is matching Angela or Jack Bauer. But if it didn't, then we would end up with false. So this is our function with inputs, and function with inputs and outputs. So now you're ready to tackle the assignment on functions part 3. In the last lesson, we started to reorganize our code after the model view controller design pattern. We've just added the check answer method to our quiz brain. However, our code is still incomplete. So in order to make this work, we need to get our check answer function to return an output. And that output has to be either true or false, so that we can determine what color to tell the UI to change to. If we head back over to our quiz brain, let's modify our check answer function to allow for an output. And the data type is going to be a Boolean. It's either the user got it right or the user got it wrong, true or false. Now we're getting an error saying that we're missing a return in a function expected to return bool. We said that we would return an output, but nowhere in our code do we actually do that. Let's go ahead and delete these comments and return true if the user got it right, and return false if the user got it wrong. Now that our function has an output, we need to catch that value at the point where we call this function, namely in our viewController.swift. Here is where we call our function that belongs to the quiz brain, and when this line runs, then this line will be replaced by the value of the output. So let's go ahead and capture it inside a constant. So I'm going to call this constant user got it right. And I'm going to set it to equal the output of this function call. So if user got it right is equal to true, it means they got it right. If user got it right is false, it means they got it wrong. And now, instead of checking this whether if user answer is equal to actual answer, we can check if user got it right. Now, because this is already going to be a true or false value, we don't actually have to make any checks to see if it's equal to true or equal to false. As long as the value is a true or false, a Boolean, then we can simply make our check like so. You can of course go much further to shorten this code, but always remember to optimize for readability. And readability depends on your level of skill or the people who you're working with. If another programmer was looking at your code, would they be able to easily understand, for example, if I was to shorten this to quizbrain.checkanswer sender.current title? Maybe, maybe not. I'll let you be the judge of that. This part of the code does exactly the same as all of this code, but we've just split it out into several components to make it easier to understand step by step. Next, let's turn our attention to the update UI function. Here, we're grabbing the question text to display, and we're also calculating the user's progress. However, these two things sound like the perfect job for our model, don't you think? As a challenge, I'd like you to use your knowledge of functions to move this logic into the quiz brain. I want you to fix both of these lines of code, 48 and 51, or whatever line your code is on, so that you end up with a view controller that has code that looks like this: quizbrain.getQuestion text. And down here, it should be something like quizbrain.getProgress. And you need to be able to fix the quiz brain to make these two lines of code work. At the moment they won't, because there isn't such a thing as get progress or get question text, but if you go ahead and modify your view controller to make it look exactly like this, and then complete the challenge by adding the necessary code to the quiz brain. Pause the video now and give that a go. Alright, so we know that we need to grab the question text with this method, getQuestionText, inside our QuizBrain. So let's go ahead and create this method. Inside our QuizBrain, maybe just below our check answer, I'm going to create that new function, getQuestionText, and then I'm going to make sure that this function has an output. And the question text is, of course, a string data type, so that's going to be my output. And what I'm going to return is the question text, which corresponds to the current question number. So I'm going to use my return keyword, and then I'm going to search through my quiz for the one at the position of my question number, and then I'm going to get the text property of that question. So now if we hit save and we go back, and you might need to beat your code with a stick by hitting Command B for it to refresh and update, but this line is now completely error-free and all the bits of code are colored in the right colors. Now let's fix the next one. So we need a method called getProgress in our QuizBrain that returns a floating point number that we can assign as the progress. So if we go back into our QuizBrain and create that function called getProgress, and this of course has to return a float because that's what the progress view requires. Now, in order to work out the progress, we can of course use the equation that we used before, which is the current question number divided by the total number of items inside our quiz array, so quiz.count. And then, because these are integers, we have to first convert them into floating point numbers before we make that division. And now we can return our progress. Now, if we hit save and we go back to our view controller and hit Command B to build, then you can see this line is now passing as well. So, well done if you managed to get that right. If you didn't, be sure to review the last lesson on functions with outputs to get a better idea of how it works. The next thing we're going to do is let's deal with the quiz progression functionality. The part that keeps track of the question number should really be inside the QuizBrain because it's kind of a quiz functionality. Let's go ahead and cut it out from here and move it over to our QuizBrain. In our QuizBrain, I'm going to create a new function called nextQuestion, which is going to handle the question progression functionality. And then I'm going to paste the code that I had from before into here, and I can Command A to select and go to structure and re-indent to neaten up the code so that it's easier to see. Now that we've removed these lines of code from our view controller, we have to replace it, so at the position where we used to have it, we have to replace it with a call to quizbrain.nextQuestion so that we pass the baton on over to here. At this point, we've restructured our code quite a bit, and we're slowly starting to conform to the MVC design pattern. You can now see how our model is getting all the quiz-related responsibilities. It's now our QuizBrain that knows all about the quiz questions, not our view controller. It's also our QuizBrain that decides if the user got the answer right, which question comes next, and how far the user has progressed. But notice how we've now got some different errors over here, and it says something about left side of mutating operator isn't mutable. Self is immutable. So what exactly is immutable and what does it mean? If you already know all about this, then feel free to skip the next deep dive, but otherwise head over to the next lesson where we're going to do a deep dive on immutability, and I'll see you on whichever lesson you choose. Hey, it's me again, Angela from the App Brewery. Welcome to another Swift deep dive. And in this deep dive, we're going to talk about immutability. More specifically, what does it mean when we say that a struct is immutable? Let's quickly recap some key concepts. When we create a struct in our code, we're essentially creating a blueprint for an eventual object that will get created from our blueprint. And in this blueprint, we get to plan ahead for how this eventual object will be. For example, we create variables, such as our question number, and when our variables live inside a struct, that variable is associated with our struct, and it's known as a property of that struct. Similarly, we've created functions inside our structs, and when functions are created inside a struct, they're known as a method. So you can consider these properties as a way of defining what this eventual object created from the struct will be like. So its attributes or its properties. And the methods can be thought of as what the object can do. So when we created our QuizBrain struct, we were essentially creating the blueprint for the eventual QuizBrain that would get created. And we can take our blueprint and initialize it, which turns it into the actual object. Now we come on to the topic of immutability. Swift was designed so that anything marked by the let keyword is immutable. But what does that mean? Suppose you created this structure from a bunch of different Lego blocks using the let keyword. But at some point, you decide that you want to change some aspect of it, say the color of one of the bricks. Well, unfortunately, because the structure was created using the let keyword, meaning it's immutable, you can't just change this one brick from green to yellow. Well, instead, you have to destroy the entire structure and create a brand new one that has a yellow brick there instead. So the way that I think about immutability is, imagine if you created a sculpture from stone, right? If you created Michelangelo's David and you decided that it should have a larger nose. Well, you can't just come along and chip away at the stone because the nose is already too small. What you actually have to do is to completely destroy the sculpture and carve a new one with this gigantic, ugly-looking nose. And that's how you would work with immutable objects. You destroy the old copy and create a new copy that encompasses the change. So how does this discussion about immutability relate back to our Swift code? Well, firstly, it relates to the keywords var and let. Things marked with var are mutable, and things marked with let are immutable. But immutability also relates to structs. With structs, Swift makes an additional distinction. There's a difference between mutating a struct from the outside and changing a property from inside the struct. Let's go back to the example of my town so I can show you what I mean. Remember when my other hero, Keanu Reeves, moved into my town? Well, I certainly remember. In this case, we changed the citizens property from outside the struct. We wrote mytown.citizens.append and mutated the citizens property. But now, let me show you what happens when we try to change a property of our struct from within the structure itself. So suppose that we wanted to create a function inside our town struct that allows us to change the resources. Suppose that in our town, we also had a method called harvest rice. And in this case, what happens is we add some rice to our resources, right? So this is a property of our town, which is a dictionary that has a string as a key and an integer as the value of the amount of resources we have. So when we harvest rice, what actually happens behind the scenes is we tap into our resources, we go ahead and reach in and look for the rice resource, and then we set it to equal 100 bags. But in this case, we have a method that changes a property of our struct from within the struct. And we get an error, cannot assign through subscript self is immutable. What does that mean exactly? What's actually going on here? Well, we're trying to mutate the resources property of the struct itself. The code that we wrote is actually shorthand for self.resources brackets rice equals 100. That's why the error message mentions self is immutable. You can think of self as a property that gets automatically created. We can always access self inside a method, just like how we did in our init function, with self.citizens or self.resources. And it refers to an instance of the structure itself, from within the structure's declaration. But here's the catch though. Inside a struct, when self is created automatically in the background, it's defined with the let keyword. That's why self is immutable. So if we want to mutate any property from within our structure, like self.resources, then we need to mark our harvest rice method with a special keyword called mutating. And then you'll see all our errors will go away. So now we can say mytown.harvest rice, and then we can go ahead and print mytown.resources, and you can see that when this code runs, that in addition to having some wool to begin with, we've also got a bunch of rice now. Yay, food! And the only thing we have to do is that if we're making a method that modifies one of the properties from within the struct, then we have to mark that method as mutating. By marking the method as mutating, self will behave like a var, and we can freely change any of our struct's properties. And the other way to look at this is by thinking of structs as having two kinds of methods. The first kind of method is a plain method that doesn't change anything about the struct. But the second kind of method is a mutating method that can change the state of the structure. So given everything we've talked about, I've got a question for you. Do you think you can call harvest rice if we wrote let mytown instead? Well, the answer is no. When we use the let keyword, our struct and all its properties are immutable, and we cannot call a mutating function like harvest rice. And that wraps up our deep dive on immutability. See you in the next lesson. In the last lesson, we added the logic to progress to the next question into our quiz brain. However, Xcode gave us an error as soon as we tried to change the question number. And the reason is we're trying to change a property of our struct from its methods. Here is our struct blueprint, and here when we actually use that struct, that quiz brain, well, this is the actual struct object. So each of these properties, say the question number or the quiz, well, they are associated with that object created from the struct, and they cannot be changed. The only way we can change them from inside one of our methods is to mark those methods with the keyword mutating. In other words, we have two kinds of methods in our structure. The first kind is a method that doesn't change anything and just returns a value, like getProgress. And the second method is one that changes a property in the quiz brain. The only thing we have to do is to help identify which functions will change a property in the quiz brain. That's why we have to mark our next question method as mutable. So if we click on this suggestion, you can see that it's telling us one of the fixes is to mark this method as mutating to make self mutable. So if we click fix, you can see it adds the mutating keyword before the func keyword. And what this tells the computer is that when this function is run, it will replace the old value of question number with a new value. So every time you create a struct and inside one of the functions or one of its capabilities, you need to be able to update one of the properties. So a var or a changeable property, you have to do that inside a mutating function. So if we run our app right now, you can see that our app works perfectly just as it did before. But in this case, we've shifted all of the quiz logic into a separate structure called the quiz brain. And our controller, or the view controller, now is only responsible for delegating these tasks to the quiz brain. Say, hey quiz brain, give me the next question, or hey quiz brain, check this answer for me, or get me the question text. And the controller is now talking to our model to be able to make the quiz work. And our controller is also talking to our user interface, namely changing the button background colors or updating the UI every time we go to the next question. And the code is now much easier to understand, more reusable, and more modular. So we've now implemented the model view controller design pattern to our Quizlet app. To practice coding in this MVC design pattern, we're going to set you a challenge. And the challenge is to make our app be able to keep track of the user's score. So what you're going to do is you're going to create a new label and you're going to drag it to the very top of our vertical stack view. So it gets placed here. And then we're going to modify some of the attributes or properties of this label. And I'm going to change the text color to white to be able to see it against the dark background. Now, the next thing I'm going to do is I'm going to create an IB outlet that links from this label to my view controller. So I'm going to create it just about maybe here, and I'll call it score label. Now, finally, we're going to go to our view controller, and under update UI, I'm going to set the score label's text property to equal to, say, score, colon, and then I'm going to use my string interpolation to insert a method to get from my QuizBrain. So I'm going to tap into my QuizBrain and I'm going to say get score. So here comes the challenge for you. At the moment, there is no such thing as get score in QuizBrain. So pause the video and make sure that all of your score tracking and score managing and score keeping functionality happens inside the QuizBrain. And if you manage to successfully complete this challenge, this error should of course go away, but also we should be able to see the score start out with 0, and every time we get an answer right, the score will go up by 1. So if we get an answer wrong, nothing changes, but all the correct answers will increase our score. And once we get to the end of our quiz and it resets, well, our score should also reset to 0. So this is the challenge for you to practice using MVC and making sure that this quiz-related functionality lives inside the QuizBrain. Pause the video now and try to complete this challenge. Alright, so here comes the solution. We know that we can't write any code in our view controller, which is solely responsible for updating the UI and talking to our model. So we have to make our model be able to perform the functionality of keeping track of score and sending it back via this method called getScore. So if we go over to the QuizBrain, this is where all of the heavy lifting is going to happen. So the first thing I'm going to do is I'm going to create a variable that's going to keep track of the score in a similar way that I'm keeping track of the question number that the user is on. The score is going to start out with a value of 0. But when is it going to get increased? Well, whenever we check the user's answer and it matches the correct answer, well, in that case, not only do we return true and tell our view controller that the user got it right, but we also increase the value of score by 1. Now, we're not going to do anything to punish them when they get it wrong, but we do have to address the issue of the mutating function, because again, we're modifying one of the properties of a struct, so therefore we have to mark this function as mutating so that we rebuild our structure with a new value for score. Now, the next thing we need to do is to be able to send this score back through the function that the view controller calls, which is called getScore. So I'm going to copy that, and in my QuizBrain, just above my getQuestion text, I'm going to create a new function called getScore, and this is going to return the score, which is of course an integer or a whole number, and it's simply going to return the value of our score property, which lives inside our QuizBrain. So now, the very last thing we need to do with score is to remember to reset it down to 0 when our quiz restarts. So not only do we reset our question number, we also reset our score. And now if I run my app, firstly, my errors should go away because this method now exists. And also, I'm now able to keep track of the user's score. When they get a question right, the score goes up. And when they get to the end of the quiz, the score resets. So did you manage to get that right? If you want more practice on using the MVC design pattern to be able to switch out or modify just the QuizBrain component and leave everything else as is, we've got an optional challenge for you. And the challenge here is if you go into the README, you can see that in addition to the default quiz, we've also got a section called the multiple choice quiz. So if you were to copy all of these multiple choice questions and replace the questions that's currently inside our quiz array with the multiple choice questions, can you figure out how to modify the code in the app so that you end up with a multiple choice quiz? And if you manage to successfully complete the challenge, then this is what your app will look like. And it's now modified to be able to serve up 3 possible answers, and then the user can select the answer as one from the 3. So there's a number of things that you'll have to modify in the app for this to be able to work. And if you want to tackle this optional challenge, then go ahead and replace the quiz array now. And once you're done, you can compare your answer against my answer by downloading the completed project for the multiple choice quiz, which you'll be able to find, of course, in the course resources. But either way, no matter what you choose, I'll see you on the next module.
Subscribe now and press the bell icon. Never miss an update.
Hey guys, welcome to another module of the Complete iOS Development Bootcamp. In this module, we're going to be building out a BMI calculator. And in the process, we're going to learn more about classes and compare them to the structs that we've already seen, as well as get a greater understanding of optionals. By the end of the module, you will have built a beautiful BMI calculator app, which will be able to calculate a user's BMI. You'll see the UI slider in action and implement it, as well as learn more about some topics such as creating classes, the difference between classes and structs, creating user interface programmatically without the use of storyboards, as well as making a multi-screen app by learning about segues. We're also going to be learning about some advanced features or optionals, including optional binding, optional chaining, and the nil coalescing operator. And finally, you're also going to see color literals in use, which are kind of similar to the image literals that you've seen in Dicey, but these are going to be used to select colors from a palette directly in your code. So it's a jam-packed module as always, and once you're ready, head over to the course resources page and click on the GitHub link to clone the starting project. And then once you're done, join me on the next lesson. In this lesson, we'll get to grips with UI sliders and get them working inside our app. So you should have cloned the starting project and have the project open inside Xcode. Now, first, let's take a look around the starting project. So notice that we've got our model view and controller folders already created for you. And in our views folder, we've got our main storyboard that has all our designs. But in this case, we've actually got 2 screens or 2 view controllers compared to previously where we've limited ourselves to building single screen applications. So in this case, we're going to have one screen, which is for the calculator, where the user toggles their height and weight and then presses the calculate button. And then that will take them to the next screen where it shows them their result and some advice. Now, notice that in the calculator view, we've added some UI sliders, and if you need to find them, they're in exactly the same place that you always find everything, which is, of course, in our objects library, and here we've got a slider. So it displays a horizontal bar, and it represents a range of values. We can define the maximum and minimum values in the attribute inspector once we have the slider selected. So for my height, which is in meters, I've got the minimum to be 0 meters, which hopefully nobody is, and I've got the maximum at 3 meters. Now the weight I've set to be 0 and 200, so you can feel free to adjust these as you see fit, but I think these will work fine for most people. Notice how we've got these labels here inside a stack view, and these labels should update to equal the value of the thumb in the slider track. So I've set the starting value to be 1.5. Now you can also set it to be at the beginning if you wanted it to be at 0, which is the minimum value. But I quite like starting it out in the middle. It looks quite neat. Notice there's also a warning up here that says view controller is unreachable, and when we click on it, it tells us which one it's referring to, which is of course this result view controller. But don't worry about this warning for now. We're going to fix it when we learn about multi-screen apps and how to navigate to this second screen. For now, we can just safely ignore it. But what we can't ignore right now is our sliders don't yet work. Now, the behavior that we're after is something like this. We should be able to move the slider along the track and see the height label here on the right update. So every time I move the slider, then the associated label should change its values according to where I am on the slider, from the minimum of 10 to the maximum of 200, and the height goes from 0 all the way up to 3. Now the height has 2 decimal places of accuracy, whereas the weight is rounded to the nearest whole number. So that's the objective. That's the behavior we're aiming for by the end of this lesson. But let's break it down into a series of steps. The first step will be printing the value of the slider when we move it along the track. So here's a challenge for you. Can you link up the height slider with an IB action called height slider changed and the weight slider with an IB action called weight slider changed, and then figure out how you can print out the value of each slider when they do in fact get changed. I'll give you a few seconds to pause the video before I show you the solution. Alright, so how did you do? Did you give that a go? Well, the first thing that we need to do is, of course, link up some IB actions, right? This is a component that can take user interactions, just like the button. How do we do that? We, of course, pull up our assistant view, and then we can start linking up our design with our code. And I'm going to select this horizontal slider, which you can see is the height slider, and I'm going to control drag over here, and I'm going to call that action the height slider changed. And notice how the event type that triggers this IB action is when the value of my slider changes. And to be more accurate and to make life easier for me down the line, I'm going to change the data type to be a more precise data type. Rather than any data type, it's going to be a UI slider that's going to be linked to this action. So that's my height slider done, and now I'm going to do the same with my weight slider. So this one's going to be called weight slider changed. And again, change the type to UI slider, hit connect. So now I've got my 2 IB actions down. Now the next step is, how do I change my code so that whenever this IB action gets triggered, I can print out the value of my slider, where I am on this slider track. So we know that when we select these UI sliders in the interface builder, and when we look in the attribute inspector, the value property is the one that we actually want, right? Like right now it's set to 1.5, but I could set it to 1.7, or I could set it to 0, and that moves the little circle along the track. Now, if we go and check in our IB action, notice how we've got a sender, which has a data type of UI slider. So if we tap into the sender, which is of course that slider, and we write a dot, you can also just scroll through this list and see if there's any properties that you think might be what you want. And we can see that there's actually a property that matches the one we saw in the attribute inspector, the value. And the explanation is that this will be equal to the slider's current value. Well, that sounds pretty much like exactly what we need. So now all we need is to wrap it inside a print statement and then copy it over to the weight slider as well. And you've now got the functionality that we described. So that completes the first 2 steps. We've linked our sliders to our view controller, and we've successfully accessed the value of each slider. The next thing to notice is that when these values get printed, well, they actually have quite a lot of decimal places. That's a high level of precision, but we don't really need it to be so precise. Here's another challenge for you. Can you figure out how to round the height slider value down to only 2 decimal places? So we move the height slider. The goal is to only have 2 decimal places being printed rather than 4 or 5. So pause the video and see if you can complete this challenge. So there's quite a few ways of doing this, but if I did a just cursory search of how to round a number to 2 decimal places using Swift, then one of the solutions that you might come across is to use the string formatting. So we pass in the number that we want to be rounded, and then we specify the number of decimal places we want by using this percentage dot. And the 2F refers to 2 decimal places after the floating point, or you could have 1F for 1 decimal place, 0F for 0 decimal places. So let's try this. In our height slider, we already know that we can get access to the sender.value, which is going to be quite precise, so it has a lot of decimal places. And this is going to be the thing that we want to round. And if we apply the code that we found here, where we write string, and then we type format, just like we saw, well, this particular method is going to return a string initialized by using a given format string as a template into which the remaining argument values are substituted. That sounds pretty confusing, but essentially all it takes are 2 inputs, the format string and the thing that you want to format. In this case, the thing that we want to format is, of course, sender.value, so we'll put that in here. And the format string, as we saw before, we just had to put percentage dot to F, just as we have in the code snippet here. And then finally, we're going to go ahead and print this entire string. And now if we run our app, you'll see that functionality I described earlier on, so 2 decimal places. The next thing to do is our weight slider. We want it to be a whole number. So when we move the weight slider, we don't want to see any decimal places. And so I'm again going to leave this as a challenge to you. There's actually multiple ways of doing the same thing, but pause the video and see if you can achieve this effect. Alright, so in this case, we could have done what we did before, which is where we simply do string format the sender.value, and instead of 2 decimal places, or 2F, we put 0F. And now, when we run our app, you can see that we have no decimal places. Now, the alternative way of doing this is we could have also converted our sender.value, which, if you check, is actually a floating point number. We can actually just convert it into an integer by writing int and then having a set of parentheses, and inside we write sender.value. Now, when I do that, you'll see that I get the same effect, again, with numbers with no decimal places. So now that we've got our height to 2 decimal places, our weight to no decimal places, we're ready to move on and get the user to be able to see these values. Firstly, we're going to add some IB outlets. The place that we want to display these values are, of course, this label and this label right here, because the user can't see the debug area, so we need to be able to put these values onto the screen. At the top of my file, I'm going to go ahead and control drag my height label here, and I'm just going to call height label. And also I'm going to create a link from this label right here, which I'm going to call weight label. Now I've got my 2 labels connected. Let's quickly format our code. Well, how do I get these numbers into these labels? And I'd like to pose this as a challenge to you. Upon successfully completing the challenge, you should be able to move the slider and see these labels move with you from the maximum to the minimum, reflecting the value of the slider. Pause the video and see if you can figure out how to do this. Previously, we were already able to print these values to the desired accuracy into the debug console. We now need to get them into these height labels and weight labels. So let's delete the print statement, and we're left with the value that we want to put into the height label. So now all we need to do is tap into our height label, and then get hold of its text property and set it equal to the string that we formatted based on the sender.value. Now, if you used this method that I showed earlier, where we converted the sender.value into an integer, well, it might be a little bit harder to put it into the weight label, because when we write weight label.text equal to int sender.value, well, there's going to be a type mismatch, because the right-hand side is an integer data type, whereas this text property needs a string data type. So how can we fix this? Well, one way is to wrap the integer inside a string. So we first convert this into a whole number, and then we convert it into a string. But to be honest, that's quite roundabout, so we might as well just use the same method that we have above, which is where we use the format, and then we have %.0f for 0 decimal places, and then we put in our sender.value. So now if we run our app, you'll see that these labels move when I move the slider. But notice how previously we had some units in there, but now we move them, the units are gone. Pause the video and see if you can change the code so that when we move the slider, the units stay as they are. So meters for the height and kilograms for the weight. So pause the video and try to do this. Alright, so before we start formatting, this line is already getting pretty long. So let's go ahead and set this equal to a separate constant. So I'm going to write let height equal this. And then in my height label, I'm going to set the text property to be equal to an interpolated string. So I'm going to insert the value of my height in here, and then I'm going to tag on the meters unit. And I'm going to do the same with my weight. Let weight equal that, and then my weight label dot text is going to be equal to the weight inserted into my string, and then with my kilograms added on at the end. Now we have this behavior that we want. In the next lesson, we'll use our slider values to calculate the BMI. But to do that, we need to be able to get hold of the slider values outside of our IB actions. For all of that and more, I'll see you on the next lesson. In the last lesson, we started working with UI sliders. In this lesson, we'll use the slider values to calculate the BMI. What if we wanted to get hold of our slider values outside of these IB actions, where we have access to the sender, where we're getting that sender.value from? How might we do that? So if I go ahead and create an IB action from this calculate button and put it right at the bottom of my view controller, so let's call that the calculate pressed, and change the type to UI button, click connect. Now I've got this IB action which gets triggered whenever the user taps on the calculate button. Now, how can we get hold of the weight and height inside these curly braces? Because this sender is, of course, the button that triggered the IB action, whereas this sender is the slider that triggered this IB action, and they are separate from each other. One way of doing this, which is probably the easiest way, is to simply create some IB outlets from these sliders as well. We've got our IB actions, which gets triggered when these are moved, but we can also create a IB outlet from the height slider, which I'll simply just call height slider, and another IB outlet from our weight slider, which is going to be called weight slider. And now, because we have these variables to play with, our height slider and our weight slider, which are linked to the interface builder sliders, well, inside our calculate pressed, we could quite easily get hold of the height slider dot value and the weight slider dot value. And if we run our app, you can see that when I move these sliders and click calculate, you can see the original floating point values from each of these sliders being printed. So now that we have the height and the weight, let's set this to a height constant, and down here let's create a weight constant. How can we use these two pieces of data and calculate the body mass index? Here's the equation for calculating the body mass index, or BMI. We take the weight in kilograms and we divide it by the height in meters squared. So height times height. Now I want you to try and be able to print out the BMI based on the weight and height that we got from the sliders and calculate it and print it into the console based on this equation. So pause the video and try to complete this challenge. Okay, so we have our height and we have our weight. We just need to implement the equation so that we can create the BMI. So I'm going to create a constant called BMI, and it's going to be equal to the weight divided by the height squared. Now, there's two ways of doing this. You can either do the simple way where we just write height times height, because after all, that is what height squared does at the end of the day. But the other way that you could do this is use a custom Swift method. So you might have come across this if you Google for how to square a number using Swift, but there is a function called the power function, which takes two inputs. The first, the number that you want to raise to a particular power, and the second, the actual exponent. So in this case, if we wanted to get the height squared, we would write pow, and then the first input would be the height, which is the value we want to raise to a power. And then the second value is the power that we want to raise it to, which is 2. So this line of code is effectively exactly the same as this part of our equation, where we raise our height to the power of 2. And now we can print our BMI into the console. And you can see if I put in my height 1.8 and my weight 63 and hit calculate, you can see my body mass index printed here. The thing that you have to be careful about is that in programming, as with maths, it follows something called BODMAS, which defines the order that the calculations are completed. So the first thing that happens are anything that's in a bracket, and then anything that's an exponent or a root, and then we have our division or multiplication, and finally our addition or subtraction. So you might have written the code as weight divided by height times height. Now in this case, what happens is that the first calculation, weight divided by height, actually gets carried out first, instead of what we need, which is the height squared, so height times height. And if you run the code as it is right now, you'll see that if I put in my height and weight again, instead of getting something around 19, I'm actually getting 62, which is extremely morbidly obese, which would shock somebody if they used your app that was using this incorrect equation. So we have to put in those brackets around the height times height if we want to write our equation like this, so that the brackets are carried out first before any of the other operations. Now that we've managed to get our slider to work, to be able to put input into the slider, to change and update our label, and use it to calculate the BMI, well, what else is there left in this module? Don't worry, there's still plenty of things coming up, and in the next lesson, we're going to learn about a really exciting topic, which are classes. For all of that and more, I'll see you there. Hey guys, welcome to another Swift Deep Dive. In this deep dive, we're going to be learning all about Swift classes, what they are, what they can do, and how to create them. Now, classes, like structures, are again a way of defining a blueprint. They're a way for us to be able to plan out properties and methods, and eventually, when we run our app, be able to initialize our class into an actual object. So in this lesson, I'm going to talk about how to create an object from a class. But in addition, I also want to talk about some of the core concepts of object-oriented programming, namely inheritance, subclasses, superclasses, what it means to override a method, and what it means to call a method from a superclass. So let's create a separate project in Xcode to show these concepts in action. I want you to go to File, New, and choose a new project. Now, when you see the wizard, I want you to choose macOS and select the command line tool. Now, the reason for this is we're not actually creating an entire app, but we are creating a project which can have multiple Swift files associated in the same project. Our project name is going to be called Classes Demo, and then you can go ahead and click Next and save it anywhere you like. So this is what you should end up with, and notice how we have a main.swift file that already gets created for us, and inside all we have is just a print statement. So I want you to delete everything that's currently inside your main.swift, and you'll notice that when we run our project this time, what will happen is it will look inside the main.swift file and run all the lines of code in here as if it were a playground. So if I wrote print hello, well then that is what will be run and printed into my debug console when my program runs. So we can expand this and we can collapse the right hand pane. And in fact, I'm also going to collapse this left hand pane so we have a full length debug console. So now it looks pretty similar to what we have when we create a playground. But in this case, I can actually create multiple files inside the same project, my classes demo project. So how do we write the code for our class? Defining a class is very similar to defining a struct. We have the class keyword, and then we have the name of the class, which is capitalized from the start, and then we have a set of curly braces inside of which we can define the implementation of the class. Let's create a new Swift file for a class in our project. So here I'm going to right click and I'm going to create a new file in that folder, which is going to be a new Swift file, and then hit next. And now I'm going to name my file the name of the class that I'm going to create, which is going to be called enemy. So let's imagine that we were building a simple game where we have to create enemy characters for our game. So the first thing I'm going to do is I'm going to delete all the code in here. We are going to create our code entirely from scratch. In this enemy.swift file, I'm going to create my enemy class. To create my class, I'm going to use the class keyword, and then I provide the name of my class, which is going to be called enemy. And it is convention that when you create a class, that the name of the file matches exactly the name of your class. Now I'm going to open a set of curly braces to define this enemy class, what it can do, and its properties and its methods. For the enemy characters in my game, they might have a number of attributes or properties, right? Things like maybe they would have a health stat. Let's say that they start out with 100 health. And they might also have an attack strength. So this is how hard they hit. Now these are the properties of my enemy class. But I can also describe behaviors that the enemies can perform. So I would do that by creating a function. Let's say that each of my enemy characters can move. So I could have a move function. And when this move function is triggered, all that happens is that the enemy characters walk forwards. Now we can also define a attack function. And when the enemies attack, what should happen is maybe they would land a hit, and it will do some damage depending on the attack strength of this enemy character. So I'm going to use string interpolation to insert the attack strength value in here. So, for example, a default enemy character with an attack strength of 10, when it attacks, it's going to land a hit and does 10 damage. Now that we've defined our blueprint that defines an enemy character, it's time to go into our main.storyboard, and we can initialize our enemy class here and create an object from that class. So to initialize a class, all we do is write the name of the class and then a set of parentheses. So in our main.swift, I'm going to create a new enemy. Let's say it's a little skeleton. And I'm going to initialize it as a new enemy object. So the name of the class and then a set of parentheses. So now that I've got this enemy object, which is a skeleton, I can tap into its properties. So for example, I could print the skeleton.health property. And if I run my app by clicking the play button, you'll see that the skeleton gets created on line 2, and on line 3 I'm printing its health, which turns out to be 100. And that, of course, comes from the default health property for everything that's created from the enemy class. Now, in addition to using the properties, I can also get my skeleton to do something. So I can write skeleton.move or skeleton.attack. So now if I run my code, you can see that the health is printed as 100, the skeleton now walks forwards, it lands a hit and does 10 damage. Just by creating this enemy class, I can now create lots and lots of enemies. I could create more skeletons, so skeleton 2 is going to be created again from the enemy class, and then maybe we could have a skeleton 3, and instead of having to create each one of them with a health stat and attack strength, define its behaviors, I've now used that template or that blueprint, the enemy class, to create 3 entire skeleton objects, which each can move, can attack, have all these properties. So as you can imagine, it's a lot easier to simply replicate and airdrop in all of these different enemies without having to define each of them from scratch. But in the last module, we saw how to use structs or structures, and we could do pretty much the same thing with them, right? But that's not where it ends. The magic of classes really lies within a special capability that they have, which is the ability to inherit from a superclass. So what do I mean by the superclass? And what does it mean to inherit from a superclass? Well, the key to understanding this is that we can have a relationship between classes. Think of the superclass as a parent. It knows how to do certain things and has certain properties and methods. However, what if we want to take its existing capabilities and build on top of it? Well, yeah, we could do this by adding more code to our existing class. But there's also another way. We can create a subclass and add our additional functionality there. Think of the subclass as the child of the superclass. The superclass has taught the subclass everything it knows how to do, for example, reading and swimming, and the subclass can now grow and develop its own capabilities, like playing with the iPhone, getting addicted to YouTube, or live streaming on Twitch. In other words, the subclass has access to all the properties and methods of the superclass. That's what we mean by inheritance. Now, let's see inheritance in action in our Xcode project. So let's say that I want to have these generic sort of simple enemies like skeletons. I don't know why skeletons always get a bad rep. They always seem to be the most easy to destroy enemies in any game that I've played. But let's say that we wanted to have a more powerful enemy. And we wanted to leverage the code that we've created in our enemy class, but we wanted to make it do more and be more specialized. Let's say that in my classes demo, I create a new file, again a Swift file, and I name this file Dragon. So I want to create a dragon class in this file. So I do exactly the same thing as before, but this time I'm going to use the class code snippet that Xcode Autosuggest gives me, and I'm going to hit enter once I select it. Now this is the default way that we would create a class. Whereas before we created a class that was just a simple standalone class, in this case I'm going to use the ability of classes to inherit from other classes. Firstly, I'm going to give this class a name, which is going to be my dragon class. And dragons are also an enemy. So they're going to inherit from the enemy class. So that means when I create a dragon from the dragon class, I don't actually have to redefine these properties or these methods. It already has inherited all of those properties and methods. And I can show you by simply going into my main.swift, and I'm going to delete all of this code here, and this time I'm going to create a dragon. So the dragon is going to be created from the dragon class. And now with my dragon class being completely empty, other than the inheritance from the enemy class, I'm going to use my dragon object, and I'm going to get it to move, and I'm going to get it to attack. So now if I go ahead and delete all of this code and simply go ahead and press run, you can see that when this line 6 runs, the dragon walks forwards, and it also lands a hit when the attack method runs. So without having to lift a finger essentially in our dragon class, we've already managed to inherit all the capabilities in the enemy class just by inheriting it, like so. Now that's not where it ends though. The whole reason that I created this dragon class is for it to be able to do something different. So let's create a property that is unique to our dragon class. So maybe it has a wingspan. And let's set it to a default value of 2 meters. So it's a medium-sized dragon. But when I create my dragon object, I could change that. So I could say dragon dot wingspan, and let's set it to 5. Let's make it a giant dragon. So this wingspan property, of course, does not exist in our default sort of enemy class. I can't say skeleton dot wingspan. That doesn't make any sense. Skeletons don't have wings. So that is a custom property that only exists inside the dragon class. But of course, the dragon class also has access to all the properties that the enemy class has because it's inheriting from it. So for example, it has the health property, it has the attack strength property. So let's set the attack strength property to a bit higher than your average enemy. Let's make it 15 instead of 10. But in this case, I'm creating a new dragon from the dragon class, and I'm tapping into a property from the superclass, so the class that we're inheriting from. Now, I also want my dragon class to be able to do something that the default enemy class can't do. Now, it seems to me like from all the movies I've watched, dragons always seem to be able to talk. So let's give our dragon the capability of speech by adding a method called talk. And this method is going to take a input called speech, and that's going to be a string data type. And then all that it's going to do is just print the words. It says whatever the speech happened to be. So I'm just going to insert that speech input in here. And now we've got a dragon that talks. So back in my main.swift, I'm going to say dragon.talk, and the speech that it's going to give is my teeth are swords, my claws are spears, my wings are a hurricane. So now we've got a dragon that talks, that moves, that attacks, and if I run my code as it is, you can see that my dragon is talking, it's walking for some reason, and it's landing a hit, doing a 15-point damage. So you can see we've now got this dragon object created from the dragon class which can do everything that the enemy can do, but it can do a lot more. So there's some custom things that only the dragon can do that a bog standard enemy can't. But if you look at our code, when the dragon moves, it probably shouldn't walk. I think it should probably fly instead of walk, right? So in addition to defining custom properties and methods, we can also tap into the methods that are available to us from the superclass, so the class that we're inheriting from, and we can override it. So if we tap into the move method, you can see that this override keyword goes in front of our normal function declaration. And this means now that when we trigger the move method, we can say it does something completely different. In my case, I think that when a dragon moves, instead of walking, it probably should fly forwards. So now, if I go back to my main.swift without changing any of this code, I run my code, you can see now when my dragon moves, it flies forwards instead of walking forwards. And I've managed to achieve that by overriding this method that I got from my superclass and providing a custom implementation. So doing something completely different from the move method that the dragon inherited. Now, sometimes, however, you actually want the behavior of the method from the superclass. So in our case of our dragon, what if I want it to land a hit, do some damage, but also to maybe be able to spit some fire in addition? Well, in that case, I can do this. I can override the attack method from my superclass, and I can do something customized to the dragon class. Namely, maybe dragons should be able to spit fire, and it does 10 damage. But this is not all that I want it to do. I want it to perform the method that came from the superclass, the enemy class, which I'm inheriting from, but then do some custom stuff as well. So I want both the functionality of the attack method from the superclass, as well as some functionality that I've added on as custom. So to achieve this, what I do is I use the super keyword, which refers to the enemy class, which I'm inheriting from, and then I write .attack. So now I'm triggering the attack method from my superclass, which will print land a hit does X amount of damage, and then I want to spitfire and do an extra 10 damage. So now if I go back to my main.swift and I run my code, when dragon.attack gets triggered, my dragon will first land a hit does 15 damage, which comes from super.attack, and then it's going to spitfire and do another 10 damage, which comes from my custom additional implementation of the attack method. So this really is the superpower of classes. You can see that by inheriting from the enemy class, I saved myself a lot of work and a lot of repetition. When we create functions, we know that they help us reduce the amount of repeated code by packaging a whole bunch of instructions inside the same package. Now, when we create classes and inherit from other classes, we're again saving ourselves from creating repeated bits of code, and instead we are just layering functionality upon a superclass. So in fact, without this capability of inheritance that comes from classes, we wouldn't have been able to build any of the apps that we have created so far. If you go to Help and Developer Documentation, you can see how inheritance is used amongst the components that are part of Apple's UI kit. And that includes almost everything we've shown on screen, like UI labels, UI sliders, UI image views, everything with a UI in front of it, basically. So, for example, when we create a button, we're actually creating a UI button. So if you search for a UI button and click on it, you can see that this is a UI button class, and it allows you to respond to user interactions. But this class actually inherits from the UI control class. So if we click on UI control, we get taken to this class's documentation, and you can see that this is the base class for all of the controls, which convey a specific action or intention in response to user interactions. So we're inheriting some of these capabilities when we use a UI button. Now, a UI control itself then inherits from a UI view, which is an object that manages the content for a rectangular area on the screen. And then a UI view itself inherits from UI responder, and UI responder inherits from NS object. So what does that mean? Why is it structured like that? Well, let's think about it in reverse. Apple's most basic class is the NS object. This is the simplest and most generic component, and it's how Apple started out. The NS, in fact, stands for Next Step, which was the company that Steve Jobs started when he got kicked out of Apple initially. Now, the UI responder can do everything an NS object can do, but it has its own additional capabilities. The UI view, in turn, builds on top of the capabilities of the UI responder, and the UI control builds on top of that again. At each level, more code and more capabilities are added. So the components become less generic and more specialized until finally we get a UI button that the user can press. So now that we've chased it all the way up the tree, we can see how it would take so much longer if we had to create everything from scratch and create all of our view controllers from scratch, all of our UI labels from scratch, rather than simply just inheriting and using the capabilities that Apple has already created within our UI kit. And this is all possible because of how classes work and how they're able to inherit from other classes. So in the next lesson, we're going to take a look at the difference between structs and classes and when we would use each. So for all of that and more, I'll see you there. Hey guys, welcome to another Swift deep dive. In this deep dive, we're going to look at the difference and similarities between structs and classes and when you should choose to use each. So previously we already saw that we could create a class like so, and by simply changing that class keyword, we can create a struct. But of course, structs are unable to inherit, so they don't have the part that classes have, where they're able to specify a superclass that they can inherit capabilities from. But there are a lot of similarities too. So in this class that we've created, where we're not inheriting from any superclass, it almost looks like a struct. And similar to structs, we're essentially creating a blueprint to be able to group together attributes and behavior into one component, and later on we can use that blueprint to create an object from it. And we can use it to create as many as we want. So we could spawn, for example, a whole bunch of skeletons simply by tapping into that class blueprint or a struct blueprint. Now, similar to structs, we also have initializers in classes, so I could delete these default values and simply specify their data type, and these are both going to be integers, and then I can initialize it. Now, notice how if we have a struct, we get a free initializer, so we don't actually have to write the init method. But if we had a class, on the other hand, then we would get an error saying that class enemy has no initializers, so we have to provide the init ourselves. And I will do exactly that. So I'll provide an input called health, which has a data type of int, and then I have another one called attack strength, which is also an int. And once those inputs get passed in, I'm going to set the self.health, which of course refers to this current class's health property, which is this one. And I'm going to set it equal to the health that got passed in as the input. And I'll do the same with my attack strength property. And now when I go and initialize my skeletons, for example, let's say create skeleton 1, I have to provide those arguments, right? So if we go ahead and create an enemy and open a set of curly braces, you can see both the health and attack strength parameter expects a value so that I can initialize this skeleton object from my class and pass in the necessary values for my properties, which don't currently have a value. So let's say that the skeleton 1 has a health of 100, attack strength of 10. Now here comes the curious thing. If I go into my enemy class and I create another function, so let's call it take damage. So let's say that our enemy got hit. Well, then we can specify a damage amount. So let's call that amount, set it as an integer, and then inside the function, we're going to update the health property to deduct the amount of damage that it got dealt. So now, when we call the take damage method, our enemy's health should be reduced by the amount that they got damaged by. And now, if I want to create another skeleton, well, if I wanted another skeleton, say, let's skeleton 2, for example, I want it to be exactly the same as skeleton 1. So why don't I just set it to equal skeleton 1? So looking at this code, it would appear that skeleton 2 is a copy of skeleton 1. Let's delete the dragon code and investigate if this is indeed the case. Let's see what happens when skeleton 1 takes some damage. So skeleton 1 took some damage, so dot take damage, and let's say it got damaged by 10. Now, here's a question. If I was to print and get hold of my skeleton 2 object, and I wanted to access its health property, what do you think that should be? Remember that I copied skeleton 2 from skeleton 1 at the point where skeleton 1 was just initialized, so it had full health and it got an attack strength of 10. And then skeleton 1 took some damage, but skeleton 2 nothing happened to skeleton 2. It was just sitting around waiting to attack. So what do you think this line would print? And I want you to have a think about it before you run this code, because it's quite curious. Alright, so if I run the code, you can see that what gets printed is actually 90. Why is it that skeleton 2, which didn't take any damage at all, why does it have a health of 90? Well, this is because classes are passed by reference. So here on this line, where I created a copy of skeleton 1, I haven't actually created a real copy. All I've done is I've created another reference to the same object. So this is basically a second reference to the same skeleton object that I initialized here. Had I wanted to create a whole new object, I would have to essentially copy this code and initialize a new enemy. For if I did this, you can see that skeleton 2 is completely unscathed when skeleton 1 takes damage. This is kind of dangerous though, because just by looking at this code, it doesn't look like as if that's what would happen. And this is why classes tend to be considered as more complex and therefore more error prone than structs. Because in the case of a class, this copying behavior is quite unintuitive, and we've now got two references to the same object, and if we manipulate that object from skeleton 1, say take some damage of 10, and we manipulate the object that we think is a separate object, we take some damage, well actually what ends up happening at the end of the day is that both of these things are actually referring to the same thing. So if I go ahead and print my skeleton1.health and skeleton2.health here, you can see that they're both going to be the same, and they actually in total took a total of 30 damage, even though I thought I was manipulating separate objects. If we had instead created a struct instead of a class, well, firstly, in a struct, we're reminded when we actually mutate our struct. And that happens through this mutating keyword. Because this function will update a property of the struct, it alerts us to this fact already. And we won't be able to do this without making it mutating, because remember, structs are immutable. Now, when this function happens, the old struct gets destroyed and a new one with the updated value gets created. But when I make a copy of a struct, it really does make a whole new copy, and they're completely separate. So now if I try to run this code, it gives me another reminder that this struct is gonna be changed. It says that cannot use mutating member on a mutable value. Skeleton1 is a let constant. So this is a constant and this is a constant. So when we run that take damage, it has to destroy the old object and create a new one in its place. But because we have created a constant here with the let keyword, it is not able to do that. So we have to change this to vars. But now if I try to run my code, the first thing you'll notice is that I lose my capability of inheritance. So my dragon class has to be commented out because enemy is now a struct and it can no longer be a superclass or inherit from any class. But if we're still looking at our main.swift here and I run my code, you can see that skeleton1's health went down to 80 because it took 10 damage on line 5 and line 8, and skeleton 2's health, the one that was printed second, actually only took 10 damage, so it still has a health of 90. So now you can see that our struct is being copied, and skeleton 2 is no longer a reference to the same object that was created in skeleton 1. It's in fact a completely separate copy, which means that when I do things to it, it doesn't affect my skeleton 1 or my previous copy. And so this makes it much simpler to understand the side effects and what might happen when I manipulate these objects. One of the biggest differences between structs and classes is that structs are passed around by value. So what that means is that if I had a photo and I wanted to give it to you, then I could make a copy of it and give you that copy. Now, classes, on the other hand, are passed by reference. So if I wanted to give you access to my photo, I would tell you where my photo is located. So I could give you the location of it on my computer. I could say it's under users/AngelaU/desktop/photo.jpg, and you'll find it there. Now, the problem occurs when lots of people need access to the same resource. Now, in the case of a struct, if lots of people have multiple copies of the same thing, well, if they destroy their copy of it, say you decided to draw whiskers onto my face in this lovely photo that I gave you, well, you've only just destroyed your own copy. Everybody else's copy is unaffected. Now, on the other hand, if lots of people had access to the same resource based on a reference, so they all knew where it was on my computer, and one of them accidentally deletes it, well, that's kind of it for all of us. We've all lost that resource now. So that's why Apple advises that you always default to creating a struct. So start by creating a struct whenever you need that blueprint to create new objects. But if you find that you need inheritance or you need to work with old Objective-C code, then you can simply turn your structure into a class. So that wraps up our deep dive on structures and classes. And to recap, here's a brief summary of some of the things that we talked about. Structures are immutable, meaning that every change that you make to the structure involves destroying the old copy and creating a new one. In addition, we saw how structures are passed by value. So it's passed around by the actual value that's held. Now, in comparison, Classes are passed by reference, meaning that we can have more than one variable that points to the same object, and we're simply passing around the reference to that same object. In addition, classes have the ability to inherit from other classes. This means that we can use inheritance to add additional functionality to subclasses, as we saw with the components of Apple's UI kit. So if you'd like to learn more about structures versus classes, or read about each of those in more detail, I recommend heading over to this page in the Swift Programming Language Guide and taking a look at it. So I'll link to this page and you can get more of a background on structures and classes. In the previous lessons, we worked out the BMI value. In the finished app, this value should be displayed on a separate screen when the Calculate button gets pressed. So now that we've got the BMI value worked out, how can we navigate to a new screen and pass this result over to be displayed? Notice how our screen with the sliders is linked to a viewcontroller.swift file. So our second screen also needs its own viewcontroller file. So how do we create such a new file? Well, firstly, we're going to right-click on the controllers folder, and we're going to create a new file inside this folder. And the type of file we're going to choose is a Swift file. And then we're going to name this file Second View Controller. So notice how we've currently got a viewcontroller.swift, which gets created every time we build a new iOS project, and it comes with some template code already written for us. Well, in this case, we've created a second viewcontroller.swift file entirely from scratch. And the first thing that I'm going to do is I'm going to try and create what we have over here, which is a class. And the class that I'm going to create, instead of being a view controller, which controls our first screen, this calculator screen, I'm going to create a class called second view controller. So as soon as I start typing the word class, you'll notice that the code snippet comes in, and if I hit enter, it'll insert all of the placeholders that I need to fill. So what's the name of my class going to be? Now in Swift, it's convention to name the file that contains the class the same name as the class itself. So my class is actually going to be called Second View Controller. And the superclass is going to be the same as we've got over here in our first screen that Apple created for us. It's going to be a UI view controller. Now notice that as I'm typing this, I'm getting some errors here. And the error tells me that I'm using an undeclared type UI view controller, so it doesn't know what data type this is. But how come we got to use it here? Well, it's because we were importing something called UI kit. And here we're simply importing Foundation. These are what we call frameworks. These are bunches of code that Apple has written to make our experience of developing iOS apps much easier than it would be if we had to build everything from scratch. Now, Foundation allows you to work with most of the features of the Swift programming language. But if you want anything that is specific to iOS, say a UI label or a UI slider, or in our case, a UI view controller, everything basically that starts with a UI comes from the UI kit framework. If you go into Help and go to Developer Documentation, here you'll find on the left here a section on UI kit. So this is everything that the framework contains, and you can read more about it here as well as see all of the things that it includes. And it's really, really broad ranging. Everything from the UI controller to other things that we've been working with, such as the UI label or the UI view controller. And this is what we need to be able to manage our second screen. So as soon as we go over here and we switch out Foundation for UI Kit, because UI Kit actually already includes everything that's in Foundation. It's a level higher and it already has the foundational capabilities, but it has a lot more. So now that we've imported this UIKit framework, well, we now have access to all of the components that Apple has already built inside UIKit, including, for example, a UI label or a UI color or maybe the UI image view. So these are already things that we've come across and we've used. These are the components that Apple has pre-built so that we can simply drop it into our code to start using it without having to define that labels have text properties, they also have a background color property or a text color property. All of these things have already been done for us. So if we take a look at this new class that we've created, notice how this code looks really similar to how we created structs. Well, similar to structs, we start off by using a keyword. Instead of struct, it's now a class. And then we define the name of our class, which is also capitalized to begin with. And these names, which start off with a capital letter, are differentiated from the ones which don't, like the variable names and the function names, so that we know that when we use these, we're tapping into a blueprint, a struct blueprint, or in this case, a class blueprint. The other thing that normally gets created for us when we create a new iOS project and we get our default view controller.swift is the viewDidLoad method. But in this case, because we're creating everything ourselves, let's create the viewDidLoad method from scratch. So as soon as I start writing viewDidLoad, you can see that there is the suggested viewDidLoad method. And if I hit enter, it'll insert all the code that's required. Now, after I delete this code placeholder, you can see that this looks much the same as what we've got in our template view controller. The only thing that's missing is this super viewDidLoad. So let's add that to our viewDidLoad as well. Now that we've successfully created our own view controller from scratch, given how important of a component the view controller is in iOS, I really recommend taking a quick look at the documentation for the UI view controller to start to understand what it does. And in this lesson, as we create our own view controller from scratch, it'll help you understand a lot of the things that are covered. Feel free to go either via developer documentation in Xcode if you have it downloaded, or simply just go to developer.apple.com/documentation and use the search bar as we do normally. So now that we know more about Swift classes, let's continue building out this class, our second view controller. So now that we've got this second view controller file that's managing our second screen, we're going to do a few other things. First, I want to show you how we can create the layout and design of our second screen without using the storyboard. Instead, we're purely going to be using Swift code to programmatically generate the design. Secondly, I want to initialize our second view controller and show it on the screen when the calculate button gets pressed. And finally, we're going to pass over the calculated BMI value that we've got from our first screen over to our second screen so that it can be displayed. Once you're ready, let's get started. Inside our viewDidLoad is, of course, the code that will be triggered when our view loads up. Now, in our case, what we want to happen as the first thing is to create a new label. Now, whereas previously we had access to the storyboard, in this case, I'm going to create the label entirely programmatically. And it's easy when we can rely on our UI kit. So inside our UI kit, there is a component called a UI label. And previously, we were able to drag it from the object library and put this UI label onto the storyboard and then link it to an IB outlet. But at the end of the day, it's still a UI label. So in this case, we're going to create a new constant called label, and I'm going to initialize a new UI label object from the UI label class. So similar to how we initialize structs, we put the name of the class that we want to initialize, and then we put a set of parentheses. So now we have a label, and we can modify some of the properties of our label. So for example, let's say I wanted to change the text property of our label. I simply just tap into the object that was created, so the label, and then write the dot to access the properties and methods, and then I'm going to get hold of the text property and set it to equal the string hello. So now I should have a label that has the word hello as its text. This line of code should be pretty familiar to you by now. It's exactly what we've been doing with our labels created from the object library and referenced with an IB outlet. And if you're ever confused when you're working with components that come from the object library, you can always just hold down Option and click to see what lies under the hood. So in this case, height slider is a UI slider, and our weight label is simply a UI label. However, unlike the UI label that came from the object library, where we are able to resize it and move it around and adjust it, well, in this case, we just have a normal label, and it currently doesn't actually have a size yet. So to do that, we have to define the frame property. So we write label.frame, and this is the frame rectangle which describes the location and the size of our label. And you can see when you click on it that it expects a CG rect, which stands for a core graphics rectangle. And the way that we would create a CG rect is the same as we would create an object from any class. We write the name of the class, CG rect, and then we initialize it with our parentheses. You can see that there's quite a few ways of creating a CG rect or initializing a CG rect, but the simplest way is to simply provide an X position, Y position, width and height, all as whole numbers. So that's one I'm going to choose, and the X position I'm going to set as 0, so left, and then Y position also 0, so the very top. So my label is currently going to go in to the top left corner. And then the width, let's say 100 points, and the height maybe 50. So now I should have a rectangle that's at position 0, 0 with a width of 100 and height of 50. The next thing we have to do is to actually put our label onto the screen. And the screen, in this case, or the very, very basic component that is in every single view controller, is this thing called a view. And the view is the very background that comes with any view controller. So if I go into my object library and I search for a view controller and I drag it onto the screen, you can see that it doesn't come with much, but it does always come with a view. So that view is going to be the thing that we want to tap into in order to add our label onto it. So we can't just drag and drop our label onto the screen. We have to tap into this view property, which is the view that this controller manages, which is, again, exactly the same as this thing here in the storyboard. And we're going to use a method called add subview. Add subview will add a view to a parent view. So this will become the child and this will become the parent. So let's delete the placeholder there. And the view that we want to add is our label. Now notice how our label has a data type of UI label, but our add subview needs a UI view. So there seems to be some sort of a mismatch. Why is it possible that we can put this label in even though it's expecting a UI view data type? Well, that's because if we option click on our UI label, you can see that it inherits directly from the UI view. So this is the parent of the UI label, and the UI label can do everything that a UI view does and more. So that's why our input, our UI label, is in fact compatible with the expected data type of a UI view, because at the end of the day, a label is also a view. Now, the other thing to remember is that when we get a new UI view controller, the view starts out being transparent. So in order to easily differentiate this second view controller and the view that gets put onto the screen, we should really set its background color. So we can write view.background color, and let's set it to something really obvious like a red color. So we can write UI color.red, or a much quicker way of doing this is to simply delete that part, and because Xcode knows that the background color needs to be a UI color, when we simply just write .red, it already knows that what we want is a UI color .red. So we can modify our label and our view and customize it all day long and change all the properties and mess around with it in our code, but currently there's actually no way of accessing this second view controller to be able to see our label and our view with the red background color. So we know that the first thing that comes on screen is our view controller. So this is also a good place to make the transition to display our second view controller. And the perfect place is our calculate pressed IB action, so that when we press the calculate button, we can show the second view controller. Right here, I'm going to create a new object from that class that we just created just now. So here is the blueprint for a second view controller. And here I'm going to create the object called second VC, which is going to be created from the second view controller blueprint. And then I'm going to add a set of parentheses to initialize it. And now that I have this object, the second VC, to be able to actually see it and to be able to make it display on screen, I have to get the current view controller, which is on screen, to present this second view controller. So I'm going to tap into the current view controller, which can be accessed through the self method, which you can see is of type view controller, which is going to be this class right here. And this is currently on screen, so if it's able to present a view controller, then I can show my second VC. So I'm going to set it to present animated as true, so have a little animation when that transition happens, and completion is going to be equal to nil. So once the animation and presentation is done, I don't want it to do anything else. So now if I run my app, and I press on my calculate button, well, now I get my second VC, remember, with the red background popping up on top, and I've got my label that I've created shown at the 0, position, top left corner of this second view controller. And we've done all of that entirely with code. Now, we can see our label and our second view controller, but how can we pass over our BMI value to be displayed on this second view controller and placed into our label that we created? Well, let's create a property for our second view controller. Let's call it the BMI value, and I'm going to set it to equal 0.0 to begin with. Next, we're going to use this property, the BMI value, inside our label. So instead of the label text saying hello, it's going to display the BMI value. So now that we have our second view controller class with a BMI value property, we can now pass over our BMI when we create a new second view controller object. So here we've initialized a second view controller, and we can tap into that object, second VC, access that property called BMI value, and set it equal to the BMI that we've worked out over here. The only problem here is that this BMI value here is a string, whereas this BMI that we've calculated is a floating point number. So let's go ahead and use our string format method. So we'll use format, we'll round this down to percentage dots, 1 decimal place, and then we'll pass in the BMI as the value to be formatted. So now if we run our app, and I'm going to delete my print statement now, let's take a look at what happens. Let's go ahead and move our sliders around, and when I click on calculate, you can see the calculated BMI getting placed into the label that we've created entirely from scratch, and it's being populated with the text that comes from that BMI value property of the second view controller. We've now managed to see how we can create our UI entirely with just code without touching the storyboard. In the previous lessons, we've been learning a lot about inheritance and managing our screens using a UI view controller. Now it's finally time to learn about segues so that we can navigate between our screens in the storyboard. Now, when we created our second view controller class entirely from scratch, it gave us a lot of control and allowed us to show you how we would inherit from UI view controller, how we could override the viewDidLoad method that came from the UI view controller, as well as tap into properties that come from the UI view controller as well. And we got to see the class as well as the object created from the class in their purest forms. But you saw how much work it was just to create a single label. Now imagine if we had to create the entire user interface. It would require over 50 lines of code. But luckily for us, there's a much easier way of presenting another screen. So let's go ahead and delete our second view controller file. And instead, we're going to go to File, New File. And this time, instead of choosing a Swift file, we're going to choose a CocoaTouch class. Now, CocoaTouch refers to the framework that Apple has created that includes UIKit and a whole bunch of other libraries that allows us to piggyback off their code and make our lives a little bit easier. In this case, the class that we're going to create is going to be called the Results View Controller, and it's going to be a subclass of our UI View Controller. Now go ahead and click Next, and then make sure that it gets grouped with the controllers, and then click Create. So now you should end up with a new file that already has UIKit imported, that already has UI View Controller as the superclass that we're inheriting from. And it should also have created the class called Result View Controller that's inside a file called resultviewcontroller.swift. It's also got the viewDidLoad already implemented, and all we have to do is to delete these comments and add our own custom code. Just as we have done before, where we have our IP outlets, our IP actions, and we link our design with our code, I'm going to use this result view controller as the code file that's going to control and manage this screen. So we've already designed this screen for you, but in order to link it up with this new file, go ahead and select it either with this little yellow button here, alternatively in the document outline. And then we're going to pop open the right-hand pane and go to the Identity Inspector, which is this one. Now we're going to set the class that controls the screen. And we're going to start typing result, and it should hopefully pick up on the name of our class here, which is Result View Controller. So you can go ahead and hit enter once it finds that. You can also click on the drop-down list and try to scroll through this list to find it as well, but I find it easier just typing. So now that this is linked up, when we go into the assistant view, we should be able to start linking up some IB outlets and some IB actions. Now, occasionally, Xcode doesn't quite pick up on this link as fast as it should do. So when you select each of these view controllers in the main.storyboard, it should be automatically pulling up the linked file. So in this case, it's the viewcontroller.swift. But in this case, it actually hasn't clocked on yet. So what we have to do is go to automatic and select the result view controller. So in your case, you might not have this confusion, and Xcode is always changing, always trying to improve. It might be that you don't have this and you see this result view controller come up straight away when you go into assistant view. But at least on my copy at the moment, this is what I'm seeing. So this is how you can fix it. So now that we've got our code file and our design file side by side, let's go ahead and create some IB outlets and IB actions. So the first one that I need a reference to is the place where I'm going to display the BMI value. So I'm going to create an outlet here, and I'll call that the BMI label. And then I'm going to create another outlet from this label here, which I'll just place below, and I'll call that the advice label. And finally, we're going to create a IB action from our recalculate button right at the bottom after view did load. So this action is going to be of type UI buttons. So that's the sender data type. And then the name is going to be recalculate pressed. So that's it. And we can go into our full screen result view controller. And now we've got our two IB outlets and an IB action, and we're able to use the design that we've created in our interface builder. Now, this might be a good time to also rename our viewcontroller.swift, because it's probably better if the name tells us straight away which screen it's managing in the main.storyboard. So you can see that when you select this view controller scene and you go into the identity inspector, you can see that this is where that class is showing up. Now you could manually go and change the file name, change the class name, and change the name of it in the identity inspector on the main.storyboard as well. But that's quite a lot of work. A much easier way of doing this is simply to right-click on the name of the class view controller, go to refactor and rename. And now Xcode should be able to pick up on all the places where we're using that name view controller, including the file name, the commenting, the class name, as well as in the main.storyboard. So right here, we're going to change this to the calculate view controller, and then go ahead and click rename for all of these places to be changed and updated. Now, occasionally, Xcode might trip up when you try to rename the name of the file, and it doesn't actually change it over. So what you can do is you can go to Controller and Show in Finder, and inside that folder, make sure that the name of the file is calculate viewcontroller.swift. If not, you can simply just click and then pause 1 second and then click again. If not, then you can simply just change its name here as well. And that should fix that problem. But otherwise, we've now got our two view controllers, each linked to a code file that inherits from UI view controller. And this result view controller is going to be the second screen that we want to display onto our app. Previously, we had to initialize a view controller manually using our code. If we go into main.storyboard, there's actually a much easier way of navigating to the next screen. We can simply create a segue. So if you select the calculate view controller, either in the document outline or this little yellow circle here in the main.storyboard, and you hold down your control key, then you can click and drag and point to the result view controller. and then let go. And now you're going to select a segue, and we're going to select present modally. Now the segue is basically going to initiate a transition to the next screen. It's going to display the transition in an animated way, and you can choose your animation by simply selecting that little arrow that is representing the segue and then change the transition type. But we're going to keep everything as the default. And we're going to give this segue an identifier, so a way of being able to identify it through our code. And I'm going to call this go to results. And now we have a segue which will transition to the next screen, and we can trigger it by using that identifier, go to results. So now if we go ahead and copy this identifier so we don't make any typos in our code, and we go to our calculateViewController.swift. Now here we're going to delete this line where we create our second view controller, because that doesn't really exist anymore. And I'm also going to delete these two lines as well. Instead of all of that, what we're going to do is we're going to use a method that every UI view controller has, and we've managed to inherit it by inheriting from UI view controller. So we can tap into our current calculate view controller, and from this view controller we can trigger the method that's inherited called perform segue. So it's this one. And if we go ahead and hit enter, it should insert all of the parameters that we need to fill out. So in this case, in order to perform a segue, we have to put in the identifier, and that's of course the identifier of the segue, which you should have copied over, and you need to make sure that it's spelled exactly the same as what you had in the main.storyboard right here. And then we're going to specify the sender, so who is going to be the initiator of the segue, and it's of course our calculate view controller. So that is of course ourself, our calculate view controller, the current class. And now if we run our app, and we click on calculate, you should see that it navigates to the next screen, which is our result view controller. So now it's just a matter of passing over the BMI value. Inside our result view controller, I'm going to create a new variable. So this is going to be a property of my result view controller, and I'm going to call it BMI value. And I'm going to set it as a optional string, because initially when I create my result view controller, I don't know what the BMI value is going to be. It's only when I've calculated the BMI, then can I actually pass it over. But now that the segue is responsible for initializing our result view controller, and I no longer have to initialize it manually, well, how can we set the BMI value property? If you take a look inside the result view controller, notice that when we created it, the template code also included a navigation section that's been commented out. You can see here it says that in a storyboard-based application, you'll often want to do a little preparation before navigation. And this is the method that you need to override in order to run some code just before the segue initiates. So in preparation for the segue. And in here, it has a comment that tells us if you want to get hold of a reference to the new view controller, well, you can simply use segue.destination. So you can either cut this and copy it over to our calculate view controller, or you can simply just write prepare for and find the prepare for segue method. And this is going to be a method that we inherit from UI view controller, which we're going to override. So inside here, we can tap into the sender.destination. And this sender.destination is going to be the view controller that will be initialized when the segue gets triggered. In a multi-screen app, it's more than possible that you could have multiple screens that all originate from one screen. So let's say that I was to find another view controller and I was to drag it onto the screen, and I also have a segue from my Calculate view controller to this other view controller. Well, now I've kind of got two segues, right? I've got one that goes here and one that goes here, and they both start from the Calculate view controller. And when either of those segues are performed, the prepare for segue method will get triggered. So to be able to differentiate between our segues, or at least in a potential future where there might be a clash, we should first check to see if the segue dot identifier is equal to the identifier that we assigned to the one that goes to the results screen, this one. So let's check to see if segue identifier is equal to go to result, spelt exactly the same way again, and then in that case, well, we know that we've narrowed down on the actual correct segue. So now what we can do is we can create a reference to that new view controller that's going to be initialized when the segue gets performed. So let's create a constant called destination VC, and we're going to set it to equal segue.destination. Now, this destination is the view controller that will be initialized when the segue gets performed, and it has a type of UI view controller. So even though we know that for a fact when the go to result segue gets triggered, then it's definitely going to be this one, which will initialize a result view controller. But if we tried to say destination VC dot BMI value, well, we're going to get an error because it says UI view controllers don't have BMI values. And indeed, that is true. So why is it not picking up on this property that we have in our result view controller? Well, it's because that the segue.destination has a data type of UI view controller, and therefore our destination VC is also a UI view controller. But the BMI value only exists within our result view controller. So in order to narrow it down to say that the segue destination is actually a result view controller, we can say as results view controller. And as soon as we do that, then it recognizes the BMI value and our destination VC turns into a result view controller data type. So now we can set this BMI value to 0.0 and all of our code is now error-free. Now, why is it that we had to do this, and what does it mean when we write as? Well, remember that we're overriding this prepare for segue method, and that when Apple created this method, they didn't know that we were going to create a result view controller. They didn't know about a BMI value that we needed to set. So what they've done is that the segue will initialize a box standard UI view controller. Now, it's our job to narrow down the data type and specify the exact data type that the destination will be. So by using this as keyword, we are effectively performing something called downcasting. At the moment, we have a UI view controller, which of course is the superclass of our result view controller. We can cast it down to a result view controller by writing the keyword as. Now, the exclamation mark here says this is going to be a forced downcast. So just as when we use the exclamation mark to unwrap optionals, this expresses our certainty that when the segue's identifiers go to result, then the destination view controller that gets created is definitely going to be a result view controller. So now, can you use what you've learned and what you know to try and get the BMI value that we calculated inside Calculate Pressed over into our prepare for segue so that we can actually set the destination VC's BMI value to the actual calculated value rather than just 0.0. There's a few bits of code that you'll need to change, but the end result, if you're successful, is you should be able to change the height and weight toggles, click on calculate, and you should end up with the actual BMI result being passed over and displayed in this BMI label. Pause the video and see if you can complete this challenge. Alright, so at the moment we know that we've got our BMI being calculated in the calculate pressed IB action, but we actually need that value in our prepare for segue method. So how do we move it over? Well, one of the easiest ways is to simply create a variable in our calculate view controller. So we can call it BMI value, and we can set it to start off being equal to 0.0. And then when we calculate our BMI, we can format it so that we only get it to one decimal place. So we could say BMI value is equal to a string that is formatted with this particular format. So it's going to be %.1f, and then the value that we want to format is of course that BMI floating point number that we got here. And so now we've got our BMI value stored at the top level, and we can place it in here as the value that we'll pass over. So now when our segue gets triggered, we'll pass over the BMI value to our destination VC, which is our result view controller, and it should land in here. Now when this view loads up, we can set the BMI labels text property to equal the BMI value. Now if we hit run, you'll see that our calculated BMI gets passed over and displayed in our result view controller. So now that you've seen how we can use these segues to move forwards, going from one screen to the next, how do we go backwards? How can we dismiss this screen and show the one previous? So I'm going to delete this view controller because we're only working with these two. And you might think that the solution is to create a segue, this way back. But actually there's a much easier way. If you go into your result view controller, the time point where we actually want to remove this result view controller from the app and instead show the previous screen, which is our calculate view controller, is when the user presses the recalculate button. So inside this IB action, we can simply tap into a method that again comes from our UI view controller, and we can call it by simply writing self.dismiss. And this will dismiss the current view controller, which is of course our result view controller. So if we go ahead and insert that code, we can set the animated property to true so that the transition happens in an animated way. And we can set the completion to nil so that nothing happens after we dismiss it. We just go back to the previous screen. And if we now run our app, you can see that we're able to go forwards by clicking on the calculate button, which triggers the segue, and go backwards by clicking on the recalculate button, which dismisses that second screen, the result view controller. Now, here's something I want to show you. When we create apps that have multiple screens, what essentially happens is that the newer screens get laid on top of the previous screens like a stack of pancakes. And if you want to see them in 3D, then you can simply make sure that your app is running and then click on this particular icon. And it will show you what's currently displayed in the app. But if you click and move, you can see it in 3D. You can see that our result view controller is simply overlaid on top of the calculate view controller. So once we dismiss this view controller, then we go back to our previous screen. You can also see where our labels lie on top and relative to other user interface elements. And there's a really handy way of debugging what's going on with our UI. So that's just a neat trick. Now that we've figured out how to go forwards by creating a segue in the storyboard and then triggering it by calling perform segue, which comes from our superclass that we're inheriting, the UI view controller, and then we're able to prepare for that segue by setting some properties in the destination of the segue, and finally we're able to dismiss the presented view controller by calling the dismiss method, which again we have access to because it comes from the UI view controller, which we're inheriting from. Now, of course, Swift is smart enough to know that we're using the dismiss method from this current class. So in fact, the self keyword is not necessary. In some cases, especially when we're creating initializers, it's quite helpful to use the self keyword to make it easier to understand what's going on. So it's up to you whether if you want to keep it or if you want to simply delete it and keep your code clean. But that's how we can create segues and how we can go backwards and forwards and navigate through our multi-screen app. Now, in the next lesson, we're going to continue building out our app, and we're going to modify more of our result view controller by changing the background color depending on the BMI, changing the advice, and making our app conform to the MVC design pattern. So for all of that and more, I'll see you on the next lesson. Let's take a look at our view controller as it is at the moment. Notice how, as we're adding more and more code, the role of the view controller is expanding and becoming less well defined. For example, our view controller is calculating the BMI as well as rounding the BMI to 1 decimal place. So this is a good place to pause and reconsider how we're organizing our code. Our app will only get more and more complex going forwards. In the final version of our BMI calculator, we're able to change the height and weight, and depending on the BMI that gets calculated, we'll end up with a different colored background and some different advice text. So if we think about how we would organize this information, the advice, the BMI, and the background color, well, that seems like it's very much within the M of the MVC. And that's what we're going to do in this lesson. We're going to refactor our code to bring it in line with the MVC design pattern. The first thing we should do is therefore create our M, or the model. And there it is in our project. We've already created a model folder for you. So all we have to do is right-click on it and create a new file inside. Now in this case, we're going to be creating a new Swift file. And then we're going to call this file calculator brain, because it's going to be responsible for handling all of the logic of calculating our BMI. So inside this new file, I want you to create a new struct called calculator brain. So see if you can remember how to do that, or if not, take a look at the Swift cheat sheet to remind you. Now, of course, to create a new struct, we need the struct keyword, and we can even use the code snippet from Xcode to help us. The struct name is going to be calculator brain, and inside the calculator brain, we're going to create all of the properties and methods that are required to calculate our BMI, to interpret our BMI, provide an advice, and provide the appropriate color. So now, if we go into our calculate view controller, let's rip out all of the parts which it's not supposed to be doing. So including the BMI value, as well as the calculation and also turning it into a string part. And instead, we're going to create a new object called calculator brain from our calculator brain struct and initialize it with our set of parentheses. Now that we've got access to this calculator brain object, we're going to go down into our calculate pressed method, and we're going to say calculator brain dot calculate BMI. And we're going to pass over the height as one of the inputs and weight as one of the other inputs. Now, this will give us an error right now, but don't worry about it for now. And down here, instead of getting the BMI value, which doesn't exist anymore, which is why it's saying use of unresolved identifier, we're going to get our calculator brain to provide that value. So we'll call get BMI value. Now, of course, we don't have these methods yet. We don't have a calculate BMI that takes a height and a weight and then later on is able to fetch the BMI for us. Well, that is the challenge for you. So pause the video and see if you can make these two errors go away without writing any code inside the view controller other than these two lines, as well as initializing the calculator brain. So keep the code exactly as I have here, and by changing the calculator brain, see if you can make this code work and make our error go away. Pause the video now. So the first thing we're going to do is we're going to create this method, calculate BMI, over in our calculator brain. So let's create a function called calculate BMI, and the height needs to be a float variable, and the weight also needs to be a float. And then once those things are passed in, we're going to calculate the BMI. So let BMI equal the weight divided by height times height. Now that we've got the BMI calculated, that error will disappear. So let's address the next one. So we also need a method called get BMI value. So I'm going to copy that, and it should be able to provide us a value in the form of a string, because in our result view controller, we're expecting a string. So we need to make this method inside our calculator brain. So let's go ahead and create a method called get BMI value. And it, of course, has to return or output a string data type. So how do we get hold of this BMI value that was calculated in this other method? Well, why don't we go ahead and create a property for our struct, our calculator brain. Let's call it BMI, and let's make it a floating point number, which is equal to 0.0 to begin with. Now, instead of creating this BMI here as a constant, we're simply going to set this BMI to be equal to the calculated BMI. Now that it's stored in this variable, we can get hold of it in our function here, and we can format it so that we end up with a BMI to 1 decimal place. Now, you can of course choose a less wordy name than I have, but I just want to make sure that when you look at this, you know exactly what it's trying to do. And this is going to be a formatted string, which is going to be accurate to 1 decimal place. So .1f. And then we're going to pass in the value of BMI as a float, and we should end up with a string which we can use as the output. So returning our BMI to 1 decimal place. Now, the final problem we have is that we get the error, of course, BMI is a property of our struct, and because structs are immutable, in order to change it, we must destroy the old copy and create a new one. So we have to mark this method that changes our property as mutating. And now we should be able to take a look at our calculate view controller. All of the errors should go away, and if we run our app, we should have exactly the same values as before. And that's the solution to the challenge. We're now calculating the BMI in a separate struct, and we're returning the BMI to the calculate view controller as a string. Now, let's take a closer look at our struct. In particular, let's think a little bit more carefully about how we're handling this BMI property. Currently, our BMI property in our calculator brain has a default value of 0.0 to begin with. And we did this because when our calculator brain object gets initialized from this struct, we must have a value for this BMI property. We can either do it here, or if we simply declared it as a float data type, well then we would have to initialize it when we create our calculator brain right here. And round about now, I'm going to get an error right here saying I'm missing an argument for the parameter BMI. But if you think about it, at this point in time, I don't actually know what the BMI is, because I have to wait for the user to toggle the sliders, then press the calculate button before I can actually get a value. So it really doesn't make sense to provide a value for the BMI when we initialize it. So how can we represent this a little bit better? In reality, what this BMI value really should be is it should really be equal to nil to begin with. And only when we actually calculate the BMI should it actually get a value. So does this remind you of something when we have to work with nil values? Of course, we need to turn this into an optional. But as soon as BMI becomes a optional floating point number, well, we've got errors down the line. And previously, all that we've done is simply to just force unwrap when it's safe to do so. But in this case, is it really safe to unwrap this BMI? Because right now, if this method getBMI gets triggered before this method, where we actually fill the BMI with a value, at this point it's still nil. So if we're trying to turn a nil value to a 1 decimal place string, this is going to crash big time on us. And you can confirm this if you simply just go into the view.did of our calculate view controller and call that calculator brain method called getBMI. And right now, if I run my app, pretty much as soon as my view loads up, my app is going to crash. And of course, it crashes on this line right here because unexpectedly found nil while unwrapping an optional value. And we can see right now this BMI value right here is equal to nil. So therefore, this BMI 1 decimal place value, of course, is not going to be able to get calculated. So let's go ahead and remove this offending line of code. And we should also remove this exclamation mark, which force unwraps this optional. So how can we solve this problem instead? Are there other ways of working with optionals? Well, to learn more about that, head over to the next lesson where we're going to do a deep dive on Swift optionals. Hey guys, welcome to another Swift deep dive, and in this deep dive we're going to learn more about using optionals. Now, previously you've already been introduced to our ill-fortuned cat, Fluffy, and because of our lack of understanding of optionals, we put her life in severe danger. So how can we make sure that we're not getting calls from the animal rights people and make sure that we treat our cat properly? Well, let's see how we can keep her out of harm's way. So what's going to happen in this deep dive is I'm going to walk you through 5 different ways of working with optionals in Swift, including force unwrapping, checking for nil values, optional binding, the nil coalescing operator, and optional chaining. So that's a lot of new words, but let's get started. So I'm going to go ahead and create a new Mac OS command line tool, just as we did before, and I'm going to call this optionals demo. And when I go to my main.swift, I'm going to delete everything that's currently inside, and I'm just going to use it as we do with our playgrounds. So first things first, I'm going to create a optional, so I'll call it my optional, and I'm going to give it a string data type. But of course, to turn it into an optional, we just have to add the question mark at the end. Now, notice how the string data type is actually completely separate from the optional string data type. So if I was to give my optional a value, let's say Angela, and if I create a constant which requires a string data type and I try to set it to equal my optional, this is not going to work because this expects a string and this has actually a completely different data type, an optional string. So how do we work with optionals? How can we turn it into an actual string that we can put into labels or buttons and manipulate in our code? Well, one of the simplest ways of working with optionals, as we've seen, is to simply just force unwrap the optional. But this, of course, requires us to really think hard and fast about whether if there's a case where we could be unwrapping the optional and it could actually have a nil value stored. Well, in that case, well, Fluffy gets it. In this case as well, if I go ahead and simply just unwrap the optional, then I make all the errors go away and I kind of am just telling Xcode that, you know what, I know better than you and I know that this is never going to be nil. But what if my optional was actually, in fact, storing no value at all? What if it was equal to nil? So in this case, yes, Xcode is not reporting an error, meaning we have no error at the moment. And our project builds successfully. But when I run my code, it crashes. So in other words, I experience a crash at what we call runtime. And it crashes on the line where I'm force unwrapping my optional because it was unexpectedly found to be nil. My optional was equal to nil. So this is probably the least safe way of working with optionals. It requires you to be really concentrated and search through your code to make sure that it can never be nil. So I know in this example it seems super obvious because we're setting my optional to nil 2 lines earlier. But what if you were working on a more complex project with many files and many lines of code that you can't always keep track of? Well, in that case, it will be a lot less obvious. So what else can we do? Well, a slightly safer way of working with optionals is to check to see if it's equal to nil. And if it's not, then we force unwrap it and use it in our code. If we had wrapped this line, which is crashing our app at the moment, inside an if statement where we check if my optional is not equal to nil, well, in that case, then we can use it. So now if I run my code again, then this line is just going to be skipped. How can we tell it's skipped? Well, we can write an else statement where we say, my optional was found to be nil. So now let's run it again. And you can see we get my optional was found to be nil, so this if statement was skipped, saving us from crashing our app. But here's a problem. This is firstly quite wordy. Even though I've already checked to make sure that my optional is safe to work, I still have to use this exclamation mark to force unwrap the optional every single time. So if I wanted to create another constant, let's say text2, which was a string, and I wanted to be able to work with my optional, well, again, I can't simply just use it without adding that exclamation mark where I force unwrap it. So this behavior where we are checking to see if the optional contains a nil value, and if it's not nil, then we work with it, is so common while we're working with Swift optionals that there is functionality that's built into optionals to handle this, and it's called optional binding. So in this case, what we do is we can write an if let to bind the value of the optional, if it's not nil, to a new constant. And within the curly braces of this if statement, we can now work with this safe version of the optional, which has been unwrapped. So in this case, instead of writing if my optional is not equal to nil, I can write if let safe optional equals my optional. Well, in that case, safe optional is going to equal the value of my optional, but notice how safe optional has a data type of string, while my optional is an optional string. So now, if I wanted to work with the value of my optional, namely the word Angela, well, I can now simply use the safe optional. And you can see that if I decide to print my safe optional and run my code, you can see that I get the value that's stored inside my optional printed from the safe optional. So it's just a way of performing that action of opening up the box, seeing if there's anything inside. If it's nil, then simply go ahead and skip and go to the else statement. But if it's not nil, then we're going to put the value inside my optional inside this new temporary constant, which we can use inside the curly braces. But this simply just skips the optional if it's equal to nil. What if we wanted to provide it a default value in the case where my optional is equal to nil? How can we do that? Well, there's another functionality of optionals that comes in really handy right about now, and it's called the nil coalescing operator. And it's simply just two question marks next to each other. And that's what it's called. And why is it the nil coalescing operator? Well, because what it does is it checks to see if the optional is nil. If it's not nil, then we're going to use that value. But if it is nil, then we're going to use the provided default value. So in our case, currently my optional is nil. And I'm going to delete all of this if and else statement right now. And I'm going to try and again do the same thing, create a text constant that holds string data type, so real strings, not optional strings. And I want to work with my optional. Now here I can say my optional, well, if it has a value, then set that as the value of the text. But if it doesn't have a value, namely if it's nil, then we're going to use the double question mark, the nil coalescing operator, and we're going to provide a default value. So I am the default value. And now if we go ahead and print our text, then you can see that because my optional was equal to nil, it was not set as the value of text. Instead, it's the default value after the nil coalescing operator that was set as the value of text. And that's what's getting printed right now. So those four things that we saw, force unwrapping, checking for nil values, optional binding, as well as the nil coalescing operator, cover all the cases where our optional is just holding a simple value. Now, there are certain cases where instead of having an optional value, we actually have an optional struct or an optional class. Well, what do we do in that case? Let's say that my optional is no longer just a string. Instead, I'm going to create a struct, which is called my optional, and it's going to have some properties. So property equals 1, 2, 3, and some methods. So we have a method, which is just going to print, I am the struct method. This is our very simple struct with a property and a method. Now, if I create a optional version, so my optional, and it's going to have my optional as a data type, but it's an optional. So I haven't yet initialized it. So if I wanted to actually turn it into a real struct, then I would have to say my optional equals my optional, and of course that set of parentheses will turn it into a real value. So that was the equivalent of giving the previous optional a value, right? It wanted a string. Well, in this case, it actually wants the structure to be initialized. In this case, if I wanted to tap into the property of this optional or the method of this optional, then how would I go about doing that? So let's say I wanted to print my optional dot property. What would actually happen in this case? Well, I can't, because this is an optional. So even though the property is not an optional, but because the struct is an optional, we can't actually proceed unless we either unwrap our optional, but if it was nil, then it's a little bit dangerous, right? Because if I turn that into a nil again and run my app, you can see that it's going to crash on this line. So even though the property itself is actually not an optional, it's just an integer, and we can see its value right here, we can't get to it if we haven't yet initialized this structure. So if it's equal to nil, then we can't proceed further. Now, how can we make this code safer? Well, then we would have to use something called optional chaining. So in this case, because our optional has some properties or methods that are accessed using the dot notation, in order to get to it, we add a question mark after the optional. And what this says is, if this optional is not nil, then continue along this chain and go ahead and access that property. And we can do the same with methods as well. So if the optional had an associated method, then only when it's not nil do we actually execute that method. So in this case, if we replace this exclamation mark with a question mark, then when we run our app, it won't crash anymore, but this won't be equal to anything either, because my optional is currently nil. So we can use this chaining method to access the properties and methods of our optional. And this means that if our optional indeed was in fact initialized, so it now does have the property and method set, then when we run it, it will actually execute that method. And it will print I am the struct method. So those are some of the 5 ways that you can use to work with optionals. And we're going to be applying that in our app in the next lesson. So continue to the next lesson and I'll see you there. In this lesson, we're going to add the finishing touches to our BMI calculator. We're going to apply the MVC design pattern to add some additional functionality to our app. By the end of this lesson, our app will display a piece of advice text underneath the BMI value, and also show a different background color depending on whether if the BMI that was calculated happens to be underweight or overweight. In the process, we'll learn how to work with color literals and also get more practice working with optionals in Swift. Speaking of optionals, prior to our optionals deep dive, we were looking at our BMI property in our struct. We transformed this property into an optional, and we were wondering how to best work with it in the getBMIValue function. So coming back to our project, having learned about all the ways that we can handle optionals, let's think about how we can apply those methods that we learned about to our optional value here. The first thing that we learned about is we could simply do a if BMI is not equal to nil, well then in that case, and only in that case, do we actually trigger this block. Now, once we re-indent our code, and then we go ahead and unwrap this BMI value safely within the check of our if statement. Now that error goes away, but we get a new error. It's telling us that we're missing a return in a function expected to return string. Because yeah, when we created this function, getBMIValue, we promised that we would give a string as an output by the end of this function. But you can see that if the BMI was indeed nil, then this entire block of code is going to be skipped, and we're going to land right here without having any value to give back. So what can we do? Well, we could provide a else statement. So we could say that, well, in the case where BMI is nil, then let's simply just return 0.0. So that's one way of looking at it. The other way is using our optional binding. So where we say, if let safe BMI equal to BMI, well, in that case, as long as this has a value, then we should be able to use this safe BMI as an actual floating point number. So here we don't have to do any unwrapping anywhere, and we can just simply tap into the safe BMI. But again, in this case, we still need that else statement, because if the BMI is nil, then again, this block will be skipped and it will jump to the else statement. Now, if we wanted this code where we're using the BMI value if it has a value, otherwise providing a default value, well then this whole block of code could actually be vastly simplified by simply deleting the if and the else statement and using our nil coalescing operator. So in this case, we're going to say that, well, if there is a value in BMI, well then use that value, but otherwise let's just use 0.0 as the value that we format. So out of those three options, I would actually prefer this approach. The syntax with the nil coalescing operator is both more clear and more expressive. So now that we've figured out the BMI value, the next step is getting hold of an interpretation for the BMI value and assigning it a piece of advice as well as a color. Now, in that case, we should probably end up grouping our BMI value with its color and advice together in the same data type. So does that remind you of something? Well, it means that we should probably create a model for our BMI. That's right, we're going to build our app to be more in line with the MVC design pattern. So in our models folder, let's go ahead and create a new file. And it's going to be a Swift file. And let's go ahead and name it BMI. And make sure it goes into the models folder. In this BMI file, I'm going to create a new struct called BMI, and it's simply going to have three properties. A value, which is going to be a float, a piece of advice, which is going to be a string, and finally a color, which is going to be a UI color. Now notice how it's not coming up in my auto-suggest here, and that should be a good hint to you that we actually are using something that we don't currently have access to. And this says just as much, because we need to switch our foundation to UIKit so that the UI color, which comes from UIKit, can be found and we can use it. So it's a pretty simple struct for our BMI. It's going to be a custom data type that groups together the value, which is the number, and then the advice text as well as the color. Now we can head back into our calculator brain, and instead of having our BMI being a float, I'm going to change its data type to being that new BMI struct that we created. But again, it's going to be an optional. So now that we've changed the data type, we have to do a few fixes in our code. And the first thing is that we should change this, which is no longer a value, a floating point number. It's now a BMI struct. Instead, it should become BMI dot value so that we can tap into that floating point number. But notice how as soon as I type the word value, what gets automatically inserted for me is that question mark there. And from the last lesson when we did our deep dive into optionals, you should be able to recognize that this is effectively chaining our BMI optional. So because the value is a normal floating point number, but the BMI is of course the optional here, in order to reach into the BMI to get hold of that value, we first have to check to make sure that the BMI is not nil, like it is here. And if it's indeed not nil, well then we can get hold of the value that lives inside. But if it is nil, then we're simply going to use 0.0 as our value. So that's our first part fixed. Now down here though, we can't simply just write BMI.value and use optional chaining to try to assign this to our value property in the BMI struct. Because remember that the value was set as a let constant. Once we create this BMI with the value, advice and color, all we want to do is just pass it around. We don't want to change it. It's only ever going to have one value. And so that means what we actually want is to be able to create a BMI struct from scratch. So instead of writing BMI.value, let's create a temporary constant. Let's call it let BMI value equal height. And then we can create our BMI, by using that BMI struct and then using the initializers to fill in each of these values. So the BMI value that we calculated, of course, goes into the value placeholder. And then we need a piece of advice and a piece of color. But these two things are worked out based on what value we got. Because the reason why the BMI is such a useful indicator for health professionals is because it takes into account not just somebody's weight, but also their height. A really tall person has the same weight as somebody who's really short, then the shorter person probably is more overweight. So in the BMI chart, you can see these different bands which classify the BMI values, where below 18.5 they are underweight, between 18.5 and 24.9 they are healthy, and then above that they are overweight, obese, and extremely obese. The National Institute of Health classifies some of these categories, and we're going to use these categories to create an if statement in our code. So as a challenge, I want you to look at the BMI value that we calculated from dividing the height squared by the weight, and then I want you to print underweight, normal, or overweight based on what that value is equal to. For this challenge, just print to the console for now. We'll be adding the functionality to show the interpretation inside the app in a bit. So take a look at this breakdown, pause the video, and try to complete this challenge. Alright, so let's first comment out this line of code, which we don't have any values for, and then we're going to use our BMI value, which gets calculated, and we're going to check to see if the BMI value is less than 18.5. Well, in that case, then we should print underweight. But the next category for the normal weight is for people who are between 18.5 and 24.9. So how can we express that range? Well, we could use an else if, which only gets triggered, remember, if the if statement, this check, fails. Well, in that case, if it's not less than 18.5, well then is the BMI value less than 24.9? Well, in this case, we should be printing normal weight. And finally, if the BMI value is not less than 18.5 and it's not less than 24.9, well then we can catch everything else above 24.9 with the else statement, and we can print overweight. So this is one solution to our problem. Now you might have done it slightly differently. You might have checked to see if the BMI value was greater than 18.5 and it was less than 24.9 to catch that particular range. And that would be the case if you only had an if statement. But if you have an else statement, remember that it's already checked the previous condition. It's already checked and made sure that the BMI value is not less than 18.5. And that's the point at which the else statement actually gets triggered. So we don't actually have to check the lower end, we just have to check the upper bound, which is 24.9. And that's the solution to the challenge. Now, let's make use of this logic. So now, instead of printing underweight, normal weight, and overweight, let's instead create our BMI struct when we have these different categories. So if the BMI value was less than 18.5, well then maybe the advice is we should tell them to eat more pies. And the color that we will use to show that they're underweight is maybe we could just use the UI color dot blue. Now notice how UI color again comes from UI kit, and without importing UI kit we won't be able to use it. But there's another way that we could do this by using something called a color literal, and we're not going to use UI color anymore. Instead we're going to start typing color literal, and once that hint comes up we're going to hit enter. And now in this little square we can double click on it and out pops a little color palette that we can pick from. Now if these colors aren't enough for you, then you can click on other and you get the full choice of RGB sliders or the rainbow or the crayons, whichever one you prefer. But in my case I'm simply just going to choose this light blue color for people who are underweight. And then for normal weight I'm going to say maybe fit as a fiddle. and let's add an exclamation mark here as well to express our enthusiasm. And let me just fix my typo there. Now let's change this color to green for normal weight. And finally, for overweight, we're going to say maybe eat less pies, because that's what everybody eats, just pies all day. Now, and I'm going to change the color to red. Alright, so I've got blue, green, red, and I've got a piece of advice for everybody from each category. And now we've calculated the BMI based on the values that were passed in. We've interpreted them and created a separate BMI struct for each value category. So let's tie everything that you've learned so far together with a challenge. Head back over to the Calculate View controller, and down here where we have access to this destination VC, which is the result view controller that's going to be shown up on screen, I want you to type 2 more lines of code. So we're going to tap into the destination VC, and we're going to set a property called advice, and we're going to set it equal to the calculator brain dot get advice. And then we're also going to tap into the destination VC and set another property called color, which is going to be coming from the calculator brain, as always, and it's going to be called get color. So using what you've learned about optionals, about MVC and structs, I want you to complete this challenge by getting rid of the errors here. Now, you're not allowed to touch anything else inside the Calculate View controller, and you have to fix this code and make it work so that when you run the app and you change the height to some extraordinary number and click Calculate, it should calculate a low BMI, which means a blue background, which means eat more pies. And if you had a normal-ish sort of height and a normal-ish sort of weight, then you should end up with a green background with fiddle as a fiddle as the advice text. And finally, if you have a really low height and a normal weight, then you might get a higher BMI result with a different advice and a red background. So essentially, these 2 lines of code will allow us to pass on the advice that we get out of our calculator brain, the color that we got out of our calculator brain, and make it display in the result view controller. So there's a couple of things that you have to fix and you have to write, and it requires all of your knowledge that you've learned so far. Pause the video and try to complete this challenge. Alright, so there's a few ways that you could have solved this challenge, but first of all, we have to get rid of these errors. And through the code that I've written, it requires that we have a property called advice and a property called color in our destination VC. So that is of course going to be our result view controller. So here we've already got a BMI value, which is a optional string, because when we create the result VC, we don't yet know these values. We have to pass it over, because the segue creates that view controller, at which point we don't know any of these values. And it's only when we cast it down to a result view controller, and then we can set its properties. So we need to create advice and color over here. So I'm going to create a variable called advice, and this is also going to be an optional string. And then I'm going to create a variable called color, which is going to be an optional UI color. So now that should get rid of these 2 errors, and that's no longer highlighted in red. So let's go ahead and address the next part, our get advice and get color methods. So we currently don't yet have those things in our calculator brain. So let's go ahead and create it. Let's create a function called get advice, and this should probably return a string because the advice text is a string. And then let's create a function called get color, and this will return a UI color. So if you haven't converted your foundation into a UI kit, then you'll have to do that now in order for Xcode to know about this data type. So now it's saying that we're missing a return in a function expected to return. So in this case, we need to get hold of the BMI's advice property. So let's go ahead and try to return BMI.advice. Now it automatically chains our BMI, which currently is still a optional, and then it tries to tap into the advice property as long as it exists. But of course, if BMI was nil, then advice would also be nil. So therefore, this entire bit of code is actually still an optional string. So how do we turn it into an actual string? Well, we could use our optional binding, we could use our nil checking, or more simply, and to keep it short and sweet, we could also just give it a default value of no advice in the case where our BMI is actually nil. Now, in pretty much all circumstances, this would never get triggered because our prepare for segue is always going to be triggered after perform segue, which of course lives in the calculate pressed IB action, which already calls calculate BMI. Now, we know this, but our code doesn't know, and there might be a case in the future where we've forgotten all about this. So to catch that optional being nil, we provide a default value, which should alert us that something has gone wrong. So let's go ahead and do the same in our get color. So I'm going to return BMI chained with the dot color property. In this case, I'm just going to provide a default color, say a UI color dot white, or if you want to keep it consistent with the rest of these, then it might be a case of turning this into a color literal. But of course, when there are errors, the color literal doesn't really pop up very easily in Xcode. So I find it's easier to just copy it from somewhere else and paste it in, and then we can double click on it to change it to white. Alright, so now that we've created our getAdvice and getColor methods, if we go back to our calculate view controller and hit Command B to hit our code with a stick, then that should get rid of all of those errors. But now you might realize that if we run our app, it's still not enough to get the advice and color being displayed on screen, because while we have access to them in these properties now, we're not using them yet. So in our view.did_load, in addition to setting the BMI label, we're also going to set the advice labels text property to equal the advice string that we passed over. And notice how I'm not unwrapping these optionals. And the reason is because the BMI label.text property is actually expecting an optional string, because it can be nil. You could have a label with no text, and that's perfectly fine. The label can handle that. So in this case, these two data types match, and that's why we're not getting any errors. But how do we set the background color? Well, remember that in the UI view controller, we have a property called view. And that view, of course, comes from the UI view controller, and it refers to this view that we see right here, which is, of course, the background of this screen. Well, that sounds pretty much like what we need to change in order to change the background. And notice how at the moment we've got this blue background showing up, but it could also be yellow, or it could be red, or it could be any other color, basically. So we're going to tap into this view, which we always have access to whenever we create a new view controller, and it's already linked to our code with a property called view by default. So every single time you drag on a new UI view controller from the object library and you put it onto the screen and you link it up with a UI view controller class, then you should have access to that view property, and that will determine what the background looks like. So let's go ahead and change the view.background color property, and we could set it to the color that was passed over. So now let's go ahead and run our code. And you should see that when we change our weight and height, our BMI gets calculated, and depending on the result, we get a different interpretation and a different background. So have a mess around with that and see what you get. And if you didn't manage to complete the challenge in its entirety, be sure to review your code and try to fix it so that it works. And if optionals were confusing, then take a look at the optionals deep dive. If this view property tripped you up, then be sure to take a look at the lessons where we talked about classes and inheritance. Now that's it for this module, and I hope to see you on the next one.